Hello everyone, my name is Hyder Abbas. I welcome you to this series on cloud computing with AWS. Today, all the application, be it online store, ride sharing platform, banking application, or any modern application in that matter runs on cloud. If you want to become a DevOps engineer, cloud engineer, backend developer, go up in ladder in your career, cloud computing is no more optional, it is very essential. We are going to start this entire series from absolute scratch. First, we will understand what is cloud computing, why we have to go with it, and then we will understand AWS. We will understand how to create the account and manage that identity and access management. We will understand about one of the important services in AWS, which is EC2, alongside auto scaling group, load balancer, security group, networking with VPC, NAT gateway, internet gateway, elastic IPs, public and private IPs. We shall also understand about S3 database like RDS. We'll understand CloudWatch monitoring and also the SNS. We shall also understand about Elastic Beanstalk. We will understand ECS, ECR, and all the important services in AWS, which is going to play essential role as a cloud or DevOps engineer or even for the backend developer. We will understand both theory and practical. I'll be giving all the demonstration of all the services which we are going to see in this entire series. I'm pretty sure that at the end of this entire series, you will be very much confident to go and use AWS and work with cloud computing in any of the real application, right? So I'm very excited for this entire series on cloud computing with AWS. I hope you are too. Let's get started with a positive mindset of being a finisher and complete this entire series on AWS. Imagine tomorrow you want to launch your own application. You have identified a real world problem and you wanted to give solution in the virtual world for which you have built an application. It is not just about identifying a problem or building an application by writing the code. It is also about giving life to that code, making your application available for the user, right? Whenever you want to launch your application or make it available for the user, there is an infrastructure requirement. You need to have servers, database, storage, right? Security, dedicated maintenance team, electricity, backup. So many infrastructure requirement arises. Can a startup or maybe an individual, before even get some users to the application or maybe before even generate any revenue, spend crores of rupees on infrastructure which is required to run your application or maybe launch your idea? The answer is no. This exact problem gave birth to something called as cloud computing. Now we need to understand what exactly cloud computing is, what problem it is trying to solve, why everyone is talking about cloud computing and every company is moving towards the cloud infrastructure. Before cloud computing existed, companies used to rely on something called as on-premises infrastructure, meaning whatever infrastructure is required to run your companies, having them physically available on premises, meaning servers, the electricity, the power backup, security, 24 by 7 dedicated, team which is used to manage this infrastructure, networking, everything physical. Of course, the upfront cost used to be very high. You have to spend crores of rupees to get this infrastructure, and that too, there is a possibility that there will be some problem in the infrastructure which you are maintaining physically because of the natural disaster or maybe something like hardware crash or maybe hard disk some issue happened, right? There is a concern with respect to security. There has to be a team which used to monitor very closely everything on the infrastructure which you are trying to maintain. And what if your application is maybe becoming famous and there is a possibility or maybe you want to run some sale and lot of traffic might come to your application, then you have to also increase number of servers where you are deploying your application. And maybe you have bought some 20-30 servers thinking that there is a huge traffic coming to your application, but that didn't happen. Maybe there is few footfall to your application. Then whatever servers you have spent money on, again there is a loss there as well, right? So there was a lot of problems and limitations associated with maintaining the infrastructure on premises. That's where a demand emerged in the IT ecosystem, wherein about the infrastructure there has to be some solution in order to launch and maintain your application. The concept of buying all the infrastructure which is required to run and maintain your application emerged, and this gave birth to something called cloud computing, wherein you have an option to buy the infrastructure over internet. You need not to maintain anything physically. Everything, whatever is required to run your application, to make your application available for the users with respect to storage, servers, database, networking, security, maintenance, scaling, as and when there is a huge traffic coming up to your application, automatically number of servers should increase, and if there is no traffic, less servers should be used. And buying all this over the internet is only called as cloud computing. In simple terms, whatever infrastructure needed to run your application with respect to server, storage, security, backup, right, maintenance, scaling, buying those services and infrastructure over internet is only called as cloud computing. It is like you are using the electricity. You need not to build a power plant to use the electricity. So whenever you need, you'll be using it, and you'll be paying as per your usage. Exactly same with the cloud computing also. You have to pay only for the usage. All the, or I can say most of the cloud services works on pay as you go model, meaning how much ever you're using, you have to pay only that, right? So example, just to maintain or maybe launch your application for the low footfall or maybe a low traffic, 2 or 3 servers are sufficient, and there is a sale and you're expecting huge traffic to come to your application, then you may have to increase the server. In the cloud computing, we have a concept of auto scaling. As and when the traffic increases, automatically number of no servers will be increased. If there is a no traffic to your application, no one is coming to your application, then automatically number of servers will be decreased. So how much ever infrastructure you are using, you have to pay only for that, because it works on pay as you go model. And also with the additional benefits like fast deployment of your application, maintenance, backup. All the cloud providers which are there in the market right now, they have data centers across the globe. It is easy for the users to access the application. They'll take care of storage, security, backup, any disasters, everything they will only manage. And also it is faster deployment. If you want to create or use this infrastructure, it will take few minutes in order to create, unlike the traditional on-premises infrastructure wherein you have to put a lot of efforts to maintain or buy the on-premises infrastructure, do the setup. It used to take days and months, but here it is in minutes, right? So it will enable us to deploy our application faster. Because of this, today almost all the big companies have already moved to the cloud, and all the startups are also moving into the cloud, and it is also creating a demand for the engineers who can manage the infrastructure on cloud. The demand of cloud engineers also emerging, and it has always been one of the trending role in the IT ecosystem. There are many cloud providers available in the market. The popular one happens to be Amazon AWS, right? Microsoft Azure, Google's GCP, Oracle Cloud, Alibaba Cloud, like this, many of them are there. And out of all, the most popular and widely used is Amazon Web Services, which is AWS. And in this entire series, we are going to focus on cloud computing with AWS, right? I hope now you could just able to understand what exactly is cloud computing, what problem it is trying to solve, right? Now we understood the limitations associated with the on-premises infrastructure and what exactly is cloud computing, why we may have to go with cloud computing. Now another important question comes here. When we use cloud, what exactly are we getting from the cloud providers, right? Is it just servers, or maybe a software, or a complete platform? Here is where IaaS, PaaS, SaaS comes into picture. Different companies have different requirement. Some companies want the complete control over the infrastructure, server, choice of operating system, the runtime environment, right? And some companies want just a platform to run their application, and some companies want a whole software. Here is where cloud models comes into picture. All the cloud providers have different cloud models. Number one happens to be infrastructure as a service. Number two, platform as a service. Number three, software as a service, right? When it comes to infrastructure as a service, IaaS, cloud providers gives you services like networking, servers, right? The resource computing, and you have to take care of the application. You have an authority to decide the complete operating system. You can decide the environment which is needed to run your application. It is like, if I have to give you a simple example, you will be getting the kitchen, but you have a complete control over all the utensils and all the gas stove, whatever is available in the kitchen to prepare your food. You have to prepare your own food, but you have a complete control over the kitchen. All the components which are there, which are readily available in the kitchen, you can use, you can decide which one to use, and you can prepare your own food, right? Now, coming to the platform as a service, the entire kitchen would be given alongside the food ingredients, and they will only give you whatever is required to prepare your food. You have to focus only on the cooking style, right? So you need not to worry about all the components, utensils which are there in the kitchen. You just have to focus on the, a cooking style. But in the infrastructure as a code, you have to worry about the food ingredients, and you will have a control over the entire kitchen, but you have to prepare, you have to do everything there, right? But entire kitchen and setup would be given to you. But here, the entire setup, food ingredients, and all the components which are required to prepare your food, it will be provided to you. You just have to focus on the cooking style, prepare the food, and eat it. And coming to software as a service, the entire food would be given to you. You need not worry about how to prepare food ingredients or anything. They will prepare the food, and you just have to take it and eat it, right? So infrastructure as a service, cloud providers gives you servers, networking, the resource computing which is required, and you have to take care of your application. You have a control over operating system, you have a control over runtime environment, you can decide about the storage, right? All the infrastructure is given, but you can control and you can decide what is needed to run your application. And when it comes to platform as a service, PaaS, cloud providers provides you infrastructure. They'll also provide you runtime environment, operating system. You just have to focus on developing your application. You need not worry about the infrastructure. You need not even worry about the runtime environment or operating system. Everything they will provide, whatever infrastructure is required, and they will give you a ready-made setup. You need not to choose, unlike in the infrastructure as a service, wherein you have to control the operating system, you have to control the servers. It will be given to you, but you have a complete control and you have to manage that, right? Meaning you need not to manage any physical data center. They have taken care. Cloud providers have taken care of that. It's just you are deciding the operating system, how much storage you need, right? How many servers you need. All of the decision you may have to take it. The entire runtime environment which is required to run your application, you have to take care. But in the platform as a service, that will be taken care by cloud providers. You just have to focus on application development, nothing about the infrastructure which is required to run your application. All the platform, servers, storage, operating system, runtime environment, everything they will take care. And it is like a fully equipped kitchen with all the food ingredients and all the components which you need not to even worry what to use. You just have to prepare your food. Rest of all will be taken care by cloud providers. And software as a service, SaaS, it simply means they will provide the entire software. Users will directly use the software over the internet. Okay, so the entire application, or you can say software, only provided over the internet. You need not to worry about anything. You just have to, as a user, you just have to use that software. You need not to manage about infrastructure here. You need not to worry about the servers. You need not to worry about the storage, updates, runtime environment, operating system, nothing. You just have to use the software here. And the good example could be Gmail or Zoom or Google Meet, right? Directly you're using the software. You're not worried about what is there behind the scene, what infrastructure is getting used, how it is scaling, how it is updating. You just have to, as a user, you're just using the software there. So simply, if I have to summarize infrastructure as a service, the infrastructure would be provided to you, but you have to manage everything. platform as a service, entire infrastructure alongside the management. They will take care. You just have to worry about your application code. Software as a service, they'll give you entire software itself. You just have to use that software. So if you are getting into the roles of DevOps engineer, cloud engineer, right, then you have to, or maybe you're getting into the roles of infrastructure, then you have to focus more on infrastructure as a code, IaaS. If you're a developer, then you can just focus on platform as a service. And if you're just a user, you can just go with maybe software as a service. I mean, you just have to use the software. You need not to worry about anything behind the scene which is happening. And we as a user, we are using so many softwares day in and day out. So we are the, clients for software as a service industry. We are just using so many softwares day in and day out, right? So I hope you could able to draw the conclusion here, and you could able to understand what exactly is IaaS and the platform as a service, software as a service, at least at the basic level. Now coming to the cloud computing, there are many cloud providers available in the market right now. Currently, the dominating one is AWS from Amazon. Then we have Azure from Microsoft, and we have GCP from the Google. Also Oracle, Alibaba, there are many other cloud providers which are emerging right now in the market. But most of the dominating cloud provider right now is AWS, and hence we are going with AWS in this entire series. Before we see anything practical, let's understand little more on AWS. Amazon Web Services, it started by Amazon in 2006. Initially, for their e-commerce business, they had built a huge infrastructure, and later on they realized, let's rent out this infrastructure to others also. Other companies can also use our infrastructure and they can pay us, right? That's where the AWS gave birth, and in 2006 it started. Currently, AWS has 200 plus services, right? And you need not to master all the 200 plus services to start working with AWS or to get into the role of cloud or DevOps. There are some important services which you have to focus on. The most important, first you have to know about the EC2, how to create the servers, how to work with it, the security group, right? The networking, load balancer, auto scaling group. This is very, very important about the volumes, snapshot. Then you have to understand about the databases, RDS, DynamoDB. Then you have to know about, very, very important, what you can create in AWS, how much authority you have, the IAM roles, policies, right? That is also very, very important. And apart from that, you should also know about the networking and the most important concept here, which is VPC, right? Subnet, Internet Gateway, NAT Gateway, Elastic IP. These things you should have a good hold on. And then you have to also know about services like Lambdas, S3 buckets. You should know how to create and how to work with the storages, right? And then the platform as a service, which is Elastic Beanstalk, that also you should be aware of. ECS, ECR, EKS, which is very, very important again for the Kubernetes, for the deployment purpose. There are many services available. And in this series, entire series, we are going to see most of the commonly used services which any DevOps or cloud engineer must know, right? Now, before we proceed further, I also would like to talk about the AWS global infrastructure. As you can see on your screen, AWS Cloud spans 123 availability zone across 39 geographical regions. Regions here, we can say Mumbai region, Hyderabad region, Frankfurt region. We have multiple regions across the globe. You can see in the North America, we have multiple regions. These are the regions there. And in the Middle East, we have these many regions. And you can see in the Asia Pacific, we have these many regions. And in India, we have Mumbai also, Hyderabad also. It is a geographical region where AWS has the data center, and every region has multiple, availability zones. It's like region you can consider as the whole city, and the zones you can consider buildings in that city. And every region has multiple zones. A zone is an isolated data center within that particular region. And because of the regions and availability zone, it reduces the latency and also improves the performance of your application. If your users are more dominating in India, then you can deploy your application within the Mumbai region. You can decide whatever infrastructure you're going to create. Where are you going to create? It is in the which region you have to also specify. You can see by default, once you create the AWS account, I'll also give you the navigation of that. You'll be given chance to choose the region where you're creating and working with the infrastructure there. going forward, anyway, you will be able to understand that, right? So totally we have 39 currently as when I'm recording this latest. Okay, in 2026 we have 39 geographical region, and we have 123 availability zone across the globe. Okay, which helps in improving the performance of your application and the low latency. Very, very important. Okay, and apart from this, we also have the edge locations here. You can see we have these many regions, and we also have the edge locations, which are smaller AWS locations, which helps in content delivery and caching. Services like faster website delivery, video streaming, CDN, right? All of this will be using in within the edge locations. It is for the caching and faster delivery of the application to the end users. Fine, we have multiple edge locations also available here, and many of the key components which AWS has, which made AWS to grow, and people across the globe right now are preferring AWS, is because initially they took very, very important steps there. Number one happens to be pay as you go model. How much ever you're using, you have to pay only for that. If you're not using any of the resources, then you need not to pay for it, right? So how much you're using, only pay for that. Rest of all, you should not pay. And also about the scalability, automatic scaling. If the traffic increases suddenly, then automatically number of servers also will be increased to improve the performance and to maintain your application. If there is no traffic, if the traffic declines, automatically number of servers also gets decreased. So you need not to pay unnecessarily. If it is getting used, pay. If it is not getting used, you need not to worry about the bills and payments. Similarly, it has many advantages with respect to security, networking, reliability, right? Global presence, global infrastructure. There are so many key points because of which AWS became one of the most popular and dominating cloud providers right now in the internet. Fine. So I hope you could able to understand something very basic about what is cloud computing and why are we going with AWS over the other. It has a huge market. It has 200 plus services, and it is very, very popular. Most companies prefer AWS for their infrastructure or deployment of their application. Now we may have to create an account in AWS and start working and understanding the components and all the services of AWS practically, for which we have to first create a free tier account. And how do we create a free tier account, you will see, and then one by one we will try to understand these services practically. How do we create a free tier account in AWS? For which you can open any of your favorite browser and search for AWS free tier account, and we have an option here. The first option, please do click on this. It will redirect to this page wherein we have an option here, create an account. Please click on this. Again, it will open a new tab wherein we have to enter few details, right? So now we have an option. I would like to enter few details here. First, I would like to enter the email ID. Okay, let me enter the email ID here. I have entered the email ID. I would like to give the username, right? And click on verify the email ID. It will send you the verification code on your email ID. Please do enter the verification code here. I have entered the verification code here. Sometimes it may go on your spams. Please do check that also. And now click on verify, right? And after which it will ask you to give you the password. Please give the password which you can recall. Let me enter my password here. I have entered the password here. Now continue to the next step. I have clicked here. Again, it will redirect to this page, and we have an option here. Go with the free or paid. You can go with the free. I would like to click on choose the free plan because we are creating a free tier account here, right? And now it will ask you to enter few details here. It is for the business or it is for the personal. I would like to click on personal, and it is asking me to enter my full name. Let me just enter here and fill all the details which it is asking. After you fill all this, you can just click on agree and continue the next step. Now it will ask you to enter the billing information wherein you have to enter either credit card or a debit card details. You need not to worry, auto deduction will not happen on the free tier account. So if by chance there is some bill and if you have not paid, account will be suspended. Auto deduction will not happen. So freely you can enter all the billing details. So let me enter here. After filling the debit or credit card option, we have an option here, save the card and charge automatically for the future payments. Please don't click that. Okay. You can scroll here and you have an option here. Do you have a PAN? Please click on yes, and you can enter the PAN number here, and you may have to upload the PDF of your PAN card that is needed. They'll not be using it for any of the financial deduction, but that is required for the billing. So let me add that here. All this detail is for the India. Based on the country of your stay, you can mention the details which is being asked while creating the account. Fine. Now I would like to click on verify and continue. And for the authentication of the billing information, it will deduct very small amount. If you are in India, it is 2 rupees, and similar if you are in some different regions which you can easily pay. So let me just enter the OTP and proceed further. I'll click on submit and I'll just close this. It will redirect to me a different page, and we have an option here, confirm your identity. I would like to just say here personal use, and ownership type, I would like to just go with the individual here. And based on the region of your stay, you may have to enter that region specific documents which is being asked, right? For India, it may ask PAN card and the other details here, and based on your country of stay, you can enter that particular details here. All this is for the formality. You can proceed ahead and fill all the required details in order to create this free tier account. After filling the required details, I'll click on continue. Now again, it will redirect to one more page wherein we have to verify our identity by entering the mobile phone. Based on your region of stay, you can enter. You can decide whether you want a text message or voice call. Okay, I would like to just go with the text message and enter my details. Now it is asking me to enter the code here. Let me just enter. I have entered the code. Let me click on continue here. All right. Now maybe we may have final step or the account will be created. Okay, so it has redirected to this page wherein we have got one message here. Congratulations, we are activating your account, which should take a few minutes. You will receive an email when this is complete, right? Once you receive the email, you can just click on this, and again we have an option of sign in to console, and we may have to sign in with the required details, right? Whatever details we have given, the email ID and password, same thing you may have to give and log in. You'll be able to see the dashboard which you can see on your screen, right? Now, how do we create an EC2 instance and how to create a Linux machine and use that for our purpose? We shall see going forward. Now, the account is successfully created. We can use this free tier account for our requirement. Now we have created the AWS account, and once you have created, you could be able to log in into your account, and you'll be getting AWS Management Console. There are some components on your screen which you can see, which is there in my dashboard, may not be able to see in your management console. Recently visited, because I have visited these many services recently. Cost usage, some of the paid services, even in the free tier account, not everything. You don't have access to all the services in free tier account. You have a limited access, whatever you can use with some limitations. AWS does not give you all 200 plus services and the complete access, do whatever you want. That's not the case here. In the free tier account, you will have a limited. Okay, there are some services if you use, if you cross the limit, free tier limit, that could be charged, but AWS also gives you $100 limit within the starting 3 months. If you use some of the services, if you explore some of the services, you can see here, explore AWS. As and when you explore those services, those many credits will be added into your account. Even if there is some bill, automatically that will be taken from the free credits given to you. Okay, so if you play around safely, it will never cross the $100 free credits you may get. So you will be within your limits. But you have to make sure one thing here in the AWS, that you will not be creating the resources and forgetting. That you should never do it. Okay, you have to be very careful, and always you have to monitor some of the dashboards. You can see here, we have an option here, go to billing and cost management. On your screen, if you are not able to see, here also you can just search in the search bar. You can say billing and cost. You can see billing conductor, we have billing and cost management. You can just click onto this. And often whenever you're playing around and working with the services, make sure first of all, when you create any of the service for your practice purpose, delete after your demo is done. That you have to do then and there itself. Don't carry that maybe later I will delete. That may cause problem and bills might be generated and you will be in the trouble, right? So you have to see this particular dashboard here and there, and you have to understand what is the billing. Okay, and also we have an option here, cost monitor. Very, very important if you are experimenting with AWS for the first time. We have an option of setup required. You just click on this, and if you click into this, you have an option. I'll go with the existing template. zero spend budget. Even if you spend a slightly, maybe 10 rupees or maybe $0.01 also, you'll be getting the mail. If not, you can just set your monthly cost. It should not cross. Maybe I could able to afford not $100, of course. I'll go with maybe $1. Okay. If $1 excess in the entire month, I should be getting the mail. I'll be just entering the mail IDs here. I have entered the mail ID and I'll just click on create the budget here. Okay, budget will be created and I'll be getting the mail if it cross $1 also. You'll be notified. Please keep checking your mail and set your budget. It's not compulsory though. In the free tier account, you'll be getting $100 if you're not using fully, and if you are not going to use randomly without deleting these services. Once you're using something, you may have to make sure that you are deleting it, right? And after which you have here search button. It is a place where you may have to search for the services which you are going to use here. Okay, whichever you want, EC2, S3 buckets, you want to create a database, you want to create the access management with the IAM, you want to work with the Lambda, you have to just search here. Example EC2. See here, you'll be able to search here. AWS supports 200 plus services. So if you want to use this, you just have to go here and search. And it is recommended the services which you may use often, you can just bookmark. It will be available in your AWS management console. Easily you can navigate. You need not to search every time. Example for EC2, I have bookmark. Maybe VPC, something you have to deal with. You may have to create a network. You may have to work with the networks often. You just bookmark here. And maybe whatever the services you may create often, right? So example, I may go with the S3 buckets. Often I may create. Okay, you just bookmark here. And IAM, maybe I'll go back here and say IAM, and you can see management access. What exactly is IAM? What is EC2? Everything we will understand in this entire series. You need not to worry. I'll just bookmark here. Fine. And you can see it is available right now on your screen, top left. You need not to search them. You just have to click whenever you want to create an instance, whenever you want to work with networking, whenever you want to create some roles or users, you may have to go with it. What is roles? What is users? Everything we will discuss. I'll expect you have no prerequisite for this entire series about the AWS. Okay, so you need not to worry on this. All the common services you can bookmark. That's what I'm trying to say here. And whenever you visit any of the service, recently visited service will be available here. And this is your generic AWS management console. This is very, very important, and anything you want, you just have to search here, right? And one more reminder, again, I would like to highlight here is whenever you're practicing any of the services, then and there itself, please delete after your demo is over, after your practice is over, right? Don't take that lightly and don't carry that forward for the future that I may delete in the future. Don't do that. It may cause unwanted bills and you may have to face the issues. Fine. So now let's get started and understand AWS services one by one. Now we need to understand one more very important concept here, which is about identity and access management, IAM. Once you have created the account, you have logged into the account as the root user, but in the real world, we will not be logging to the account as a root user, because in every company, there will be multiple teams. There will be development team, testing team, cloud team, DevOps team, right? So all of them, will they get the same root credentials using which they can all log in and can do whatever they want? The answer is no. The root credentials, the one who created the account, that credentials, that particular user will have the complete access to the AWS. All the 200 plus AWS services they can access. They can do whatever they want. They can create, they can modify, they can update, they can delete, and they can do anything in this entire account, and that is not secure. We cannot give access to the whole AWS to the entire team of developers, testers, DevOps engineers, cloud engineers, and allow them to use and do whatever they want. That may not work here, right? So here is where we use one concept called as identity and access management. Before I show this, I would like to also highlight here, once you logged into the account, make sure you are in the region which is near to you. If you're watching from the USA or Canada, you have to select your region. And if you're from the India, maybe Hyderabad or Mumbai region. Since I'm recording from India, the nearest region for me is Mumbai. And most of the services here are regional basis. You may have to create based on your region. That will be created exactly in that particular region and data center here, right? And one more point is that for the root account, you have to also enable multi-factor authentication. That is very, very important. Even otherwise, after a few days of you creating the account, AWS will force you to enable the multi-factor authentication for the root user, because that should be accessed securely to increase the security, or you can say to enhance the security. You can go at the top right, and we do have an option of security credentials here. If you click into the security credentials, see here, we will be having an option here, multi-factor authentication. Right now, I have already enabled, right? So two ways you can do, either from the keyboard where you're using the laptop, where you're going to often use this account, there only with the keyboard key, you can do this. If not, you can assign a MFA device in your mobile phone. You can download Google Authenticator application. And if you just click on assign, how you would like to assign pass keys and security key from the keyboard itself, but you'll not be able to log into that account often from different laptops or different machines. If you want to log into this AWS account as a root user from different devices, then you have to better go with the Authenticator app. You can see here Authenticator app. You can download the Google Authenticator app in your phone, and you can just configure. Very easy steps here. Next. If not, you can just also go with the pass and security key. It's not too difficult. With just next step, you'll be able to do it, right? And if I have to get back here, you have to just go here and search IAM. Anyway, I have bookmarked like the way I have shown in the last video. If not, you can search for IAM and manage access to AWS resources. The moment you click on this, see here, you'll be able to redirect to this. We have multiple options here: roles, policies, IAM users, group. One by one, we will try to understand as and when needed. But to start with, I'll be creating some of the users here. So what exactly happens in the companies is that for every user, you'll be given a user credentials. For that particular user, different login credentials will be created. And also there will be limitation that particular user, how much they can access the AWS. Example, for development team, maybe there is no need to see about the building. They just want to see about EC2. They just want to access EC2 resource out of all the resources. So we'll be creating the user, and we will assign, or we will set the policy that this particular user can use only EC2. Apart from EC2, if that user logs into the account, he'll not be able to do anything. Fine. Or maybe tester. Maybe in that case, you don't want to give access to VPC or some of the services for the test engineer. Then you'll be given a limited access to the entire AWS account here, right? So I'll just go to the IAM user here. Let's create one user. We'll be creating multiple users. We can create the group also. We will see going forward. But to start with, just to show you a basic demo, I'll say here, create the user. User name, it is asking, I'll give it as maybe dev1. That's the username I would like to give here. Provide user access to AWS management console. It is optional, because in the AWS, you can create or manage the infrastructure with multiple ways. You can go with CloudFormation. You can go with AWS CLI, which is often used in the real world scenario. You can also go with Terraform. Multiple ways are there to manage the infrastructure on the cloud. This is management console is not just the one way here. Okay. So dev1, provide user access to AWS. I will allow him to access this. Okay. Do you want to generate the password or custom password? I'll go with the custom password, and it has some requirement. Based on the requirement, I'll add the password. Let me add this. I have added the password, and also here there is an option. User must create a new password and next sign in is recommended. What exactly this means? As a root user, I'm creating one more user, and I'll give a default password. I'll ask him that this is your credentials to the AWS account. My developer will log in, and he will have an option to change the password when it is required. So user must means it is compulsory for the user, whoever is going to log into the account based on the credentials I'll share. They may have to change their password. Of course, you should not be giving a common password for all the users, right? Everyone can log in and play around. Then the blame go for a particular user if something happens there. Using this, you can also monitor and enhance the security that what a particular user can do with this AWS account. So I'll give the option here wherein users must create a new password in the next sign in. I don't want to do that. If you want, you can do this. This is a good practice that usually we give because we are going to share this with different team members, right? Maybe we have 5 members in the development team. I'll create 5 different users and I'll give them the credentials. Once they log in, they should have an option to change the password based on their preferences. Okay, it should be must. Anyway, I'll just go with the next and I'll go back here. We have an option to add the user to the existing, group. copy the permissions, attach policies directly. Attach policies in the sense what this particular user can do with the AWS account. Policies here referring to permissions, what this particular user can do with this AWS account, how much permissions, how much authority this particular user has on this AWS account. And we can group multiple user into one group and give permissions at once, policies at once, right? Maybe the entire development team should have an access to S3 buckets, RDS, DynamoDB, and also EC2, complete access, right? And testing team should have access for something else. DevOps team should have a administrator access. So if there are different team members, multiple team members, instead of giving the permissions one by one, example, 5 members are there in the development team, then 5 users, I'm giving the permissions one by one. It will be very difficult, right? So we can group multiple users, okay? And at a time, we can give the permissions for this particular group. For all the 5 users in that group will have the same permissions, right? So right now, I'll not be creating the group. I would like to go and say attach the policies directly. What permissions? I'll go back and say EC2, okay? So EC2, if you say, we have multiple specific access also you can give here. You can see very specific also, very minute to minute, that in EC2 also they can just do with this, right? So I'll give here EC2 full access. This particular dev one user will have a complete access to EC2, and that to only EC2 I'll give here, nothing else apart from it, okay? And I'll say next, and I would like to say create the user. I could able to create the user, okay? And this is the sign in dashboard which you can use it, and dev name and the password also, okay? That has been created. Okay, now I'll go back to AWS console. Right now, I am logged in as a root user. I have a complete privilege. I can do whatever I can. I'll just say here S3 maybe. I'll just click on S3. I can create the S3 buckets. I can do anything I want in the entire AWS account because I have logged into the account as the root user, right? Now we can see here, we have an option. There are some default S3 buckets which are already running here. Okay, I'll just say here create S3 bucket. I have an option. Okay, I just wanted to show you this. What is S3 bucket? We will see. What is EC2? We will understand. EC2 is one of the important service to create the servers, to manage the servers, right? So what exactly that is, we will see in this entire series. I'm just talking about the permissions. What happens in the real world? Once you go to the company, you will not be given access to the entire AWS account like the way you have got right now. You are creating the account, you got the complete access. That's not the case in the real world. You have a limited access. Now I have created the user, I have created the password. I could able to recall that. I'll go back here and I will just, sign out from my account. Okay, I'll just say here sign out. I have signed out. Again, I'll click on sign in, and you can see the moment you sign in, we have multiple options here available. We can see here account ID you have to specify. That is very, very important part. Account ID I have not copied. I may have to log in again as a root user and also copy the account ID. Let me do that. Again, I have logged in as the root user, and you can see here we have an account ID here. This account ID is very, very important. You may have your own account ID. You just have to copy that account ID. And again, I'll just log out once again, and I'll just get back. I'll say sign in. All right. And you can see you have a dashboard here, IAM user sign in. If you want to log in as a root user, then you have to go with sign in using the root user email ID. That is the owner of this entire AWS account. But this time, I would like to mention the account ID. The user which we have created is dev1, and the password I could able to recall for dev1. Let me add the password here. I could able to add, and now I'll click sign in. You can see here I could able to sign in as the dev user. And unlike for the root user, I had the complete access, right? The cost, usage, recently visited, everything. But do you have a same access right now for the dev1? No, dev1 has an access only for EC2. If I go and search here S3, I can search that. But if I click here, you can see I can just see this. But can I create? Do we have an option here? It is disabled. You can see it. If I click on create the bucket, you'll not be able to create. Even if you mention this and if you just click on create the bucket, you'll have an error. Okay, maybe I'll just give an example for you. Some name I'll give. Okay, random name. Bucket name should be globally unique, which you'll understand eventually. If I just click on create the bucket, I'll be getting the error. You can see here, failed to create the bucket because you don't have permission. Create bucket permission is required. And for dev1 user, I have only EC2 access. It cannot do anything apart from the EC2. But if I go to the EC2, whatever you want, you can do it. I just click on EC2. It is a way to create the instances, servers. which very soon you'll be able to understand. But you can do whatever you want with the EC2. I have given the access to the complete EC2. You can see all the services. You can click on launch the instance. You can launch the instance and do whatever you want, but not apart from the EC2. I hope you could able to understand this, right? So everyone who's getting into the AWS, you'll be given IAM user and password, and that too your manager may set restrictions for your account. You may not have access to the entire AWS services. You have a limited access. With those limited access only you can work in your company. It is there to enhance the security and to make sure that people in my company, there are so many developers, so many testers, we have so many DevOps engineers, cloud engineers, everyone, if you give entire access and root credentials, they will do whatever they want, and by mistake or intentionally they may delete some of the important resources also, and you don't want that to happen. You want to track that particular user has how much access and what they are doing with their account. And this is possible with the help of identity and access management. I hope you could able to see this. I'll just log out again, and you can see here by default it is choosing Europe or Stockholm, but you have to make sure that you are in the region which is nearest to you. It is very, very recommended. Right now Mumbai is nearest to me. I'm not in Mumbai. So, but you can see here we have a nearest region, and make sure that you create the resources which is near to you, or if not, if your manager or tech lead is asking, you may have to go with it. Okay. So I'll just log out again here, and I'll log in as the root user once again. But this time I'm going to log in as the root user, and root user will have multiple access. I'll just click on sign in with the root user. Great. And I'll just give my email ID. I have added the password here, and again you can see multi-factor authentication code. I have enabled MFA for my root user. Okay. I'll be entering the code here. I could able to sign in with my code. Now I have the entire access back. Okay. Again, if I just get into IAM, we have created the users here. But if you want, you can create groups also, which we may have to understand going forward. I hope at least fundamentally you have understood what exactly is identity and access management all about. Now we understood the basics of IAM, and we also understood how IAM user is different from the root user with respect to the privileges and the permissions, right? Now imagine a company where we have 100 developers, or maybe 50 testers, 50 DevOps engineers, 50 cloud engineers, right? So there is a big team here. Now, if you want to give access to the AWS to everyone, you'll be giving the permissions, the policies one by one. Will you assign that this particular user will have this much permission? Again, this user will have this permission. Will you be able to add the policies one by one, one by one? Then it will be a time consuming process. You'll not be doing this. We have a concept of IAM group, right? So if you just click on to the IAM user groups, it is like a group of IAM users, or you can say multiple IAM users grouped as one. Maybe entire development team, I'll group it because entire development team will have a same access, same privileges, same policies. Okay. So now we don't have any group as of now. You have an option of create a group. So it is asking me to give a name of a group. Maybe I'll give it as a dev team, right? And then in that group, do you want to add any user? You can add if there are. Last we have seen recently that we had created one dev1 user. I would like to add it. You can add later also. It's not compulsory that first you have to create the users, then you have to add. Group can be created without users, and at later stage you can add users into this particular group. So dev team, already we have a user I have given, and we have very, very important part here, attach permission policies. It is talking about the IAM policies. What privileges, how much this particular user or group have permissions and authority over the entire AWS account, what they can do with it. Okay. So we have to add the policies. We have predefined policies. You can see here, we have a number here. More than this predefined policies are there. If you want, you can create your own policies also. You can customize also. Now I would like to choose from the predefined policies which are already available here. For the entire development team, I want to give EC2 a complete access. You can see full access. You can be very specific also. And I want to also give access with respect to RDS. Okay. You can see here. Amazon RDS data full access, Amazon RDS full access. I would like to give this Amazon access, RDS full access, and whatever policies you want, you can give. Policies here referring to the permissions. This particular group, the members of this group, what they can do with AWS account. Okay. So I have added this, and I would just create the user group. within no time the user group will be created. You can see we have one dev team here. If you want, you can create one more team just for the demo. I'll just go back here and maybe I'll give it as DevOps team. Okay, that's the name I would like to give. And maybe DevOps team, I would like to give the entire access. If you want to give the entire access or maximum access, you can go with the administrator access. Administrator access, it is like equivalent to having the root user access. They can do many things with this particular account. Okay, so if I just click on this, the entire DevOps team will be able to do so many things here, not just one or two. Or you can be very specific what they can access. You can also specify maybe entire VPC access with respect to networking, EC2, S3, how much ever, it's up to you. I would like to go with the administrator, and right now I'm not going to add anything because we have not created any user for the DevOps team. I would like to just go back here and create. We have created two teams here, right? So we have a policy here. Policies, it's all about the permissions only, what they can do. You can see here, it is in the JSON format. If you want to read some of the policies, you can just click on this. It will be in the form of JSON. You can see here, if I have to wait for a minute, it is loading. You can see it is loaded. For admin, we have multiple options. All allow 469 services for this particular administrator access, in the sense it is equivalent to the root user access. Admin access I have given to DevOps team. Now DevOps team can do anything in the entire AWS, which is not recommended. You can give the admin access for the individuals, maybe not for the entire team. Okay, so you have to be very careful about this. See, entity attached permissions, you can see here, policy version. So these many permissions we have. So if you just again click on to this, we have an option of create a policy. You can custom create the policy. Instead, you can custom create the permissions. You have your own personal requirement that for the specific things a particular team can access. You don't want to go with the predefined options which are already available. You can create your own permissions here. You can set your own policies. You can see the service here. You can see I would like to maybe, for example, go with EC2, right? In the EC2 also, what actions are allowed, you can specify. Okay, allow all the EC2 actions, which by default it is there. It's equivalent to EC2 full access, and you can be very specific. Maybe I want to give all the list actions in the EC2, and coming to the read access, all the read access, like whatever you want, you can specify. With this, what I'm trying to say is you can also create your custom permissions, custom policies. Okay, so I would just keep this many just for the demo purpose. I have given certain policies here, and I'll say here next. And you can see here, no resource are specified. Please specify the selected one. Okay, and it is because some of the services I have selected which has some dependency on the other services. Okay, that's the reason on this. So if I have selected some services, it has a dependency on the other services. That is the reason here, right? With this, what I'm trying to say is you can customize and create your own policies. Policies here are the permissions, right? So I'll say here maybe all EC2 actions, they are allowed. Whatever you want, you can just create it, and you can see it is there in the JSON format. It is visual because we are going with the management console. You can see JSON also available. Fine. What actions they can do, that also you may have to specify. Again, if I have to go to the policies, either you can create your own policy. I mean, the create or use the existing policy. Okay, choose the service, whichever service you want, whichever you want, maybe EC2. And in EC2 also, what actions you would like to perform. Example, I'll say here maybe security. See, maybe I would have just given delete the security group, create the security group, what actions they can perform, read the security group. You can choose and you can create your custom policies also based on your requirement. Okay, or you can just select the existing. We have these many policies, permissions available, which you can attach to a particular user or group of users, that this particular set of users can do these many things in the entire AWS account. Okay, apart from that, they cannot do. Policies is all about permissions. And we have one more important part here, which is about the roles. It is like giving the temporary permission to a particular resource. If I have to directly talk on to the realistic approach, suppose we have created one EC2 instance. Right now we have not done. Very soon we are going to start with the very important topic of this entire AWS series, which is EC2. Already I may have some instances which I have used for some of the purposes. You can see here instances. We will see how to create the instance. It is like server. It's like buying a computer on the cloud. Okay. I would like to just click on to this, and we have an option of action here. Okay. We have an option of security here and modify IAM role. If I attach any role here, maybe EKS role, in this role I have added some permission. So if the moment I do this, okay, right now no roles are there, but the moment you update this,
What exactly happens? I have not specified any rule. This particular EC2 instance will have that many things to work with. Example, for this instance, I want to give access to the Kubernetes cluster. So it's not good that to save the password and users the credentials of Kubernetes cluster into this instance. That's not secure. So we have an option wherein temporarily we can set the permission. So if you want this particular instance from this particular machine instance, if you want to allow access to Kubernetes cluster, then you can create the IAM role, attaching the temporary policies to that particular role, and that role I am attaching to this particular machine, which will enable this machine to access the EKS cluster, the Kubernetes cluster. And from this particular machine EC2 instance, you can consider right now, since we have not yet talked about EC2 instance, as a laptop, maybe a computer you have got on the internet, right? So from this particular machine, I should have an access to S3 bucket. Maybe I should have an access to RDS or some database. What to do? You have to go back to your IAM. In the IAM, you have to create a role. Okay. I can see here we have an option of creating the role. Very important it is. I'll say create a role, and which AWS service, what is the use case? You have to specify the use case. For EC2, I'm going to use this particular role, EC2 instance, one machine. So that machine should have what permission? Maybe I'll go with EKS. Okay, the Elastic Kubernetes Service. Okay, I'll just go with the Amazon EKS service policy, whatever you want. Worker node policy, right? Networking policy, load balancing policy, CNI policy, which are the important, cluster policy, whatever you want you can access. If not, you can give the full cluster access also. I have given some permissions, some policies I have attached just to give you a demo, very basic demo at the beginning level. Okay, I'll give the role name here as the new EKS role. Okay, and the role has been created, and this role, if you attach to a particular resource, particular instance, from that instance these many things you can access, right? So I have an EC2 instance. From there, I want to access Kubernetes cluster. How do we access? By default, permission will not be there. So for which you have to create a role. In that role, you have to attach the permission, and that particular role you have to attach to EC2 instance. Example, right now we have created the role, right? Here we have added some permissions. So I want that permissions to be available here. So I'll go back to my instances. How to create the instance, we shall see very soon. You need not worry on this. Okay, just to, when I'm talking about the roles, I want to give a realistic approach directly. So I'll just go back here and click on actions. We have security. I'll just say modify IAM role, and which role? EKS new role, for example. I'll update this IAM role. The moment I updated, whatever permissions we have added inside that particular role, from this machine, all of them can access, right? The permissions which I've added related to Kubernetes cluster. So from this machine, I can work with Kubernetes cluster. That's all it means. I hope you could able to understand. After practice, make sure, very important part, that whatever you have created which you are not using, adding the users, creating the users in groups will not be charged. So apart from that, if there are anything, please make sure a habit or practice that if you're creating any resources for the demo and practice, please delete that after the practice is over. Fine. So now I hope you could able to understand the fundamentals of identity and access management. It is a way to define who can access what. If you want a particular resource to access one more resource, then IAM roles comes into picture. IAM policy is all about the permissions, what all things you can do with AWS, right? So IAM users, individual users who can log into the AWS account with the limited access. And for that particular users, how to set the rules, we have to go with the concept of policies. Adding the policies in the sense, adding the permissions, what that user can do. And these permissions and policies can be added to the group of users also with the help of IAM group, right? So bottom line, what I'm trying to say is that whenever you work with the AWS, you may not always work with the root user like the way we are working right now. Okay, we have created the account, we have complete access. But once you get into the company, you will have a IAM ID, IAM password, you will be logged in, and you'll be having a limited access based on your role in that particular project and in that particular company. And you'll be able to do only that much. You will not have complete access. I hope you could able to understand this, particular important concept here. Fine. Now you have understood identity and access management, the IAM users, groups, policies, IAM roles. And in fact, if you search on the internet about the AWS IAM, you'll see so many tutorials on the users, roles, or maybe the policies, right? But if you enter the real tech world, you'll see nobody is manually creating the IAM user in the production account for every employee. that will become a massive security risk, right? So in the real world, AWS access works differently. And I would like to give you some insights that how exactly a big enterprise companies manages the AWS access in production. That is very important. We may have to understand that, and I would like to just give you some insights before we proceed further. First important thing we have to understand is that in the real world, we do not keep everything inside one AWS account. We use something called as AWS organizations. In AWS organization, we then create multiple accounts: development team account, testing account, production account, security account, staging account. Why? Because production is highly sensitive. Developers should not accidentally delete the servers or maybe change some billing or configuration settings or access the customer data. To avoid this, we create multiple AWS accounts within AWS organizations. And on top of all this, enterprise companies usually apply something called SCPs, service control policies. Think of SCPs are organizational level, the guard rails. They define what AWS account, or maybe you can say what AWS account should never allowed to do. So even if someone has an admin access in the development account, an SCP can still block actions like maybe launching a resources outside a particular region. You are allowed to launch any of the resources only in the Mumbai region. So SCP can help you to restrict to launch a resource outside the Mumbai region. Or maybe an admin access. Someone who has an admin access in the development team is trying to delete the security policies, right? So an SCP can block such actions, right? Because SCP works at the organization level. And since they work at the AWS organization level, they override the account level permission, which makes them extremely powerful for the AWS security, enterprise security governance. Now comes the important question. If developer needs to access the development team account or maybe testing team or sometimes the production logs, will company share a separate AWS password for every account? Absolutely not. That will become very difficult to manage and it is extremely insecure. So in the real company, once you get into, usually employees do not log in with a separate AWS username and password. Instead, companies connect AWS with their corporate identity systems like Okta, Azure AD, or you can say Google Workspace through AWS IAM Identity Center, or you can say AWS SSO. And think of AWS Identity Center as the central access portal for AWS. It decides which employee can access the AWS, which AWS account they can open, and which IAM roles they can assume, and what permission they receive. All of that will be managed with the central access portal, which you can call it as IAM Identity Center. But also you have to understand one more important point is that the AWS IAM Identity Center itself is not actually the authentication, system. In many companies, authentication happens through their company's identity provider. It could be the Okta, or you can say the Google Workspace, Azure AD, right? Through them, they will be doing the authentication and they'll verify that this particular user can access the AWS. So what exactly happens here is when an employee enter the email address, password, and do the multi-factor authentication, right? Then the AWS redirects the login to the systems like Okta, the Google Workspace, and the identity provider will verify that this particular employee is still part of the company. Can he access the account, right? Should this employee still have the access and is still this employee is a part of a company or not? And this becomes very, very useful because when an employee leaves the companies, the security team can centrally disable the access through the identity providers. Centrally, we can disable that particular employee. And since we are doing the authentication through the identity provider, so once from the identity provider itself, the access has been disabled, then the definitely authentication will not happen. And that particular employee who has left will not have access to the AWS account. So here identity provider handles the authentication and AWS IAM Identity Center handles the, or you can say manage the AWS access management. And one more thing which you have to understand here is that many startups may not use the external identity provider. In that case, we go with the AWS Identity IAM Identity Center itself. But in the larger companies, most of the enterprise companies, the third, or you can say external identity provider are very common use case. And that is what we will be integrating that for the authentication, which may not be the case in the startups, and there we directly go with the AWS Identity Center. And after the employee is finally successfully able to log in, then AWS will decide this particular employee can access which AWS account and which IAM role they can assume, and what permission they have. And also very important point here is that most of the companies, most of the organization, multi-factor authentication MFA is mandatory, and will be able to log in to your AWS access only through multi-factor authentication, not just with the username and password, or even through the identity providers. So once you are able to log in, then AWS will decide which of the AWS account you can access and what permission you have with that particular account. And here is where the IAM roles plays very, very important role, right? Most of the modern cloud environments, usually companies avoids to give you the permanent AWS credentials that is not fully secure. Instead, employees assumes role here. We have discussed about the role in the previous video. It is like the temporary access or what actions you can perform on a particular AWS account, right? So maybe if you are a developer, you may have a development role in the development account. You may have maybe only read only access or read only role in the production account. Think of it like a temporary security badge which is given to you. It's like you request for the access and AWS verifies your identity, and then AWS gives you a temporary badge, a security badge, and that could be maybe you can use for 1 hour, and after 1 hour automatically that particular badge will be expired. And also this is one of the big security advantage, right? So if even if the credential leaks, after sometimes it is expire and they become useless, and there is no way you can access because the security badge you had got was a temporary, and after certain period that has got expired and it is now useless, and it is very, very big security advantage here. And also in many companies, production access is heavily restricted. If you want to access, you need your manager approval, security team approval, and also you will have a limited access. Then the token, then access may get expired, and every action will be monitored. The security team will monitor that who has logged in, which roles they have assumed, what actions they have performed, which APIs call they have made. Okay, all of that will be monitored heavily in the production account, and it's not easy to get access to everyone because it is very, very important. By mistake also, none of the real resources which are there in the production account should be deleted or maybe modified, which may create more problem going forward, right? So because of it, the security team will heavily monitor and audit each and every action which we are performing in the production. And also the IAM roles is not just for the humans, like the way we have seen in the previous videos. If there is some maybe Spring Boot application inside the EC2 instance, if that has to access to the RDS database, then there also we can attach the IAM roles. Like the way I have shown in the previous video, I had created the IAM role and went to the EC2 instance. There in the security, I had added the role, but that means that EC2 instance now can access the RDS, or maybe that EC2 instance can now access the Kubernetes cluster. So it is not just for humans to have a temporary access to the account. It is also for some of the resources to access one more resource. I hope you could able to get this. And also I'd like to highlight one more important point is that usually in most of the tutorials you will see whenever application configuration file is there, right? Maybe in case of Spring Boot, the .yaml file or application.yaml or application.properties file for the Spring Boot case, or maybe YAML file for some other application configuration. Usually we hard code the AWS security keys there. That is a huge security risk, and usually we don't do that in the real world. Instead, again, there also IAM roles will be attached to the EC2 instance, Kubernetes service account, right? Automatically your application will receive the temporary credentials which is required securely internally. So here also with the help of IAM roles you can manage, and you need not to hard code all the access keys directly in the application.properties file or maybe application.yaml file, the actual application configuration file where you usually write the DB configuration server information, right? There we should not hard code the AWS access keys. That also could be managed with the help of IAM roles, and that IAM roles, once you attach to Lambda function or maybe the EC2 instance, internally application will receive that temporary credentials which it requires to run the application. I hope now you could able to understand that in the real world how exactly AWS work on the scale. Now we need to understand one of the most important service in AWS, which is EC2, Elastic Compute Cloud, the most important. And if you say you are learning AWS or you are getting into the world of DevOps, EC2 is one of the must service. It is a way to get, or you can say create a servers on the cloud. Suppose you want to host an application, you want to maybe run some APIs, you want to install Jenkins, you want to create a Docker container, or maybe you want to create, a Kubernetes cluster. Where we will be doing this? We will be creating an EC2 instance. We'll be creating a server on the cloud. And if you want to create a server on the cloud, then you have to go with this EC2 service. The most important, it's like buying a computer on AWS data center, right? Maybe you have a laptop, you have a physical device, you have a physical machine in front of you. You can do whatever you want. If you want that machine on the internet, over the internet you want to buy, then you have to go with this EC2 server. And once you buy whatever you want, you can do inside the server. Maybe you want to create a Jenkins server, Docker server, maybe Linux machine, which you might have seen to practice the Linux commands, right? So you have to first go here and search for EC2. And since it is one of the most important service, you just have to bookmark so that very often you can visit it. Okay, the moment you bookmark, it will be available on the top left corner. You just have to click on to this, right? And the moment you click onto this, you'll be getting this option, Amazon Elastic Compute Cloud. Elastic here meaning it can scale up, scale down. You'll be seeing that in the auto scaling part. Create, manage and monitor virtual servers in the cloud. EC2 instance, server, virtual machine, all of them are referring to same only. Create a server on AWS, create a virtual machine on AWS, or maybe you can say create a EC2 instance. All of them are referring to same thing. Okay, and you can see here we can create 600 types of instances with the choice of latest processors, storage, networking, operating system, and the purchase model to help you best match the needs of your workload. You will have freedom to choose the configuration you want here. Okay, so the moment you click on launch an instance, you'll be given this option. I would like to click on launch without a walkthrough, and then you'll have an option to give a name to your instance. Maybe I'll give the name to my instance as anything you want. Maybe I'll say Linux server. Whatever name you want, you can give. So that shouldn't be a matter of concern. And the second part is the Amazon Machine Image, AMI. It decides which operating system you'd like to go with, right? Some of the configurations are there. Mac, then we have Ubuntu, Windows, Red Hat. We have multiple. You can click on browse more AMIs. Okay, so many AMIs are available in the marketplace. You can see here community AMIs are 500 plus which are there. Quick start AMIs 45 are there, right? So whichever you want, you can choose. You can decide. I would like to just go back here with the default options which I have. I would like to click or maybe decide among them, right? So we have an option here. So I would like to maybe go with Amazon Linux this time, just for the demo purpose. Okay, Amazon Linux. And then we have an option here, instance type, T3.micro. It decides about the CPU, performance, RAM, memory. Okay, you can see here, free tier eligible. For a free tier account, you'll have multiple options available. Okay, even flex large also we have an option here, 2 CPUs, 8 GB memory, right? And we have other configurations also which are not enabled by default for free tier account. So we have multiple options here. The configuration basically, how much CPU, what should be the performance of your server which you're creating, you can decide. So I would like to go with the default which we have right now, T3.micro. It could be T2.micro also based on the region which you are creating here. Okay, I would like to click this. We can see right now I'm in the Mumbai region. You can decide which region you want to create. Since Mumbai is nearest to me, I would like to create in the Mumbai region. After which comes one more important part here, key pair login, right? So we don't have an option to log into the server which you are creating with the help of username and password. We have to go with this key pair, a security key, right? And this security key can be created separately also. First only you can create and keep it ready, and then you can just decide which one you'd like to go with. See, we have so many key pairs here. Okay, these key pairs earlier I had created. I can just choose among them, or you can create at the time of launching an instance. Both options you have. Separately, you can create a key pair, a security key, which is required to get connected to the server which you are creating. I'm creating a Linux server, right? It's like buying your Linux laptop on the internet, on the AWS. Okay. So I'm creating a Linux machine there. And to get connected to that Linux machine, you need terminal. From the terminal, this is what required. You have to upload your key pair in order to log into the AWS account which you are going to create. And this could be created maybe independently first itself and you can use it, or you can just create a new also. I would like to go with the new. I'll say here maybe demo key. Okay, demo key is the name I have given. .pem. It will be available the moment you click on create. It will be available in your downloads. Okay. And once it is done, we do have an option of a security group. Other options are also there with respect to VPC. It is going with the default network subnets. Right now, you need not to know about it. Going forward, once you understand AWS networking, VPC, subnets, internet gateway, NAT gateway, elastic IPs, by default, you'll be in a position to understand. For now, you can ignore it. Okay. Go with the default network which we have. See here, we have an option of firewall security group. It decides whatever instance you're creating, who can get into this instance from this machine which you're creating, right? The virtual machine, what you can do, the outgoing traffic, the incoming traffic, you can decide. And security group also, first only you can keep it ready. You can create n number of security groups you want, okay, separately, and you can just select the existing security group option, right? If I just, go with select the existing, since I have created so many, for my account, I have so many options here. Okay, so many options are available for me. You may not be able to see that because I had created so many security groups. You can decide their inbound and outbound, and you can just select it here. Maybe you can decide 3-4 security groups with the rules of traffic incoming and outgoing, and then you can just select it here, or you can just create at the time of launching an instance also. Okay. And right now allow SSH traffic from, because if you want to log in into this instance using this key pair which you have created, it must be tick mark. SSH traffic must be allowed. Make sure it is tick mark. Okay. Remaining traffic you can configure later also. Once the security group is created, instance is created. If you want to enable some other traffic, incoming traffic to your instance, you can edit this, all the incoming and outgoing traffic. So there is no problem there. But make sure that at the time of creating, you allow the SSH traffic. It is very, very important. Right. Now, then we have an option of storage. By default, for the Linux machine, it is giving 8 GB. Okay. And you can decide, you can increase also. For me, 8 GB of storage is more than sufficient at this position. All right. And number of instance, only one instance I need. The moment you click on launch the instance will be launched within no time. Okay. You can say instance ID. Here also you can select, or else you can go to the instances and you can see we have one instance here. Running instance. Right now we have one running instance. Maybe name is not there. You can just give a name. No problem. Okay. Linux server is a name I would like to give. Any name you want. See, right now it is currently running. If you want to get connected to this, I'll say here connect. And we do have an option of SSH client. You have to click on to this. And first we have to give the permission. In the Linux, you might have learned about the permissions. Read permission for this security key you have to give, and then you have to do it. So now what you have to do is, you have downloaded the key pair, right? Maybe keep it in a folder. I have kept in a folder called as key pair sections, okay, which I'll be showing you. You can see here, I have so many other key pairs because I had created so many instances. I have used this account for multiple purposes. You can see we have demo key pair. Wherever this key pair is there, right, from that particular path, open the terminal, whichever terminal you want. I would like to go with the git bash terminal, okay. Which will be easy. And once you open the git bash terminal, okay, I have opened it. You can see here, I just have to add this, okay, the read permission we have here, right, to the terminal. You have to paste. You have to allow it to read this key pair, security key, right? I have pasted it, done. And once it is done, you just have to go back here, and we have this SSH example here. You just have to copy this, okay, and again you just paste it. All right. And you can see here, it is asking you some permissions. Okay, let me add it, or else I'll just again go back here. And again, I would like to just refresh this. Anything is fine. You'll be getting this key. All right. I would like to copy this once again, and you just have to paste it. Maybe it is taking some time, but you'll be in a position to do it. You can see we are getting this error. Let me just check again. You can see here, we are getting this pop-up also. You may not be able to connect to this instance. Maybe by mistake that SSH connection I had disabled. What to do now? You just go to the instance which you have here, okay, and we do have an option of security. You can see we have a security groups here, right? So we have edit inbound rules, add the rule. traffic, incoming traffic. Okay, so I'll go with SSH, right? I have enabled any IPv4. I'll just say save this. By default, it will be saved if you have not tick mark that SSH connection. All right. Now the issue should be resolved. I'll go back to my instances. I'll go back to my Linux machine. I'll just connect this. And again, if I maybe refresh this, it should be this time able to do it. Okay. See, the pop-up is gone. I'll just copy this and get back here. More on to the inbound traffic, I'll talk. You need not worry. I'll just click into this. I'll say yes, done, permanently added. And now you have got into your Linux machine. Okay. So you can see you could able to get into Linux machine. You can see maybe who am I, Linux commands, if you know Linux. Okay. ls, we don't have anything. I'll say present working directory. Some of the Linux commands I just tried to, run here just to show that we got access to the Linux server. Now, if you want to create this as a Jenkins server, you can install Jenkins, you can install Docker containers, whatever you want, you can do here. It's like you have already got your computer on the AWS, right? So one more important part I would like to highlight here is that after the practice over, if you want to reuse this instance multiple times, we have an option of instance state. You can stop the instance. Okay, you can stop it. You can stop it either from here. Even if you go to the instances section, there also, example is Linux section, right? We have an option of instance state. You can stop it. It is getting stopped. And maybe you want to permanently delete. If you have no plan of using this, don't keep it. It is very, very important, even though it is a free tier, but still the hard disk is getting used 8 GB. There is a limit of using the volumes storage every month. So you cannot surpass that. If you're not using it, if you're not practicing, okay, make sure you delete, terminate. Terminate means deleting permanently. You're destroying your computer, right? You cannot get that back. It's over, finish, fine. So I hope you could able to, understand the basic of it. We will understand more on to the security group, right? So we just have understood the one of the important service, which is EC2. Very often you'll be creating multiple instances to deploy your application, to create any of the servers, right? Maybe to practice, or maybe to just deploy an application or install Docker, Kubernetes, Jenkins. We need to go with the EC2 instance. Fundamentally, we have understood. More on this, again, we shall understand in the upcoming videos. Now we need to understand about EC2 networking basics, because launching a server alone is not enough. You should also control who can access the server, which traffic is allowed, which traffic is not allowed, which port numbers are open, right? This is very, very important. More on to the concept of security groups, the inbound traffic, outbound traffic, right? So in the previous video also, you have seen that by mistake SSH connection was disabled, and from the terminal we could not able to get connected to the server. Again, we went back to security group and we have allowed the inbound traffic. More on to this we have to understand now. You can see here in the EC2, we have an option of security groups here. Security groups can be created at the time of you launching an instance, or first only you can create and you can define it. Okay, so I'll just go back here and say create a security group, and maybe name of the security group I would like to give it as maybe I'll say here AWS security group for now. And description, whatever description you want, you can add. What is the network? Default VPC, because we have not yet learned about the VPC and networking. So we shall see that going forward. But for now, the default network which is available for us, which is the default VPC, right? So outbound traffic all, okay. But the inbound traffic right now, this security group has no inbound traffic. So if I add this to any of the server, if you want to allow terminal access from the terminal, you should be able to get connected to the server and perform some options. You have to enable, maybe you can see here SSH connection, okay, the port number 22, right? Custom, or maybe from a specific machine only you have to give the entry, or anyone, any IPv4 machine, right? Any IPv4 machine they can access. If you want custom, you can specify maybe from your own laptop only it should allow the traffic. That also you can decide, okay? So any IPv4, and maybe if you want to enable the HTTP traffic, anything else, you can keep on adding this. Maybe from the database I want to allow the traffic. I am going to launch a SpringBoot application or some other application in my server, and that should access a database also. You can enable here. You can see MySQL, you can enable PostgreSQL, you can enable whichever you want, you can enable. For example, if I have to give a basic example, I'll go with MySQL. You can see the port number 3306 from anywhere. You can just specify where is your MySQL database. If you have created in the RDS, moving forward, you will see that you can specify custom also, any also. It's up to you. Okay. So like this, you can enable more. Maybe later also you can edit this. For now, I have enabled only 2 things here. I will create the security group. Similarly, okay, description is compulsory. Maybe I'll say here demo, okay, demo practice, whatever you want. Right now, I may add multiple also, okay. So that shouldn't be a matter of concern. So I'll just go back here and create a security group, okay. This you can create directly at the time of launching an instance, like the way you have done earlier. Similar to that, key pair also you can create, okay. You can see here, we have so many key pairs. You can use older key pairs which has been created earlier. You can create a new key pair here, and same you can use later on. Maybe I'll go with a new key pair. I'll say here new demo key pair, right? So .pem, make sure it is there. I'll say create, it will be downloaded and available in your downloads. And now I would like to go back to my EC2 instances. We do have an option of instances. Maybe I'll click on launch the instance. I'll say here maybe it is a web server, okay. Amazon Linux, I would like to go with. Great. T3.micro, let it be. And this time I don't want to create a new. We have already created, right? I want to use the existing one. Maybe I'll just refresh it. I'll have an option of existing one. You have multiple, see, new demo key pair. Okay, this key pair people should use in order to get connected to the server which we are creating here. And security group, do you want to create? No. I'll say here, please choose the existing one which we only have created, AWS security group. Okay, and I have added this. And now I would like to just click on launch the instance. Okay, instance will be launched, and directly or separately, however you want, you can get connected. You can see here, click on to the connect here. It will take some time. The instance will be launched. Meanwhile, I'll just open my terminal where we have already security keys available. Okay, so I'll do one thing here. Let me just go back and add the key pair which we have created in a particular folder. I would like to do that. You can see here, I have added this. I have to give a read permission first. This is about the Linux commands. If you know the Linux, you must be knowing it. If you say connect, SSH connection I want to achieve. See here, read permission 400 means for a particular user, I'm allowing the read permission for this key pair. Inside this PEM file, security key is available. Okay, so I've enabled this, and after which I would like to just click into this, and we just have to add this, right? So you can see here, I have added it. Great. So I'll say yes, and we have created the instance here. Fine. So now I would like to just install some of the basic web servers just to give you a demo. So I'll say here sudo, I'll say maybe yum update or DNF update for Amazon Linux. It is a Linux commands, guys, nowhere related to AWS. But as a DevOps or cloud engineer, you must be knowing about the basics of Linux. Okay, so I'll say update. So again, error because there is a spelling mistake. DNF or yum, both of that you can go, no problem. I'll say maybe update, right? So let me correct it, update. And if I hit the package manager to install any of the software, we have to go with either yum or DNF. You can see it is updated. Now I would like to go and install, maybe I'll say yum install Nginx server, one of the server to host a web application. Basic server I would like to install here. I'll say -y and let me install. Within no time, the Nginx will be installed. Okay, you can see it is installed now. Now, in order to access this Nginx server, you have to go to the browser and check if it is accessed. For which you just have to use the public IP. There are two types of IPs, dear friends. One is the private IP. If you want to get connected within the network, internal network, maybe one more server you have created, both the servers want to connect to each other. Maybe from here you want to get connected to the database internal, not the outside world. Within the network, if you want to get connected, you have to go with the private IP. And if you want someone to get connected from anywhere, then we have to go with the public IP, right? So now we had launched one server there, and using the public IP, I would like to just try to access it, right? The moment I say hit here, and I may get error here, it is not accessible. You can see the site can't be reached because the security key we have not allowed 80 port number. For Nginx server, you have to enable the 80 port number, right? So I'll go back to my security. Whatever security group we have, I'll just click into this. And this we have an option of edit the inbound rules, and now add a rule. You can see here, I'm allowing, like I'm just saying who can access this incoming traffic, right? HTTP traffic should be allowed. So I'll just scroll down. You can see here HTTPS, we have HTTP. You can see 80 port number is allowed. By default, Nginx default servers will be listening to 80 port number. I'll say any IPv4 from any machine which has IPv4 as the address, people can access. I'll say here, save the rules. I have saved the rules. Again, I'll just go back here and refresh. All right. I have like just refresh this, and we are not getting, maybe we have not enabled this. I'll do one thing just to make it more realistic. I'll go back to my security group, edit the inbound rules. Okay, I'll just delete this for now. The Nginx or the HTTP one, I'll delete it. You should not feel that. I'll just save this. Okay, maybe because of this it is not happening. I'll just go back here and clear my screen. I'll just start my Nginx server here. You can see I have added, this is a Linux command, systemctl, to start any of the servers or processes behind the scene. So I'll just start it, and maybe I'll just enable also. I'll say systemctl. Okay, this is the Linux command. I'll say here enable Nginx. You can see here it should be enabled. Now I'll just check the status before again I run it. Okay, systemctl. I'll say here, of course, ctl. I'll say status for this Nginx server. The moment I hit this, see, it is right now running. Though it is running, but since we have not enabled the security group, if you go to the instances, the instance which we have right now, the web server, the name I have given, I'll take the public IP. I'll go back here. I'll just paste this. If I hit this, you can see you'll not be able to access how much ever you wait. If you go to the security group, enable the inbound traffic, like you're allowing HTTP traffic to the server. You are deciding who can access, who are allowed. I'll say here, HTTP traffic over the web, the HTTP traffic coming to the 80 port number from any device which has IPv4 address should be allowed. And after saving this rule, I'll just go back here, and you can see welcome to Nginx. Immediately you are able to access the default Nginx server here, right, which we have launched in our EC2 instance. So inbound traffic decides who can be allowed, right? If you want to allow traffic from the database, you have to enable it. If you want to allow traffic from anywhere you want, HTTPS traffic, you just have to add it. And we have an option of all traffic here. This should not be enabled. It is very risky. You should not allow anyone and everyone to access your server which you have created. You have to be very precise who are allowed here. Okay, you can decide custom also. Some of the resources you want, you can just decide custom. You can give this. Maybe if you have launched Jenkins server, Jenkins will be listening to 8080 port number. Tomcat will be listening to 8080. You can say custom TCP 8080. Then you can say from any IPv4 machine. There is no specific. You can specify also if you want this Jenkins server which is launched here to be accessed from a particular machine. You can give the IP address also. You can say custom here. You can give the IP address also here, right? I'll say any IPv4 machine, any machine, okay, can access the Jenkins server which is there inside this machine, inside this web server listening to 8080 port number. Like this you have to enable. Okay, by default the outbound traffic is all only. You can access everything. Okay, inbound traffic, and then we have an option here. You can see a private IP which is used for the internal communication, not for the external, right? And public IP from external. You can control this. Who can be allowed from your server, what you can access, the incoming traffic, the outgoing traffic. Earlier in the last video also we had got an error because SH connection, this particular inbound traffic was by default disabled. I had to enable this, and then only I could able to access my server which we had created this, right? I hope you could able to understand the fundamentals of this. It is very, very important. At any stage, you can edit the security group, you can modify, you can edit the inbound rules, outbound rules, and first only you can create, later you can select. At the time of launching an instance, there also you can decide the security group, which is very, very important, which is the firewall for your EC2 instance. Now we have understood the basic EC2 networking with respect to the security group, inbound rules, outbound rules, and also we have seen something about the private IP address and public IP address. Now we need to understand more onto this public and private IP address, and also we have something called as elastic IP address, right? What exactly is the difference between this public IP address and the private IP address and elastic IP address? We may have to understand in this particular video, right? Now to start with, see, every machine which is connected to the network, right, whether it is intra-networking or inter-networking, every machine, every server which is getting connected to a network must have an IP address. Like every house will have an address in general, right, in our real world. Similarly, every machine must have an IP address, whether it is a physical device or virtual device which you are creating on the cloud, they need IP address, right? Now here we have a public IP address, we have private, and we have the elastic IP. What exactly it is, we have to understand, right? Now, if a machine does not have an IP address, first of all, you can never get connected to that machine. You cannot even make SSH connection. In sense, like the way we have got connected to our machine, right, through the terminal with the help of SSH connection, that is also not possible if networking is not there, if IP address is not there. I hope you could able to understand. Now, coming to the private IP, you can see here, this is the private IP address, and it is going to remain fixed even if you restart this system multiple times. If you turn off, if you turn on, if you shut down, or maybe you can say if you're stopping this system and restarting, this IP address will remain same. It is fixed, generally used for the internal communication within the AWS network, or you can say within the VPC. If there is some application inside this server which you have created inside this instance that has to get connected to database which is there within the same network in the same AWS, then for the internal communication between two resources within the VPC, within the network, what is VPC we will understand. Within the network, within the AWS, then private IP address is used. It is for the internal communication. One EC2 instance getting connected to one more EC2 instance which is there within the same network. Your EC2 instance, the server which I am referring to, which maybe have an application that has to get connected to database, right? That will also get connected with the help of this private IP address only. Public IP address, generally, if you want to get connected to this instance over the network, anyone over internet can get connected to this particular machine which we have here with the help of public IP, right? Public IP is not fixed. Every time you restart the system, public IP will be changed, and it is generally used to get connected over network, over internet. Maybe there is an application inside this particular instance, inside this particular server, and that needs to be accessed by anyone and everyone globally. Then they have to use this public IP to access this application which is there inside this particular instance. They have to use this public IP, and it is not going to remain same. It is going to be changing every time you restart the instance, right? You can observe here right now the public IP. Please note down somewhere in the notebook, or maybe have a snap of this. You can see this is the public IP, and this is the private IP. Have a snap of this, okay? And what I'm going to do is I'll just say here instance. I'll stop it or restart. Anything is fine. I'll just stop it. I'm stopping the instance. All right. So I'm stopping. It will take some time. It will be stopped. You can see here the instance has been stopped and the public IP is gone, but the private IP still it is there. It is going to remain same only. So we don't have a public IP now. Again, I'll just go back to my instance and start my instance. The moment you start, it will take some time. Within a minute of time, you'll be able to see that the public IP will be allocated, but it is not going to remain same. Earlier, whatever public ID we had, it will be different. You can see here, you can also compare. Okay, you had taken the snap. Okay, you can just compare it. Whatever public IP we had earlier, it is different here. So public IP is not fixed here. It is going to change every time you restart your instance. You are stopping and restarting, public IP will be different. But private IP is going to remain same, and it is used for the internal communication between the resources within the VPC, within the AWS, within the network in general. And public IP address is dynamic. Every time you restart, it will change. And using the public IP address only, you can establish connection to this instance over the network. Even the SSH connection, you need the public IP to get connected. Through the terminal, we got connected, right? It is the using the public IP only. If you say connect here, and you'll see this is the public IP only getting used. You can see here, this is the public IP and specifying the region also. But you can see it is the public IP which is getting used even for the SSH connection, right? So the connection must have gone, and I have to use the same. Okay, I've copied this using the public IP only. You have to establish the connection, whether it is SSH connection or maybe there is an application over the internet someone want to access. For everything, public IP only will be used. But the problem here which you have observed is that every time you restart your instance, public IP is getting changed, right? Now maybe there is an application residing inside this server, right? And you have restarted the instance due to some reason, and public IP is changed. Now, can you use the same IP address in order to access the application which is there inside this instance? The answer is no, because the public IP is changed. You cannot use the same IP address to get connected because it has changed. You have restarted the instance, public IP only, the address only has changed. Now, if you want to get connected with the older address which you had, older IP, public IP you had, you cannot use that. That will not work because this particular server's instance public IP has been changed. Now, I want a public IP which is going to remain fixed, which is going to remain static. Every time I restart my server, the public IP should not change. Here is where the concept of, you can see here, elastic IPs comes into picture. And guys, elastic IP, if you use, it will be charged. You will be charged for it. It is not free. And after using the elastic IP, whatever demonstration which I'm going to show this, after you are done with the demonstration, make sure that you are deallocating and you're deleting, like the way I'll be showing in this particular video, okay? Because it will be charged. Even for the free tier account, you cannot just use it. So I'll just go back and say here, allocate a IP address here, okay? Amazon pool of IP4 addresses, that's fine. A particular zone I have specified, and I'll just say here, allocate, okay? And within no time, the IP address will be allocated a public IP which is going to remain same. So I'll just do one thing. I'll just click here, and we have an option here, release or associate the elastic IP address. I'll say associate elastic IP address. I'll just click into this, and we'll have an option where you want to instance. Which instance? The web server instance I want to allocate, okay? And allocate IP address to be, okay, only this much is more than sufficient, okay? And I'll say here associate. After I click on associate, it has been associated. If you just click on into the instances, you can see here, I'll just refresh. You can see we have the public IP, which is the elastic. You can see it is a public IP now, and here also it has been changed, right? And if you want a public IP through which people can get connected to your instance to remain static, to remain fixed, even if you restart your server n number of times, this public IP you don't want to get changed, then you have to go with the elastic IP. It's like a way of allocating a public IP to our server, to our instance. And that too, it is going to remain static, fixed, and it will not change, right? You can see here, this is the public IP. You can take a snap of this. I'll do one thing. I will just stop and restart it, okay? So I'll refresh this, all right? And I'll just stop my instance, okay? I'm stopping the instance. Within no time, it will be stopped. As you can see, the instance has been stopped, but still the public IP is there. And even if you restart, it will not change. I'll just start my instance. It will not be reassigned. The same public IP will be used. Doesn't matter how many times you're restarting your server. Okay. It is a way of allocating a public IP to your server permanently, fixed public IP, which is not going to change every time you restart the server. Okay. And you can see it is restarted, but the public IP remains same. Right? I hope you could be able to understand the fundamentals with respect to private IP, public IP, and the elastic IP. Now, what you have to do is, I'll just go back to my elastic IP after the practice is over. Make sure you do this. Just click into this, and we have an option of, disassociate the elastic IP address. I would like to disassociate. After you disassociate, you just have to go back to the action and make sure you release it. Okay. I would like to just go back and release this IP. It has been released because you will be charged for it. Make sure after your practice is done, you are releasing it. And not just that, it's a good practice if you're not going to use this particular instance. You have planned that that's all. I'm not going to get connected or do something with this instance. Then you can just delete this instance, terminate it. Terminate means permanently you're destroying this instance. It is a good practice. You're doing this only for the practice, right? If you're not going to use unnecessary, why to just allocate the resources in the AWS and just keep it as it is? So that's not recommended. Make sure you delete all the resources which you're practicing. Now we need to understand about EBS, Elastic Block Store, which is talking about the concept of volumes and snapshots. Snapshots here referring to the backup, volume here referring to the storage. Like the way your computer, your laptop will have the storage, right? Hard disk. You can consider EC2 instance, the virtual machine, as your laptop or computer, and you can say volume is like your hard disk which is attached to your system, right? So we have volumes concept here. You can create your own volume also. Even otherwise, when you are launching the EC2 instance, right? So I would like to just go back and click on launch the EC2 instance, whichever EC2 instance in that matter. I would like to go with, maybe I'll say here EBS demo instance, right? So Amazon Linux, let it be, not a big deal. So you can see here T3.micro, not a problem. And again, you can just, of course, SSH connection is required. Or else we can just use the existing security group which we have created earlier in this series. You can create a new one, not a big deal. Either you can create a new key pair in order to get connected to this particular instance, or you can use the existing key pair. I would like to use the existing key pair because we have seen this earlier also. Okay, if not, you just have to click on create a new key pair because that is required to get connected here. And here comes very important part here. You can see here, configure the storage. By default, for any of the Linux system which you're creating, right, a basic Linux system, 8 GB. And here you can see the types, different types of volumes here. We have something called as root volume. Every time you create any EC2 instance, any server, volume is must in order to store the logs, system configurations, Linux operating system information, right? And all the operations which you are performing inside the system. Hard disk is required, root volume is required, storage is required. So by default, every time you create any instance, root volume will be attached. And we have a basic here, you can increase this, not a problem. And here if you observe, we have GP3 general purpose, and we have general purpose GP3, GP2, and then we have IOPS, input output operations per second. Okay, IO1, IO2. Okay, these are the commonly used options which we have here. Generally, for a basic to moderate application, we go with the GP3. But if your application demands a high input output operations, lot of transactions you're going to perform with the storage, right? Example, you're creating this volume storage for your database where many read and write operation happens, then you have to go with the IOPS. If not, you can just read the document here, the Amazon EBS official documentation. If you just go to the EBS volume, you just have to search EBS, Amazon EBS volume doc. You'll be getting this particular page. And we have an option here. You can see here GP3, GP2. Then we have IO2, IO1, input output 1. And you can see the difference with respect to the configuration. With respect to GP3 and GP2, which is generally we use 1 GB to 64 TB, we can go with, and GP2, 1 GB to 16 TB. And when it comes to IO to input output, okay, and we have an option here 4 GB to 64, and here 4 GB to 16. But more important part here is max IOP, input output file operations. You can see here we have 80,064 KB input output operations, here 16,000. And look at the difference with respect to GP3, GP2, general purpose, and IO. What is the difference? What is the amount which we have here, right? So there is a huge difference. And here also you can see max throughput. Here is the throughput, and it will be faster. You can see here 2000 MB per second. You can see here for GP2. And look at the difference with respect to input output and general purpose. There is a huge difference here. Of course, if it is allowing you to pass large amount of data, high throughput, okay, and perform large amount of input output operations, then it will come with the cost. Of course, the cost, there will be difference with respect to general purpose and the input output. But if you're attaching a storage for a database where you have to perform lot of transactions, lot of operations, right? So many read and write operations very fast with high throughput, okay, large data you can transfer, and so many input output file operations you have to perform at a time, then you can go with the input output IO. If not, for a basic or moderate application, you can just go with the GP3 only. We have an option here, this documents you can read it, right? So since it has a high throughput and you can perform max input output operations per second, if you want faster, then you have to go with input output, okay. Maybe video streaming is there, or lot of operations you're performing with database, then you can go with this. If not, you can go with this general purpose itself, right? So by default, it is giving me the option of GP3. If not, you can go with the IO also based on the requirement. So this is a root volume. Every time you launch an instance, root volume, a basic storage must be there. So later also you can attach, like the way in your laptops, in your computer, there will be a default hard disk, SSD will be attached, storage will be attached to your laptop or your computer, right? Later also, if you want, you can attach the external hard disk also by connecting through ports, or you can add how much ever hard disk or external storage system to your system. Here also we can add additional volumes to our instances, okay. And we have an option of multi attach also, wherein one volume is getting attached to the multiple system, but that is little complex. You don't want to get into that here, okay, a rare case. But here we have a root volume, which is a default volume, default storage. I would like to just click on to launch an instance, which you already know, okay. Now you can create your own volume, and that volume you can attach to this particular instance apart from the root volume, right? Like the way in your system also, apart from the default SSD which you have with your system, you can attach the external hard disk also, external storage also. Here also we can do. We have to understand how exactly we can create the volumes, and how can we mount that to the existing server which we have here, right? So if I have to just go back to EC2 here, and the volume has been created, that's fine. But here we can see the option of volumes, And if you just refresh it, it is a default volume. You can see we have an option, the state of the volume is in use, currently getting used. The root volume at the time of you launching the EC2 instance, this has already been attached, but you can create your own volume also. Okay, the size is 8 GB by default for now. All right, and then now you have an option of create a volume, right? You can decide what is the volume type, how much is the size required. You can see here for every type of EBS volume, there is a specific limit. Within the range of limit, you can decide how much size or what size of a particular volume you need here, right? So I hope you could able to understand fundamentally. Now we have to create this additional volume, okay? And this volume we have to attach to the existing EC2 instance which we have created, and we shall be seeing that moving forward. Now let's create the additional volume and attach this to the existing instance which we have created, and also try to mount it, try to get connected to that particular volume which we are attaching, and do some operations. Okay, now before even I create it, I'll just go back to my EC2 instances which we have created already. Let me just navigate to instances, and this is the EBS demo instance which we have created. And also you can see here, I'll just refresh, and I would like to establish the connection, and also make sure that it is there in the AP South 1 zone, right? So AP South 1 region, if you are creating the EC2 instance in Mumbai region in specific zone, you have to create the volume also in the same zone and same region. You cannot create the volume in a different region, maybe Stockholm or maybe USA, and you can try to connect here. That is not going to happen. If it is Mumbai, the volume also must be in the Mumbai. Fine. So now what I'm going to do is I'll just connect this. First of all, let me just take this and go back to my terminal, the same terminal which we have done earlier. You must be knowing it. SSH connection to my EC2 instance. All right, let me clear my screen, and there is one command to check volumes which are already attached, right? LSBLK, that's the command. The moment I hit this, you can see here we have one volume which is of 8 GB size, which we have already seen, or maybe we have attached at the time of launching the instance. It is a root volume, a default volume, and that was a size it was suggesting us, and we have gone with it. So right now we have only one volume available here, right? So now what I'm going to do here is I'll just get back here, and you have to go to the EC2 again. So let me just do one thing. I'll just open this in the new tab, right? So in the EC2 we have elastic block store, which is volumes, and right now we have a default volume. I'll just name this as the root volume. Okay, this is a root volume for the instance which we have created, right? And every instance must have a volume, must have a storage. I'll just go back and create a additional volume here. Okay, I would like to go with the general purpose GP3. That's more than sufficient for me. You have an option, but I would like to go with the general purpose itself. 100 GB it is suggesting. You can launch based on the size which we have here, the options which we have, but I would like to go with maybe only 20. That is more than sufficient for me. Later also, if you want, you can adjust this, you can increase, you cannot decrease. Later, once the volume is created and attached to a specific EC2 instance, if you want to modify due to the demand, you want to increase, you can do that, but you cannot decrease it. If you have given 100 GB and later if you want it to be back to 50, that's not possible, but you can make it to 150, no problem. Okay, 3000 input output operations you can perform, and this is the throughput which is default, which you can configure also based on your need. For me it is more than sufficient. All right, and do not create volume from a snapshot. What is that? We will understand. Snapshot is just a backup, and from a backup you can create a new volume. I'll just try to demonstrate that also, but for now do not create, let it be default, which is already available here. Okay, so AP South 1 for the Mumbai, right? So there is where my EC2 instance also present. If it is in the different, then it is not possible to attach, right? So let me just create this. We have created the volume, and I would like to just give the name here, EBS additional volume. Okay, that's the name I have given here. All right, I have attached the name, and right now you can see it is in the creating state. It will take some time, so let's wait for it and let it get created. You can see now it is in the available state. Currently not in use, no one is using it, just we have created it, right? So now I would like to just click onto this, and we have an option of action, right? And here you can see, do you want to create a backup snapshot, which we will see it. But now we have an option of attach this volume. I would like to click on attach this volume. Where do you want to attach, right? So I would like to just attach to the current instance which is running, EBS demo instance, which we only have created. And then we have an option of device name. It's an option, it's like a mount name, where you want to mount. Okay, so we have multiple options here available. Okay, I'll just go with any of this which I could use. Let's go with this one. whatever we have. You can just see F2P, SD F2P. It's a data volume. It's a place where we are going to mount or get connected to. Attach this particular volume. Within the no time, it will be attached, right? So it will take some time, and you can see here completed initialization state. You'll see very soon that it is also completed within no time. So I would like to again refresh it. Now let's check the terminal, and we will just see again lsplk, and you see we have this new volume which we have created of 20 giga. It's already been attached here. This is the root one, and this is the new volume which we have attached. You can attach more volumes also, no problem. And also there is a concept of multi-attachment system, wherein one volume also can be attached to the multiple EC2 instances for the complex cases. But usually one instance can have multiple volume attached. Right now we have created one volume, additional volume, and that we have tried to attach it here, right? Just it is able to identify that there is a disk which is attached to it, the hard disk. The volume has been attached, which is of 20 giga, but you cannot use it. If you want to use it, first you have to create the file system. Only then you'll be able to mount it and then start to use it, right? So now I would like to just run some command in order to create the file system, and for which the command is something like this. You just have to attach, okay, and this is the name. Okay, internally what we have gone with earlier is the xvdf. That was the name we have seen at the time of creating the volume, but it is internally giving using that and giving you this name. That is totally fine. And now we have to create the file system here. Okay, so this is the file system type which I have specified here. Okay, and this is a place for this particular disk. I want to create a file system before I even mount or do some operations here. Okay, these commands you can run it as it is, but however make sure that when you run the lsblk command, whatever the name you're getting, you have to use that name here. In my case, this is the name. In your case, it will be a different name. Make sure you go with it. Okay, so I'd like to just hit this, and you can see here it is done, done, and done. Fine. And I would like to now create one directory here. All right, I'll say maybe data is the name of the directory. All right, and now again I'll say here sudo. I'll say mkdir. I would like to just go with some other name. Maybe I'll say here application. Fine, it has been created. Let me clear my screen here, and let me again clear and just run lsplk here. All right, and this is the name again we want to use in order to mount it. We have to say here sudo mount. I'll say here dev, and the name of the disk is this, and I want to mount it to the directory which we have created by the name application, right? So I'd like to just hit this, and the moment you hit this, we are getting it mount point does not exit. What is that error? Let me just see to it. And I would like to just first check if mount is ready here. The moment I hit this, it is not there. And maybe the way I have created the directory, there is some mistake there. What I'm going to do is I'll say mkdir. I'll just create maybe new directory here. Of course, I'll go with, I'll say sudo mkdir, and I'll create with this here root option. You have to say this, and then you have to say maybe the directory name. I'll say data or app, whatever you want. I'll say here application. Okay, and I would like to just, or maybe I'll say a demo. Anything's fine. Okay, I'll just hit this. Now no problem, and demo is a directory which we have created. Now I would like to just rerun this. Okay, all right, and again the same mounting, but this time followed by, I'll say here demo. That's the name I have given there. Okay, and I would like to just hit this. All right, and now let me clear my screen. I'll say tf-h, which is talking about the disk, and the moment I hit this, you'll be able to, so you can see demo out of the 20 GB, how much is used, how much is available here. You can see 1% is used internally for the file system which it is creating, and we could able to see something is available here. Now whatever you want, you can perform the operation into. I'll just say get into demo, and then whatever operation you want, you can perform here. Maybe I'll say just touch alien.txt file, anything you want. Okay, of course the permissions are not there. I'll say touch alien with the sudo privileges. It's a Linux command. Okay, so I could able to do some operations. I'll say ls. See here, we do have this available here. So present working directory also, if you see, we are inside this mount path directory where we have mounted the external the hard disk which we have attached, or you can say external volume which we have attached into this particular, EC2 instance. Let me clear this. And if you want to check whatever the volume you have attached, whether it was formatted and the new file system which you have created, it is there or not, for which you can just run this command here. Okay. Usually before you create the file system, it is recommended to run this. Directly have created the file system, that's also fine. If I just hit this, okay, you can see here the ext4, the same command which we had run earlier at the time of creating the file system. After creating the volume, after attaching, we first did one thing, we formatted and created the file system, and this was the type of the file system we have used, and we could able to see here. That means the file system is also successfully created, and then only you should be able to mount. And we could able to mount because first we create the file system and then we created the directory in the root, and then we could able to mount and get connected to it. I hope you could able to understand this. And also if you want, you can just change the size also, as I have discussed earlier. Okay, this is the additional volume which we have here, and I would like to just refresh it. And we have an option of modify. Okay, in the modification you can increase, you cannot decrease. Maybe I want to make it to 30. Okay, so I'll just make it to 30, and again I'll just say modify. I'll say modify. It will take some time for the modification. We can see requested volume modification, the volume is being modified. It will take some time. You can see here a volume state in use, modifying. It will take some time and it will be modified. You can see it is right now 0%. I'll wait for some time. Within few minutes it will be modified. As you can see, the modifying is done. It is now optimizing. Let's go and check in the terminal. I would like to just go back and just run lsplk, and you can see we could able to see that now it is 30 giga. It was 20, right? The additional volume which we have attached. Now I'll just check with respect to the usage of the disk. df-h, it's a Linux command, guys, in order to check the disk usage. Okay, so I would like to just hit this, and still it is showing now here the new one is 20 giga, because it is using the old file system. You have to just resize or maybe remodify the file system and update that. We have increase in the size in the volume which we have attached. For this you just have to run one command, and let me just add this. Okay, you can follow the same here. I would like to just hit this, and you can see it is resizing is required. All right, and after I do this again, I'll just go back here. I'll say lsplk, and we do have this. I'll say here df-h. The moment I hit this, and now you can see here also it is 30 giga. It has been updated, right? So you can modify your volume also which you have attached. You can detach the volume and you can reattach to a different instance also, right? If you want to copy the data from one EC2 instance to another, that way also you can do it, right? One volume which you have attached here, there is no restriction that it should be attached only to this instance. We can attach to a different instance of the same zone, same region, same Mumbai South, AP South 1, right? Because you cannot create a volume of in a different region, different geographical region and zone, and you cannot attach to an instance which is there in the Mumbai region. That will not work. It has to be in the same zone and same region, right? So I hope that also you know consider. Now once the practice is over, it is also recommended for you to detach and delete it. Okay, again you can recreate for the examples. We have an option. I want to maybe this time detach this, right? So I'll just get into the option of actions, and we have an option of detach the volume. It will be detached from the instance where we have attached it. Okay, so within no time it will be detached, and if you have no plan of using this, you can delete also, right? So if there is no real world usage, it is not recommended even for the practice to just keep it as it is. Delete the resources. Now we have to understand something very important again with respect to the snapshot, which is the backup of a volume. And from that snapshot, again, how to create a volume back. There are more things to be understood. At least now I hope you could able to understand about the fundamentals with respect to creating the volume, attaching it to the EC2 instance, and also achieving the mounting. And once mounted, you can perform or you can create whatever resources inside the additional volume which we have created. Now let's understand about these snapshots. Basically, it is talking about the backup of your volume, right? Whenever we have a volume, there will be some data, whether it is additional volume or a root volume. It is always recommended to create the backup. If server crashes, if something happens to the root volume or maybe the additional volume, you should have a backup. Snapshot create a backup image, and AWS will maintain internally with the concept of S3 bucket. You'll not be able to see S3 buckets directly, but AWS internally uses S3 to keep your backup, keep your snapshots. Okay, now you can see here we have a concept of snapshots. You can create the snapshots directly also. okay, or you can create with the help of volume also. We have an additional volume, right? So I'll just click onto the additional volume, and we have an option of actions here. There's an option of create a snapshot. From a volume, you can create a snapshot. It's like I'm talking about create a backup of this particular volume. That's what I'm trying to say here, okay? Create a snapshot. You can see here, I could able to create this snapshot, okay? And it is creating, you can see here, availability zone AP South 1A. I would like to highlight one important point here, that the volumes are zone specific within the region and snapshot are regional, okay? So I would like to just go back here. You can decide also, create a snapshot, create a point in time snapshot to back up the data on Amazon EBS volume to Amazon S3. Internally, Amazon AWS will use S3. You need not worry about the buckets here. You just have to create the snapshot. You just have to create the backup. Even otherwise, if you just go to the EC2, directly also you can create, later you can attach. You can just click on to snapshots here. We have an option of create a snapshot and volume or instance. Maybe I want to create a snapshot for this particular volume, okay? And you can see volume ID for which volume? For this additional volume, I want to create it. Great. Description, maybe I'll say here backup for, maybe I'll say here my volume. Whatever description you want, you can give. So that should not be a major matter of concern. You can see here. And now I would like to click on to create a snapshot, and it has been created. You can see here. And one more point I would like to highlight here is that snapshot, you cannot attach to any of these resources directly. You cannot attach to the EC2 instance like the way we have mounted the EBS volume, right? Snapshot, we cannot do. It's just a backup. AWS will maintain just in case if some disaster happened to your server, to your volumes, you have a backup available. And in the real world scenario, usually we automate the system of backup, or you can say automate the system of snapshots for every important resource. We keep on creating the snapshot. In sense, we keep on creating the backup, and we maintain if something happens to the server or maybe database, we will have the backup. Now, once the snapshot is created, very important point I would like to highlight is from the snapshot, again, you can create a volume, right? So from the volume, you can create the snapshot. From the snapshot, you can create the volume again. Now, whatever backup I have here, I want to access the backup. Maybe it was there in one of the volume. That volume is deleted. Something happened to that volume, right? So I would like to just click on to the volume. We have this additional volume which we have detached. You can see here, volume state is available. That means the additional volume which earlier we had attached now has been detached. It is not attached to anything. Or maybe you can delete this, or something happened to this volume. No problem. We have created the backup. From this backup, again, you can create a volume. A new volume will be created. So what I'm going to do here is, maybe I'll just, you can give any name you want for the readability. And we have an option of action. And you can see here, create a volume from snapshot, create an image from this snapshot. I would like to just create a volume from this particular snapshot. I would like to click on to this. And then we have an option, how much GB, you can see 30 GB general purpose. Again, the same options generally, where you want this volume to be available. I want this to be available in the South EA itself, because the EC2 instance which we have used earlier. And if you just click into this, and we have an option here, you can see your particular, if you have to maybe get into security, and again, I'll just get into maybe networking. You can see it is available in 1A zone, and the volume also would like to create from this snapshot into 1A zone itself, okay? And the rest of all, I would like to keep it default, all right? And now let me create a volume. This time I'm creating a volume with the help of snapshot. Whatever backup I have taken, I wanted to use that backup, and I'm just creating a volume from that backup, okay? So now if I just click volumes here, you can see here it is getting created. It is now available, right? This is the additional volume we had. I would like to delete this additional volume which we had created. I would like to delete. Assume that it has got deleted, something happened, right? So you just have to confirm here, delete the volume. Let me just delete it. Great. I'll just refresh. Now, whatever volume it has been created right now, it has been created with the help of a snapshot. Okay, we had created the snapshot. From the snapshot, it has been created. I'll just say here, volume from this snapshot. I'll say snapshot. Volume snapshot is a name I have given here for the readability. This volume we have created from the backup, from this snapshot. Now, this is what I would like to connect to my EC2 instance. So I'll just click into this action, and we have an option of attach the volume, and where to attach to this instance which is currently running. All right, and device name, whatever you want, you can give the device name. Let's go with anything, dev SDF, anything is fine. I'll just attach the volume. It will give a different name, internally maintain SDF, but there you will see it will give a different name, right? So just get into this. Now, if I get back to my normal place, I'll just, back to my root directory, normal place instance. I'm referring here to root directory. Okay. I'll clear my screen, lsblk, and you'll be able to see we have one more. The ID is different here. It is a different volume which we have created from the backup. Earlier, we had a volume, but we had maintained the backup. Something happened, some disaster, because of which we lost the storage. We lost the value, but we need not worry because we had a backup. From the backup, again, we could able to create the volume back, and we could able to, get that here. Now I have to do the mounting for this particular, but before we do the mounting, you may have to create the file system. So let me just create that. You can see here, I have added the same command which we have used earlier, the Linux command, to create the file system. This is the file system. I would like to create a file system. This is the type of the file system and place for this particular volume. Okay. So now I would like to just hit this. All right. It's already there. It's in, but anyway, I'll say here, yes. Okay. It is asking me, it contains this file system. Okay, no problem. Okay. I've told yes here because earlier same instance we had used to mount and create the file system for a different volume. Okay. So now I would like to do the mounting. I'll say lsblk, and to mount, I'll say here sudo mount. We already had created the directory earlier, right? So you can see here, we had already told that sudo mkdir, and maybe we had told this app. So, or maybe we had told demo, earlier we have done that in the previous video. So since it is the same instance, I would like to use the same thing. I'll say sudo mount. I'll say here dev, and then we may have to mention the, ID of this, which it is giving to us, right? And then I'll say demo. Okay. So let me hit this. We could able to do this. Now let me get into demo. And if I say ls, you can see I could able to get into the working directory. Whatever you want, you can do it here, right? So anything you want, you can do within this working directory after mounting, but you could able to mount now. You can also check here. I'll say df -h. The moment I run this, you can see here, currently, 2 GB has been used internally for the internal system, for the file system, but this much is available, 1% is used, right? And it is a different volume ID, which we had created from the backup we had earlier. I hope you could able to understand that, right? So now the real world, one more scenario if I have to give you. Imagine there is a EC2 instance in, Mumbai, AP South, 1A zone, and there is one more instance in 1B zone, right? Both of them are two different zones. And whatever volume you have created, that is 1A zone. Volumes are again zone specific. We have attached to the EC2 instance which is available in 1A zone, right? Now the same additional volume which you had attached to the EC2 instance 1A zone machine, right? The volume, I want to use the data which is there in the additional volume into one more, instance which is there in the 1B zone. Can you attach a volume which is created in 1A zone into the instance which is there in 1B zone? The answer is no. Let me explain pictorially here. As you can see pictorially, assume that we have two EC2 machines which we have created. Okay, one in 1A zone, one more in the 1B zone. Okay, we have a default root volume which will be there with every EC2 instance. Now assume that I have created one more additional volume, and this additional volume which I have created, the extra volume for my application, this is additional volume, and this also I have created in 1A zone of AP South 1. Okay, and now there is some important data here which I want to attach to this instance. Now can I just detach this particular volume and take this particular volume and attach back to my one more EC2 instance? No, because this particular volume you have created in 1A zone. You cannot directly detach and attach in one more instance of 1B zone. What to do now? You can create a backup of this. In sense, you can create a snapshot of this, right? So I'll say here, create a snapshot. You have seen how to create a shot of one particular, volume. You just have to create a snapshot of this volume. And from this snapshot, again, you have seen practically how to create a one more volume, right? I just want to create one volume here. And this time while creating the volume, I'll mention I want to create the volume in 1B zone. Okay. And now you are creating one more volume here. Okay. of a 1B zone, and this volume I'll be attaching to this particular instance, and you'll be able to access here. Fine, I hope you could able to understand. You have seen practically from a volume how to create a snapshot. From a snapshot, how to again create a volume you have seen, and you know how to mount that volume. I want you to give a try as a assignment which I have given to you in this particular video. You know how to create a volume, how to create a snapshot, from a snapshot how to create a volume, and how to do the mounting also. You know, this could be one of the realistic approach. But basically snapshot are for the backup. If something happens to the volume or to the instances, you can always have a backup, and that snapshot you cannot attach to any of the instances directly. You just have to create a volume out of a snapshot, and then you have to attach. This is one of the use case, right? Now once you're done with the practice, make sure that you are deleting all the resources. Okay, don't keep it volumes. You'll have a limited access in even the free tier account also. Okay, so I'll just go back and delete this snapshot. Okay, you also please do it. I'm doing this in the video so that it should give a message to you also that whenever we create any resources after our practice is over, you have to delete it. I'll just detach it. Okay, since we had attached it already, so I'll detach. After detaching, I'll just take this additional volume. Since the practice is over, I would like to delete. Okay, it is a very good practice. It is detaching. I'll be deleting. After this is done, I'll go back to my instance also. Instance also, since I'm not going to use anymore, I would like to delete. Make sure you also do this, and it is very, very important. I'll just take this and I'll just terminate this instance. Okay, you can see here, terminate. All right. So make sure you practice all this. It will make more sense to you. Now, before moving further, let's understand one more important concept, which is EC2 user data. User data is a startup script that gets executed automatically at the time of instance launching. Instance here referring to the server, the virtual machine, whatever we have done in our EC2, right? So whenever you launch and you want something to get executed automatically, that's where EC2 user data comes into picture. Basically, it is a commands which we give to AWS, and AWS executes that automatically whenever launching any server, or you can say EC2 instance. And this we call it as bootstrapping. Here bootstrapping referring to automatically preparing a server during the startup, right? If you want to install maybe Docker, you want to install Nginx, you want to install some of the softwares, and you want that to be installed the moment you launch your server, the moment you start, or the moment you create a new server, new EC2 instance, few of the servers should be automatically installed without you manually having to get connected to the server and run the Linux command one by one. What exactly it is, will be in a position to understand. So I'll be maybe running the Linux commands which are responsible to launch a basic static website. Okay, so I'll just click on to the EC2 here. And if you click on to the EC2, we have multiple options. I'll just click on to launch the instance. Of course, launch without a walkthrough. And here I would like to just give the name of this as the web server. Okay, and Amazon Linux, whichever you want, that shouldn't be a major matter of concern. I would like to click on to this, and then t3.micro is more than sufficient. Just in case if you want to get connected to the server, just click on to any of the key pair you want, which is required to get connected. I'll allow the HTTP traffic, okay, alongside the SSH connection. I have enabled this also. And now we have an option here, advanced details, right? So here we have so many options, ignore them. At last, we have an option wherein you can just run a script. Here you can write shell script or Linux command which you want to get executed at the time of launching this machine, launching this virtual machine, or you can say server. So whatever you specify in the user data, that will get executed the moment this particular server is, launched. Maybe I want to launch a basic static website just to give you a demo, right? We can launch this server and get connected through SSH connections and then run the Linux command one by one. Maybe you want to install HTTPD server or Nginx server and get into the Nginx server, host a index.html file, static website. Everything can be done one by one by running the Linux commands. But we don't want to do that. I want that to happen the moment I create this machine, for which you just have to write the Linux command or maybe shell script which you want to get executed the moment I click on launch the instance. Alongside the instance creation, AWS will also execute whatever Linux commands you mention here. So let me add a basic Linux command here which is responsible to install a basic web server and host a maybe static website. As you can see, I have added here just to install the Nginx server, and we are starting this Nginx server. We are enabling, And inside this Nginx server, it is a Linux commands. Okay, these are the Linux commands. Okay, so I'm just launching a basic welcome to AWS user data. Okay, and I would like just to say here Telesco learning. Okay, nothing more, right? So it could be something else also. Maybe the commands which are responsible to install Jenkins, the commands which are responsible to maybe install Docker, anything, right? Whatever Linux command you want, you can execute here. I have just added a basic shell script. I want this particular website to be launched. Okay, the moment I create this server, I have given the name. I have gone with the Amazon, right? So all fine. And now I would like to just go back and click on to launch the instance, right? So within no time, the instance will be launched. You can see here, instance has been launched. I just click on to instance. I'll just refresh. You can see it is initializing. It will take some time. Within 1 minute of time, you can use the public IP and you can access the website which we have hosted inside the server. We have not got connected to this through SSH. We have not manually got connected and running the manual command. That is not what we have done here. We have done that at the time of launching with the help of EC2 user data concept. I'll just now refresh again. I'll just click on to the public IP and go back to my browser and I'll just paste it here. Okay, the moment you paste it, you can see here, welcome from the AWS user data, Telesco learning. Whatever the page, whatever command we have run there got executed and we could able to see this. We have not done anything extra here. I hope you could able to get the concept of EC2 user data. It is a way to run or execute some of the Linux commands at the time of launching or creating the EC2 instance, web server, or you can say virtual machine. It is very helpful. Going forward, you'll be able to use it freely. Now, before we move further, let's launch a static website in our EC2 instance, or you can call this as web server, like the way we have done in the EC2 user data. But there, we just ran basic Linux commands at the time of starting the server that could have already got executed. Make sure that to delete the server if you are not using, you have to terminate them, like the way I have shown earlier, right? Now, before we do anything, just to give you an idea, website, it is just an HTML, CSS, and JavaScript pages which are residing on a web server on any of the instance, right? And to host that, to keep that, we have a web servers concept, Apache, and we have Tomcat, right? We have HTTPD, we have Nginx, which is one of the popular web server, which is used to host a static website, which is used for the reverse proxy application, load balancing, right? Basically, Nginx is one of the software using which you can host your website. It is a place where all the web pages which you are creating, you have to keep it. Keeping the web pages inside this server software is only called as hosting the website. Just having the EC2 instance is not sufficient. Inside that, you should have a web server on which you have to keep your files, and if you keep that files, it is like equivalent to you hosting the website. Let's see a basic demo before we move further. I would like to just click on to launch an instance. Okay, of course, we have seen that earlier n number of times. I'll just give it as a web server, right? So Amazon Linux, let it be same. And just to get connected, I'll just use this keypad. It is very important. And make sure now itself you're allowing HTTP traffic. Okay, this traffic is very, very important. Later on, using the security group, you can edit the inbound rules. If you are hosting the website with the server software such as Nginx or HTTPD, the default port number will be 80 on which your website, or you can say these server softwares, are listening to. Okay, so nothing more now. Okay, I would like to just launch an instance. And once it is launched, I would like to establish the connection, right? So let me just refresh it. I would like to refresh. Within no time, it will be ready. As you can see on your screen, it is now running. I would like to just click onto the instance, of course, connect. And we have seen that earlier also using the terminal. I would like to establish the connection. Okay, so right click and let me just establish the connection. I'll say yes. All right. And let me just clear my screen. Now, before I do anything, I have to install the web server, and this time we are going with one of the powerful and most popular web server, which is Nginx, right? So since it is an Amazon Linux machine, I have to first install using the package manager. These are the Linux commands which I'm running here, and someone who's learning cloud or DevOps, they must be knowing the Linux. Okay, it is a way to install the web servers on the Linux system, and this server which I have created is a Linux system here, right? So I'll say here install Nginx. Okay, I'll say -y, update this and install is what I'm trying to say, right? The moment I hit this, it should be installed. As you can see, it has been installed. Now I would like to say here sudo systemctl. All right. I'll say start the Nginx server, right? So let me just click onto this. It will start. And now I would like to enable it, right? I'll say systemctl. I'll say enable Nginx. The moment I hit this, it should be enabled. Now you can check the status. I'll say systemctl is one of the important command in the Linux. I'll say here Nginx. The moment I hit this, we can see it is right now no running. If you want to get back the terminal access, press Q onto your keyboard. You'll be back. Okay. So now I have to get into this particular server. For you to get into this server, you have to go to a specific path, right? So let me get into the path, because inside this path, inside the Nginx server, you have to keep your static website files. And for which I would like to just add this particular path, right? So now I'll say present working directory. I'm inside this. I'll say ls. Okay. So I just have to open this index.html page. I'll say vi. Okay. Let me just get into sudo visual editor. Vi, it's a way to open the editors in the Linux system. Okay. I'll say index.html. And whatever already content we have, I would like to just get into insert mode, and let me erase this. As you can see, I have removed. Now I'll be adding my own, HTML content here. This content you can get with the help of any of the AI tools. If you just give any random, prompt, and whatever website with the, inline CSS styling, if you want, you can just get that and you can just host it. Okay. I have got this content from the AI tool. Okay, I have not coded this. Of course, in the era of AI, you just have to get, just to show you the demo here, right? So now I have added this. Let me save this, and that has been saved. Okay, so it's like you have hosted the website. Now I would like to just get back to where I was. Okay, the normal home directory. It's done. We have done the editing there, right? Now, before you even check, you just check the security group once again. If you have enabled the HTTP request, get into the security. We have seen about the security group, right? So now here you can see edit the inbound rules. You can see 80 port number is enabled. HTTP request is enabled. If it is enabled, only then you will be able to access the website which you have hosted inside this particular server, the Linux server which you have created here, right? So I would like to save. No changes have been made. That's fine. So if I have to get into this running instances, this is the instance currently running, right? You just have to use the public IP of this. And now I would like to just go and access the application. Let me just click on to this. As you can see, you could able to access. Sometimes it will take some time, 1 minute. You need not worry. You just have to show the patience. Refresh your instance and refresh this web browser. You'll be able to access. This is a static website which I could able to host using the EC2 instance web server, right? So I have created one Linux machine. You can say the web server. Inside this, I have installed the required softwares, web server softwares, and I could able to host a static website. Whichever website you want, you can host it, a static website. Of course, if there is a database, how do we do that? We shall see going forward. But at this stage, just to host a static website, I have just created the EC2 instance, and I could able to, launch, or you can say host a website. Now people can access with the help of public IP of this particular system. If you want to give a permanent public IP, we have seen earlier the concept of elastic IPs comes into picture, which is chargeable for the free tier account also. But for the demo, this is more than sufficient. The normal public IP have used, and now we could able to launch a website here. And after it is over, you can just do one thing. If you're not gonna practice or use this instance, you can just terminate it. Have this practice. After demo is over, if you're not going to use it, please make sure you delete this, right? All the EC2 instances will be charged based on hourly basis. Like every 1 hour, it will be charged. Even if you use for 5 minutes, you'll be charged for 1 hour. Even if you use 59 minutes, you'll be charged for 1 hour. The moment you cross 1 hour, 1 hour, 1 minute, it will be charged for 2 hours. That's how it works. It is hourly basis bills. Okay. Since I have no more work with this server, I would like to do one thing. I'll just go back and terminate this, right? Now we need to understand one more interesting topic, and also very, very important, which is about the load balances, right? So for which you have to understand some scenarios. I would like to represent that pictorially. You can see here, imagine this is your AWS cloud, and to deploy your application, you have created one server, the EC2 instance. And inside the server, you have deployed your application. Now, if people want to access this, they have to access through the public IP. And I'll make an assumption we have some end users of our application. End users in the sense, the one who uses the application. Now, assume that they are making call to our application, and they'll be making call to the application which is residing inside this particular server, right? Now, if there are limited number of users trying to access the application, there is no problem, right? If there are few users trying to access the application, that's fine. This server has a capacity to handle that traffic. Imagine suddenly your application is becoming famous and thousands and lakhs of people trying to access your application. That means there will be a huge burden coming up to this server which is hosting this application. Can a server handle thousands and lakhs of users simultaneously which is hosting this application? The answer is no. It may lead to single point of failure. The server might crash, right? It cannot handle huge load coming onto this, right? And also there are other disadvantages associated with it if you're trying to host your application using single server. If something goes wrong with the application or maybe to the server, then people cannot access because the application is there only in the single server in that case, right? So it may lead to single point of failure. And also the downtime. If something you're with respect to configuration or any issues on this server, then people cannot access the application, right? There are many advantages, limitations associated if you host your application in single server, right? Now, generally what we do is, instead of hosting our application into one server, we will be making use of multiple servers, right? So our application will be residing into multiple server, depends on the use case, depends on the traffic which is coming towards the application. For example, I have taken here 3 instances, or you can say 3 servers. Anything is same here, right? So it could be 5, it could be 10, it could be 100 servers based on the traffic which is going to flow on to your application. Here is where the concept of load balancer comes into picture, because this time your application is not hosted on single server. You cannot give the public IP of a single server. If you give so, then entire traffic will come to that particular server, right? You cannot say that a certain group of users to be accessed the application using this public IP, certain group to be accessed using this public IP. That's not going to happen, right? So generally we give just one URL, one link using which people should able to access the application. But in the backend, behind the scene, we have to manage the operations in a way wherein we are dividing the load into multiple server. We are trying to host our application instead of one server into the multiple server. And here in between, we will be introducing one common factor called as load balancer, one important component which we call it as load balancer. So all the end users who's trying to access our application, end users in the sense the one who's going to use our application, the users, right? Now they'll not be reaching to the servers directly. Rather, they will reach to this load balancer. We'll be giving them the common URL. Everyone will reach to the load balancer. Doesn't matter whether it is 1000 users or 10,000 users or 1 lakh user. All of them are trying to access the application through the load balancer. The traffic is coming to the load balancer. And behind the scene, this load balancer will divide the traffic into multiple server in the round robin technique. What do you mean by round robin technique? Like round robin, there are many other techniques for the traffic distribution, but the most common and the AWS load balancer uses a round robin technique. In sense, the first traffic will automatically be divided into a first server. It will forward to the first server. The second traffic will go to the second server. If in case there are 3 servers, if it is 10 server, it will follow one by one. The same fashion it will follow. Doesn't matter whether it is 10 servers or 100 servers. Third will go here. Again, the fourth will go to this server. And you can say the fifth will go to this. And the sixth will go to this. Similarly, the seventh will go to this. Equally, it will distribute. Okay. The eighth traffic coming to the application will go here. Ninth will go here. Like this, equally, one by one, the entire traffic will be distributed among these servers which are available in round robin fashion, round robin technique, right? So if there is a huge traffic coming to the application, that will not directly go to the server. In between, we have a load balance here, which will take the traffic, and this load balancer will divide and distribute the traffic to the servers which are there in the backend. It could be 3, 4, 500 servers. None of them are reaching to the server directly. They are reaching to the load balancer, and load balancer follows a round robin technique and will forward the traffic to these servers which is hosting our applications one by one. If there is any problem in one server, it will not lead to single point of failure because our application is hosted in multiple servers. We have multiple instances of our application, not just one instance, right? If something goes wrong here, the traffic will be redirected to the other available servers, right? So people can still access our application. We are not dependent on single server, right? So basically here what happens is we'll be hosting our application into multiple servers, and that will be increase and decrease as per the traffic. Going forward, you'll understand one interesting topic called as auto scaling group. How exactly that works, we shall also see it. But using the load balancer, the traffic will be distributed. People will be reaching to the load balancer URL, and it is load balancer's responsibility to divide the traffic into multiple servers which is hosting our application. Now in AWS, if you see here EC2, if you open the EC2 in the AWS, right, this is our AWS, and you just have to search for EC2, or which is available in the recently visited, you can search also. We have an option here, load balancing. You can see here load balancers target group. I would like to click on to load balancers, right? And if you see here, elastic load balancer scales your load balancer capacity automatically in response to changing the incoming traffic. That's fine. I'll just click on to create a load balancer. When I click on to create the load balancer, we have an option of application load balancer, network load balancer, gateway load balancer. Other also there, classic, which is a previous generation. Now, very often for all the APIs, the backend websites, web applications or microservice application, we go with application load balancer. Day in and day out, whatever applications we are using, right, they all are the web applications, websites. Behind the scene, there are APIs, right? It could be microservice or monolithic. So we could able to access with the help of application load balancer, which is getting used in order to divide the incoming traffic to the application into multiple servers. Alongside that, we do also have the network load balancer, which is if in case there is an application which is more concerned about the high ultra performance, low latency application, video streaming or networking related, their networking load balancer comes into picture, and we have a gateway load balancer for the security purpose firewall. It is getting used, all the applications which are talking about the security and firewall, right? So if you want to understand this more, first you have to understand about the OSI layer. Whenever there is communication between the client and the server happens, the communication between client will send the request, server will send the response. In between there are 7 OSI layers. If you understand that, you'll be able to get some idea about how application load balancer, network load balancer and gateway load balancer are different from each other. But practically, very often you should be knowing something about the application load balancer, which we shall see practically. We'll understand what is target group, and we will see everything practical. But before we get into this, let's first try to understand what is the difference between these three load balancer with respect to networking and OSI layer. So far, we have understood why do we have to go with the load balancer, what problem it is trying to solve, and what exactly is load balancer all about, right? And when we have tried to explore the load balancer within the EC2, we have come to the conclusion that there are different types of load balancer available here. We have application load balancer, network load balancer, and gateway load balancer. Also, you could able to see here HTTP, HTTPS is trying to give you some message, TCP, UDP, and here gateway load balancer. And you can just also read this. Choose an application load balancer when you need a flexible feature set for your applications with HTTP and HTTPS traffic. Most of the applications which we are dealing with today in the real companies, the SpringBoot, the React, the Node.js, all the softwares which you can access over the internet, all of them are catering to this traffic itself, right? And then we have the network and gateway. If you want to understand the actual difference, you also have to understand something fundamentals which you might have already learned in your college days. What is that, if you ask me? Whenever two computers, right, two machines interact over the network, a lot of things happens behind the scene. It has to go through the OSI layers, which you might have learned in your college days. Even otherwise, you might have come across with this open system interconnection model, or you can call this as OSI, right? That could also be one of the very famously known, So when these two machines, or you can say computers, they are getting connected, right? One is making a request, the other where we have our application is sending you the response. Here, data needs to be physically transmitted, addressed correctly, broken into packets, sent reliably, and then finally understood by the application which is receiving here. So many things happens behind the scene, and to manage all of this, networking is divided into multiple layers here. Okay, so we have the application layer which is closest to the client when he make the request. Then we have presentation layer, session layer, transport layer. Then we have network layer, data link layer, and physical layer. Multiple layers are there. So if I have to just pictorially maybe try to represent here, let me just add this. You can see all these layers would be available, right? Now you need not to memorize all the 7 layers, what exactly it does at this point of time. If you want, you can refer to any of the AI tools and try to understand this to revise this concept, which you might have come across somewhere while you are learning the technology or maybe engineering here. But out of all the 7 layers which we have here, few layers plays very important. Number one happens to be the 7th layer, which is the application layer, right? And the 4th layer here, which is the transport layer. Everything else running underneath, and AWS manage it for you. So let's understand these two properly, because it is relevant to whatever we are learning here, right? Application and network load balancer, it is relevant to it. If you know this, then only you'll be in a position to understand. The layer 7, which we have here very close to the client, the application layer, right? It understands HTTP and HTTPS, the protocol behind every website, every web application which is running on the internet, right? It is accessed through the protocol called as HTTPS. The URLs, the path inside the website link, I mean /home /API order, path-based routing. Maybe you might have come across something like this, right? So if I have to, you can see on your screen, if I just have to represent, you can see here something like this. Okay, so layer 7 understand all of this, and it can make intelligent decisions about where to send the traffic. And this exactly where application load balancers comes into, or you can say application load balancer, ALB, operates. So the application load balancer which you have here, it operates at this 7th layer. Okay, because the 7th layer, application layer, understands about the HTTP, HTTPS, URLs, right? The headers, the host names, or host name in the sense we can say admin.com or tedisco.com, right? All of these things. Authentication tokens, content type, cookies, all the related things which are relevant to the web application hosted on the internet. This particular application layer understands it. Okay, and this is where exactly our application load balancer operates. Okay, and we call this type of things which you can see on your screen, we call this as the path-based routing, and application load balancer does this automatically. Okay, and in the most of the companies which is running microservices, where one application is split into 10, 20, 30 smaller services, microservices, behind the scene multiple applications are there, right? So ALB, the application load balancer, is what keeps traffic going to right place. ALB is very smart. It reads the request, understands it, and routes it intelligently. Okay, so in real world, whatever we are dealing with, the applications, once you get into the companies, 70-80% of the time you're dealing with the web applications, all the applications, and there, if you want to route the traffic properly, we will be using the application load balancers only. Okay, now coming to the network load balancer, it works in the 4th layer, which is the transport layer. And this layer does not care about the URLs, the paths, or you can say HTTP headers. It takes care of only IP address, port number, protocol, whether it is a TCP or a UDP. Okay, TCP handles reliable connection based communication. Okay, on UDP handles the fast connectionless communication, basically for the video streaming, gaming, or such things. Okay, and this is where our network load balancer comes into, or you can say network load balancer operates at this particular transport layer. Okay, So, and NLB, the network load balancer, does not read our URL. It does not know if you are requesting to API, or you're requesting to an order, or you're requesting to a course or admin. No, it does not do that. So what NLB does is forward the connection extremely fast, millions of requests per second, okay, with the lowest possible latency, right? So whenever you need a raw speed and you do not need the URL based routing, then you have to go with the NLB, the network load balancer, okay? So the gaming servers, or you can see the financial trading systems, right? IoT platforms, all of these places network load balancer comes into picture. And then we have here, you can see here, the gateway load balancer. Okay, this one is different from both network and ALB. So it is not about routing web traffic. It is about the inserting the security, appliances like firewalls, okay, or deep packet inspection tools, right? So it is all about the security systems. Think of it, you can say security checkpoint at a border crossing. Every vehicle, every packet must pass through the checkpoint before it continues to the destination. So gateway load balancer sends all the traffic through a third party security tool first, and then forwards it on. Okay, so basically the large enterprises, banks, or government organizations, or companies with very strict compliances requirement, where every packet must be inspected by certified security appliance before entering to the network. In that case, you can go with this gateway load balancer. Okay, so if you want to understand about the ground reality, what exactly happens once you get into the company wherein you're developing the applications, or React application, Angular application, or you can say the Spring Boot application, all the web applications day in and day out, we will be dealing with, you'll see application load balancer in front. You might see a network load balancer also, but not often. It is very specific, okay, just in case if you want to have streaming, or if you're dealing with a streaming application or a fast application with where the speed matters, latency matters, then you may see this. But most of the cases, day in and day out, in the real world, you may deal with the application load balancer only, because all of our applications which we are building or going to work with are dealing with HTTP protocol, and we have to go with this application load balancer. Now we have to understand how to work with application load balancer. And also, if you just click on to this, we have an option of internet facing. We have to understand this. And also we have a concept of the target group. Many things are associated here, and we have to see practically how to work with load balancer by considering application load balancer as an example, right? Now it's time wherein we see the practicals, we understand the load balancer practically, and we will see how it is diverting the traffic to all the backend servers, right? And we have to understand the load balancer, target group, multiple backend servers, how traffic actually flows. Before we do anything, I'll just do one thing. I'll be creating two servers here by adding the data. I'll do one thing, a user data concept you have seen, right, which can be used in order to run some of the Linux command at the time of launching the instance. Something similar I'll do so that I can show you something practical. Okay, so we have this Amazon Linux. I'll just give the name here as server number 1. All right, and t3.micro is more than sufficient. Let's go with any of the key pairs here, just in case if you want to get connected. I'll allow first only the HTTP traffic. Okay, if not, later also you can configure, or you can just go back and choose the existing security group which we have used. Okay, so let's go with the existing security group, right? And in the advanced details, I'll be adding the user data which can show the demo of launching one particular website. I'll just do one thing. I'll just add this script here. Okay, so let me add the script. You can see here, basically it will install the Nginx server, and welcome to, maybe I'll say here message as Telesco server 1. Okay, at the time of launching your instance, if you want to run some of the Linux commands, then you have to go with the user data. We have seen this concept earlier in this series. I hope you are aware of this. So I'm just installing the Nginx server and hosting a basic static website. Welcome to Telesco 1 in server number 1. Great. So I'd like to just use the same for the one more instance. Let me launch the instance first of all. I would like to launch the instance here. Instance is launch. Now let me go back and launch one more instance. Okay, launch the instances. I'll give the name as server 2. You can take 2, 3, 4 also For the demo purpose, I'm using only 2 servers in the backend. Assume there are 2 servers where our website is hosted. How the load balancer is diverting the traffic to both the servers. Okay. So now let it be t3.micro. Just in case if you want to get connected to server, use the keypad. And I want to use the existing security group, which we had created earlier in this entire series. I'll go back to the advanced details, and here in the user data, I would like to add this, right? I'll say here maybe there is core server number 2. That's the only difference, right? So I'll say here launch the instance will be launched. If you have to go to the instances here, okay? Instances, and if I refresh, you can see server 1, server 2, both the instances have been launched. And inside this, we have our web application, because with the help of user data, we also launch the static website. Okay, very basic one. That's fine. That shouldn't be a problem. Now, if you look onto this, we have an option of load balancer and target groups. So load balancer will not directly reach to the servers, right? So if in case, if there is traffic coming to the load balancer, it will not reach to the servers directly. Just in case in future, if you want to increase the servers, you are achieving auto scaling, as in when the traffic is increasing, number of servers is also increasing. Each time will you go and register the servers to the load balancer? The answer is no. In between, we will have something called as target group. Okay. So we will have a important component in between. Name of the component is target group. Okay. So let me just add this. As you can see here, this is our target group. So load balancer will reach to the target group, and inside the target group, you have to register number of instances. So our load balancer will not divert the traffic directly to the instance. Rather, it will just direct to the target group. Inside the target group, we have to configure all our servers. Whichever servers are configured in the target group, the load balancer will divert the traffic into all these servers. So it will not reach to the servers directly. In between, we have to create one target group. So before even you create the load balancer, first you have to create the target group. I'll click on to the target group. You don't have any target groups in AP South 1, all right, in this region. Instances I'm creating this for. I'll just give the name as I'll say server target group, whatever name you want, you can give. Okay, HTTP, right? Right now, I would like to go with the default network, default VPC. Very soon in this series, you will understand about the VPC also, networking also, very detailed. You need not worry, which is very important. Right now, I'd like to go with the default network, which is already given by AWS account. And after which, this is just the healthy checkpoints. You can add it. Just in case if it reaches to the index.html, you can see here advanced health checkpoints, and you can read here the number of consecutive health check success required before considering an unhealthy target. Okay. The number of consecutive health check failures required before considering a target is unhealthy. Before you send the request, when you have to consider that wherever we are reaching to the servers, whether they are healthy or not, right? We have to give the, it is like depends whether you want to first check whether the servers for which you are sending the traffic, whether they are healthy or not. So for this also, you can add this additional details. For me, at this point, it is not required. I would like to not add anything there. And here, let it be, because I don't want to add anything for now. Okay, so that's fine. And you can just click on to the next, right? And here you have to include in this target group, which servers do you want to include. And I would like to say here, both the servers I want to be the part of target group. In future, if number of servers you are increasing, you have to include that into the target group. You have to add it. So I'll just say here, include as pending below. You can see here both the servers are now part of the target group. So we had created 2 servers which are hosting our static website, and now we have to divert the traffic from load balancer to the target group. And the target group, anyway, we have registered our servers which are hosting our websites. Okay, now I just have to click on to the next here. All right, and that's all. I'll say here created. So now target group has been created, and inside this target group we have to register targets. You can see registered targets are two servers have been registered. Now I'll get on to a load balancer and create a load balancer. Of course, the application load balancer, and name of the load balancer, let's go with, maybe I'll say here telescope load balancer, right? Internet facing internal. This load balancer, is it for the internal traffic between multiple services within, right? Or is it internet facing? Of course, it is internet facing only. Okay, so I'd like to go with this and default VPC, and I want this to be available in maybe South 1A zone and 1B zone. In Mumbai region, 3 zones are available. Every region will have multiple zones, and in the Mumbai region, we have 2 zones available. Maybe my instance are in either 1A or 1B. I'll just say here how much of an instance we have in any of the zones of Mumbai region, my load balancer should be able to access them. Okay, so I'll make it available in all 3 zones of Mumbai region. All right. And do you want to use a default security group, or do you want to add something which is already available? It's up to you. Let me go and add the existing which is already available. Okay, wherein we have some inbound rules. You can add up to 5 security groups here. Okay, so that's fine. Forward to the target group, right? So I'll just go back here. We have a server target group which we have created. Inside this target group, our servers are registered. So I would like to just add on to this. Okay, now that's all. I would like to just scroll down. I'll say here create a load balancer, and it is asking me to give a proper name. All right, I'll say here Telesco load balancer. All right, I just again click on to create the load balancer. So load balancer will be ready within no time. Okay, all right. As you can see here, it is provisioning. If I refresh, it should be ready. Now you have to access the application not by reaching out to the public IP like the way earlier in the series we have done it. Will not be reaching to application through a specific server. We may have right now 2 servers. It could be 10 servers where our application is hosted. We may have 20 servers where our application is hosted. We are now reaching to the load balancer URL, and load balancer will forward to the target group. Inside the target group, how much ever servers are there, traffic will be equally with the technique of round robin technique. Equally traffic will be distributed to all the servers. Round robin technique we have seen. First we'll go to this, second, third. If there are 3 servers, again 4, 5, 6, 7, 8, 9. Equally the traffic will be diverted to all the servers. Equal load will be distributed. Again, if I have to refresh within some time, it should be ready. As you can see now, after some time, it is now active, right? You just have to take this DNS name which we have here. I would like to copy this, get onto the browser, and I'll just paste it the moment I hit this. You can see welcome from the Telesco server number 1. I would like to just refresh it. Server 2, server 1, server 2. You can see equally load balancer is diverting the traffic into 2 servers, right? 1, 2. The load is not distributing, or load is not just going to only 1 server. There is no burden. So if there are 2 servers, equally traffic is diverted or distributed to 2 servers. If there are 10 servers, it will be equally distributed to 10 servers. 20 equally it will be able to distribute to 20 servers here. And load balancer and servers, they have not directly configured. We have registered our servers into the target group, and from load balancer to target group, and target group to the servers, or you can say whatever servers have been registered inside the target group, traffic is flowing there. I hope you could able to see the demonstration of this load balancer. Now we need to understand the concept of auto scaling, why it is needed, right? More onto this automatically once you get into the world of Kubernetes, you'll understand how actually in the production, how we increase the number of pods and all. But at this stage in EC2, we have an option of auto scaling group. What exactly it is, why do we have to know about it? You need to understand, right? Imagine your application is deployed in 3 servers, and with the help of load balancer, equally you're dividing the traffic into 3 servers. That is fine. Suddenly, if number of users increases, wherein 3 servers are also not sufficient, maybe the traffic is huge, right? In that case, will DevOps engineer at the time when the traffic is at the peak create the servers manually? The answer is no. Imagine one more situation wherein suppose there is a big occasion and you are expecting so many concurrent users coming to your application, and you have prepared the servers in advance. You have done all the infrastructure preparation, and you have got 100 servers, and your application is deployed and everything is ready, but the traffic which you are expecting did not turn up. Something happened, natural disaster happened, or some other thing happened, right? And the traffic which you were expecting did not turned up. Do you think it is a waste of the resources? You have prepared all the 100 servers, you have created, you have deployed your application, you have multiple instances of your application, but that is not getting used. So much of loss, right? And suppose you were not expecting some traffic, you have prepared some 5 to 10 servers, but suddenly there is surge in the traffic. traffic. Then again, will you create the servers manually? The answer is no. Here is where auto scaling group comes into picture. It is a way wherein you can automatically increase the server and automatically decrease the servers based on the traffic. If there is a sudden surge in the traffic, automatically number of servers will be increased, and if there is no traffic, automatically number of servers will be decreased. And you have a decision making authority wherein you can decide how much it should scale up to, what should be the configuration of those servers, and how many minimum servers must be there for your application. All that control you will be having it, right? So in the EC2 we have an option of you can see here auto scaling group. If you click on to auto scaling group, right, so you can see here Amazon EC2 auto scaling helps maintain the availability of your application. Auto scaling groups are a collection of Amazon EC2 instances, right, that enables automatic scaling, fleet management features. These features help you to maintain health and availability of your application. There are many advantages also associated here. You can see at the time of you creating the auto scaling, you can decide minimum how many servers must be there to host your application, and if in case if there is a traffic, how much it should scale up to. You can have that, the last maximum number of server maximum size you can decide, like maybe up to 100 it should scale, or up to 10 you have to scale. What should be the desired? Keep it this much. This is what I am expecting, and as and when traffic increases, you please increase, and if there is no traffic, you can just at least keep this much of size. You can decide that how much should be minimum, how much you are desiring to keep the servers for your application, and if there is a traffic, how much it should scale, right? So there are many advantages associated here. You can see number one is a fault tolerance. Detect when an instance is unhealthy, terminate it, and launch an instance to replace it. And then we have a cost management. Save money by dynamically launching the instances when they are needed and terminating when they are not needed. Like unnecessary, you're not just creating 100 servers and keeping it ready by having expectation that more traffic might fall, right? You need not to worry on this. If there is no traffic, there will be less servers will be used here. Okay, if there is a traffic, then the servers will increase. And availability ensures that your application always has the right amount of capacity to handle the current traffic demand. You should not worry about the traffic, so it will be taking care of it. So if the traffic increases, it will increase the servers. If it decreases, it will only decrease the server with the fault tolerance feature, which is very, very important. Practically also we may have to understand here, right? So an auto scaling group is a collection of EC2 instances that are treated as a logical unit. Okay, we can configure. And we may have to now see the practicals, how load balancer, target group, and this auto scaling group works together, right? And what exactly we can configure, we will see in the next video. I hope you have already seen what is target group, what is load balancer. Now combining these two and with the auto scaling group, we may have to see the demonstration before we proceed further. Now let's see some demonstration with respect to the auto scaling group, right? So I would like to just click on create auto scaling group, right? It is asking me the name. I'll say here maybe Telescope auto scaling group. That's the name I have given here. Launch template, very, very important. You can see here, choose a launch template that contains the instance level settings such as AMI, Amazon Machine Image, instance type, key pair, security group. So whatever instances it has to create in order to increase if there is a traffic or decrease, those instances configuration it is asking us to define with the help of a template here, a launch template. You have to give the template just in case if you want to increase the traffic. If something happens to one server, if it is crashes, it has to recreate that, right? Fault tolerance. If it has to recreate, what should be the configuration of that instance? We have seen while creating the instance types are there, different configurations are there with respect to CPU, with respect to memory, with respect to storage, right? So we have to define here, create a launch template. I would like to click on to this, right? And let's create one. I'll give the name of this, let it be servers, okay? And description, I'll say servers. And please here, provide guidance to help set up launch. It's okay, even if you don't add this, that's totally fine. Okay, not a problem. Fine. So I would like to just quickly get into the quick stacks. Let it be don't include in launch template. If you want, you can define which Amazon or which Linux system you want here. If not, don't include. It will only decide with respect to the versions here. And instance type, maybe I would like to go with the t3.micro. You can see, you can choose. For the free tier account, we have limited access. For a normal account, you will have entire access. So I would like to go with maybe t3.micro, that is sufficient here. Okay, and let's go with Amazon only, tt.micro. And key pair, if you don't add, you'll not be able to log in, or maybe you will not be able to connect to that instances which will be created by auto scaling group. If you want to get connected through SSH connection, then you have to choose the key pair, because the security key is required. I'll just choose it. Okay. Now coming to the subnets and networking, anyway, very soon about the VPC and subnet you'll understand. VPC is a whole network, subnet is just part of this. If VPC is your entire home, subnet is one bedroom, one part of your home, which eventually you'll understand going forward. So I would not decide by myself. I will let my VPC decide which subnet it has to go with. Okay, I'll not decide it. Okay, and zone also will not say which zone. If you want, you can specify 1A, 1B, 1C in Mumbai region. Inside the Mumbai region, which zone you want your instance to be. I would like to give that authority to auto scaling group. Let that decide. Okay. And do you want to use existing or create a new security group? I would like to go with the existing security groups. We have multiple, right? AWS security group we have created earlier, and you have seen that already. If in case if you want to give some HTTP access, then please watch that first. We have done that already. And their traffic, inbound traffic, we have already enabled HTTP traffic. Okay. So if there is any application which is launched inside this instance, that can directly access through the browser, because the security group which we have attached to that instance already has HTTP traffic. Inbound rules we have already enabled. We have seen earlier in this entire series. Okay. So you can see here, the add a new volume. By default, it will go with the default volume, it seems. Let it choose a same. Okay. And you can see here, AMI volumes are not included in this template unless modified. If you want, you can add this volume. Okay, you can define which volume you want, how much GB you want. It will be able to take the decision. Okay, and it is volume 2 which is custom, and we have volume 1 which is the root by default. So this will be there. I want to go with the root. I don't want to add something new. By default, it is going with 8 GB root volume. That's fine. So advanced detail, I would like to just add the EC2 part, which we have seen, user data part, wherein it is just launching one static website. Okay, welcome from auto scaling group. I would like to just add one custom message, Telescope learning. Okay, just to show you the demo, I'm launching a static website at the time of launching this instance, right? So that's fine. Now I would like to just click on to two volumes are there here. One volume is more than sufficient for me. So I'll just go up, and I don't want the second volume here. I'll just remove it. Okay, one is more than sufficient. I'll say launch template. Let me click onto this. It will be launched. Template has been created. Now I'll go back to auto scaling group. I'll just refresh. I'll have an option. You can see Telescope. We have servers. One more is there, which is with respect to Kubernetes cluster, which I was experimenting for the live class anyway. Servers, I would like to just add this. Okay, I have added, and it is giving you the details. That's fine. I'll say next. And you can see which VPC, which network you want all of this to happen. I would like to go with the default network. I know many times we have seen VPC. We will understand it is the most important concept. Anyone who's getting into the world of cloud or DevOps, networking plays very important role after the Linux part. Okay. So now default network, every region there will be a default network on which all the resources will be by default created. But the real world, every time we want to create any resource, we create our own network. We define the subnets, internet gateway, NAT gateway, then we choose. So we have not yet seen yet. So I'd like to go with the default option, which we have right now. Don't worry much on this at this particular stage. Default network availability, select the zones. Okay, let's go with 1A, 1B, 1C, all the zones. Let it create. And here we can see it is new. Earlier it was not there. It is new feature. What is that? Auto scaling automatically balances instances across availability zone of a region, Mumbai region. If launch failures occur in zone, select a strategy, which strategy you want to follow. Okay, balance best efforts. If launch fails in one availability zone, auto scaling will attempt to launch in another healthy availability zone. We'll say, okay, you go and launch. I have no problem because I have enabled all three zones here. If you are very zone specific, then you have to go with balance only. In sense, if something is not creating in one zone and you want it to retry in that zone only, you don't want auto scaling group to be trying in the other zones, then you have to go with the balance only. But if something goes wrong in one zone, I'll allow my auto scaling group to launch my instance in any other available zone, no issues there, right? So now I'll just click on to next. Okay. Do you want no load balancer right now? Attach the existing load balancer. In the previous video, whatever earlier we have seen, right, load balancers and target group, that has been deleted. Okay, me at the time of recording this, I don't have anything. Attach a new load balancer or attach the existing one. I'll go with attach the existing one, and I'll go back to EC2. Right now, I'll go back to my, you can see here, target group and load balancer. We don't have anything right now. I'll just go back and create one target group. And we have seen earlier how to create a target group. So that shouldn't be a major matter of concern. Okay. So I'll just go back and say Telesco target group, right? I don't want to add any health check protocol for now. That's fine. Default VPC. That's beautiful. And I'll just say here next. And right now there are no instances. Later also we can attach, not a problem. I'll just say here next. I'll say here create the auto scaling group. That's fine. Now I'll go back to the load balancer. And of course, create a load balancer. I'll say create the load balancer. And I'll say here maybe Telesco load balancer, whatever name of the load balancer you want, you can give. That shouldn't be a problem. So availability zone, since all my instances I have enabled in the auto scaling group to be available in all the zones, I'll just tick mark here all. And the traffic group, let's go with AWS SD, because here I have already enabled the HTTP SSH traffic. Earlier we have done that. If not, you can create a new and add the security which you want. We have seen about the no security group earlier in this series. Okay, so that's fine. And forward to the target group, I'll just refresh. We already have a target group, that is for target group. I have added this. Wonderful, no problem. I'll say here create a load balancer. Within no time it will be ready. If you just wait for 1 minute, the status will be active. As we know, it will be active within a minute or 2 or 3. That's fine. We have already created, right? I'll go to attach to an existing load balancer. Choose from your load balancer target groups, which we have already configured, right? I have attached this, and let it be default now. I don't want to go with any custom configuration here, right? Enable the zonal shift. Anyway, we have given the strategy there. That should also be not a major matter of concern. I'll just click on to next. Now, what should be the desired capacity here? I want to have at least 2 servers. Minimum, if there is no traffic at all, at least 1 must be there. And maximum, I'll go 4 if there is any traffic, or maybe you can go with 10, or you can go with 15. That shouldn't be a problem. Okay. So maybe I'll just go with 4 at this stage. Desired 2, please create 2. Okay. Minimum at least 1 should be there, and maximum 4. Even if there is a traffic, it will not go beyond this. You can also attach the CloudWatch and stuff, but we will be learning about the CloudWatch going forward in this series. Okay, so now no scaling policy used by yourself. I don't want to add this. And we have instance maintenance policy. Launch before terminating. If something happens to an instance, right, if something happens, it crashes, do you want to launch new before terminating, or terminate and launch at the time of scaling it, or maybe scaling in, scaling out? What is the behavior, what is the strategy you want to follow to maintain your instance? I'll say no policy, mixed behavior. What is required, you take the decision. I'll allow my auto scaling group to decide. Okay, for rebalancing events, new instances will launch before terminating others. For all other events, instance terminate and launch at the same time. So let's go with this for now. If in case any requirement you have, you can go with the options which are available here, right? So now I would like to keep the things default. Okay, I'll say next, I'll say next, I'll say next. And now I would like to create it. Before I create, again, I'll just recheck this. By this time it is active, right? And now I would like to say create auto scaling group. And also would like to show you the instances. When I created, there are no instances here, right? But within no time, you will see instances are getting created, because we have told desired capacity 2, right? I'll just zoom out this. You can see updating the capacity. Okay, desired 2 of them are healthy. I'll just go back here and refresh this. You can see 2 of them. I have not created manually, right? I have attached in the auto scaling group as a template, and auto scaling group created these instances. Now I hope auto scaling group has also created the load balancer. We had created, but we had attached that, right? So I'll just go back here. I'll say refresh, and I'll just get into this. I'll just take this DNS, and I'll just try to access my application. I'll just paste this and hit this. It will take some time and it will be configured. Let's wait for a minute. As you can see now, welcome from the auto scaling group server Terisco learning. I can see it is, I don't have any example because at the time of launching we had given the same user data. So it is there in both the servers here. Okay. And also I would like to just show you the fault tolerance. If I have to go to the instances, you can see right now we have two instances, right? I'll just take instance number 1 and I'd like to just go back to my instance state and I'll say terminate it. I'm just deleting it. Okay, something goes wrong here and it is shutting down. But if I just go back here, still my application is accessible because we have multiple instances available, right? And you can see even if something goes wrong to one server, but my application, my end users are still able to access. And also I'll just refresh it. We'll be able to see one more thing. Okay, it is shutting down. As you can see, after some time, I have not created it. Automatically after this is terminated, it is creating new one, fault tolerance. It will only create a new instance if something goes wrong to one instance, because the desired capacity I had told is 2. You can increase that also. Later stage also, you can get into auto scaling group. And this is what we have done earlier, right? I just get into, maybe you can see edit, and what is the desired capacity you can define here. Maybe desired capacity is only 1. You can increase this later also. Maybe initially you thought 4 would be maximum sufficient for my application. Later you wanted to change it to 10, 20, and desired maybe you want to change to 5, 10. That's totally fine. You can edit that at the later stage also, and it should not create any problem. Okay, fault tolerance also I hope you could able to see here. And of course I cannot get more traffic into my systems, and I cannot actually increase number of servers at this stage. But going forward, in the concept of EKS, Kubernetes and all, you'll be able to understand how auto scaling happens when it comes to increasing the number of pods and all. But I hope fault tolerance and how auto scaling group, load balancers and target group together working here fine. And more on to this anyway, you will understand going forward. And one more important part is that after everything is over, please do delete auto scaling groups, load balancers also. You can go to the EC2 dashboard. If you refresh here, you will have an overview how many instances are currently running, elastic IPs, how many of them are there, which is very, very important. You have to release that, you have to delete that. Okay, so delete the load balancers, target groups, instances after your practice is over. It is a good practice because anyway it is not your production. You may be having a practice setup, so make sure you delete all the resources when it is not used after your practice is over. Now we need to understand one more very important service, which is S3, Simple Storage Service, right? If you want to store images, videos, maybe PDF, some files, folders, or it could be application logs at scale without worrying about the size or amount of data, then we have to go with Amazon S3, right? So storage, Amazon S3 store and retrieve any amount of data from anywhere. Amazon S3 is an object storage service. Everything in S3 will be stored as an object. Your video, audio, or maybe your profile pictures, images, files, application logs, whatever folders you're storing, that will be considered as an object, right? And here also you can see very important part. Every object in S3 is stored in a bucket. To upload files or folders to S3, you will need to create a bucket where the objects will be stored. So in order to store any files or folders we have at any scale, you can see here, very, very important part. You can see it offers industry leading scalability, data availability, security, and performance. And here, store and retrieve any amount of data without worrying about the size. Whatever files you want to store, which will be stored as an object in the S3, we have to first create the bucket. It's like a container. Once we create the bucket, inside that bucket, we can upload our files and folders. We will understand practically eventually, right? And we can see here with S3, there are no minimum fees. You only pay for what you use. Prices are based on the locations of your S3 buckets, right? Based on the data which you're storing, how much of the data consumed, and also there are some storage classes here. Depends on which storage class you are going to use. The payment will be in that, and based on the region here. Though you have to create the buckets at the region, it is regional specific. But at the time of you creating the bucket, you have to give a name which is unique globally. Across the globe, the name should be unique. but you have to create this bucket in a specific region. So data will be stored in a region, but for that name, whatever you give, it has to be, globally unique, right? And you can see here, there are many benefits, associated. Also, you can go through the official document: data performance, durability, security, compliance, the auditing, right? Flexible storage option. And you can see customers of all sizes, industries can store and protect any amount of data virtually, any use case such as data lakes, cloud native applications, mobile applications, right? With cost effective storage classes. We will have different storage classes based on your need. You can decide which storage class you are going to go with, right? And some of the use cases, it has given you a backup and restores, okay? And archive, hybrid cloud storage, data lakes, big data analytics, disaster recovery. So many benefits are associated with it, okay? So let's try to create one bucket. So basically, if I have to give a bottom line, it is a place wherein we can store the data without worrying about the size, without worrying about the scalability, right? And which could be easily managed. Generally, in the real application, all the videos, images, application logs will be stored in the S3 buckets itself, okay? Now, I would like to just go and create one bucket here. All right. So general purpose or a directory, you can see here, recommended for most use cases and access patterns. General purpose buckets are the original S3 type. Okay. So it will have, you'll be given the option to go with the different storage classes, and the bills also you may have to pay based on the storage classes itself. Okay. And bucket namespace, right? So global namespace, by default, S3 creates general purpose buckets in the global namespace. Global namespace in the sense the name has to be unique globally. Okay. I would like to give a name of a bucket. Maybe we'll say telescope, and I'll say here 1, 2, 3, 4, 4, 3, 2. It has to be unique globally. No one has created this name globally. Only then I'll be able to create it, right? So now copy settings from the existing bucket. If you already have a bucket and you want to take all the settings which you have already done, you can copy, but I would like to give it as it is. And then you can see here object ownership. So ACL disabled, recommended, ACL enabled. So ACL, it is access control list here, right? So who is going to control whatever files you're going to add here, this bucket, who is going to control? If you disable this, only you will have, the owner of this account will have access to his buckets. Outsiders cannot do anything with it. They cannot modify, they cannot delete or do anything, right? So control ownerships of objects returned to this bucket from other AWS accounts and use of access control list. Object ownership determines who can specify access to this object. If you enable this, other people can also access it, but I have disabled, which is recommended for now. Okay. So buckets owner enforce. Great. Now you have to block all the public access, block public access to buckets objects granted through new access control list, any access control list. No one can access. The owner of this account only can modify and access this entire buckets. I have given block all the public access here. Now we have bucket versioning enabled here. You'll understand eventually. Maybe going forward, you'll understand this, but by default, it is disabled. And bucket key, by default, it is giving you using an S3 bucket key. By default, the encryption type, it is choosing server-side encryption with Amazon S3 managed keys. Okay. Server-side encryption with Amazon AWS key management service also available, or dual layer is also available. I would like to go with the server-side encryption, which is by default, it is only choosing it. Okay. So you can see here tags right now, it's optional. Versioning I have disabled. What is that? You'll eventually understand. Okay. Object log, by default, it is disabled. You can see here store objects using write once read many model to help prevent objects from being deleted or overwritten for a fixed amount of time indefinitely. Okay. By default, it is disabled. We will try to talk that also. For now, these things I have kept it default. I have blocked the public access. ACL, the access control list is disabled, right? Only this account can access it. It is general purpose, and I've given the name globally a unique name. And now I'll just create bucket. Okay. So now bucket is created. Inside this bucket, you have to store the data, whatever the data you want. You can see we can create a folder. Inside the folder, you can add the data. That could also be done. Or you can just directly upload. No objects in the sense your video, your images, your PDFs, your, everything will be considered as an object here. Right now, there are no objects available. You can see we have a metadata. Later also we can configure this. We'll have an option. You can see by default, we have gone with bucket versioning disabled, right? We have an option of editing this. Okay, going forward, we will try to understand. But for now, I have kept everything default only. I have just created a bucket, a container. Inside this bucket, I'm going to upload the images or videos or anything, right? So let me click on to upload. We can see here next page, it is asking me, do you want to add a folder or just a files? I would like to just add a files here. And I have multiple options. I'll just add the live class notes here just for the demo. Some files I'll add. Okay. So I have added the notes. That's all. Nothing more here. All right. And you can see the size. It is a text. It's not a folder. It is normal file. And I'll just click on to upload. Okay. It is uploading. Now it has been uploaded. All right. I'll like just close this. It's done. And inside this bucket, we have one bucket. You can see this is the bucket, and inside this bucket, and this bucket also observe it is in the Mumbai region. Great. And I'll just click on to this. And you can see this is the bucket, last modified size storage class. By default, I have gone with the standard. Little more on this I'll talk. Okay. And the type of the file which I have uploaded is the text file. So I would like to click on to this. And if you want, you can access right now, but I have disabled the public access, so others cannot access except me. Whatever I want, I can do it. And bucket version by default, it is disabled. What do you mean by that? Right? So what exactly happens if you disable the versioning is, if you upload a new file here, whatever old file will be there, it will be overridden by the new file which you have uploaded. You will not have option to keep multiple files, multiple versions of same file, rather I would say, right? So since it is disabled, if you upload one more file, I mean the one more version of the same file, it will override the whatever file which is already there here. We will understand. So what we have done right now is we just created one bucket. Inside this bucket, we just added some files. We can create folders, you can add folders also, but one text file I have added to start with, right? Now let's understand more on to the S3 buckets, right? Now you can see we have added one file. Doesn't matter which file you have added, PDF file, text file, or video file, or image. See, by default, at the time of we creating this bucket, the versioning option we had, which was by default disabled, and we had kept it as it is. Versioning here referring to keeping multiple versions of the data which would like to store it in this S3 bucket, right? So we have one Jenkins CI/CD v3.txt, one notes I have added. Now I would like to do one thing. I will say here upload, okay? And I'll say please add some files. I would like to add the same file once again. So I'll just go back to my Jenkins CI/CD v3. I'll say open, all right? I'll say upload here. The moment I say upload, it is succeeded. And now I'll just go back here, close this of course. And if I just refresh this, you can see we have only one version. It is giving you the new name, new time here. Same file, if you have re-uploaded, it will by default override the existing file of the same name which is available on your S3 buckets. So if you want to keep multiple variants, multiple versions of a specific file in your S3 bucket, then you have to go back and enable the versioning here, bucket versioning. Not just that, even if you want to apply the object lock here, by default it was disabled. At the time of you creating the bucket, we had an option to go with the object lock, which was by default disabled, and we had kept it as it is, right? So see here, object lock here, store objects using a write once read many model to help you prevent object from being deleted or overwritten for a fixed amount of time or indefinitely. Object lock works in version buckets. If you have enabled the versioning to buckets, only then you can create this object lock. By chance, at the time of bucket creating, if the versioning is off, you have disabled, then you cannot go and make the changes to object lock here. So what I'm going to do here is, first I'll go back. So see here, buckets, in the bucket objects we have, you have to go to the properties. The existing buckets I'm making changes. I'm not creating a new bucket here. Okay. So bucket versioning, I would like to click on to edit here. I'll say enable. Okay. I'll say here save. You cannot disable, you just have to suspend. Disable option is not there, suspend option is there. Now I have enabled this, right? So bucket versioning is enabled. Since it is enabled, I would like to just show one thing. One more time, same file I would like to upload here. Okay. See, I'll say here add files, and I would like to add the same file here, right? So I'll just click on to this. I'll just say kindly upload it. I have uploaded. I'll just close this. And now if I refresh, you can see here, if I just click onto this, we'll have multiple versions of this. You can see versions. You have two versions here, different timings. I hope you could able to understand here. You can see versions are two here. And then again, if you go to the permission, of course, at the time of we creating, we had given only the owner permission. Owner can read and write. Owner only can read. The others, we have not granted the public here, public access to this particular bucket, right? So also you have an option here by default show versions. Earlier it was not there. After you enable the versioning, you'll have an option of show versions. If you click onto this, then you can see we have two files of different versions. It is a way of maintaining multiple variants of a specific file into your S3 storage, just in case if something is deleted. If you want to know about the old data, then you have to go with this. By default, versioning will be disabled. If you re-upload the same file once again with small changes, then it will override the existing file which is already there in the S3 bucket when the new file is added. Okay, different files you can add it, but the same file name, same text file you cannot add once again, because by the name, same text, it was already there. Once again, if you upload, it will overwrite. But if you want to keep multiple versions, you have to enable the versioning here. And after that, if you go to this properties again, we have an option of object log. Let me just click on to this, right? So object log, I'll just click on to edit and I'll say enable here. Permanently allow objects in the bucket to be locked. Additional object lock configuration is required in bucket details. After, you can see here, bucket creation to protect objects in this bucket from being deleted or overridden. Default retention disable, automatically protect new objects put into this bucket from being deleted. I have by default disabled this with respect to retention. I'll just click on to acknowledge, enable this. I acknowledge that enabling object lock will permanently allow objects in this bucket to be locked. I'll just save this. I've come back here and you can see show versions. Again, the multiple versions are already there by default here. So I'll say properties again. We have made the changes. You'll be able to make the change to this object lock only if it is version. Since it was version, you could able to maintain multiple files, then easily I could able to lock it. Okay, I have in between tried to add multiple files again just to for the demo, which is not recorded here. You can see we have multiple options available here. Delete marker one, I had just tried to delete it, but anyway, we have multiple versions of this available here. I hope you could able to understand with respect to the permissions and the object lock. I mean, with respect to bucket versioning and the object lock here. And also, if you just scroll down, we also have an option of transfer acceleration. Use an accelerated endpoint for a faster data transfer. If you just click on to learn more, okay, and you can see configuring fast secure file transfer using Amazon S3 transfer acceleration. So what exactly it is, you can go through this official document. At the time of you watching, you can pause this video, you can navigate here. Amazon S3 transfer acceleration is a bucket level feature that enables fast, easy, secure transfer of files over long distance between your client and S3 bucket. Depends on maybe the S3 bucket is there in the Frankfurt. I'm right now in India. I want to upload very fast, right, in the different region. With the long distance with your client in S3 general purpose bucket, then you have to enable the transfer acceleration here. Okay, so right now there is no much difference between me and the location, so I'll not enable this. By default it is disabled, so you can keep it disabled only. Okay, but just in case if you want a faster upload or data transfer of the files into S3 bucket, then you have to go with it. So if you ask me in the real world scenario where S3 buckets are used, right, if there is a database and in that application, if there are images, if there are videos, right, log files, all of them we will not be keeping in the databases. Generally every application will have a database, right, and also it will have a storage. Of course, S3 bucket is not the block level storage like the way we have the EBS volumes, right? Here it is not a block level storage. And also it is not a database. So we will not be storing your videos, your images and application logs and all of that in the database. We'll be storing in the S3 buckets only, and it is scalable. You need not to worry about the size. Any amount of data you can just add into this particular bucket. So you have to create a bucket, you have to add it. Fine. So this is all about the fundamental with respect to the S3 bucket. And if you're not going to use it, you can just delete this. Before delete, you have to empty your buckets. When you're deleting, you have to empty. And once you could able to empty, only then you will be able to delete it. Okay, I'll just say permanently delete. I'll say empty. It has removed everything which was there here. And now I'll just go back to my bucket and I'll say here delete this. Okay, you just have to give the bucket unique ID which you had given, globally unique name. You just have to delete this. Okay, I hope you could able to understand fundamentally. Now we have seen how to create a S3 bucket and how to store objects inside the S3 bucket, how to upload everything inside the bucket will be considered as an object, and how do we work with it. Versioning, object log, that also we have tried to understand. Now we have to understand little important key points with respect to the S3 buckets. You can see here. Of course, if you go to the official document of Amazon S3, so you can see Amazon Simple Storage Service. S3 is an object storage service offering industry-leading scalability, data availability, security, and the performances. Millions of customers of all sizes, industry store manages, analyze, and protect any amount of data. Okay, so that's fine. And there are some important key features here which you can see. Scalability, the most important. You can store virtually any amount of data with S3, all the way extra bytes with an unmatched performance. Okay, S3 is fully elastic, automatically growing and shrinking as you add and remove the data. There is no need to provision storage or pay only for what you use it. And durability and availability, you can see here the most important part. Amazon S3 provides the most durable storage in the cloud and industry leading availability based on its unique architecture. The most important, S3 is designed to provide 99.999 11 nines data durability and availability by default, backed by the strongest SLA in the cloud. And since S3 is the regional, so in the region, all the zones it will be available. Even if something happens to zone, so the other two zones, the data will be available, the bucket will be available, and people can able to fetch and access the data. And it is a regional basis. Okay, in one region you will be creating it, and in the region, of course, multiple zones will be there by default. You know this by now. If you have reached to the this level of lecture, you are aware that every region will have multiple zones. So if there are 3 zones here, if something goes to the first zone, it will be maintained in the multiple zones. So you are still able to access the data which is there inside this bucket. Okay, that is the reason it is giving you 99.99, the 99 percentage of guarantee with respect to the availability of the data here. Very, very important here. Okay, and then we have security and data protection. Then we have lowest prices and highest performances. There are other associated key points which I would like to highlight here are, if I have to just scroll down, you can see here S3 is an object storage, which files are stored as an object inside a bucket. Done. Bucket names must be globally unique. No two AWS customers can have the same bucket name. If I have given any name to a bucket in the entire world, globally, no one can give a name to the same bucket, right? S3 is regional. Of course, we have seen this. A bucket is created in a specific AWS region, Mumbai, Singapore, or any region, but the bucket name is globally unique. So buckets are regional, but the names is globally unique. That's the difference here. And maximum object size, one file which you're adding into the S3 bucket can go up to 5 terabyte TB, 5 TB. Okay, a single object can be up to 5 TB. But for a larger file, more than 5 GB, we use multi-part upload parallelly. It will be considering as multiple files, and the one file finally will be uploaded, which can go up to 5 TB. Okay, and of course, the last but not the least, S3 provides high durability and scalability. AWS automatically manages storage, replications, and scaling, making it highly durable. 11 nines, 99.9999, and virtually unlimited in capacity. There are many benefits. These are just a few key points associated with it, which are there with respect to S3 here. And alongside that, if you also look into the storage classes, very important again. Okay, I'll say here more storage classes. It decides at the time of you creating a bucket, you have to also choose which storage class you would like to go with. Okay, based on the performance and your requirement. We have multiple here. You can read one by one, open all, or you can just read one by one. Example, S3 standard IA is for data that is accessed less frequently but requires rapid access when needed. Okay, every storage class has a specific use case here. If I have to scroll down again, performance across the S3 storage classes, we have the common storage classes here, and official document it is. Okay, you can see aws.amazon.com s3 storage classes. If you just get into this storage classes, if you scroll down, you will have a chart which you can go through in your free time. Okay, use cases S3 standard, which we have seen, S3 intelligent tiering, then S3 express one zone, S3 standard IA. Then you can see here multiple options are available: Glacier Deep, Archive, Glacier Flexible Retrieval. So if each of these storage classes, it has its own advantages and own disadvantages. Okay, you can see the use cases here. Okay, general purpose storage for frequently accessed data, automatic cost saving for data with unknown or changing access patterns. This one, high performance storage, and you can see here the first byte latency with respect to latency, durability, availability. You can see here multiple options are there. You have to see and you have to decide which one is suitable for your application. You can go through this document. It is very important for anyone who knows the S3 bucket. I would advise you to also give a walkthrough onto this official document and try to understand with respect to different storage classes available here. By now, I hope you got a fundamental idea about what is Amazon S3 and how do we use it. So far, we have seen whenever we wanted to launch a static website, we wanted to host a static website, we have gone with the EC2 instance. We have seen that with the example of user data, or otherwise, we have seen we have launched a server, Linux server, then we have connected through the SSH, and then we have installed the Nginx server, and we had launched a static website by creating an index.html file, right? So can we do, or can we launch a static website without EC2 instance? The answer is yes. We have to go with the S3 buckets. We have seen the S3 buckets in order to upload some of the files, but this can also be used to launch a static website, right? To host a static website, you need not to worry about launching a server, security groups, nothing is needed, right? As you can see on your screen, I'll just click on to create a bucket. Okay, first we have to create a bucket for anything in S3, right? So the name has to be unique globally. I would like to give it as maybe Telescope website 1.2. That's the global name I have given for the bucket name. So ACLs by default disabled, very important. Now, since whatever static website which is going to be launched in this S3 bucket, I would want the public to access it, for which I have to, whatever this is by default tick mark, I'll say here, untick that, because I want public to access it. Anyone and everyone across the globe, they have to access my website, which I'm going to host in the S3 buckets. So if you say block all the public access, then people cannot access it. Okay, very, very important. And also you have to click on to I acknowledge that the current setting might result in the bucket and the object within becoming public. I want it to become public because I want people to access it, right? Now, by default, versioning is not needed. That's fine. So I'll just click on to create a bucket. Okay. Once the bucket is created, you have an option of properties, right? And if you just scroll down, we have an option of static website hosting. You can see here, static website hosting. Use this bucket to host a website or redirect the request, right? So I would like to just click on to edit. And if you just see here, static website hosting, I'll just enable. By default, it is disabled. Great. And now I have to tell the names of the file. One is HTML, index.html, error.html. These HTML pages you can generate using any of the AI tools, and you can keep it whatever website you wanted, whatever content you want inside that static website. You can keep it in your local folders using the AI tools, and you can just keep whichever folder you want in your system, and you can just give it index.html, error.html. Okay, and after which I'll just click on to save the changes, and then I'll just get back to my bucket here. Okay, again, and then we have an option here. Okay, so I'll just say object upload. Okay, and I just have to click on to add the files, and I have kept it within the website folder. I have created the index.html and error.html. Long back I had created here in some of my live classes, but I would like to use the same here. So I'd like to just upload these two files. Okay, index.html is uploaded, error.html is uploaded. Great. I just click on to upload here. This names I have given there also, right? Now after this is over, I would like to close this, and then again we have an option of permissions here. If you just click on to this, anyway, you can see block all the public access I have turned off. I want public to access this, right? And here in the bucket policy, I would like to add some JSON data which gives permission for public to access it. Let me add that. I'll just click on to edit and let me just paste this. And here you just have to give the name of your bucket wherever this name is. You can get this with the help of any of the AI tools, okay? Or you can just type it, anything is fine. And you have to give your bucket name here, right? So these are the JSON which gives the permission. It is a policy, okay? And I want people to access this public read policy, allow, okay? And anything, whatever files we have, everything should be accessible, right? So this permission I have given here, and I'll say click save. Once it is saved, it is done. Now you have to again get back to properties. And if you just scroll down, static website hosting, once you have enabled this static website hosting, you have an option of bucket website endpoint, right? You just have to copy this, or you just have to click onto this. I'll just click onto this, and you see there is co-learning, empowering minds through technology. So I could able to host my static website. Here I have not launched EC2 instance, right? We have not configured the security groups. We have not installed Nginx servers. All this we have done earlier. We have not done it directly with the help of S3 bucket. We could able to host the static website. This could also be one of the use case of S3 buckets. We have hosted a static website using S3 bucket. We created the bucket and then we enabled the static website hosting. We have done the configuration with respect to bucket policies, and also we have managed the public access settings, right? Now, what if there is an option wherein you can host a static website even more easier? First, we have seen with respect to EC2 instance. Then we have seen with respect to S3 buckets. Now, is there a way where we can host a website even without bothering about the bucket policies, without bothering about the public access settings? The answer is yes. Even more simpler you can do. Here is where the AWS Amplify comes into picture, right? Now I would like to host a static website, a basic, using the AWS Amplify. I'll just create a bucket with the help of AWS bucket. Also you can do it without AWS S3 bucket. Also you can host a static website in AWS Amplify, but I would like to go with the S3 itself, right? So first of all, I would like to create a S3 bucket here, a globally unique name. Of course, I'll say Telescore Demo 444, right? And of course, I'll just keep it everything, block the all public access, whatever the default things are there. I would like to keep it as it is. Versioning is also disabled, right? And I'll just create a bucket here. Okay, so bucket will be created within no time. Then if you just navigate to properties, we have to scroll down, and earlier we have seen that, right? When you see static website hosting, use this bucket to host a website or redirect the request. Also, there is a message here. We recommend using your AWS Amplify hosting for static website hosting. Okay, and by default it is disabled. I'll do one thing. I'll just click on to, maybe I'll just first go here and right. Let me do one thing. I'll just refresh this. Okay, and I'll just enable this. All right. And I would like to mention the name of the files, index.html and maybe error.html. Great. And I've just added these names. Later on, I'll just add those files. Okay, I'll just click on to upload, and like the way we have done earlier, add the files, and the same files I would like to upload like the way we have seen earlier. Let me add this file also. All right, I have added this. I'll say upload. It will be uploaded within no time. All right. Now again, I'll just get back to properties, and here itself we have an option of we recommend using the AWS Amplify hosting, right? For hosting a static website, I'll just click on to create Amplify application, right? It will navigate to a different page, and here we have an option here. So start a manual deployment. Okay, or if we just get on to this apps, see here. All right, we have a full here, deploy an application, start with a template. If I click on deploy an application, it will redirect to this page. Okay, start building with Amplify. I just go with deploy without Git. So without AWS S3 also you can do this, but I would like to go with AWS S3 here. So deploy without Git. Okay, I'll just click on to next, right? And now it is asking me to give the name of the application. I'll say here maybe Telescore Demo. That's the name I have given here. And you can see drag and drop or go with AWS Amazon S3. I would like to click on Amazon S3 because in the S3 bucket, I have already added the HTML static files. Okay, I would like to click on to this. And now it is asking me to give the name of a bucket. Okay, there is an option of browse. All right. So Telescope demo, I'll say choose this. Great. I'll say save and deploy. Okay. Deploying. All right. It is done. Deploying, you can see deployed. I would like to just click on to this and you're able to access. Unlike the previous video, we have not done any configuration with respect to bucket policies, right? Earlier, we had also done this with permissions. You can see here in the last video, if you have observed this, in the permission, we have added this. And also it was block all the public access. By default, it is on. We had disabled it at the time of bucket creation itself. We have not done anything here. We have kept the bucket defaults as it is, and we have not even added any policy. By default, AWS is only giving this policy. Okay, we just went to AWS Amplify, and now you can see the moment I click on to this, I could able to access my application. Not just this, it has many other benefits here. You can see here easily you can do custom headers, custom domains also. If you have registered any domain in the Route 53, we have not yet seen. Going forward, you will see that. Okay, easily you can map your custom domain also. There are many advantages associated with it. I'll just get into this again. And also you know very well, earlier also we have seen, if you have not enabled the versioning, if you re-upload the same file once again, it will replace the older file unless you have added the versioning. Since I have not enabled versioning here, I'll just open the index.html page. I'll make some changes here. Okay, so I'll say Telescope learning. I'll say maybe telescope.com. I'll say updated, a new website. Okay, telescope.com updated. I have given the message here, right? And I would like to just save this. Done. After saving, I'll just get back to my AWS. All right, I'll just re-upload. If you re-upload, automatically older file of the same name will be replaced. Okay, without versioning. That is the case earlier also we have seen it. I would like to just add this. I'll say upload. Okay, it will be uploaded within no time and the old file is gone here. Now again, I'll just go back here. Okay, with respect to properties, and you can see you need not to create one more time. You just have to go here, and again there is an option here, deploy updates. I'll just click on to this. Okay, and I'll say S3 bucket. Again, I'll say browse, and of course this is the bucket, right? Choose the prefix. I'll say save and deploy. Okay, so it is deploying. As you can see, it is deployed. I would like to now click onto this, and you can see Telescope learning, telescope.com updated. Okay, it is easier to update your static website also. No much worry with respect to the configuration changes. I hope you could able to see the demo with respect to AWS S3 and Amplify together, because at the time of we have launched the website with AWS S3, there was one option there that instead of using S3 bucket, go with AWS Amplify. It is more simpler because you need not to worry about the bucket policy. You need not to worry about the blocking the public access, nothing. Everything AWS will take care. I hope you had the demo. And also you can see here, when you just navigate to the documents of this, okay, you can read out if you want to know more on this. And when it comes to the pricing, you can see here for a free tier account, most of you may have a free tier account only. You can see free for 12 months. Great. And without a free tier account, pay for what you use, includes multiple sites per project and public SSL certificate at no additional cost. Okay, and you can see no cost up to 100 build minutes per per month. And if it is not a free tier, then also it is very minimal charges. They are not taking you much. But for free tier account, you have free access for 12 months. Actually, AWS Amplify is a way to host a static websites, maybe documentation website or portfolio website. Okay, they have made it very easy just to host a static website. I hope you have seen the demo. Okay, once the demo is over, for anything, please make sure you delete the resources. Whatever resources you are creating, it is not recommended to keep it once the demo is over. Now we need to understand one more important concept, which is related to databases. Database is a place wherein we store the data. All the modern applications are multi-tier applications, and every application you take is getting connected to database and storing the data, the orders, the customers informations, the courses information, whatever data be it, right? And when it comes to databases, we store the data in the structured format usually, and we call that as relational databases. In sense, storing the data in tables in the form of rows and columns. This is the header, and we have the data here, right? So storing the data in structured tabular format, we refer to relational databases. And also, instead of storing the data in one table, usually we create multiple tables and we establish the relationship between multiple tables and we store the data. If you store everything in single table, no problem, but it is very difficult to manage the data when it comes to retrieval or maybe updating the data. So what generally we do in the relational databases is we create multiple tables and establish the relationship between these tables, right? So basically storing the data in a structured tabular format in tables and establishing the relationship between those tables, what we refer to as relational databases. There are many popular databases here. We have MySQL, Oracle, right? So and so there are so many databases, PostgreSQL, using which we can store the data in the form of tables, right? Now Amazon also supports this service, okay? And we here call it as Aurora and RDS. So if you want to open this page, you just have to search for RDS in your Amazon, and we have managed relational databases service. You just have to click onto this, and you can see here relational database service. That's what the RDS means here. Amazon Relational Database Service, Amazon RDS, Relational Database Service, and Amazon Aurora are fully managed database servers that simply set up, operation, and scaling of relational databases in the cloud. See, managing the database is a difficult task, right? You have to take care of the networking, you have to take care of the servers, you have to install it, you have to configure, you have to worry about the backup, security. But AWS provides the managed database service on the cloud, wherein you need not to worry about it. So all the configuration requirement, all the backup, the security, AWS will take care. You just have to worry about your data, your application getting connected to this. You have to worry about the queries and the table. Whatever table you want, you can create it. Rest of the things it will only provide, right? So we have an option here, okay? And after which, if I have to get back to the databases, there is an option to create a database. I'll just click on to create a database. Okay, restore from the S3 or full configuration. I'll just click on to full configuration, and you can see here free plan has access to limited features and resources. You are getting one message. Since this account is a free tier account, you may have limited access. That's fine. Okay, so I would like to go with the MySQL, one of the popular one. Okay, let's go with it. Great. And here we have an option, full configuration. Do you want to control or easy create? Easy create, use the recommended best practices configuration. Some configuration option can be changed after the database is created. You'll have an option to make some changes, but most of the things what is required, it will only add, it seems. So instead of this, I would like to go with the full configuration, wherein I should have an option to do the configuration based on my need here. Now, when it comes to the free tier account templates, choose a sample template. Is it for production? Use default for highlights and fast consistent performance. Is it for dev or testing environment or free tier? Since we are doing for the free tier, we don't have an option to go with dev or testing environment or even the production. So I'd like to go with the free tier option here, right? If you go to dev or testing or production, you'll have an option of multi AZDB cluster deployment, wherein it will create multiple instances of your databases, and the uptime will be 99.95. I'm not sure if you can see. If not, while you're watching this video, if you could able to open this, you'll be able to read this properly, okay? Because since they have disabled this, you may not be able to see properly, okay? But for our free tier account, for the demo, single AZDB instance deployment, only one instance will be there. But in the real world, in the production, we always go with the multi-AZ, or we'll create multiple instances and backups of our database. Okay, now here also no data redundancy. That's totally fine. Okay, I'll just create one instance here, and if I have to scroll down, addition MySQL version you can choose. I would like to go with the default, which is by default enabling, and DB identifier instance name is I'll just go with the Talisco DB. That's the name I would like to give. Master username, let it be admin, not a big problem. And password, I would like to give something which is very simple. I've given the password. Of course, it is weak, but it's more than sufficient for the demo account. Password authentication, that's what I want to do it. And later on, we do have an option of the instance type. Okay, for a free tier account, we have limited instance. I would like to go with this micro. 1 GB RAM, 2 CPUs. That's more than sufficient for us to get connected. Okay. Storage purpose, again, we have multiple options here. I'd like to go with the default, which it is giving you. And 20 GB is more than sufficient. Don't connect to EC2 resource. From EC2 instance, if you want to enable the connection, you can just connect to an EC2 resource. Okay. Set up a connection. Even otherwise, later on, you can establish the connection. Not a big deal. Coming to the VPC, we will see that right now, everything so far we have created in the default network itself, right? If you want, you can create the network, which eventually very soon you'll be able to understand what is that VPC and subnets you have been hearing for most of the resources. I would like to go with the default network here, default subnet group, public access. Yes, generally, we create the database in the private subnet without the public access. Only application can access within one network. Outsiders cannot access. But for the demo, I have to show this. Going forward in this series, I'll be connecting this database to the application also, one backend application, maybe while I demonstrate the concept of ECR, ECS. Okay. I'll try to connect the database and an application and see how both of them are working together. But at this point, I'm just creating a database, which I will only try to get connected and do some operations here. Okay. So we will see that in the ECS in the AWS series also. Going forward, once we start to discuss about the Kubernetes in future, there also I'll just Kubernetes and Jenkins, we will see how the entire infrastructure also works together. But for now, I'm just creating one DB. In this AWS series, you will see how to connect to the application also. Okay. So public access, yes. VPC, choose the existing default we have. We don't have any other VPC. We have not yet created. Availability zone, no preference. Let it be available wherever it is. Not a problem. It's not required. Database insight standard, that's fine. When it comes to monitoring, advanced means it will be able to monitor everything, performance and all of that. But I would like to go with the standard. All right. So nothing more. I'll just click on to create a database. Okay. It will create the database. It will take some time to create this database. Okay. Meanwhile, what we can do is we can just create one EC2 instance. In this entire series, we have created the EC2 instance multiple times. Okay. Get connected to that instance so that from there we can make a connection to this. If you have any maybe MySQL workbench locally in your system, if you have installed MySQL in your local system, from there also you can establish the connection here. Okay. From the application, how to do it in this series going forward, I will try to talk on to this maybe once we discuss the ECS and all. Right now, at this stage, just go to the EC2, create one EC2 instance and get connected to that EC2 instance. And how to create EC2 instance, get connected, you will be able to understand that. So which version, if you ask me, fully I will not show because anyway you will be knowing it by default. We have seen that n number of times. Go with the Amazon only. I'll give here maybe as DB server or something as a demo, Amazon. Let's go with Amazon 2023. That's more than sufficient. And make sure you use existing or maybe create a new, not a big deal. Later on, whatever the security group is there, whichever it is, you have to also enable the inbound traffic for this MySQL database in order to get a connection between the EC2 instance and MySQL. Okay. So go ahead and create this EC2 instance and get connected. Let me do that. As you can see on your screen, I have got connected to the EC2 instance which we have created there. Okay. So my instance is up and running and I could able to establish the connection to my instance here. Before we proceed further, for your EC2 instance, get into the security group. And of course, whatever the security group you're using, I would like to just edit the inbound rules. And here, I'll say here, maybe MySQL. Okay. You will have an option of MySQL Aurora. Okay. So from any IPv4, from anywhere you can establish the connection. I'll say here, save this rule. This is very, very important. So there was an error in modifying. Let me just go back here. All right. And I would like to just again click on to save. Since it is already there here, guys, it is already configured, right? That's the reason it is creating an error. Let me just delete. Anyway, we have already configured MySQL and not just custom. I'll say any IPv4. Okay. I'll just save this. That's all fine. So make sure you also enable the MySQL here. Now again, I'll just get back to my RDS. Okay. And great. So it is running right now. Databases, you can see one instance is there. So we have one instance here. You can see here, guys, connectivity and security, how to establish the connection. It is only giving you this command. You just have to use this. Okay. Up to -p if you use, it is more than sufficient. Before you run any of this command from the EC2 instance, make sure, you install MySQL client in your EC2 instance, a client software to get connected, like the way MySQL Workbench is there. In order to get connected to MySQL server, we need to have a client software in our EC2 instance in order to get connected. If not, directly with the management console also set up EC2 connection, you can establish it. If not, manually, like the way we have done, we can do this. Now coming to the security group, here I'll just go back and I'll enable the traffic here. Okay, so I'll say here, of course, get into the security group. I'll say edit the inbound rules. You can be very specific, add the rule. Okay, custom also you can add, or maybe all traffic. I'll say here from where, from anywhere if you want, you can say, but it is recommended to go since I'm allowing all the traffic, it is not good security wise. So I'll just go back to my EC2 instance here. Okay, so let me just open this in a new tab. All right, so I'll just get back to my instances, and in my instances, of course, I'll just get back to my security group. All right, and let me just get into this. We have this security ID, right? I'll just copy here and get back to this, and I'll just specify this. Okay, so I'll save the rule here. Okay, all traffic from the EC2 instance will be able to get connected here. Okay, this is very, very important. You can see here monitoring logs or events. Okay, and configuration, multiple options we have. Connectivity and security, it has given some endpoints here. Using these endpoints, you can establish the connection. Now what I'm going to do is I'll just get back to my EC2 instance. All right, and I will just run one command to install MySQL client. You can see on your screen, I have added sudo dnf as a package manager. Install this. This is one of the client. Okay, you can use any of the AI tools to get this client software for EC2 instance. Okay, I'll just hit this. Within no time, it will be installed. As you can see, it has been installed. Great. Now I would like to just get back to my RDS, and we do have this, right? Up to -p, you can just copy. You need not to go fully. I'll just take this, get back here, and I will just try to establish the connection here. Okay, the moment I hit this, enter the password, the same password which you had given at the time of creating that, right? So I had given maybe admin123, simple one. All right, I'm now inside. I have got connected here. Now I'll just run some of the commands in order to create the database. Okay, so I'll just create the database. It is created. I'll say please use this database. These are the SQL commands, my dear friends. I'll just hit this database change. Right now, see, it was none earlier. Now we are inside this Telescope database. I'll just create one table here. Okay, within this database. Okay, this is the command to create it. So yes, it is done. Now I'd like to just insert the data. These commands I have got it from the AI tools, so you need not worry. If you know SQL, you by default know. If not, you can just pause it and type it. If not, you can get it from any of the AI tools. Okay, it is not a big deal at this stage of time. Okay, you have added this, and now I'll just check really if there is a data there. Okay, I'll just get back here, and if I say select star, you can see we do have a data. I hope you are all able to see this. We do have data. So we could able to create the database from our EC2 instance. We got connected and we could able to perform some operations here. Now, how the real application get connected to the database which is there on the AWS cloud? Going forward, we will see now also. Maybe in future at the end of this DevOps course, there also we will try to understand. I hope you could able to understand. Now, once the practice is over, as I have mentioned multiple times, since you're not going to use this often, make sure you delete this. Okay, keeping the resources which you're not going to use is not recommended. So I'll just go back here and click on to delete. I don't want to create a final snapshot. You know the concept of snapshot, right? It is talking about the backup. I don't want to have any backup because it is not a production database. It is recommended to have a backup, but I don't want. Okay, so retain automated backups. No, I don't want anything. I'll just say delete me because this was a demo database. Make sure you do this. Okay, so all right, maybe I'll just go back here. I'll say delete. I acknowledge it is deleting, and make sure EC2 instance also which you have created, if you're not going to use, please you delete this. Okay, so instance, and since we are not going to use this, I would like to delete. I hope you have seen the demo of RDS with respect to MySQL. Now we need to understand one of the most important concept which any DevOps or cloud engineer must know, which is virtual private cloud, VPC. So for all the resources which we have created, we have done that in the default VPC, default isolated network environment, which has been given to us by AWS. Whenever you create AWS account, by default, one default networking would be given to you, and within that network environment, all the resources will be created. But in the real world, we will not be creating our resources in the default network environment. We will be creating our own isolated network environment. We call it as VPC, right? So now we need to understand about the VPC. If you search for VPC isolated cloud resources, you can just click onto this, and you can also see here we will have an option to create the resources. Right now, whichever region you are in, by default you will be able to see one particular VPC here, which is the default network given to you. In this video, we have to understand about some of the important components, and throughout this entire series of VPC, we will understand and explore practically about VPC, subnet, internet gateway, NAT gateway, VPC pairing, route tables, security group, which we have seen earlier also. More on to that we will try to understand here, right? The difference with respect to IPv4, IPv6, that also we will try to understand. All the networking related components, or you can say VPC components, which plays very important role for you to start your journey with AWS resources, right? All the resources which we have seen so far, or which we are going to see going forward, whether it is RDS or whether it is EC2 instance or S3 buckets or any resource in that matter, we will not be creating the default network given to us. We will create our own VPC, virtual private cloud, and inside that we will be creating our resources. Fine. If I have to just click onto this, we don't have by default. You can see here we have a default VPC, and you'll also be able to see this, but we may have to create our own VPC. If I just click onto the dashboard, you can see we don't have anything by default. Some subnets are there. What exactly it is? Route table, NAT gateway. These things, these components are very crucial. We need to understand here. You can consider that a VPC is your own secure network within the AWS. If you consider AWS as the huge city, consider that every company is getting a secure plot, and that secure plot, or maybe a land or a region, you can consider as the VPC, within which we have to create all the resources here, right? So basically VPC provides a secure isolated network environment where we manage all our AWS resources. It is very, very important. And it provides the control over the network configuration, such as setting up the policies, or you can say managing the traffic rules, and also setting up the firewall policies and configurations, and so and so. Okay, we eventually will be able to understand moving forward as we see the practical. And if I have to show you pictorially what exactly these are, you can see this is your AWS. Within the AWS, we will be creating our network. Within the network, we will partition the network into multiple parts. Dividing your VPC into multiple parts, we call that as subnets. Right now on your screen, there are two things here: public subnet, private subnet. We can have multiple public subnet, we can have multiple private subnet. What is public subnet? What is private subnet? We will understand in this video only. We will get the clarity, and practically also we will see that. What I'm trying to say is this one network can be divided into multiple parts, multiple divisions. That multiple parts are divisions, we call it as subnet, right? And in that subnet, we can consider few subnets are public subnets, few subnets are private subnet. Subnet, basically it is one of the part of the VPC, and inside the subnet only actually we will create the resources, whatever resources it could be. It could be RDS, it could be EC2 instance, or it could be some other resources which we are managing, right? So if you want to create an EC2 instance, first thing what we do is we will be creating our own VPC. Okay, we will create our own isolated network. Within this, within some of the partitions, that is within some of the subnets, we will be creating our resources. Now subnets are also of two types. One is public and one is private. Public subnet means people can access it directly. All the resources which are there within this, people can access it. Outside, public access would be given. If I have to give you pictorial representation, it is something like this. Users can also access the resource. Maybe you have launched a static website here and you want everyone to access. Then if you want everyone to access the static website, which is hosted inside the EC2 instance, that EC2 instance has to be within the public subnet. It is for everyone. People can, get in. Consider your home as your example, right? In your home, the entire home is divided into multiple, parts, right? We will have living room, we will have bedrooms, we will have kitchen. Now, some people, outsiders, can get into your home and you can welcome them in your living room, and you are allowing them a limited access, right? Those people cannot directly get into your bedroom, they cannot directly get into your kitchen, they have a limited access within your home, right? And only the members of your house, the members of your home can access some of the resources of your home, maybe your bedroom or maybe your kitchen, right? Now within your house, within your home, there will be some division, some parts where outsiders are also allowed. There will be some isolated areas within your home where only people from your own home are allowed. Something similar here also. Public subnet means whatever resources we create here, we allow outsider to access it. Private subnets means outsider access is not allowed. From outside, these resources people cannot access. It is not allowed here, okay? And these resources can be accessed within the VPC, within this network, by different resources, by different components they can access, but outsiders cannot access it. And how do we divide them, that this is a public, this is the private? Two important components comes into picture here. One is internet gateway. Shortcut, I'll give it as IGV. You can consider this as the internet gateway. And then we will have something called as NAT gateway. See, after creating the VPC, we will be creating the divisions by creating the subnets here. Now all the subnets will be equally distributed. Then later on, we will decide the traffic flow. We will decide something called as, we will set some rules called as a route table. Here I would like to represent that as route table. Let me just remove this. You can see here route table RT in short I have written. Let me just change the color here. Okay, great. And route table. So we will set the routing traffic, that for resources within this subnet who can access, resources within this subnet who can access. Okay, so basically it is a way to route the traffic. So after we create the VPC, we will be creating the subnets. That means we will be creating multiple divisions of that VPC. Great. After this, we will be setting the route tables. In the route table, we will first decide that this particular route table, these many subnets will be part of this. For this route table, these many subnets will be part of this. And then we will start to edit the rules, routing traffic rules. Now whichever subnets we will be attaching the internet gateway, that subnet automatically will become the public subnet, right? So subnets we will equally create. Later on, which will decide that this is a public subnet, this is a private subnet. For whichever subnet, whichever area of your VPC, you will be attaching the internet gateway, that particular area, that particular subnet will become a public subnet, right? So if I attach internet gateway to this particular subnet, then you can consider whatever resources we create inside the subnets, people can access it, right? Maybe you have an application you want everyone to access, then you have to create a resource within the public subnet. And to this subnet, we have to attach internet gateway. Now, a private subnet, if you don't attach internet gateway, by default, this particular subnet will be considered as the private subnet. But if you want, from this resource, whatever resources we have within the private subnet, you want to allow internet access. That means from the resources which is there within the private subnet. Now here, you have to, if you want to allow the internet traffic, okay, from here, some resources are there, you want to have outgoing internet traffic, then to this particular resource, you have to attach the NAT gateway. What we have to attach? NAT gateway, right? So we'll be creating one NAT gateway here, and that NAT gateway we will be setting in the route table, okay? And we say that this particular NAT gateway we will set into the route table where this subnet has been configured, okay? So in the route table, we will add these subnets, and then we will attach NAT gateway that shows for this resources within this particular subnet, outsiders cannot access, but whatever is there inside this, from here, we can make a call to internet. We can get connected to internet as an outgoing traffic. From the internet, people cannot get in, right? So NAT gateway, we attach to the subnets so that all the resources within the subnets can have internet outgoing traffic. We can access the internet networking. People cannot get into it, right? So if I have to give a bottom line conclusion, we will be creating an isolated network before we create any resource in the AWS. One VPC created, tick mark. Then that VPC we will be dividing into multiple divisions, multiple parts. That multiple divisions are parts we refer as subnets, tick mark. Now we'll be creating 2 subnets, 4 subnets. Now those subnets can further be divided into public subnets and private subnets. How we will be dividing them into public and private? So whichever subnet we will be attaching internet gateway, that subnet will become public subnet. Wherever we will not be attaching the internet gateway, that will remain as the private subnet. Imported resources such as database, we don't want outsider to access directly. All such resources we will be creating in the private subnet. Now all the resources within the private subnet, if you want to give internet access, outgoing internet access, they want to access something in internet networking, then in that case you have to attach NAT gateway to that private subnet. Now how do we attach NAT gateway to certain subnets so that resources within that subnet can have outgoing internet traffic? Then we do that with the help of a route table. We do all this routing with the help of route table. And how do we attach this internet gateway to certain subnets, and we refer that subnet as the public subnets through the concept of a route table, right? So route table, we will be attaching the internet gateway, and in that route table you will see these subnets, these particular subnets are part of this, and by default the internet gateway will be attached to these public subnets. It shows people can access the resources which we create within the public subnet. I hope you could able to get here. And all these things we will be seeing practical also, you need not to worry. So we'll be creating these resources, each and every term which I have tried to explain you theoretically, I'll be showing you practically also. You need not to worry on this. But before we proceed further, I want you also to know about some of the important components here with respect to the difference between IPv4 and IPv6. Let me add this. As you can see in your screen, I have tried to explain the difference between IPv4 and IPv6. Earlier also we have seen one of the concept which is about the public IP, the difference with respect to public IP versus private IP and the elastic IP. We have seen that practically also, right? Now, there are several types of internet protocol addresses used in the computer. All our laptops, devices, or the machines which we are creating, they are following IPv4 by default. 4 set of numbers will be there, and IP address will be divided by these things using the dotted decimal notation here. 4 parts will be there. 192, this is just an example. 168.1.0. 4 divisions will be there divided by this dotted decimal notation. Then you can consider this as IPv4, right? Every machine on the internet must have an address. That address again we can follow either IPv4 or IPv6. Most of our devices right now, your mobile phones, your computers, your laptops, or the virtual resources which we are creating on the cloud, they follow by default IPv4 only, wherein we will be getting 4 sets of number which something looks like this, and you might have seen already, right, which is of 32 bits. Now IPv6 is the replacement for the exhausted IPv4 addresses. The way we are creating and increasing the resources which we are using day in and day out, right? The virtual devices which we are creating on the cloud or the physical devices, every device will have an IP address. There is a possibility that that might get exhausted, okay? And because of which IPv6 is a replacement for that exhausted IPv4 addressing. It was designed primarily to solve the address space problem while introducing several other efficiencies and security benefits. IPv6 is of 128 bits. 8 set of 4 hexadecimal digits will be given. Uses hexadecimal notation with the colons here. Something like this, like the way you have seen in your laptop, in your mobile phone, we have IP, IP address. If they are following IPv6, the IP address will something look like this. You can see this is just an example here. But most of the devices right now, we are still following the IPv4. But by chance, if it is exhausted, so many devices have been already created, then we can go with IPv6. This is just a basic difference with respect to IPv4 and IPv6. I hope you could able to understand. Earlier, we had seen about the public IP, private IP, and elastic IP. Elastic IP is a fixed public IP, wherein doesn't matter how many times you restart your resource, the IP address will be fixed. If not, the public IP will keep on changing. Earlier also we had seen about this. I hope you could able to understand. Now we have to go ahead and create our first VPC, and within that VPC we may have to create our subnet. If I have to just click on to info, you can see here Amazon Virtual Private Cloud enables you to launch AWS resources into virtual network that you have defined. We will have the network configuration control. This virtual network closely resembles a traditional network that you would operate in your own data center, with the benefits of using the scalable, infrastructure of VPC, right? Now, before we actually create the VPC, we have to understand one more small concept with respect to VPC sizing, CIDR block range, right? What exactly is that the VPC sizing, we will see. And once we see that, we will start to create our resources. Whatever theoretically we have seen, we will understand that practically. Now we need to understand about the VPC sizing. It is a way of allocating the IP addresses, okay, which we will be creating for the resources within the VPC. We have to decide at the time of VPC creation that for this VPC, for this network which we are creating, the isolated network environment, how many IP addresses should be allowed, right? And for which, if I have to show you this, the moment I click on create the VPC, you'll see here after I give the name, there is something called as IPv4 CIDR block. If I just click on to this info, right? If I just click onto this, you'll be having the information about this. Specify an IPv4 CIDR block or IP address range. Basically, the CIDR block here referring to IP address range for your VPC. If there is an Amazon VPC IP address manager, IPv4 address pool available in this region, you can get the CIDR from IP address, the manager pool. I will not be doing that. We don't have anything. We will be allocating by ourselves, right? So you can see here, we have an option of IPv4 CIDR manual block wherein we have to give it. And also there is something you can see here, IP address. IPv4 means of course 4 divided by this dot notation, divide by 24, what exactly it is. If I say here 10.0.0.0 by maybe 16, right? By C, a CIDR block size must be between by 16 to 28. What exactly it is, right? We have to understand this only. For which I'll be opening this. You can see here, sizing will be calculated in 2 power 2. Don't look into this for now. You can see 2 power 2 IPv4. IPv4 is 32 bits. So how exactly the calculation will happen? If you give any range, whatever the range it could be, maybe 172.31.0.0 by 20, if you say 2 power 32 bits, because it is IPv4, right? 32 minus 20, that is 2 power 12. 2 power 12 is 96. These many IP addresses could be allocated to that subnet. Okay. At the time of me VPC creation, if I say here by 20, that means 2 power 12 is maybe 4096. You can do your calculation if I am wrong here. Okay. Fine. Now, similarly, if I say 10.0.0, whatever is the IP address by 31, if you say 2 power 32 minus 30, that is 2 power 1, which is 2 exactly. The 2 IP addresses are not allowed. At the time of you creating the VPC or creating the subnets, you have to design the IP addresses range. And that range must be between by 16 to 28 is supported by AWS. If you say by 28, it is 2 power 32 minus 28, that is 2 power 4, which will give you 16 IP addresses. This is not allowed. Okay, this range, this is allowed, 28 is allowed. I'm talking about this 31, this is not allowed. 2 power 32 minus 1 is 2 power 1, which will give you 2 IP addresses. So at the time of you creating the VPC or subnets, you can give between by 16 to 28. Only this is supported by VPC. 2 power 16 is 65,536. These many IPs would be allocated to your VPC, and within VPC you can create these many resources. Each resource needs an IP address, right? From this it will take that IP address, and that IP address will be allocated to the resources which you are going to create within that VPC. It's a way of allocating the IP addresses range, nothing more than this. And the range is allowed by 16 to by 28. If you say by 29 or 30, 31, that is not allowed. Example of 31 I have given here. 2 power 32, because IPv4 is 32 bits, minus 1, which is 2 power 1, which will give you 2 IP addresses, is not allowed. The minimum is 28 and the maximum is 16. 16 means 2 power 32 minus 16, which will give you 16. So 2 power 16 is these many IPs. Maximum IPs we can have. Minimum is this much. What is the IP address range you give? By 28, if you give 2 power 32 minus 28, which will give you 2 power 4, which will give you minimum of 16 IPs. I hope you could able to understand, right? So I have also specified here one conclusion notes, which you can see here. CIDR block size must be between by 16 to 28, okay, which is minimum is this and the maximum is this, okay. We should not surpass this. We should not cross this particular range. I hope you could able to understand theoretically. We'll be allocating that practically also. You'll be able to understand. But before we also proceed further and show you something practical, one more point I would like to mention here. If I just click on to this VPC, okay, we have an option here of security group, okay, security. Security groups, earlier we have seen in this particular series itself, it is the resource level security which you may have to allocate to any of the AWS resources. Also, we have something called as network ACL, right? So if you have to click on to this, you can see here a network access control list is an optional layer of security for your VPC that acts like a firewall for controlling traffic in and out of one or more subnets. Basically, like the way security group is for the resources, the NACL, which is network access control list, is for the subnet level. Okay, Earlier in this series, we have already seen about the security group. Make sure you watch that videos before we proceed further. If I have to show you this pictorially, let me add this. As you can see on your screen, this is the AWS resource. It could be EC2 instance, or maybe you can consider RDS, any resource, okay? And we will be creating the resource within the subnet. Subnet is a part of one isolated network, which is VPC. And VPC we will be creating within the AWS, right? So now if there is a incoming traffic to this AWS resource, right? So this resource is available inside the subnet, and the subnet is available inside the VPC, and VPC is there within the AWS, right? So what did I say here? NACL is subnet level security. You can say subnet level firewall, okay? So for a incoming traffic, which one is it? NACL is the first level of defense, or is it security group? The answer is NACL, because for incoming traffic, before it reaches to the AWS, it first reaches to the subnet. And at the subnet level, if you manage the security, it is NACL. So first it has to go through NACL, then it has to go through the security. For an outgoing traffic, the first level of defense is security group, okay? Outgoing, right? The first is security group, then comes the subnet, and then we have VPC and the AWS. For the incoming traffic which is coming to your AWS resource, the first level of defense is subnet level security, which you give the rules which you set here, which is NACL. And then we have resource level rules, inbound rules, outbound rules. Earlier in this series we have seen it. If there is any confusion with respect to security group, please do refer to that video before you proceed further here, right? And then it reaches to the resource. Before it reaches to the resources, we will be setting the security group, right? The inbound rules, whether this particular traffic is allowed or not. So based on that, it will be reaching to the AWS resource which you have created, okay? So if I have to add a few key points regarding the NACL and security group, just to summarize this, let me add it. As you can see on your screen, security group acts like a firewall to secure our resources. Security group contains inbound rules, incoming traffic, and the outbound rules, outgoing traffic. One security group, we can add up to 50 rules. We cannot configure deny rules explicitly in security group. We can just give what is allowed. What is not allowed, we cannot say, okay? Security group is applicable at the resource level, and manually we have to add security group to our resource. We can create a security group and use same security group for multiple resources. There is no problem. One, you can configure the inbound and outbound rule, and same rules you can use for multiple resources. Now coming to the network access control list, you can see on your screen, it acts like a firewall for our subnet in the VPC. It's applicable at the subnet level. NACL is applicable for all the resources which are part of that particular subnet, right? So if you add some rule there, that rule will be applicable to each and every resource which you create within that subnet, which is within the part of your VPC. One isolated part is subnet, right? One area is subnet. Within that subnet, whatever resource you create, whatever rule you configure in the NACL will be applicable to each and every resource within that subnet. In NACL, okay, we can also configure the deny rules. What is not allowed, we can configure, right? So no problem there. One NACL could be used for multiple subnets, like one security group could be used for multiple resources. One subnet, we can have only one NACL. You cannot add multiple NACL, okay? That is not allowed. Okay, NACL acts like a first level of defense for incoming traffic, and security group acts like a first level defense for the outgoing traffic. This is what I was talking about. For incoming, first it has to reach to the subnet, right? At the subnet level, if you have configured NACL, that is first level defense, then it will go to resource. Before resources, it will reach to the security group. But while it is outgoing, first it has to go through the security group, then it has to go through the subnet level NACL. So outgoing traffic, the first level of defense is security group, then NACL. For incoming traffic, first is NACL, then the security group. I hope you could able to understand this also alongside the VPC sizing. Now it's time to create a VPC and understand each and every term which we have seen in the last two videos, critically with respect to VPC and all the VPC components. Now let's create a VPC, subnets, internet gateway, NAT gateway. Whatever we have seen theoretically, we will be doing that practically, right? For which you just have to open VPC, okay? Like the way you have seen earlier too. And then we have an option of create a VPC, all right? So I'm creating this in Mumbai region, which is nearest to me. You can create whichever is nearest to you. It's fine based on your preference. So, okay, VPC and more. I would like to go with VPC first, and there later I'll create subnets, not in one go, okay? I'll give the name of my network as Telescope Network or Telescope VPC. Whatever name you want, you can give. That should not be a major matter of concern. Then I would like to go with IPv4, and I'll say here maybe 10.0.0.0 by maybe 16. Maximum IPs I need here. The CIDR blocks size must be between by 16 to by 28 here, okay? So I don't want that. I'll be going with IPv4 only. Okay. Nothing more, no tags for now. I'll just create a VPC. Once VPC is created, it's time to create the subnets, partitions of that VPC. I'll just click on to subnet. These subnets are for the default VPC, which is already there for every account. So now I'll create this subnet here. It is asking me this subnet, this partition you would like to create for which VPC, which isolated network. I'll say here, please create this for Telescope. Great. And I'll give the name of this as maybe public subnet. Right now for the demonstration, I'll be creating two subnets. I'll name one as a public, one as a private. We can create 3-4 public, 3-4 private no subnets. There is no restrictions on that. Okay. Depends on how much IP addresses you have allocated for the entire VPC. So you can create as much as divisions as you can based on the number of available IP addresses which you have allocated. Okay. So no preference. It is asking me the zone. I would like to go with maybe this time AP South 1, or maybe you need not to give, it is not mandatory. It will only choose a zone in which your subnet will reside, or let Amazon choose one for me. This time I want Amazon to choose for me. If you want, you can create or you can decide also. Okay. Now for this particular subnet, out of these many IPs available, how much do you need? I'll say here maybe .0.0.0 by 24. Okay. So you can see here, I have asked I need 256 IPs. I hope you could able to see this 256, because I have told by 24. It is 32 minus 24. Of course, it is 8. So 2 power 8 is a 256, and that is what we have told here. This much I need out of all available for this particular division, for this particular partition, one area, one subnet. I need this many IPs. Okay. And at this moment, I don't need any tags for now. Okay. I'll just click on to create a subnet. One subnet has been created. I have named it public subnet, but it is not yet public. Unless and until you attach internet gateway to any of the subnets, it will not be called as public subnet. Now I'd like to just go on create one more subnet for this particular VPC, which is Telescope VPC. I'll give the name as maybe private subnet. Okay, that's the name. I will not give any availability zone preference. You can give it. There is no problem in that. Okay. Here also maybe I need I'll say 1. This is already selected, no? So I'll just go with maybe 1.0 by maybe 24. Okay. So 256 is sufficient for me. I'll just create a subnet. Okay. So 2 subnets have been created here. If I have to just again click onto this, 2 subnets I have created. These 3 are available for the default one. For my VPC, there are 2 subnets available. Okay. So great. Now, unless and until you attach NAT gateway and internet gateway, you cannot call public or private. You have just written it. Okay, that will not be called as. But I'll just go to the route tables. Okay, wherein we have to attach these subnets, and we have to do the routing. Okay, for which subnet internet gateway should be attached, for which subnet NAT gateway to be attached. All this will be decided in the route tables itself. Okay, if I have to go to the information at the top right here, you can see a route table contains a set of rules called routes that are used to determine where network traffic from your subnets or gateway is directed. Okay, so I'll just click on to create a route table. First I'll give it as public route table. That's the name I would like to give for this VPC. Which VPC? So I would like to make a decision. This is for the Telescope VPC. Great. And I'll just create the route table. Fine. And once it is created, here in the subnet associations, there are no subnets associated with this routing. Okay. So I'll just click on to edit the subnet association. Public. Great. I'll just save the association. Okay. And after which routes, later we will do that. Okay. I'll just again get back and create one more here. Okay. So I'll just click on to this. Maybe I'll say here private, or else whatever is already available, that only I will edit. Okay. So public I have taken, and you can see one more by default, the default route table for the Telescope VPC. Telescope VPC is created here, right? So this only I'll name it as a private instead of me creating. I'll say private route table. Okay. So no problem. I'll just get onto this, and then subnet association. I'll click on to edit the subnet. I'll say here, please add this subnet. Okay. Great. So routing has been done basically with respect to subnet association, not with respect to the routes that we have to do it. I just get into internet gateway on your left, and at the top there is an option of create an internet gateway. I'll give it as maybe Telescope Internet Gateway IGV. Okay. I'll just click on to this. Fine. And then we have an option of attach to a VPC. If not action also, you'll get the option. I'll say attach to a VPC. Which VPC we want to attach? I'll say Telescope VPC. Done. I'll say attach internet gateway. That I have attached. Now, what is the next task you have to do is, I just get on to the route table again. And in the public route table, which I have created, in the routes, we have an option of edit routes. And now add the route. I'll say here which route? Internet gateway. The internet gateway which we have created, Telescope internet gateway. I'll just save this. Okay. So any traffic, 000 means any traffic. I'll say save this. Great. Now guys, I have created a route table. In that route table, I have associated the public subnet and I have added the internet gateway. Now you can call this officially, this public subnet is a public subnet. Unless and until you don't attach internet gateway, a subnet cannot be called as public subnet by just giving the name. Okay, I had given the name, but unless and until you attach internet gateway, a subnet cannot be called as public subnet. I hope you are able to understand here. More subnets, if you want to be public, those more subnets you have to create, and you just have to edit the subnet association, and you just have to attach those subnets into it. Okay, and in the routes, I have attached the internet gateway. So whichever subnet is associated with this public route table, they have internet gateway attached. So hence we can call them as the public subnets. So subnets where internet gateway is attached in simple terms. Okay. The other subnets we have private subnet, and you can see here in the private route table, I have attached this, but there is no internet gateway here. So this subnet will remain private. People cannot access directly. This is basic. So if I have to get into the diagram, so what we have done so far is, if you ask me, we have created a VPC tick mark. We have created one public subnet, private subnet. We have created the route tables. Done. We created the internet gateway. Now let's create one resource in the public subnet. Okay. So now I'll just get into this and I'll just go to the EC2 instance. Okay, great. This time we are not creating the instance like the way we have done earlier in the default VPC. So far we have created the EC2 instance multiple times for different reasons, but we have done that in the default network. For the first time we are creating in our own network. I'll just launch the instance, click onto this, and we do have an option of maybe web server. That's the name I have given here. Let it be Amazon Linux, not a problem. Also T3.micro, let it be key pair, just in case if you want to get connected. So of course I do want to get connected, right? So I'll just select any of the key pair. If not, you can create a new key pair. By this you will be knowing it by default. So security group, do you want to use existing or do you want to create new? I would like to create a new, and I by default I'm enabling the HTTP traffic at this stage itself. As you all know by default that later also we can edit the inbound rules, not a big deal. And here the most important part. So by default it will be choosing the default VPC, right? You just have to click on to edit, and I'll just select the Telescope VPC. This is very, very important. The subnets, public subnet, Telescope VPC. Auto assign the public IP, please do assign because I want to access this. Create a security group, name it is asking. I'll say here new VPC resource security group. That's the name I have given here. Okay, so that's fine, not a big deal. By default it is, later also we can enable. These three things are added by default, and I'll just get on to the advanced details of it. And I would like to add some user data here. Okay, just to show that public access is enabled to this resource. As you can see, I have added here a basic Nginx server installation and welcome to no from the Telescope server. That's fine. All right. So I'll just click on to create this. I'll say launch an instance. The instance will be launched within no time. Okay. And this instance is there in the public subnet, and in the public subnet through the route table we have configured the internet gateway. So of course there is public access to it. Okay. So I'll just get on to this and I'll just refresh this. Through the public IP you can access it. So let me just copy this public IP and I'll just go back and try to access it. The moment I hit this, as you can see, the moment you hit this, you are able to get after some time. One small change I have made here. What is that? If you ask me, if you go to the VPC action and edit the VPC settings, please enable the DNS host name also. Okay, so I have enabled this. You can see it is enabled, and after that if you look into your instance also, you can see here public DNS also has been given to you, and using the public IP you could able to access static website which we have hosted inside this. So what we have done is, if I have to show you pictorially, subnet is also created, EC2 instance is also created. We could able to get connected also. You can make a SSH connection also. So what I can do is I'll just click on to connect, and of course this, and let me open the terminal. As you can see, the terminal is open. I'll be just pasting this and we are able to make the SSH connection also. Okay, make sure you check whether you have enabled the SSH connection in the security group. If you just get into instances, security, and we do have an option of a security group, and kindly see here the edit the inbound rules, SSH connection is already there, only then you'll be able to make it. Okay, since this particular resource is created in the public subnet, okay, with wherein you have attached the internet gateway through the route table, we could able to access the resources here, and also we could able to establish the SSH connection. Okay, let me also check if there is outgoing traffic enabled. Okay, so not just incoming. I'll say www dot, okay, of course we have to go with the ping, www dot, I'll say google.com. all right, so you are getting some response, that means you do have the outgoing traffic also enabled. Okay, so this resource, there is incoming traffic, outgoing traffic over the internet is enabled because this resource is created in the public subnet. Now, what is the next part I have to do is, I'll be just creating one resource in the private subnet. Moving forward, you might see in the real world that RDS, right, cluster, some of the nodes, all of that will be available in the private subnet itself, where public access, direct access is not allowed. Okay, so now what I'm going to do is, I'll be creating one resource in the private subnet. Of course, you cannot establish a SSH connection also. But from this EC2 instance, I will try to get connect to this, resource which I'm going to create, and see if there is outgoing traffic, what we have to do it. Okay, so now what I'm going to do is, I'll just get on to this. Okay, launch the instance. I'll say launch without a walkthrough. Great. And I'll say here, maybe I'll give the name as a DB server. Great. And tt.micro, fine. I'll just give some key pair. Even if you give, you cannot directly connect to it, but from the other EC2 instance, you can establish the connection. Within a VPC, two resources can establish the connection. There is no problem there. I'll just click onto this. Okay, networking. This is very, very important. We are going with Telescope VPC, and the subnet is private subnet. Very, very important. Okay, I'll say here private subnet security group. Okay, that's the name I have given there. SSH connection is allowed. That's fine. Even if you add more, you'll not be able to establish. Even if you add the HTTP traffic later on, you'll not be able to establish the connection because it is there in the private subnet. Okay, so now I'll just click on to launch the instance. The instance will be launched within no time. Okay, so I'll just click on to this. The instance will be launched. Let me just refresh this. DB server instance is launched. Okay, I'll just click on to this. You can see public IP address is only not there. If there is no public IP address, can you establish the connection? The answer is no. I hope you are all able to see this. Okay, so now what I'm going to do is, I'll open one more terminal. Let me open it. As you can see, I have opened. I'll just click on to connect, and even if you give the read permission, I would like to give the read permission, of course, to the new terminal. Okay, and after giving the read permission, I'll just get back to here. Okay, I'll just click on to this connection, SSH connection, and I'll just try to make the SSH connection. Should it be allowed? The answer is no, because this resource is there in the private subnet. Okay, and internet gateway we have not attached. You can see, you can wait, you'll not be able to establish the connection, right? So now what I'm going to do is, instead of using this normal terminal, which you can do it. Okay, in Windows we have an option of using one more terminal. We call it as MOBA XTerm. Okay, easily you can download. I need not to make a video to make you download this. The name you can see, MOBA XTerm, and you can just download. Next, simple installation step. I hope there is no need to me showing that also in 2-3 minutes of video, which is by default. Okay, so it is one of the terminal which is there for the Windows user. So I'll just click on to session. Okay, sh, I'll give the remote host. I'll just establish connection to the instance. Okay, the instance which is there in the public IP, the web server. Okay, the public subnet, the instance which is there in the public subnet. I just get on to the connect, and you have to go to EC2 connect. Okay, I'll just copy the public IP of this. All right, I'll just specify the public IP of this, specify the username. The username is EC2 user for the Amazon Linux. Advanced SSH connection, use the private key. I'll just upload the private key which we have used. I'll just click on to this and key pair. So I think we have used new demo key pair. Okay, so this is the key pair. I'll just click on to this. It will be uploaded. I'll say okay. And now we can establish the connection. This is also terminal, guys. There is a purpose why I choose this. Okay, now what I'm going to do is, see here, if I have to pictorially show, please look into this. in the public subnet, we have EC2 instance web server, right? To the web server, by using one more terminal, I have just connected. Okay. Now here I will upload the key pair which is required to connect here. Okay, the same key pair I'll be using, but this time I'll upload that here. To upload that into this terminal, we have to run some of the Linux commands. We have to follow certain process. But if you go with the mobile extern software, it is easy. So only I have gone with it. Now let me open the mobile extern again. And we have an option of here, you can see top left side, upload. Okay. And if you don't have mobile extern software, you can skip this demo also, not a problem. I'm just trying to establish connection between one server of public subnet to another server of private subnet. Okay, within same network, right? So I'll just click on to the same key pair which we have used. I'll say upload. After it is uploaded, I'll just refresh. You can see it is available now. Now I'll give the read permission. Let me get back to my AWS. All right. I'll just get on to the DB server, which is there in the private subnet connect option. And of course, SSH connection. I'll just click on to copy this, right? The read permission. Let me open this, and I've given the read permission. And now I have to establish the connection. Okay. So I'll just get back here. We have an option, right? The example to establish the connection. I'll copy this. And after copying this, also make sure that you are getting connected with the help of private IP. You can see the private IP. That is what you have to use. Okay. Because this time you're getting connected from this server which is there in the public subnet to the server which is there in the private subnet. I have given the read permission of the key pair security key, and now through the private IP, I'm getting connected. Both of them are there within the same VPC. Okay. And now I'll just get back here and add this, right? And I'll see. All right. I'll say yes. And we could able to establish the connection. You can see here the subnets which we have here, right? Of the resource of the public subnet, you can see it is 1 here. Okay, there is a difference. At the time of we allocating the IP addresses, we had given there 1 and it is 0 here. Now we are in the resource, the server which is there in the private subnet. Okay, we could able to establish the connection successfully. So this part is also done. Now from this resource, we have seen outside traffic is not allowed. You cannot make even SSH connection also because internet gateway is not there. But a resource which is there within the same VPC in different subnet, are we able to establish the connection? Yes. Private. Okay. So this is allowed. From here, I will just check if I have outgoing traffic allowed. Okay. So whether I could able to make or access the internet here, right? So I'll just do one thing. I'll say ping. I'll say www dot maybe Google. Okay. I'll say .com. All right. And I'll just hit this. You can see you're not getting any response. It will be stopped. Okay. You can wait for maybe 1 month, year, you'll not be able to get any response. So what to do? Now, if you want this particular resource to access outside world internet, you have to attach NAT gateway to it. So what to do now? Next, I'll go back to my VPC. We have an option of NAT gateway. Okay. So I'll just create a NAT gateway. I'll give the name of the NAT gateway as a Telescope NAT. That's the name I have given. All right. So I'll just click on to Telescope VPC. Great. And now I'll just create a NAT gateway. The NAT gateway will be created. Now I have to get back to my route tables. Of course, the private route table and where the private subnet is there. In the private subnet only the DB server I have created, right? I'll just go back to my routes, right? Edit the routes, add the route, right? 000. Okay, fine. And I'll say here now NAT gateway. Which NAT gateway? Telescope NAT gateway. I'll just say. You can take some time, wait for 2, 4, 5 minutes of time because it will take some time for NAT gateway to fully create it, and then again you can try it. Okay. So now what I'm going to do is I'll just get back here to my instance. Okay. I'll just say exit. I'm out of this. I'm back to where I was. Again, I'll just try to establish the connection once again. Okay. So let me just copy this. I'll just clear this. All right. And from here, again, I'm establishing connection to the DB server, which is there in the private subnet. Okay. So I got into this. Now again, I will just try a ping www.google.com. Okay. I'll just hit this. It is not because it is taking some time for NAT gateway to capture. Let me just look into it. Let me open the AWS dashboard, and here if I have to get back to the NAT gateways, okay, we can see still it is in the pending state. It will take some time. Once it is fully available, again I will just try that from the resource of private subnet, I'm able to access the internet. Okay, so people cannot access, but From here, I could able to establish connection to this. From here, I'm able to access outside world. It is possible if you attach NAT gateway. NAT gateway we have attached. It is not fully configured. It will take some time. After it is configured, again I will check. From here, by connecting to this server, I'll just check if I can able to access the internet. As you can see, it is fully available, the NAT gateway. So now I'll just get back here, okay, to the DB server, which is there in the private subnet. I'll just click on to this and let me establish the connection back, okay. From my terminal, I had closed that connection. Now from the resources public subnet, I would like to establish the connection. Okay, let me just copy this again and get back here. I'll just get connected to the resource of private subnet, the DB server. All right, I've got connected. Now from here, I will just check if I can access outside world. Ping www.google.com. The moment I hit this, yes, I'm getting the response. Now internet access is enabled here. Okay, so I hope you could able to understand the entire resource allocation. So what we have done here is we have created the VPC, we have created the private and the public subnets, and we have created the route table. We have created NAT gateway attached to this private subnet through the routing, and internet gateway attached to the public subnet through this routing. Okay, and then we could able to create a resource in the public subnet. We could able to demonstrate that people can access SSH connection can also be made, and the resource of the private subnet people cannot access. SSH connection is also not allowed, but within the VPC, one more resource, we could able to establish the connection, and from here, because NAT gateway is attached, we could able to make the outside world connection. I hope you could able to understand theoretically and practicals of how to create VPCs, subnets, private subnets, public subnets, internet gateway, NAT gateway. And after the traffic is over, it is highly recommended to delete all the resources, especially the NAT gateway. Once you delete the NAT gateway, make sure that the elastic IPs are also gone, because it is paid. You'll not be given it for free. Okay, make sure you delete the NAT gateway and all the resources. First of all, after deleting the resources, NAT gateway, internet gateway, detachment, deletion. So this is very, very important. All the resources, especially with respect to NAT gateway, internet gateway, and EC2 instances, make sure you delete it. Now we need to understand one more concept related to VPC, which is VPC peering. Okay, so it is a way wherein two VPCs of same account or different account can establish connection, right? So we'll be creating multiple VPCs, and we'll be creating the resources inside that. And if you want to establish connection between the resources which are there in two different VPCs, we have a concept of VPC peering. And you can see here in the VPC dashboard, if you just see here in the virtual private cloud, we have an option of a peering connection. You just have to click on to this, right? Right now, something was there, it was deleted. That's fine. I just click on to create a peering connection. I'll give the name here, maybe Telescope connection. Okay, that's the name I have given. Which VPC will be the requester, from where you want to establish the connection? I'll just click on to Telescope, right? And my account, the another VPC to which you are trying to connect, it is there in my same account itself. I now want to get connected to a different account. So let me use same account. You can do it with a different account also by giving the account ID, but this time I would like to go with the account ID. So let it be in the same region. And which VPC is the acceptor? I would like to go with the default VPC. If you want, you can create one more VPC like the way I have shown in the previous video, and two custom VPCs can also establish the connection, but I would like to go with one is a default VPC, which is default by AWS itself given to you, and one more is the custom VPC which we have created, the Telescope VPC. Okay, and I would like to just click on to create the peering connection. It will be created, and here we have an option of action. Since both the VPCs are in the same account, from here itself we can accept. I'll just click on to accept the request. It is done. The second thing which we have to do here is get back to the route tables, and the public route we have, right, for the Telescope VPC which we have created in the previous video. Here what I'm going to do is I'll just do one thing. Okay, I'll just get back to the default route table which is there for the default VPC, default route table. I'll just give the name as default. Okay, let it be the same name. It is there in the default VPC. Okay, I'll just click on to this and I'll just copy this. Okay, this is what you have to copy. If not, you can just edit this, and you have an option here, right? So I'll just copy this, get back to my route tables, and go to the public route table of the Telescope VPC. Okay, and here I'll just get back to edit the routes and add the routes. I would like to add this route here, and fine. And here I'll just click on to peering connection. All right. So which connection? I have to give the name, that is co-connection which we have created. I'll say save the rule. Done. And now what I'm going to do is I'll just copy this. Okay. I'll just get back here. Okay. Did the routes, whatever we have, right? I'll just copy this and go back to the route tables. This time I'm getting back to the default route table of default VPC. Okay. And next I'll say edit the routes. I would like to add the route. Let me add it. And then I'll see the peering connection, which connection we have created, telescope connection. I would like to save. This is done. Okay. After this is done, I'll just go back to EC2. One instance, last video we have seen, we have created in the public subnet of the telescope VPC. I would like to consider same. Okay. You can also use the same. If not, you can create. We have seen n number of times how to create the instances. In fact, in the last video, we have seen how to create EC2 instance in our custom VPC, which we have created, right? So I would like to keep it as it is. If not, you know how to create, you just create one. And now I would like to create one more EC2 instance in the default network itself. Okay. And I'll just go back here and give the name as maybe default server. In the default VPC, I would like to create this. Amazon Linux, let it be same. All right. Any of the key pair. Let's go with the new demo key pair. That's fine. Existing key, no security group are used more. I have enabled the SSH traffic also. HTTP, it is depends if you want to have any internet request over the HTTP. If not, you can just go only with the SSH. This is important, right? Now I would like to click on to launch instance. But before I do this, please make sure this particular instance I'm creating in the default network. Okay. And now I would like to click on to launch the instance, right? The instance is launched. But before I do anything, I will just get back to my instances, the web server one, right? Which is there in the telescope VPC public subnet. I would like to establish the connection to this, right? So now I'll open the mobile external software, whichever software you want, you can open. That should not be a major matter of concern. So I'll say exit and all right. I'll do one thing. I'll create a new connection. Okay. So SSH connections, I'll just add the public IP. Okay. If not, you can go normally only, not a problem. But I want to show you that resource of the default VPC is able to establish connection to the resource of the Telescope VPC. These two things are happening. I want to prove that, right? So now I've gone into the resource of public subnet in the Telescope VPC EC2 instance. I've taken the public IP here. Okay. And I'll just add this. Fine. Specify the username. I'll go with EC2 user, right? And advanced SSH connection. Use the PEM file, the demo one which we have used here. So let me go back here and say new demo key pair. That's what I would like to use it. That's fine. I have established the connection. Done, right? So now I got connected to the server of Telescope VPC. From here, I would like to establish connection to the server of default VPC. Okay. So default VPC we have here instances. If I have to get back to instances, this is the default server. Okay. I'll say connect. SSH connection I would like to make. Okay. First I have to give the read permission and then I have to get back here. And also previous video we have seen, right? We have uploaded the key pair which the other server is using. The default server of default VPC is using, that I have uploaded here. Click onto this, upload it. After which I would like to give the read permission. Okay. So I'll do one thing. I'll just get back here. Okay. This is the default server. I'll give the read permission. Okay. Right now I'm in Telescope server of Telescope web server of Telescope VPC. Okay. From here, I would like to get connected to the default server of default VPC, different VPC. Okay. So I have done this and now I would like to establish the connection. Okay. I'll just take this SSH, done. And now I'll just get back here and add this. I'll hit this. I'll say yes. And I could able to establish connection. You can see the IP is different. Wherever we were, the IP was different. So what we have done is we have created one resource in Telescope VPC. Great. We have created one resource in the default VPC by the name default server. Fine. With the help of VPC peering concept, we could able to establish connection from a resource of Telescope VPC to the resource of default VPC. Two different VPCs could able to communicate with each other. We can see the connection is successful. That means you could able to establish the connection. If I have to pictorial represent what we have done, let me show you. As you can see on your screen, so this is what we have done it. We have two different VPCs. It could be a custom, both the VPCs could be custom, no problem. So this is default VPC, this is Telescope VPC, and we had one resource here and we had one resource here. Both of them could able to establish the connection with the concept of VPC peering. I hope now you understood this. Make sure all the resources which you have created, all the instances, NAT gateways, internet gateways, everything you delete because it is not getting used. Unnecessary creating and having the resources in AWS is not recommended. Now we need to understand one more important concept, which is Route 53. Before we explore anything practically on Route 53, if I ask you, how do you access any web application or website on internet? You'll be answering me that if you want to access Google, google.com. If you want to access Amazon, then amazon.com. Or if you want to access anything on Telescope, you'll be entering telescope.com. Do server or computer understand these domain names? The answer is no. Computers and servers understand IP addresses. All of them communicate with the help of IP addresses. And do you access any of the real world application day in and day out with the help of IP address? Maybe 192.11.10. The answer is no. Will not be able to recall. Here is where domain name system comes into picture. It is, you can consider as the phone book on the internet, wherein we will be entering google.com. It will translate that into the IP address, and then our browser will able to identify the right server for that particular IP address. We will not be entering any of the IP address directly on the browser here, right? And in AWS, in order to manage this, we have something called as a Route 53. Okay. And if you just click onto this, if not, on the search button, you have an option here. You just have to search Route 53. You can see here scalable DNS domain name registration, right? We may have to understand this practically. So there is some problem here. Okay, ignore this, not an issue here. Okay, so here we have certain options here: hosted zones, health checks, profile. We may have to go through one by one. See here, DNS management, availability monitoring, traffic management. So hosted zone tells Route 53 how to respond to DNS queries for a domain such as example.com, right? So in order to work or maybe register your domain which you have got from anywhere you want, first thing we have to do is create a hosted zone. And a hosted zone is a container that stores DNS record for a domain. For example, if you say telescope.com, when we create a hosted zone, Route 53 manages all the DNS entries for that domain. Okay, so we will be creating it. If you just click on to create a hosted zone, you will be having the option. The first thing which you have to do here, and also guys, for this demo, I have already got a domain here. Okay, you may have to have a domain, only then you'll be able to demonstrate this example. Okay, it's on you. So I'll be working with my own domain which I have got here, right? So basically, Amazon Route 53 is AWS DNS service which will help us to register domains, manage DNS records, and route traffic to AWS resources like EC2, load balancer, or maybe you can say static website, ECS, EKS, right? So simple bottom line definition, if I have to give you, Amazon Route 53 maps domain names to AWS resources, right? And in order to work with it, the first thing which you have to do is create a hosted zone, which is like a container that stores the DNS record. Already I have got one domain name. Okay. The domain name which I have got here is tshapeskills.com, and it is not any of the website. For the demo purpose, inspired by the T-shaped skills, I have just got this for the example purpose only. Okay, and I'll just give the description here, a basic description. I would like to say here for demo, that's all. Public hosted zone, of course, public hosted zone determines how traffic is routed on the internet. And then I'll just click on to create a hosted zone. This is the first thing which you have to do it, right? So when you create the hosted zone, you can see here two things automatically got created here, right? See, one is the name server and one more is the SOA, right? So what exactly it is you need to understand. The name server which automatically got created when you created the hosted zone tells the internet which DNS servers are responsible for managing this domain. When you create a hosted zone, right, like the way we have created right now, AWS automatically generates set of name servers, which you can see here, right, on your screen, which you can see this, right? And when you buy the domain from any of the, domain provider such as GoDaddy or maybe Hostinger or maybe Google Domains, anything which of your own no preference. I'll just open this. I have gone with the Hostinger. No preference, personal preference here. Okay, randomly I have got it with the help of Hostinger. You can see here we have an option of domains. If you just click onto this, and then we have DNS servers, right? Recently, for the demo purpose, I tried to add the AWS DNS servers, name servers, which was generated by AWS. It will be different. If you buy the domain from the Google, it will have its own name servers. If you buy from the GoDaddy, it will have its own name servers. Even with the Hostinger also, it will have its own name server. You may have to change it. So whatever it is generated here, you may have to add that here in the, you know, Hostinger or whichever domain name provider which you have taken. You just have to go there and you'll have an option to edit this DNS name servers, default name servers. Okay, I just click on to change this, right? And I'll be changing them one by one. Let me add it. As you can see, I have added one by one from here. Okay, so you may have to add this name server generated by AWS into the domain name provider which you have gone with. I would like to just save this. This is very, very important. Fine. Now, it is not enough. Now, you may have to also create a record. Once Route 53 receives the DNS query, it checks the record configured inside the hosted zone. And this is where a record comes into picture. And a record maps a domain name to an IPv4, right? So what exactly happens if you ask me, if I have to pictorially represent here, a user when it enters the URL, example www.telescope.com, right? It will go to the DNS route 53, and here to redirect this to a particular resource, whichever resource, whether you're going with ECS or EKS or EC2, Lambda, static S3, buckets, doesn't matter. We may have to create a record here, address record. This is very, very important. So let me add this here. As you can see, I have added here a record can point to resources which is in EC2, or ECS or EKS or any other EC2 or AWS resources, right? It can point to it. So basically a record is all about where should the traffic go. Fine. Now after this, I'll just go back here and I will have to create a record. Before I create a record, what I'm going to do is I'll be creating one resource here. Let me open this, right? And I'll just go back here and launch an instance. I just say here launch an instance and I'll be hosting a static website. Okay, so let me just add this. I have created the web server, Amazon Linux. Okay, let it be in the default. In order to get connected, I'll be using any of the key pair here. Let me use this key pair and I'll be allowing the HTTP traffic from the internet. Let it be in the default VPC. It should not be a major matter of concern here. Now, if you want to get connected to the server, SSH connection, since I'm going to access this server, okay, over the web, so I have to enable the 80 port number also. So I have allowed the HTTP traffic. Later also, if you have forgot, you can add it. Either you can launch the instance now, later you can install any of the web servers and host a static website, or with the help of, user details also, you can add a basic static website. It's up to you, okay, for the demo purpose. I'll do one thing. I'll be launching this instance here. Instance will be launched within no time, okay? And I'll be just getting connected to this instance, right? So let me just get connected. I'll be doing the SSH connection, and you know this, right? We have done this a number of times in this entire series. I would like to just go back and establish the connection. I'll just say yes, right? You have got the connection, right? So now I'll be installing any of the servers here. Let's go with the Nginx server. I'll just say here sudo yum install Nginx, okay, -y, right? The moment I hit this, you can see the Nginx is installed, and you know very well, I just have to start this. I'll say sudo systemctl. I'll be adding here start the Nginx. I have added this, and now I may have to enable this. Let me add this command. Now I have to just get into the HTML folder for which I'll be adding this. So you know this very well. So let me add this. And this is the part wherein we have to host it. Okay. So ls, we do have this. I just have to open this vi. Okay. Of course, with the sudo privileges, it is very, very important. Okay. Let's say sudo vi index.html, right? So let me open this and I'll be editing. Let me edit this. By getting into this path, I have added the required static website, which I want it to be accessed by anyone and everyone, right? Earlier also, we have seen this. You can access your own static website of your own content, whichever you want to host it, okay? And after which, I would like to just get back using the public IP. You should be in a position to access it. I'll just go back here and paste my public IP, and within no time you'll be able to access. Now with the help of public IP address, we are able to access this. I want to access with the help of domain, which we have got it, right? So now I'll just go back to my Route 53, and here we will have an option of create a record. You just have to click on to this, right? And now it is asking me, do you want to have any subdomain, like the way in Telesco also we have, right? learn.telesco.com, right? I know what any I would like to go with the main domain, so you need not to add anything here. And record type, let it be a route traffic to an any IP v4 address and some AWS resources. Keep it default. Okay, I would like to just add the public IP here, right? This is very, very important. Now TTL seconds, I want it to respond very quickly, so I'll go with 10 or 20 seconds. I don't want to go with the 300. Now routing policy, simple routing, because right now we are hosting a static website in a single EC2 instance. So simple routing. Maybe if you have multiple load balancer, if you want to divide the traffic equally, then you can go with the weighted, like the way we have multiple options routing policies here. Right now I'd like to go with the default, which is simple routing here. Right now I would like to just click on to create a record. Okay, it will be created within no time. We have an option of looking at view status here. Let me just click on to this. You can see it is pending. Within 1 to 3 minutes of time, it will be active. Let's wait. As you can see, it is now in sync. I just go back to the browser and I'll be entering this time tshapeskills.com. You can see on your screen, I have gone with T-shape skills. It is just a random, okay, inspired by the word T-shape developer, master of one, jack of all, T-shape term. Okay, random personal domain. I have just got it to show you this demo particularly. Okay, now I'll be trying to access our static website, not with the help of IP address, which we have done so far. I'll be going with the domain name, which we have got it, right? So let me just hit this. The moment I hit this, and you can see we are able to access. Fine. I hope you could able to see the demo. Now we will have to see how do we map with the load balancers and other example. But to start with, I hope you could able to understand the fundamentals of Route 53 and DNS. So far, we have understood Route 53, DNS, the fundamentals, and also we have seen practical, very simple routing, wherein if the user enters any URL, in our case, we had gone with the T-shape skills, telespo.com, right? From there, it will go to the DNS provider, in our case, hosting, where we have configured the name servers. With that, it will redirect to the Route 53, and from there, we created the A record, which used to redirect to the EC2 instance, right? The public IP we had added there, right? Now, usually the applications will not be in single instance, single servers. We will have multiple instances of application. If you go with just one public IP, the entire traffic will route to the same. And just in case if you want to, redo something with the application, maybe you are just restarting the server, the public IP might go. You can go with the concept of elastic IP, but still, if the server crashes, a new server gets created, the public IP will be different and people will not be able to access that application. Not just that, if you have multiple instances of the application, all the instances may not have the say public IP, it may not work. We may have to introduce a concept of load balancer, which we have seen earlier in this entire series, right? Now, what is the architect which I'm trying to achieve? I have to show you. First, I'll be creating the network. As you can see on your screen, everyone knows we have seen that earlier in the series, how to create a VPC, how to create subnet within the VPC, route table configuration, internet gateway, NAT gateway, right? So we'll be creating one resource, EC2 resource within a public subnet of our own custom VPC. And maybe we may have one or we may have two instances, doesn't matter how many instances you have. Then I'll be creating a load balancer and target group, and we'll try to redirect the traffic. Okay, not to directly to EC2 instance, but in between we will introduce the load balancer. Let me pictorially add how it look like. You can see on your screen, we will be introducing a load balancer, and that from the load balancer will be redirecting to the instances where our application is hosted. We will not be directly configuring the EC2 public ID like the way we have done public IP address. We will be rather configuring the load balancer URL, right? So we have seen the demo of load balancer, target group, VPC, subnets, internet gateway, NAT gateway. All the demonstrations which we have seen so far, same demonstration I'm going to use here, right? So if you have any confusion, please you refer those videos of this series and then get back here. It will make more sense, right? I'm just trying to make it more realistic, right? So let me just get back to my AWS. First thing, I'll just click on to the VPC, okay? And we'll be creating one VPC here, okay? So we have done that earlier, okay? So let me just go back and create the VPC only. I'll give the name as Telescope VPC create.
and maybe Telescope VPC 1. That's the name I would like to give. And here, let me give the CIDR here, maybe 0.0.0, maybe, of course. Okay. And let me add this here. I've given it no IPv6 title block. Okay. That's fine. I'll just go and create a VPC. The VPC will be created. The next part is to create this subnets. I'll go back here. Ignore the other subnets which we have here, which I have used for the different purposes. I'll just go back and create a subnet for which VPC. We are going with Telescope VPC 1. That's the VPC. Okay. And subnet name, I'll say here, public, maybe subnet. Of course, SB have given for the subnet, and this we are doing for DNS, just for the differentiating. Different name I have given because we have other subnets also available. Okay. So preference zone, do you want to have any or no preference? No preference, any preference is fine. Let's go with South A. Okay. This time I'm going with the preference. And all right. And here I have to specify, I'll say 10.0.0.1. I'll say by 24. Okay, that's what I have given here. And now I would like to just go back and create. Okay, I'll create one more subnet, maybe the private subnet. I just go back here and say there is VPC. And this time I would like to go with the private subnet. Okay, maybe DNS, right? So let me just add this here. Preference zone, let's go with South 1A. 1B, you can create multiple subnets. In the VPC section, we have seen there is no restriction that you have to create only one or two subnets. Based on your name, you can go to any level, right? So just go back here and .0 dot, maybe I'll say here 2.0 by 24. That's more than sufficient for us. This many subnets what we need. And of course, it has to be dot here. Okay. I'll just create this. That's fine. We have created this. Let me go to the internet gateway. We have some gateway. I'll just keep it as it is. Let me create a new one. I'll say Telescope internet gateway, but this time we're doing for the DNS part, a different demo. Okay. I have created the internet gateway. That's great. And we have to attach this. To which VPC we are attaching this to? Telescope VPC 1. Great. Attach the internet gateway. Now let me go back to the route tables. All right. So we have some route table here. We have a default route table got created for the Telescope VPC. Of course, there is a spelling mistake. That's totally fine. Not a problem. Okay. I'll just go back here. I'll just name it as maybe public route table. Okay. For maybe I'll give it as demo. Okay. All right. And you can create a private route table. You can attach the NAT gateways, all of that you can do like the way we have done earlier. Let me just from here focus only on the public subnet part. Okay, so just click on to this, and I'll just go back and add the subnet association. I'll say here public. Okay, great. And now I have to go back to the routes, and here add the route. I'll say any traffic coming to internet gateway. And what is the internet gateway name? Telescope. All right. I'll just save. Okay. This is that. Now let me go to EC2 instance. And this time I'll be creating one instance here. Okay. So let me go back and launch without a walkthrough. I'll say here instance name as. Okay. I'll say web server. This is the instance name. Amazon Linux. That's fine. Default. That's fine. If you want to get connected, of course, you should have this a key pair which we have created. I'll be allowing the internet traffic 80 port number that should be enabled if you want to access the application. SSH must be enabled if you want to get connected. So you already know this. But the most important part, we are not creating this resource in the default VPC. We have to create the resource in the our own VPC which we have created. That is for VPC 1. Okay. Subnet. I'll go with the public one. Okay, great. Public IP enable. I would like to assign this. Do you want to create a new or choose the existing? If you have existing where you have enabled the security groups for the SSH connection and as well as for the HTTP, then you can go with that. If not, you can just create new. I'll say here security group. Okay, DNS security group is what I have given the name. That's fine. SSH is enabled. HTTP is enabled. If not, you just have to click on add the security group rule. You have to add this. Make sure that 80 port number is enabled. If not, in this entire series, you have already seen how to add inbound rules, how to edit, and later also you can edit and add the 80 port number. Okay, so we have created this instance, but in our own network. Okay, let me just go back here, get connected to this particular instance once it is created. I'll just go back here to this particular instance and I'll establish the connection. You know how to establish the connection. It's not a big deal. Let me just go back here. It should be of it. Now, let me first give the read permission. All right. We have seen this earlier. I would have to use the same terminal. Okay. And now let me just go back here and copy this, get back to this, and I have to establish the connection. Okay. I'll say yes. And yep, we could able to establish the connection. Let me just clear my screen. Now the first thing is I have to install the server like the way we have that earlier many times in this entire series. DNF or yum package manager, anything is fine. DNF, I'll say install Nginx hyphen y. Okay, update this package manager and install this. It will be installed within no time. I'll just go back here and now after it is installed and I have to start the Nginx and then we have to enable. Let me add that command also, which we have seen many times. I've added this, I have enabled. Now I may have to get into a specific path. Let me just get into it. I have specified the path and now if I say ls, we just have to edit this. Okay. Of course, with the sudo privileges, we may have to edit. Okay. So you know this. So I'll not be focusing much on this because our focus is different for this particular video. Okay. I'll be opening and let me add my own static website. You can add your own content here with the help of AI tools. You can generate inline CSS styling and HTML basic website. I have gone with the whatever option I know I wanted. Okay, so let me just edit this. I have added some content into my website. Now I'd like to just go back and save this. So let me save this. Done. And I just get back to my normal home page. I'll clear my screen. And with the help of public IP, let me just try to see if I could be able to access this. Let me go back to my instance, which I've created in my own network. I'll just try to take this public IP. And if I just place this and let's see if I could be able to access. As you can see, we are successfully able to access. Now I just go back here and go to the EC2, of course. And here first we have to create the target group before we create the load balancer. Okay. So this we have seen earlier also. Okay. What is target group? So instances, of course, name of this target group, Telescope target group. All right. So this time we are going with the Telescope VPC number 1. Great. And no health checks. That's fine now. I'll say next. And we have to include this. Let me include this instance, which we have already created. It is included. I'll say next. I'll say next. The target group is created. Now I'll just go back to my load balancer. And if I just click on to the load balancer, application load balancer, of course, and I'll just keep the name here, maybe Telescope load balancer, right? And the VPC, it is the Telescope VPC 1, which we have created right now. Security group, by default, something is added, but let me just create my own, which is giving me some requirement, which is fulfilling my requirement. I'll just go back and say here LBR DNS security group. Okay. And let me add the same description here. No problem. And this is the VPC. Okay. I've added in modules. So first, I would like to enable the SSH, right? So any IPv4 and the most important, which is our traffic, HTTP traffic. Okay. So we may have to enable this. Any IP for anywhere people can access this web application over HTTP. Okay. So I'll just create this security group. It has been created. Let me just go back and I would like to just refresh this. I'll have an option, right? So I would like to just add this here. This one is sufficient. Okay. So that's all. Forward to the target group. Okay. We have created the target group. I'll just forward this to that same target group. Nothing more than this is required. I just go back and click on to create a load balancer. Okay. Right. It is asking me for the zone. So of course I'll go with the South 1A zone because the subnets and the resources are available in the same. Okay. So I'll just go back and say public. That's fine. And let me just go back here. Okay. All right. I would like to just click on to create this. We have one more small issue because it is asking me to at least have the no public subnets in at least 2 zones, not just 1 zone. So what I'm going to do is I'll just go back to my VPC. Okay. All right. I'll just open this in a different page. Let me go back to my VPC and I just click on to the subnet. Let me create one more subnet here. VPC. I'll say Telescope VPC 1 and I'll say public, okay, DNS, okay, subleft, DNS2, okay, one more subnet I'm creating, and I'll just go back 1B this time, and I'll say 10.0.1 3.0, which is 0, of course. All right, I'll say dot 0 by maybe 24. This many IDs are sufficient. Okay. Though we have already created the resource in one zone of public somewhere, but it is asking me at least to specify multiple zones. So I'll just creating one more subnet for this particular zone 1P. Okay. So just go back and create this. That's fine. I'll go back to the route tables. The route table, the public route table for our example, I just go back to subnet association, edit the subnet association and add this to. Okay. So I'll save this. Now I'll just get back here and click on to create the load balancer. Okay. So let me refresh this once again. I have refreshed and I have to enter details once again. Internet facing network, which is our VPC. And this time I'll select both of them. Okay. So of course it is the public one. This is also public. That's fine. And the security group, which we have already created, that it is go back with this. All right. I have added this. And of course, I may have to reselect this. This is also done. Forwarding the request to the target group. I just click on to create the load balancer. It will be created within no time. Okay. So it will take some time and your load balancer will be ready. Now, once it is ready, you just have to copy this, or if not, you just have to go back to the route 53 this time. All right. So route 53 and of course the hosted zone, which we have already created in the previous video. I'll keep in mind that you have already watched that, you know how to create a hosted zone. Okay. This is just a random example. The domain which I have got it for this demo specifically, I just click on to this and then I have to create a record. Okay. So I don't want any subdomain. Let it be a traffic route to IP4 address and some other AP, AWS resources. And I don't want to mention the public IP like the way I have done previously. I'll just click onto this and it's asking me checkpoint. I'll just go back and you can see you have multiple options here. And one of the option is application at classic load balancer. And then this is for application and classic for both. Network for this. Okay. Just go back onto this. Done. And region is asking where have we done it. So we have done it in the south. The entire thing is happening in the south only. So I would like to, where is my load balancer app specifying? Okay. Which is the load balancer? We only have created right now. The load balancer, I've given the name simple routing. That's fine. And I'll just click on to create a record. Okay. So it will take some time, maybe 1 to 3 minutes of time or more. Have patience and the wait till it gets created. Okay. You can see now it is in sync. You just have to go to the browser and whatever the domain name you have, you just have to enter this T-shape sequence. Okay. So .com, the moment I hit this, you are able to access the web application. I hope you could able to see how we could able to divert from the route 53, the DNS, the server's name from there to load balancer, and from the load balancer, it will take care of redirecting to the EC2 instance available. It could be one instance, multiple instance. You already know the concept of load balancers and target. I hope you have an idea about how Route 53 and DNS works in AWS. Make sure you delete all the resources, VPC, subnets, and the hosted on everything once the practice is over. Now we need to understand how do we actually monitor our AWS resources if your EC2 instance is unhealthy, right? If the CPU utilization is very high. If you want to monitor the AWS resources which you're using day in and day out, maybe AWS Lambda, EC2 instance, auto scaling group, load balancer, or AWS RDS, right? All the resources and applications, if you want to monitor, that's where the CloudWatch, AWS CloudWatch comes into picture. And also if you want to notify if something goes wrong to any of the AWS resources, if you are monitoring continuously, then we have AWS SNS. And that is what we may have to understand in this particular video. Both of them practically also we may have to see here. And coming to the CloudWatch, it is there to collect the metrics. Metrics here referring to the measurable value, right? The CPU utilization, disk read or disk write operations, all of them are the metrics here. It is there to collect the metrics, and then we will use simple notification service, AWS SNS, to notify through SMS or through the email. So what practicals we are going to see, if I have to tell you, let me explain to you pictorially. You can see on your screen. So I'll be creating one EC2 instance, okay, and I'll be adding some load. Assume that there is a huge traffic coming over to this EC2 instance, okay. And if there is a burden,
then I'll be configuring the alarm here. Okay, the alarm should be triggered, and based on this, whatever is happening here, that I'll be publishing into SNS topic by using the AWS simple notification service. There I'll be creating one topic. It is a place where you can publish the message, you can publish the data about what is happening in your AWS resource. Okay, alarm should be triggered. I'll be setting some metrics here, that if there is a 60% load onto my EC2 instance, the alarm should be triggered, and based on the alarm, I'll be submitting the data into my SNS topic, all the details, what is happening to my AWS resource, and then I'll be subscribing whatever is there in the SNS topic through the email to my email address. Okay, so that's what I want to demonstrate. SNS topic is a place where we have to publish about what is happening to our AWS resource. Based on this, we'll be subscribing, and through the email I'll be doing the subscription here. Same thing I want to demonstrate practically, for which I'll do one thing here. Number one, I'll just go back and I'll be creating one EC2 instance, and everyone in this particular series by now, they know how to create an EC2 instance. Okay, so let me launch an instance quickly without any delay. So I'll just go back here and I'll say here maybe a server, whatever server, Amazon Linux, that's fine. If you want to get connected, I'll just take any of the key pair. What is key pair also you know very well, so you should not be worrying about it. So let me just go back here and launch this instance. Okay, the moment instance is launched, I'll be establishing the connection. Everyone knows how to establish the connection, everyone knows how to get connected to it. So let me establish the connection here. As you can see, I have got connected to my EC2 instance which I have created. Let me open this. Now I'll just go back here and I will be searching for SNS, right? Simple notification service. And you can see here SNS manage message topics for pub sub. Okay, so someone has to publish something into the topic. Topic is a place the any other AWS service will publish, in our case CloudWatch, and from there we have to subscribe, take that data. Okay, so you can see here publisher subscriber messaging for microservice and serverless application. Okay, so I'll be giving one basic demo here. I'll just get back here. Okay, I'll say here create your topic. Topic name I would like to give. Maybe I'll say here Telescope topic. That's the name I would like to give here. I'll say next step. Okay, and I'll say standard Telescope topic. I would like to give the same here. Okay, with respect to the display name, let it be same. Rest of the things are optional here: encryption, access policies, right? Message delivery, status logging. If you want to add some logs there, all of them are optional. I would like to keep it as it is. If you want to know about them, you can click on to info and you can read it, no problem. I'll just go back and create a topic. Okay, and once the topic is created, I have to create this subscription. Okay, who is going to subscribe the data in this topic? A place, if a CloudWatch is publishing something, who will read the data, who will take the data from this particular topic which I have created. Topic, I have told you, it is a place where the data will be kept about what is happening by CloudWatch, and that data someone has to take it. I'll be creating the subscription here. Just go back and click on to create the subscription. Okay, so protocol it is asking, I'll just go with the email. Great. And it is asking me to give the endpoint, okay, an email address that receive the notification from AWS SNS. As you can see, I have added my email address. You can also add. The moment I click on to create the subscription will be created. You just have to go back to your email address and you have to confirm that yes, I have subscribed. Okay, so that it is not going to a wrong place. I have opened my Gmail. It went on to the spam. You can also check. Okay, I just have to click on to confirm the subscription. Okay, it is been confirmed. Now I can just go back and configure further, right? So now I'll go back to my EC2 instance which we have created. You can just click on to the EC2 instance, one of the AWS resources. You can just click on to action, and then we have an option of monitor and troubleshoot. You just have to click on to this, right? And there you'll have an option of manage CloudWatch alarms. Okay, so I'll just get back into this. I'll just click on to this, create a alarm. Okay, existing alarm you can edit. I'll just create it. Either you can create it from here or you can just create directly from CloudWatch by searching, but I would like to go with the EC2 instance. Okay, now search alarm for us. See if there is something which you want to edit already. Okay, now where you want to notify if alarm is triggered, right? That I have to add here. I want to notify to the scope topic, right? And what should be the alarm threshold when the alarm should be triggered. So I'll say here if the CPU utilization is about 1% or 2%, okay. So I'll just go with 1% because ideally it should be about 70 or 80%, but I cannot show 70-80% of load in this demonstration. So I'll just go with if 1% of CPU is utilized. You have multiple options here, okay. You can see disk read, disk write, network in, out, multiple options are there. I'll go with CPU utilization. So for my EC2 instance, if there is a burden of 1%, okay, within a period of maybe minimum is 5 minutes. So 1 minute is not allowing. Let me go back with 5 minutes only, okay. So the alarm should be triggered, okay. If there is 1% of burden to my EC2 instance, the alarm should be triggered. So of course there will be burden. All this information will be published into the SNS topic which we have created, and from that SNS topic we have already created the subscription. So I'll be getting the mail, okay. So I have configured the alarm here. Let me just click on to create the alarm. So it will be created, and if you want you can check also. You can just get on to CloudWatch. As you can see, I have searched for the AWS CloudWatch and I have got this monitor resources and applications, okay. And if you just get into this, we'll be having the option of alarms, okay. You can see I'll just click on to this once again. Let me just refresh this. So I should be getting the alarm right now. It is showing it is okay. Okay means the alarm is not yet triggered, okay. In alarm means it is already triggered, okay. Right now alarm is created but it is not triggered because there is no burden into my server. So I have just got connected to my EC2 instance, right. I'll be installing some of the softwares just to put some burden, okay. DNF, I'll say install Maven -y, some activity I'm doing randomly to my EC2 server to just to add some burden into it, okay. So I'm just installing some of these softwares. Let it get installed. As you can see, the softwares has been installed, the Maven and Java by default. If you install Maven, Java also will be installed, and you can see still it is in the okay, okay. So that shows the burden is not yet raised, okay. So I'll just again go back here and maybe add one more here, okay, just to add some stress into my EC2 instance. I'll say sudo yum install, okay. Let me just click on to this. All right, I have added. So let me clear my screen and I'll be adding one more command. You can pause and you can just rerun the same to just to give some burden into my server. As you can see, I'm adding some stress to my CPU. All right, so let me just get back here, and if I just have to refresh, if not you can just click on to this, okay. And I'll just click on to this. It is in alarm state, okay. If I just have to click on to this, it is an in alarm in the sense it is currently alarm is triggered, there is some button, state is in alarm, okay. So now what I'm going to do is, what is the threshold it is saying, see, okay, CPU utilization is more than 1 for 1 data points within 5 minutes of time, so alarm will be triggered. I'll just go back to my email and check if it is triggered. As you can see with the topic, Tarisco topic, I have got it and I have got all the details here. Okay, you're receiving this email, your Amazon CloudWatch, it is equal to what is the threshold it is considering. All of the details you could able to notice here. Okay, so basically what we have done here is to our EC2 instance, we have done the monitoring with the CloudWatch. Okay, and we just set the threshold that if 1% of the CPU is utilized, then the alarm should be triggered, and that information should be published into the SNS topic, simple notification service topic, and through the email that has to be subscribed. Whatever data has been published into SNS topic, that has to be subscribed. So basically this AWS CloudWatch is there to monitor our AWS resources, and simple notification service is there to notify about what is happening into our AWS. I hope you could able to understand this, right? So this is one of the basic demo. If I have to get back to EC2 instance, right? So if I have to just get back to this instance once again, and you'll be able to see more on this, okay? Monitoring what exactly is happening. This also through the dashboard also you can able to monitor, okay? The alarm has been triggered because it has crossed certain threshold. All the parameters are available here. I hope you could able to understand this one of the practical demo on AWS CloudWatch and SNS. Now we need to explore the AWS code build and code pipeline, wherein we'll be creating a pipeline, end-to-end pipeline, which will take our code from the GitHub repository such as Git in our case, and also to deploy the application into S3 bucket. So I'll be creating one AWS CI/CD pipeline for static website. So in this entire video, we will be connecting our AWS to the GitHub. Then we will be building the project using AWS CodeBuild, and then AWS CodePipeline will be deploying the project into S3 bucket. All of these things has to be automated, right? So what I'm going to do first is, let me just get back to my S3 bucket here. I'll just click on to S3 bucket. I'll be creating one bucket finally where the project will be deployed. Okay, so I'll just create one bucket here, and you know very well how to create a bucket. I'll just get back here and click on to Telescope CICD. That's a name I would like to give, and I want everyone to access the web application which will be hosted inside this bucket. So I'll be enabling this, so you have to uncheck this. Okay, I acknowledge that I have unchecked because I want people to access, public access must be there. So just click on to create a bucket. So it will be created within no time, and I'll just get back to my properties. We have seen this earlier in this entire series, so only I'm just being very quick here. I'll just get back to this, enable the static web hosting. So index.html, this is the GitHub repository where we have index.html file. Okay, from where I'm going to take my project. So I already have one project in the GitHub. From there I want to take it and I want to deploy that. Okay, so I'll just give the name here as index.html. All right, so index.html, I have given the proper name here. That's done. Now I'll just save this. After saving, I may have to give the permissions. Earlier also we have done this. Okay, at the time of we demonstrated static website hosting using S3 bucket. I may have to add the bucket policies here. Let me add this particular policy. As you can see, I have added the policy. Okay, you can get this from any of the AI tool, or you can just pause and type it. Anything is fine. Okay, public read get object allow, and you have to give your own bucket name. Whatever bucket name you have given, you have to give that name here. So since our bucket name is Telescope CICD, I have given it as Telescope-CICD. Okay, so now I'll save this. Once this is done, I'll just get back here. Okay, I'll be opening AWS, or I'll say CodeBuild or CodePipeline. Okay, so CodePipeline also, if you open, it will redirect to this, and we will have an option of build here. Okay, so get started, build the projects. Right now there is no build available. I'll just click on to this, and I'll give the name here as maybe Telescope code build. That's the name I have given here. Fine. And now primary source, take the project from the GitHub, and there is no connection right now. If I have to again refresh this, let me reload this page once again. So I'll give the name once again. I'll say Telescope code build. All right, and after this default, keep it as it is. Primary source is GitHub, and you might see here, because recently I had created the connection and deleted. That's fine. You just have to click on to manage the account credentials, and here, okay, so we do have an option available here. Let me just check if the connection is still there. Okay, if not, you can just go on to the settings of this and click on to the connection. See, right now there is no connection actually. I'll just click on to create a connection, of course a GitHub connection, right? And the connection name Telescope AWS, that's fine, or maybe Telescope demo, anything is fine. I'll just click on to connect to the GitHub. It will redirect to the GitHub. Okay, so let it redirect here, and now you have to click on to install a new app. Okay, so let me get into this, and now here you can see read access actions, read and write to administrator code. I am allowing all the repositories access here, right? So let me just go back here, and all the repositories access, I'll just click on to save this. Okay, so it has saved, the connection has been made. I'll say connect. So with this, my AWS account is successfully able to establish connection to the GitHub, my own GitHub. Okay, I'll just get into this, and again I'll just click on to GitHub. Now repositories, I'll just refresh this. You can see we will be having the repositories option because I have given all the repositories actions. Okay, in my GitHub there are so many, so I may have to connect a repository where I have kept the code for this particular example. We have so many here. Telescope web app, here is where I have kept it, so I have given this. Anyway, the GitHub link also I'll be attaching alongside the video, so you need not to worry on this. Okay, so single build, rebuild every time there is a code change which is pushed into the repository. Rebuild, I have already tick marked this. This is important. Keep this default only, no problem, and let it be default. Okay, Amazon Linux, so operating system is Amazon Linux. So do you want to create a new role? Create a new role, no problem. I'll give a different name just in case if it is already available, and nothing more than this. Okay, so let me just click on to this. All right, this is fine. All right, I'll just now click on to create a project here. Okay, so this is very important. Before I even click onto this, build specification. So at the time of building the project, what needs to be done? I'll say here use the build specification which is already available here in my project, which I have attached here, right? So we have build specification wherein I have told what needs to be done for a code build. By default, most of the time this is the version. I need not to install anything because it is a simple static website, only index.html is available. Okay, if it was a Java project or some other than Gradle, Maven build tool, I had to tool that install, run the Maven goal commands and all of that. But the base repository or directory is here inside which the index.html file is available. You need not to install anything. Like what needs to be done at the time of you building the project, I have already specified and this is available here. So I would like to take this name here and get back and give the same name here. Okay, I have given the name. This is very important. Okay, so I'll just click on to create a build. The build will be created now. As you can see, the project build is created. Now I'll just get back to the pipeline to automate the things here. Okay, so I'll say pipelines. We don't have any pipeline right now. You just have to click on to create the pipeline here. Of course, the build custom pipeline. Next, I would like to give the name here as Telesco CICD new, or maybe I'll say here as demo. Okay, CICD demo, that's the name I have given here. Demo, I'll say new. Okay, so let it be new service role. Please do create it. I'll say next. Okay, and source provider is of course the GitHub. I have to give the connection name which we have only created, the repository name Telesco web app. I have so many repositories here. I just have to give the name which I'm going to use it here. Okay, so it is Telesco web app. Okay, this is the one, and the branch is main where my application is residing. And now I'll just click on to next. Okay, and other build providers, of course AWS CodeBuild, and I'll give the name of the CodeBuild. That's fine. Okay, and single build, of course, and I'll just click on to next. I'll say next, next, and finally I'll just click on to create a pipeline. Okay, and it should be ready. And also I'll do one thing. I'll just go back here, right click, open in the new tab. Okay, whatever rules is getting created, I'll add more policies into it. So we may have one role which got created right now, right? So I'll just click on to this role. Okay, and here coming to the policies, I'll add more policies. Add the policies, attach the policies. Okay, administrator access not recommended. If you want to make it work, that's fine. I'll say CloudFormation full access I'll give. Okay, and this is fine. I'll say let me just add this permission. This permission has been added. Let me just get back here, and we do have this pipeline. It is able to take, now it is building the project. The pipeline is by default was running. Okay, now it is building this project. You can see the project build is successful. Let me just now click on to the pipeline. Okay, so I'll just create one more pipeline this time. All right, build a custom pipeline. So let me just give it as Telesco CICD. I'll say new demo. That's the name I have given here. That's fine. I'll just click on to next, and source provider as you have already done. GitHub action, name of the connection. I have to specify the name of the repository here. Okay, till build it is fine. Now the deployment also I want to attach that, deploy that into S3 bucket. That also I have to specify here. Okay, so I'll just get into the Telesco web app, and the branch is main. All right, I'll just click on to next, and other build providers, we have already created the build. I have to specify the name of the build. That is also fine. I'll say next, no test, but this time deploy. We want to deploy also, not just build. I'll just click on to AWS S3 where is we have to deploy. Okay, and bucket name we have already created, Telesco CICD bucket. All right, and that's fine. Extract file before deploy. Okay, extract file before deploy, and you just have to click on to next, and again you just have to create a pipeline. Okay, now the pipeline will be different. It will not just take the code from the GitHub and build the project, it will also deploy. Okay, so let's wait for it. As you can see, it is taking the project. So this is the pipeline where everything will happen in the sequence. First it will have to take the project from the GitHub, then it has to build a project, then it has to deploy the application into S3 bucket. So if I have to open my S3 bucket right now, let me open that into new. So I don't have any buckets right now. The other bucket might be there. I mean, we have created this bucket, but inside this bucket we don't have any website, we cannot access it. Okay, so let me get back to my properties. By taking this bucket website endpoint, if I try to access, you'll not be able to see anything unless it is deployed. Now it is able to access because maybe the pipeline is successful. I'll just get back here. You can see it is success. The moment it is success, you are able to access this. Fine. So I would like to just go back here, get into my project here. All right, and index.html, and I'll make some small change here. I'll make a new commit here. Okay, so whatever is the commit doesn't matter. I'll just add one more here. Let me add one more. Okay, just to show you that it is happening because of the pipeline only. I'll say here agentic AI with Java. Okay, something I have added just to make sure that I can demonstrate it is happening. I'll just click on to this commit. The code has been committed. I'll just get back here and I will say, okay, release the change. That's all. It should be redeployed. Okay, so let it take some time, and you will be getting the agentic AI with Java also here very shortly. Okay, so now it is taking the code, building, and finally it has to deploy. Let's wait for 1 minute. You can see the pipeline is deployed just now. Okay, the entire static website has been deployed. Again, I'll just go back here and refresh this. You should be able to see agentic AI with Java as well. This was entire CI/CD pipeline to deploy the static website into S3 bucket, but we have not done manually. We have not uploaded the index.html manually into our S3 bucket. Rather, we took help of AWS CodePipeline. We took help of AWS CodeBuild in order to build the project, and also we could able to establish connection from our AWS to our GitHub, and then AWS CodeBuild to build the project, and CodePipeline could able to do all these things in sequence one by one. Finally, we could able to host our application into the S3 bucket with the help of CodePipeline, and our entire pipeline is successful. After the practice is over, make sure you delete all the resources, the pipelines, the code build, the S3 bucket, so that you are not unnecessarily using any of the AWS resources. Now we need to understand one more important concept, which is about the AWS command line interface. Okay, the AWS command line interface is a unified tool to manage your AWS services. With just one tool to download and configure, you can control multiple AWS services from the command line and automate them through the scripts. So far, entire AWS infrastructure provisioning and management we have done with the help of the AWS console management, right? So everything with the help of UI, we have navigated wherever we wanted, we got there, and we could able to create the infrastructure. But that is not the only way. There are multiple ways available in order to manage the infrastructure and services in AWS, right? So if I have to pictorial represent, we have done so far is using the AWS console about the infrastructure management or provisioning, creation of the infrastructure and managing the infrastructure. But you can also do with the help of AWS CLI, CloudFormation, which is again from the category of infrastructure as code. Then we have Terraform, which is again from the category of infrastructure as code, especially if you're working with the multi-cloud platform. Okay, so in this series, we shall be trying to explore these things. Now, we have done with the console management. Let's start journey with the AWS CLI. Okay, so you can just click on to get started. If you get into the AWS, then it will redirect to the documentation, which will give you all the requirement. And if you just click on to the install and update, you have multiple options here. Okay, and since I'm going to install on Windows, I'll just click on to Windows. Okay, we have an option here, AWS CLI, Amazon AWS.com, AWS CLI.msi. You just have to click on to this. It will be downloaded in your local system. As you can see, it is downloaded. I'll just double click onto this. Okay, once it is downloaded, you just have to double click onto this. Then it will ask you. Okay, so I'll just click on this. Please wait while the setup is at preparing to guide you through the installation. Okay, I just click on to next. Then again, I accept the terms and conditions. Next, next, install. Okay, I'm doing locally on the Windows, but Generally, in the real world, in the Linux machines, you may have to install this in order to configure the infrastructure with AWS CLI. Okay. You may also get the pop-up while installing. Do you want to allow this app to make changes to your device? The answer is yes. You just have to click onto this. It will take some time and it will be installed. Okay. So let's wait for it. As you can see, it is installed. You just have to click on to finish. After this, you just have to open the command line, okay, terminal in your local laptop. Once it is open, you just have to navigate here and you just have to click on, okay, AWS configure. Okay, you just have to do the configuration. The moment you click onto this, it will ask two things. One is access key, the other one is secret key, right? See, there are lakhs and crores of AWS accounts, right? So you just have to prove who are you, which account you're trying to get into, right? And whether do you have authority to provision or create infrastructure in that particular account. You have to give the security key and password, security key and secret. Only then you will be able to configure. It is not just for AWS CLI, same goes for the Terraform or CloudFormation. You just have to prove first who you are, whether are you allowed. You have to be authenticated and authorized to create the infrastructure in that particular account, right? So to get this access key and secret key, you just have to get into your AWS account, okay? And either through the IAM, if not, if you have to navigate here, okay, there will be an option of security credentials. We have an option of security credentials. You just have to click on to this, okay? And then you just have to get into this. We have an option of access keys, right? Click on to create an access key. I do understand. You just have to create it. So you got access key. You have to just get back here and paste it. Done. It is asking for the secret key. I'll just get back here and copy the secret key, right? So I'll just say done. And the moment I hit on this, by default, it is considering the Mumbai region. If you want to give some other region, you have to specify here. Okay, what default output format, let it be a table, no issues here, right? So now I could able to prove that I have authority to provision the infrastructure there. And now with the help of command line, I'll just check how many S3 buckets are there. AWS S3, I'll say here ls. You can see there are no S3 buckets here. How do you know? I'll just get back and to my AWS account. I'll just navigate to S3 buckets through the console management. Okay. So I'll just see here, we don't have any buckets here. Okay. So if I have to just get back here, general purpose bucket, no, we don't have any bucket here. Okay. So now with the help of AWS CLI, I'll just try to create the bucket, for which I'll be just running here AWS S3 MBS3. You just have to specify, okay, the name of the bucket should be globally unique. We have seen about AWS S3 in this series. Okay, I'll just give some unique name which has not been used. I would like to hit this. Okay, so it should be provisioned. Okay, make that bucket. I'll just go back here, and if I have to refresh, you can see the AWS bucket is created. Okay, now I'll just get back here and I'll just try to delete that bucket. Okay, I'll just say here AWS S3 RBS3. Okay, before I do this, I would like to also check how many buckets are there. S3 LS, earlier we had not got anything. You can see right now I'll be getting the output here. Okay, so we have got one. So now I'd like to delete one. I'll say S3. I'll say AWS S3, of course, AWS S3. I'll say RB, remove. I'll say S3. Please remove this particular bucket, whatever the bucket name you have given. So I'll say here 4543. Okay, I would like just hit on to this. It should be removed. Okay, so remove the bucket. I'll just get back to my AWS account. If I have to refresh, it will be removed. Okay, so how do we know all these commands? Just have to get back to this AWS CLI, right? Get started here. Only if you just click on to AWS CLI examples, if you see guided examples, command examples, if I have to click on to any of this thing, whichever you want. Okay, so maybe let me go through S3 only. You can see I've navigated to Amazon S3. If I have to just click on to this, okay, so I'll just click on to this again. Here, if I just click on to create a bucket, it will only give the command. What are the commands? If you want to be very specific to the region, name, multiple options are available. Okay, so you can just see here, and maybe if you want to see the bucket, delete the bucket, what for each and everything, it is only giving the command. You need not to even recall what you may have to do it. Okay, so like this, for each and every resource it will give you the detail. You can see for the examples also, guided command example, maybe S3 only. I'll just click on to whatever we have already used. Okay, so I just get into this commands here, and you can see here all the commands. It is only giving you what are the commands you may have to run. Okay, for EC2, I just get back here and I'll say instances, for example, prerequisite launch your instance. If I have to click launch your instance, we may have to run this. You need not to worry, you need not to recall. Okay, it is expecting you to run here. This is the command based on your need. Add a tag to your instance at the time of creating. List your instances. AWS E to describe instances. Right now there are no instances which I have created, or let me see if there are any instances. I'll just copy from here, get back here in my AWS account, because if I just hit on to this, so let's see what response we may get. All right, so you can see here we are getting some responses. Okay, so describe the instances, owner ID, instances, AMI launch index is 0 here. Okay, so capacity reservation specification open. Okay, so all other information in the table format it is able to give you. I hope you could able to understand. And these commands which I have executed, you need not to memorize, you need not to know. Okay, so if you just get into the official document like the way I have shown, it is only giving you. You just have to configure. So generally, even from the suppose I have created one Linux machine using which I'm managing my Kubernetes cluster. You need not to go back to AWS console management, okay, manager, and there from there you're trying to create or provision the EKS, AWS EKS, Kubernetes cluster. But here only in your Linux system only you can just install AWS CLI, EKCTL, all the client softwares. From there you can just provision the infrastructure. It is very, very helpful in the real world. So generally every time we don't navigate to the AWS and provision the infrastructure or manage the infrastructure. Sometimes you also do by using the AWS CLI or Terraform and CloudFormation. CloudFormation and Terraform anyway you'll be seeing moving forward. But I hope you could able to understand one of the simple example with respect to AWS CLI. So far, we have seen infrastructure provisioning, creation of the infrastructure on the AWS cloud with the help of AWS Management Console. We have also seen the demo of AWS CLI. Going forward, you'll also see how do we do that using Terraform. We have one more option, infrastructure as a code. Like the way Terraform is also infrastructure as a code, AWS own infrastructure as code, we have CloudFormation. One of the way to provision manage infrastructure on AWS. What you have to do here is you just have to go back and search for, I'll say here CloudFormation. Okay, I'll just have to say here CloudFormation. You just have to open this, create manage resources with the help of templates, wherein you have to specify the code what you need to do it. Okay, so the first thing, let me just click on to this formation. You can see AWS CloudFormation, model and provision all your cloud infrastructure. AWS CloudFormation provides a common language to describe and provision all the infrastructure resources in your environment in a safe and repeatable way. Once you write the code either in the JSON format or in the YAML format, YAML is very common among the DevOps and cloud engineers. Once you write the code, same code you can reuse multiple times. Again and again, you need not to get into AWS Management Console, navigate and create the infrastructure one by one. Once you write the code, same code you can repeatedly use multiple times. So in order to use CloudFormation, the first thing which you have to do here is create a CloudFormation stack. Okay, when you have to use the template code which you would like to use, I'll just click on to this, choose an existing template, build from infrastructure composer. Choose an existing template. I already have a template with me. I'll be giving you a walkthrough of that also. Okay, so that template, where have you kept the infrastructure as a code in the YAML format? Where have you kept? Is it in the Amazon S3 bucket? Are you going to upload the template from your local machine? I would like to choose this. Okay, so I'll just click on to this. It will redirect here. I have so many folders here. I have kept this in the DevOps. Okay, so EC2 Linux, a YAML source file it is. I would like to just click on to this, right? So it has been added. So before I do anything, I would like to also open this and give you a walkthrough on this. You can see here the code of the YAML for EC2 instance. I have added which image to use, what is the name it should be, right? EC2 instance type, image ID, security group reference, name of this, And also I'm adding the user data at the time of launching the instance. I want a basic static website also to be uploaded with security group. These configurations, AWS only will give you these samples. Once you work with it n number of times, you'll be used to it. In the YAML format, you have to write your code. This time, this YAML code is to provision, create EC2 instance alongside the user data. So the moment the instance is created, whatever you write here, that also will be executed. Okay, one EC2 instance by this name also will be launched. The same template I have updated, the same code I have updated here, or you can say uploaded here. Okay, let me just click on to next, and it will just redirect to this page. I have to give the name, whatever name you want. I'll just go with Telesco EC2 VM. That's fine. And let me just click on to next. All right. It's asking me to give a IAM role. Create a new role or choose existing. Okay, no roles are there. I'll just click on to create a new role. Okay, it should have a permission in order to create this, right? So I'll just go back here. Even if you don't add this, it will not create much, problem, because it is anyway optional. And in my YAML only have specified most of the things which I required here, right? So let me just get back here, and I'll just give a try once without specifying, because it is an optional step. Okay, so all of this, let it be as it is, the optional. I would like to just click on to next. Okay, and the template is ready. It is telling me. I just get back at the bottom. I'll just click on to submit here. Okay, it is getting submitted. So it will also give the events, live logs, what exactly is happening here. Each and everything also it will give you. It is in progress. Okay, so also I'll open EC2 instance in a new tab and check if it is getting provisioned. If a new infrastructure, a new EC2 instance is getting created. Let me click on to instances. You can see Telesco server 1 right now is running. It is still in the initialization stage. Okay, so let me just refresh it. Still in the initialization stage, and you can notice here it is getting created. You can see we have got this completed. Okay, in progress. Now it is completed. So it has created the web server and security group. First it has created, then the web server. The entire infrastructure has been created. Okay, so stack information is there, and the status is create complete. It is done is what it is telling me. So let me go back here and see. Yes, it is created, the infrastructure. And this code you can use multiple times. Again, you need not to navigate to AWS management console and click on to next, write the name, add the security group. All of that is not required. With the help of code, infrastructure as a code, you can provision any type of infrastructure. Okay, and I'll just use this public IP, and let me check in the security group if it is already there. Okay, inbound rules. Let me just get on to this. We have to enable 80 port number. It is already enabled. Okay, great, no problem. I'll just get back to my EC2 instance here, running instance, of course. I'll just get back here and use the public IP and try to access a static website which we have added there. Okay, so let me run this. It will take some time to add. If not, the user data, if sometimes may not work, that's fine. But are we able to create the infrastructure EC2 instance with the help of infrastructure as a code? You can see yes. And we had given the name also, Telesco server 1, and also we had given the security group name, everything. It is created as it is, whatever we have specified here. So basically this is also one of the way to provision the infrastructure on the cloud. We just have to create the stack. You have to either add the YAML, the code through which you want to provision the infrastructure. Provisioning here means create the infrastructure. Okay, either you can upload from local machine or you can add from the S3 bucket. Multiple ways are there from where you can create this. I hope you could able to understand. Let me just open this in the new tab, and if I have to get into the console, it is also giving you the free demo. Okay, code your infrastructure using the CloudFormation template language in the YAML or JSON format. Start from many available sample templates. It is only giving you many sample templates using which you can generate. Or we have infrastructure as code generator. Okay, multiple options AWS supports you, using which you can provision. But in the industry, very often we may go with Terraform, because Terraform is not specific to only AWS. If your company is working with multi-cloud platforms, then is there a common way, a common code which you can use for different cloud platforms? That's where Terraform comes into picture. And that is also from the category of infrastructure as a code, and hence it becomes very important. But the CloudFormation demo also, I hope you could able to see, with the help of YAML code, you can also provision the infrastructure. We have seen AWS CLI also, we have seen AWS Management Console also, we have seen the demo of AWS CloudFormation.
to make a quick update before we proceed further in this series. Now we may have to understand about the ECS, ECR, Elastic Beanstalk, right? And how AWS CLI, RDS, all of them work together in the real world. For which I may consider the application also. I may also show the demonstration of Spring Boot application, Java application. If you are from the coding background, then you'll be in a position to understand that. If you are from the non-coding background, you need not worry about the code which I'm going to demonstrate here. Please don't focus on that. As well as I'll be considering the Docker file just to show you the realistic approach, right? I'll be writing a Docker file. I'm also show the Docker files for the containerization. You can ignore that if you are not aware of Docker, because anyway going forward we will have a separate series on Docker also. You'll be in a position to understand. For now, the coding demonstration which I might show in the upcoming videos. If you're not from the coding background, if you're unaware of Docker, please ignore it. Consider only whatever services, AWS services we are trying to learn. See the demonstration which I'm trying to show you. Okay. So far we have understood EC2, VPC, networking, security group, internet gateway, NAT gateway, RDS, S3 bucket, AWS Amplify, right? Multiple of the AWS services we have already seen practically. We may have to say few more, for which I have considered some of the realistic approach by considering the application codes, Docker files. So if you're from the coding background, take it. If not, you can ignore that. Focus on the AWS practicals and the cloud deployment which I am trying to show, right? So you'll be getting the link of the resources which I am using there, the application code or Docker file. So you need not to worry on that part. Fine. And I hope you have practiced whatever we have done so far. Now let's proceed further and see little more realistic way and also understand the cloud deployment with respect to AWS before we proceed further in this entire series. Let's get started. Now let's develop a basic Spring Boot Maven web application which I would like to deploy in the AWS Elastic Beanstalk. So I would like to just search here Elastic Beanstalk. Okay. So here is where I want to deploy the application by using this platform as a service, which is the Elastic Beanstalk end-to-end web application management, right? So I would like to use the Spring Boot here in order to develop this basic web application to start with. So it is Java. I have opened the start.spring.io, a Spring initializer. Irrespective of the ID you have, you can develop the project here. You can create the project here and then you can use any IDE of your own choice. Okay. So now it is a Java Maven. I would like to use the Spring Boot stable version and let the package be com.telescope, and the application name I would like to just give it as maybe sample web application. That's the name I have given here. Any name of your own choice, so that should not create a no problem. Packaging as the jar, configuration application.properties, Java 17 I want to use, and only one dependency which is a web dependency. Based on the need of application, you can add any dependencies. But to start with, it is a simple web project. So I would like to just add only web part here. Now let me just generate this project and I'll open the Eclipse IDE. Now the project will be available on my downloads. I'll just take that and add in the directory where I have opened the Eclipse, which is Java SB, and I will extract the project there. Once you extract the project using the Eclipse ID, I will import the existing Maven project. Let me do that. Import that here. I'm using Eclipse IDE. You can open the project in any IDE of your choice. It should not be a problem, whichever IDE you're already comfortable with. Okay. So now I would like to just import this, import the existing Maven project. I may have to navigate to the path. So it is Java SB, and we do have one application just now which we have created. Out of all the applications, it is the, let me just show you this sample web application. Okay. And now I would like to say finish. The project will be imported within no time. It will take some time and the entire project structure is in front of us. You can see in the dependencies. Right now we have only one dependency, which is the web dependency, right? So now it's a basic application. I would like to just go back here and create maybe one package by the name controller. I will say here controller, that's the package. And let me create one REST controller, whichever is the name of the class you want, you can create. So maybe I'll just give it as telescope controller, whatever name you want, you can give it. And everyone knows, people at least who are watching this, they should be knowing the basics of Spring Boot. So I would like to just add here maybe, let me just give it as telescope controller. Whatever name you want, you can give it. And everyone knows, people at least who are watching this, they should be knowing the basics of Spring Boot. So I would like to just add here maybe sample web application. REST controller. Okay, I'm just going to generate the response here, and maybe let me just create one response for the home page. I will see here, maybe method name as home, return type let it be string, right? So anyone getting into, maybe I'll just say here a basic application, a basic message. I will say maybe welcome to Telesco Learning. Okay, welcome to Telesco Learning. That's what I have told here. And I'll map this entire information to a GET request by using GET mapping annotation. I have kept in mind people who are watching this, they know the Spring Boot. That's what in my mind. And now I'll just give the endpoint, which is default. This is the home. Okay, for the first time people visiting the application, by default they'll be getting it as welcome to Telescope. And similarly, I would like to develop one more response. Maybe I'll just say here get info. That's the name I'll say here, get information. And I will say here information is the endpoint. And I'll say maybe whatever message you want, visit telescope.com for courses information. Okay, great. So I have created two API methods. One is the home, one is if the end user reaches out to the info. Since they are binded to a GET request, after running this application, we can check it in the local host also. Okay, so first, before I do anything, I would like to run this application. Okay, this is a sample application. Let me say right click. I will say here run as the Java or Spring Boot application. So by default, Spring Boot application gets deployed in 8080 port number. That's the default port number for any Spring Boot web application, which will be deployed in embedded Tomcat server, which is already available in the Spring Boot. Since it is a Spring Boot project, you need not to do any extra efforts. The moment you run the Spring Boot application, by default, it gets deployed in embedded Tomcat server with the port number 8080. So that's what I have done here. So let me open the browser, or you can open the Postman tool also, not a problem, but I would like to open the browser here and I will navigate. Let me do that here. As you can see, I have navigated localhost 8080 homepage. We are getting welcome to Telescope. And if I reach out to maybe our endpoint, which we have created, info. So we have visit telescope.com for courses information. So basically a simple web application is ready. Now I want to deploy this in Elastic Beanstalk. But if before I do this, I want to package this application into jar file. Different IDs, different options we have. In Eclipse IDE, the way we have to run the maven goal commands in order to generate the jar file or var file is slightly different with respect to UI. Maybe in the IntelliJ IDEA, it's slightly different. But both the IDs, it is possible to generate the jar file, right? So now I would like to generate the jar file here. For which, before even I do this, let me also specify the port number. The default port number on which the Spring Boot application works is 8080, but I want to change it to server.port equals to 5000, because 8080 port number by default, the family of 80 and all the 80 family will be somewhere getting used in the Elastic Beanstalk. Since we have a plan of deploying this application inside that service of our AWS, so it is expecting us to give a specific family port number, for which I am giving it as 5000 as the port number. You can give any other also, but I have given here 5000 because I have a plan of using a specific AWS service in order to deploy the application, which can work for us, right? So this is the port number I have given. After giving the port number, you can just go to the application. All right, I'll say right click, and we have an option of run as maven build. Directly we have an option here, and it is asking me to give the maven goals which I want to run. Clean. If there is already jar file generated, please delete that. And the package, it will do the compilation, running the test cases, all the maven goals before package, that will be executed without any problem. Okay, so clean package. Now I would like to say apply and run here. Let me just check. Yes, it is running. It is creating. See, build is successful. And you can see here, if I refresh my project, I'll say right click and let me just refresh my project. And we have here target folder getting created. So target folder is created and one jar file is also generated with snapshot, version, everything. If you don't want this, if you want to give only name, that is also possible. So for which what you may have to do is, if you don't want to generate this, you want to clean this again. So you can open your pom.xml file, which we have here,
And if you just scroll down within this build, you may have to specify what should be the name. So let me just add this here. As you can see, I have added here, this is the name I want for the jar file. So after adding this, I'll say right click and update the Maven, update the project. I would like to update this. It has been updated. Let me save this. Again, I'll just go back here. I'll say run as the Maven build, and the goals which I want to execute is clean. I want to clean the existing jar file which is generated, and we have an option of package, right? Apply, and I'll say run here. And the moment I do this, again the jar file has to be generated. All right, it is building, and the build is successful, right? So let me just refresh my project. If it's a refreshed, we can see here we have jar inside the target directory got created. Left side you can see here, and we have here option of simple application.jar, and this jar we can use in order to deploy the application. There are multiple options available. You can dockerize, you can generate the var file, you can generate the jar file. Based on that, you can deploy. How do we do that in the AWS Elastic Beanstalk? We may have to see that. Now let's deploy the simple web application which we have created. We have already generated the jar file, and the same we may have to just deploy. And I'm going to use this platform as a service, which is Amazon Elastic Beanstalk. Okay, so I have opened this, and we have an option of create application. You can keep it web server environment. Give the name of the application, whatever you would like to give. I'll just give it as maybe simple application. That's the name I would like to give, right? Or maybe I'll say here simple application. Okay, now domain name, if you want, you can give it. If not, it will auto generate at the time of generating the URL. So I would like to keep it default. And we have an option of platform here, which platform you would like to go with, right? So we have multiple. You can go with Docker, and we have an option of, you can say, Tomcat. If you had generated the var file of the project which we have created, then you had to choose Tomcat. Since we have generated the jar file, you have to go and choose this Java. I have clicked it. Okay, by default it has selected some of the platform and the platform version. Let it be. You don't change that. Okay, then we have an option here, application code, sample application, which maybe Elastic Beanstalk only will give you, or I would like to upload your own code, or you would like to go with your own code. Since we have already generated the jar file and we have developed the application, so I would like to just click on upload your code here, right? Now you have an option here. So you would like to upload the code from the public S3 URL, S3 buckets. Maybe if you have already uploaded your code there, from there directly you can add. If not, from the local file. I have not done that. I have not created any S3 buckets. We have not added any project there. So I would like to just click on local file, and I would like to just maybe version label it asking. Let's go with V1. Choose the file. I have to just select the jar file which is available here. Okay, so now let me just go back here. We have an option of ESB, Java SB. Here is the workspace, and here we had an option of sample web application. Okay, so the sample web application, the name. So let me just check this. What is the name we had given? It was sample web application. Okay, so let me just open this. I think it is sample web application. Okay, great. The same. So let me select this sample web application, and if I open this, we have a target directory. Inside the target directory, we have this jar file. This jar file we may have to select. Open this, and the jar file has been selected. Okay, now what is the preset you want? You want high availability. That means the type of instance, how many instances. Since it is for the demonstration demo purpose, I would like to go with single instance, which is free tier eligible. So let me just click on next. The moment I click on next, it will redirect to this page. Service role, do you want to create it, or do you want to choose one? So I would like to just create one, a new role. Okay, so it will create its own role. So let me just check where we are in this specific. So it's globally. So let me just go back here. All right, I'll just say here next, and then next. A new role has been created, guys. I'll say here create the role, and the same role I would like to select here, right? So if I refresh, the role has been created. It has been selected by default. EC2 instance profile, it is asking. Okay, so what is the profile? See, other roles are there. We may have to give the authority, like which services it can use. So I'll just again click on create a role here. A new role I want to create, AWS services. So use case. Okay, you can go with EC2 also. Behind the scene also, anyway it will use EC2 only. and I'll say here next, and I'll give administrator access. It is not recommended to give administrator access to everything, but I want it to make it work, and it is not in the production, so no issues. Apart from that, I would like to also give administrator access for AWS Elastic Beanstalk and maybe web tier, worker tier, service, role SNS, okay, and maybe RDS if it's in case if it is required in future, ECS if you want to use it. Even if you go with only one access also, it is more than sufficient, okay. So I would like to add this, and role name, it is asking me AWS EC2 role, okay, let it be. I'll say here create, and the role has been created here, okay. Let me just go back, and if I have to refresh this, we do have an option of you can see AWS Beanstalk EC2 role, okay. Key pair, if just in case if you want to log into the EC2 instance which it is getting created. See, behind the scene, Elastic Beanstalk uses EC2 only. EC2 is an infrastructure as a service. A server will be created because we have given the single instance free tier. So to get connected, just in case, do you want to create any key pair? Do you want to select it? It is what it is asking. So I don't want to get connected even if you don't select. I have created so many key pairs in my AWS account for different purposes. Even if you don't select here, it is not a problem because anyway we are not getting connected to that EC2 machine for now. So I'll say here, if you want, you can just go and say next, next, next. For now, nothing much is needed. You can just click on skip to review. Let me see next what options we will have. All right, VPC and all it is asking. Let me just go with skip to review because we don't have much here to do it, okay. And you can see we do have an option. All right, which one it is choosing, single instance. It is going with instance type t3.micro and t3.small because we have gone with the free tier eligible, right? So that's the reason for this, okay. Now I would like to just click on create, and the moment I create, it will take some time. We will be getting the URL also. You can see here Elastic Beanstalk is launching your environment. This will take a few minutes. And events also, you can see here it is giving you the logs each and every second, what exactly is happening. It is giving you the logs info, okay. If you keep on refreshing, you'll be getting so many logs, and it will take some time and your application will be ready. You'll be getting the domain here, URL, using which you can access the application. So let's wait for some time for the domain to be generated, for the URL to be generated. As you can see, the URL has been given. If you want, you can just click on this, okay. So creating the environment is started, okay. Successfully launched the environment. All right, instance also has been added, so it is okay. And I just have to click on this URL. The moment I click this, I should be able to access the application. So let me just click here. As you can see, welcome to Telesco Learning. That was the basic application, right? We tried to access. Let me just reach out to the another endpoint which we had created here, info, and you can see visit telesco.com for the courses information. Basically, we could able to deploy the very basic Spring Boot Maven application into AWS by using Elastic Beanstalk. Not just that, I would like to also show you EC2. We have not created any instances, right? We had just used Elastic Beanstalk. It will create the instances on our behalf. We should not be taking care of infrastructure because Elastic Beanstalk comes under platform as a service where it will take care of everything and it will give you a ready-made option just to upload your code. So let me just show you this. See, these instances we have not created. Simple app environment, you can see on your screen. This was created behind the scene by Elastic Beanstalk, right? We have not created this. So if I have to just get back here, so Elastic Beanstalk, and we have an option here. This is the application which is executing, and this is the domain, and we could able to also access the application here without any problem. You can see here, welcome to Telesco Learning. So this was our first application which we could able to deploy. So far what we have seen is that we could able to build a basic Spring Boot web application, and that we could able to successfully deploy with Elastic Beanstalk, right? We just generated a jar file and simply we uploaded the jar file because Elastic Beanstalk comes under platform as a service. It will take care of a rest of the things. But that was just a simple application. It was a single tier application. We did not had any database there, right? So what if there is an application which also has a database? How do we do that? That's what we may have to see here. Suppose if it is in your local machine, you have installed the required softwares, maybe Java, IDE, you have developed the application, and in your local machine only you have installed the database, and you could able to get connected to that database, and you can run the application. But this time you want to deploy that in AWS. How do you do that? Can we just generate a jar of our project like the way we have done earlier and deploy that in the Elastic Beanstalk? And can that get connected to the database which is locally there in our system? The answer is no. Then what we may have to do? We may have to go with one of the service in the AWS which is RDS, using which you can create one relational database on the AWS itself. So we may have to just first create the database on the AWS. All the credentials we may have to add in the application configuration file, right? Different ways you can maintain differently, depends on what tech stacks you're using. If you're going with the Kubernetes, you can go with the config maps, and the Jenkins also we have an option of maintaining the secrets. If not, if it is a simple application, you can just add those configuration, the database URL, the password, everything on your application.properties, and you can create jar of this. Once you deploy, that application will be able to get connected to the RDS which you are creating on the AWS. How do we achieve that? We will see this, but before this, what application I'm going to deploy which has the database, I would like to just quickly give you a walkthrough. I have kept in mind that people who are watching this entire video, they already know the Spring Boot, they are exposed to the coding, because this is the last part we are seeing here, cloud deployment part here, right? So I'll keep in mind that you have already seen the development, you are aware of the Spring Boot. That's what I have kept in mind, and I would like to just quickly give you the walkthrough of the code. What I am doing with this code, you can do with the same projects which you have done throughout your Spring Boot journey, right? So this is our simple application. So if I have to give you the walkthrough on the pom.xml, we have the dependencies here, theme leaf for the front end, and data JPA, we have web to create the APIs. This is a theme leaf and dev tools for auto reloading. And I would like to go with the MySQL here. That also we have, okay? Now, if I have to give you the controller, these are the endpoints we have. I'm giving the walkthrough. I'm not developing the application because I have kept in mind that you already know the development, right? So this is one of the endpoint which will give you the list of all the courses. If you want to update, if you want to register a new course, right? If you want to delete the course. So we have multiple options in this application. I'll just show you the output also. This is the model class, entity class, which is going to get connected, or it is representing the table of database. I would like to say that. And this is our repository layer in the Spring Boot. If you're going the data JPA, I would like to go with CRUD repository, right? And this is our business logic, the service layer, which is getting connected to database and performing some activity, right? So front end, we are using here theme leaf. The back end, it's of course Spring Boot, and we are getting connected to MySQL database. I hope you will be able to understand this code here, because nothing much we have done here. It's a very basic application. Even if you know the basics of Spring Boot, or you can say the entire all the layers how we develop in the Spring Boot ecosystem. Now let me just show you the output, how it looks like in my local setup, where we have database connected here itself, and Spring Boot application is also on the local machine. You can see in the application.properties, if I have to open application.properties, see here, I'm getting connected to localhost. Okay, this is the username of my database on my local machine, and this is the password which I would like to use to get connected, and it is a local host, right? In the local setup, I would like to just show you the application output. So let me just run this here. I'll say run as Spring Boot application. All right, so it is getting executed and it's getting deployed in 8080. Once you're going to use the Elastic Beanstalk, you may have to change it to the family of 5000. I'll do that before we generate the jar file. So let me just go back to my browser and try to access this. So let me open the browser here. All right, you can see we do have this browser, and if you reach out to 8080 localhost, course list is the endpoint of the application resource. See here, we are getting this output. If you want, you can add a new course here. Let's just add the new course. I'll just say here DevOps and whatever the maybe, and I'll say here the name of the instructors, and we do have the duration. Maybe I'll say here 100 hours and some fees randomly. I will just write save the course, and you can see we could able to get this. I hope you are able to understand. If you want, you can update. If you want, you can delete all the operations. That means we do have an application which is getting connected to database and able to perform the operation. A very basic application. Same I would like to deploy with the Elastic Beanstalk, which we have already used, but to deploy a simple application. This time it is a multi-tier application, for which first what we may have to do is to create the database on the cloud itself. And that credentials we may have to add in the application.properties. Here we may have to update, after which we may have to generate the jar of this, and then we may have to deploy. How do we do that? We may have to see. Now let's create the database on AWS, right? I have logged into my AWS as a IAM user, like the way we have done earlier. And here you can just search for RDS, right? We have an option of Aurora and RDS. And here you can just navigate to the left. We have an option of databases. Here is where we may have to create it, right? So now I'll just click on the option of create database. Full configuration, easy create, anything is fine. Let's go with the full configuration. MySQL database I would like to choose here, and let it be the default. Addition, the version, let it be default. And here it is option. Is it for production? It is for testing and development. It is for the sandbox. Very basic. So I would like to just go with the dev or testing. And let me just use either single AZDB instance or multi AZDB instance. Multiple is not required. A cluster is not required here because it is for the testing. This is more than sufficient. 2 instances. Even if you go with this, that will also not create any problem. So DB instance identifier, let's keep it as it is, database 1, or maybe if you want, you can just give a different name. It should not create a major problem. Master username, admin, I would like to keep it as it is. Password cells manage. So let me give my password, which can be managed easily. I'll just give here. Okay. And I've given the password here. Password authentication, keep it as it is. And now let's go with this bustable classes. This basic is more than sufficient here because it is a simple application. And allocated storage, I think 20 GB is more than sufficient. 200 is not needed, right? Now connectivity, you can see I don't connect to EC2, that's fine. Default VPC, if you want, you can create your own VPC. You can create your own security groups, subnets, and then create it. If in case you are going to deploy that using AWS EKS, okay, and then you're using Docker, AWS EKS, which is Kubernetes cluster, then all of them have to be in the same VPC. So since we are not doing that here, I would like to go with the default VPC, which is already available, which will be there in every new AWS account you're creating. By default, one VPC will be there, which is isolated network, right? Now, public access, this is very important. You may have to check on yes. We may have to go with this public access. I've clicked yes. Existing security group, let it be the existing one, whatever we already have here. And I don't want to have any monitoring. I would like to disable that. Okay. And I don't want to have any backup also. It's not required. So with this, I would like to just go and click here. Okay. So enable enhanced metrics. When you see different process threads, I use this CPU. If you want, you can enable this. This will not create problem. Even if you disable, it should not create a major problem. Okay. So now I have selected the required. I have made it public because I want to get connected to this database. Okay. So it is for the testing. It's not like we are doing in one VPC where we are using Kubernetes for the deployment. And in that case, you can go with no here in the production. But right now, I would like to go with the yes, right? So now let me just create the database. It will take some time and the database will be ready here. Okay. So let me just disable and it will take some time. After that, the database will be ready. Let's wait for that some time. You can see the database is created. It takes some time and your DB will be ready. You just have to click here. And there are multiple ways to get connected. We have an option of endpoint. And here we have the endpoint. Okay, you can just click on this. I would like to open MySQL Workbench, a client machine, to get connected to this database. Okay, so for which I'll just say here new connection. Name of the connection, let it be AWS RDS, whatever name you want, you can give it. And the host name, the endpoint you may have to add here. The username, the master username is admin. That's what I had given. And the password we may have to store in Vault. And I would like to give the password which I have used at the time of creating that. Okay. So now I'll say OK. And let me just click on OK. Hopefully we should be in a position to get connected to this. Let me just click on this. And if I click this, I'm getting one warning here. Some of the features are incompatible. That's fine. I'll say continue anyway, and I could able to get into the database. This is a client. The database is not on my local machine. We have created on the AWS cloud, and we are just using one of the client MySQL editor to get connected to the MySQL which we have created on the AWS cloud. Okay. Now let me just create one database here. I'll say create database. Name of this I would like to give it as whatever you want. Maybe let's go with Telesco DB. All right. And let me just run this query. And if I refresh, our database is ready here. Okay. So this is the name I have to give to my application. Let me just see if I could able to get connected. This is our application.properties, and the database name is Telesco DB. So I would like to give the name of the database is Telesco DB. That's the name. And what is the endpoint we may have to specify here? This can be managed. If you're going with Kubernetes, we have a config map and secrets there. If you're going with Jenkins at the time of deploying your CI/CD pipeline, there also we have an option of maintaining the secrets and credentials. We have an option there. But right now, I would like to do it in my application.properties only because we have not seen those topics. Okay. So here only, I would like to add the endpoint of my database. I have added, and the username is admin, and the password. It's not recommended to add the password directly here in the production. Either you have to go with Kubernetes config maps and secrets, or you can go with the Jenkins secrets also. Okay. Or multiple other options are available. I would like to just save this application. Now I would like to just run this. Okay. So let me just run this, run as Java Spring Boot application. And it is running. I hope there will be no problem here. Fingers crossed. And seems like no problem. Let me just see here. Okay. It is starting. All right. What is the name of the DB? Is it Telesco DB, which we have created? I think it is Telesco DB only. No problem there. And again, yes, it is ready. And the application, it is starting, guys. You can see one by one. It is taking some time. We have got some errors here. Communication link failure. Let me just see what is the error. I think the database name is also correct, which we have given there as Telesco DB. So that should not create any problem. Admin, and this is the password which we have given the time of we creating the database. I think this is also we have given rightly. And let me just go back and add in my application. Here is where we have to get connected because we could able to get connected there, right? So let me just save this. And again, we have an issue. Let me just rerun the application once again. I'll say right click and run as the Spring Boot application, the Java application. All right. It is getting connected. So yes, it is fine now. There is no problem. And it is able to insert some default. I mean, you can see creation of table and all, it is working fine. Let's try to access the application, the same localhost application which we had here. And I would like to just refresh to this. And yes, we could able to add our application. I mean, we could able to get connected to our application. Let's try to add some data here. Okay, I'll say Java, name of the trainer, some duration I would like to give, and some fees I would like to enter here, right? I'll say save the course. And you can see we could able to do this. So now application is locally available on our machine and database is on AWS, and we could able to establish the connection. Now what we may have to do is we may have to generate a jar file of our application, and that application we may have to deploy using Elastic Beanstalk. Let's do that. The database is created on the cloud, and we could able to get connected to the database from our application by running locally. Now we have to get our application also onto the cloud. In other words, we may have to deploy our application using Elastic Beanstalk, for which I would like to open the Elastic Beanstalk. If not, you can just search here. You'll be able to open this. Earlier also we have done this in this series, right? Now create the application, and we will have an option here. Do the same steps what we have done earlier. Web server, name of the application. I would like to just give it as maybe Telesco application. And then it is asking to give the name. Let it be by default Telesco app environment. Domain, I would like to keep it as it is. And the platform, I would like to run the Java, so it is Java. Jar file is what I would like to run. If you are running the var file, then you may have to go with the Tomcat here. So sample application, are we going to upload our own code? We are going to upload our own code here, right? So version will be V1. It's not there on the S3. We may have to upload locally. We may have to choose the file, but the file is not generated. Let me open this. Before I do anything, I would like to change the port number for Elastic Beanstalk to 5000. This application will listen to the 5000 port number. And alongside that, pom.xml, here is where I would like to also add the name of my jar file. So let me just add that. As you can see, I have added this course app.jar will be the final jar which will be generated. So let me just update my package here. I'll say here the pom.xml I would like to update the entire project, and now everything will be updated, right? So now I would like to get into my project, right click. We have an option here, run as Maven build. And what is a build you would like to execute? Of course, it is clean. If there is already a target directory jar file, clean that and compile, test and package a jar file, right? So now I would like to say apply and run. Let's see. Hopefully the jar file will be generated. It will take some time. It is compiling, running the test cases, and then finally we should be having the jar file here. Okay, build is successful. And if I refresh the project, I'll say right click and refresh this project. We have target directory, and then we have course app.jar which we may have to upload there. So let me get back to my AWS. Upload your code. Version is v1, and I would like to just choose the file here. Okay, so it is maybe D drive, and in the D drive, wherever my Eclipse IDE is open, there is where my project is also. So name of the project is course application, and here we have an option, okay, the target directory. Within this we have this course app jar, course application .jar file, and let me just open this. You can see here file has been added. Okay, now single instance free tier eligible, that's more than sufficient. Next, I would like to click on next. And service role, I think if you could able to recall, earlier also we have done that. By that time we had created a new role. I would like to use the same role which has been already created. Okay, so I think we have same role. This is the role which we have created earlier for the first time when we have used Elastic Beanstalk to deploy our basic web application. Okay, now this is not required. I'm not going to get connected to the instances which this service will use behind the scene. So I will say here next, or you can just get into skip to review. Okay, even if you want, you can just select to next. And again, which VPC you want. I would like to keep everything default. Okay, whatever default VPC we have available, I would like to just choose the same and skip to review. And finally, we have an option here. Some errors are there. What is the problem? Invalid null space. Specify the subnets for the VPC. Okay, so let me just keep it normal and skip to review without selecting this. And now I would like to just say here, create this. Let's see if it is getting created without. And the moment I have clicked on create, it is creating. It will take some time, as we have seen earlier also. Let's wait and see if we could able to access the application. So our database is already on AWS, right? And now we are deploying our application also in AWS. It is using a different service, Elastic Beanstalk, and we have database RDS. And whether they can work together is what we may have to see. So let's wait for some time and see if you could able to access. As you can see, the application is successfully deployed. The environment is created, and we have already got the domain here. I would like to just click on the domain here. And of course, we have endpoints here. Directly you cannot access. The course list is the endpoint to access the resource. I will just say here course list, and the moment I hit this, I'm able to access the application, right? Now, if you want, you can add a new course. You can do whatever you want, maybe DevOps, and I would like to give the instructors names. Maybe it is 100 hours. Okay, and maybe some pricing also I will add randomly. Okay, save the course, and you can see we could able to get this here. So we have our application running on AWS and also our database in the AWS. Both of them are able to communicate with each other. Fine. Till this point, we were able to deploy our application on AWS using Elastic Beanstalk. So what we have done is we created the database using RDS. That URL we have updated in our application.properties, the configuration file, and then we generated the jar file and we have updated that using Elastic Beanstalk. We have uploaded there and we could able to deploy and we are able to access the application, right? So generally what happens is we don't just generate a jar file and upload, right? So we use the concept of containerization. In Docker, you might have already learned the concept of containers. So what we may have to do is, instead of running our application by generating a jar file and then uploading just a jar file, we may have to run that inside the containers. Now coming to containers in AWS, we have multiple options. We have an option of EKS, which is Kubernetes service, and also we have an option of Elastic Container Service, which is ECS, right? Two options we have. In production, most often people might use the Amazon's EKS, which is the Kubernetes. Again, if we have to get into the EKS, we may have to learn what is pod, what is services, different types of services, and all the different components of Kubernetes. It is a vast topic. Again, the entire direction of this will go towards the Kubernetes, and I don't want that to happen. So instead of Kubernetes, we are going to use here one of the service from the AWS, which is ECS, Elastic Container Service, right? So using that, we are going to use the concept of containers to deploy our application, right? So what we are going to do here is, we are going to create the image of our application, whatever application we have developed, and then we should also have an image of database which we are going to use it. Example, we are not just going to create the RDS on the AWS and then going to update the URL like the way we have done earlier, right? So what we have done earlier is we created database and that URL we have added here, the username and password. That's what we have done. That's not what we are going to follow here. We are going with the concept of containerization, right? So we need to have the image. Whenever you want to run anything on the container, the first thing you must have is the image. And coming to the database which we are using here, MySQL, you can get that from the official Docker registry, which is the Docker Hub, because it is a public. You can just get it from there. You can just pull that image and you can run that inside the containers. And image of the database which we are going to use can get from the internet using the Docker Hub. How about the image of our application which we have developed locally in our machine? So what we may have to do is, we may have to generate the image of our application, and that application we may have to run. So we will have one container running our application. We will have one more container running the MySQL database. Two containers will be there, which will be running inside something called as ECS, Elastic Container Service, which is like a cluster, meaning which has multiple machine server working together to make sure that your application is working fine, right? So we will have one image which will be taking from the internet about the MySQL database and will be running. One container will be formed, and we have to generate an image of our application. And for that, the moment we run, container will be formed. So our application will be running inside the container with the concept of ECS. Now, like the way we have Docker Hub, one of the registry for your images, in Amazon also we have a concept of ECR, Elastic Container Registry. So whatever application we are going to develop here, whatever application we have, we are going to generate an image using a Docker file. And that image we are going to upload in Amazon's own registry we have, which is ECR, right? And then we are going to pull the image from the official Docker Hub for our MySQL, and then we have to run these images. The moment you run these images, containers will be formed, and these containers will be running inside one of the service of AWS, which is ECS. So what I'm trying to say is, this time I want to make our application run inside the container. And to make it happen, one of the AWS service we are going to use here is ECS, right? We can use EKS also. Again, the direction of this entire discussion will go towards the Kubernetes. I don't want that to happen. I'm going to use the concept of ECS, which could be used to run your application inside the container. So whatever image we are going to create for our application, that image we are going to push inside the ECR, which is Amazon's Elastic Container Registry, like the way Docker Hub we have, where images will be there. So we are going to push our image in ECR. From there, we will take our image and run. The moment you run, containers will be formed, and inside the container, our application will be running using a concept of ECS, which is Elastic Container Service. And how we are going to do this, we may have to understand. For which we may have to also install AWS CLI. Why AWS CLI? If you ask me, just to get connected to our AWS account, and by running some of the commands, we can upload the image which is getting generated, our application image, into ECR. All these things I know what to do by using the web console. There again, we have to explore so many things. Instead of that, we have an option of AWS CLI. We may have to install that, and we have an IAM account, right? We may have to just create the secret key and access key, and we have to log in to our AWS account using AWS CLI. And then we may have to upload our applications image. Then we have to take the image of our database and we have to make it work together. How exactly these things happens, we may have to see going forward. Now let's first install the AWS CLI, which we are going to use for the further process, for which you can just open your favorite browser and search for AWS CLI. Okay. And then you may have to just click the first link, or directly you can go to the Windows. I would like to just go to the first link, and we have an option of get started here. It will redirect to this page. On you can see on the left hand side we do have an option of install or update this, right? So again, here we have an option AWS CLI install and update instructions. Based on the machine you have, you can just choose any. Since I'm going to use Windows here, we have an option of AWS Amazon.com AWS CLI. Okay, you just have to install this. Click on this. It will take some time and it will be downloaded. You can see on your screen it has been downloaded. You just have to open and click on next, which is very easy. I have done that in my local machine. It is already present. Nothing much to do. Like the way you install any software, just click on next. After which you just have to open a new command prompt. After opening the new command prompt, you'll have an option here. Okay, so the option will be you just have to search AWS -- version. That is what you may have to search here. And the moment you search here, you'll be getting this option here. Okay, AWS CLI with Python, Windows 11. You can see the entire option. It is available. If you are able to see this, that means it is successfully installed, right? After that is done, you may have to configure this. You may have to tell that which AWS account you are going to use. You may have to allow the access to the AWS account which you are using, right? There are lakhs and crores and millions of accounts in AWS. Which account you would like to access, which resource you want to create using the CLI, you may have to specify that. For which you just have to run here AWS configure. This is the command you may have to run just to let you know that you have an access to AWS your account only. Okay, so AWS configure. The moment you hit this, it will ask you the access key and secret key. For this, you just have to log into your AWS account. Okay, the same IAM account which we have done earlier. Here also we have an option of you can see here the security credentials. If not, you can just search for IAM. You can see here we have an option of IAM, and in the IAM also we have option of users, right? And we have Harsh user here. Okay, if you just click here, and we will have an option of security credentials, right? You can see here right now there is no access key, 0 access keys. You just have to click on create the access key. The moment you just do this, for what purpose? I'm using this access key for command line interface, and then I would like to say I acknowledge, and I'll say next. Okay, and it is asking me some default tag value. You can ignore that, and you can see we have an access key here. Same access key I'll copy here. Of course, after this I'll delete after this video. I'll just say here because I don't want you to access that. So I'll just get back here and copy the secret key, and I would like to just go back and add this secret key, and I will say hit this default region AP South 1. Yes. How the output format to be, it's okay. You can just leave it as it is. See here, it's done. Again, I will say AWS -- version. I'm getting the AWS version, and of course I'll say here AWS IAM list. I'll say -users. That's what I have specified. And the moment I do this, you'll be able to see this. See, we are getting this option of who created. We can see the name of the user. Harsh is the user. All the user details I'm able to get here. That means I could able to get connected from my AWS CLI, from my command line to the AWS account, because I'm able to get the user ID. I'm able to get the user name. That means successfully AWS CLI has been configured. Now we are able to configure the AWS CLI. It's time to explore ECS. But before that, we may have to also explore ECR. What we have spoke earlier is that we may have to create an image of our application, and that image we may have to push in ECR, and then using ECS we may have to take it. But before we even do that, we have also talked about one more thing. Before we generate the jar file of this Spring Boot application, we may have to add the actual URL
of our database. We have not created any database using the RDS, and of course this application running on AWS cannot use a database which is there on our local machine. What is the solution? What we have talked earlier is that we will have two containers, one container running our database, and that database image directly we can get from the official image, which is the Docker Hub, right? And then we have to make that running, and that URL we may have to update here. After we update the URL, username and password of our application which is running inside the container in the ECS, and then we may have to create a jar of this, and we have to generate the Docker image of this, for which I have already created a Docker file. I hope you know the basics of Docker. At this level, one Docker file has been added using Java. This is a work directly inside the container. There will be a jar file. Please generate, copy that from there and add it in the workspace. And this application would be listening to 8080 port number, because earlier what we have seen is Elastic Beanstalk. There 5000 was required, but here it is not required. 8080 it will work fine. And at the time of container running, I want to run that jar file which we have given the name here, a simple Docker file. So that should not be a matter of concern, right? So now what we may have to do is I'll just get back to my AWS account, okay, the same account which we have logged in as IAM user, and here I'm going to search for ECS. Okay, so we have an option of Elastic Container Service here. Okay, and we have an option of clusters. Let's create one cluster here. Create a cluster. So it is asking us to give the name of this. I would like to give the name as maybe Telescope. That's the name I would like to give here. And now we have an option of infrastructure, Fargate only, Fargate and manage instances, Fargate and self-manage instances. So usually we have to create EC2 instance in order to deploy our application. In the previous deployment, what we have done is we have used one of the service which comes under the category of platform as a service, which is everything AWS will take care of. You just have to take care of the application code and application data. The infrastructure which is needed, how many instances, right? All the volume, storage, instances, type, and everything will be taken care by Elastic Beanstalk. We need not to worry about the runtime, all the required softwares. Generally, if not, we may have to create the instance of our own configuration. We may have to install all the runtime, the required software to run our application. All this headache was not required earlier. Here also, I don't want to create the instance, start the instance, stop the instance, arrange all the runtime. All of that is not required. I would like to go with the serverless. Serverless means it does not mean that there are no servers. It is just like we need not to manage the servers. They'll take care of this. So I would like to just go with the Fargate only and nothing extra, because everything is optional here. So that's fine. I would like to just click on create this. Within no time, this will be created. So let's wait until it is created. As you can see, the cluster is created here. And if you just click on this cluster task, we may have to assign the task, run a new task. That means what it has to run. It has to run one MySQL container, for which I just will just navigate to task definition, and I'll just create a new task here. Okay, and it will redirect to this page. So MySQL DB is a name I would like to give here. AWS Fargate, let it be. So keep this as the defaults, the configuration. So I would like to just click on none, the task role here, and after which it is asking us to give the name of our container, MySQL container, image, MySQL latest image. So this image, it will pull from the official Docker Hub, the official registry of all the public images. Since MySQL comes under the category of public images, everyone can download, right? So if you just specify MySQL latest, it will only take care of downloading or taking the image which is required to create a container. So this is official image of MySQL. And then the port number, I would like to give the name of this default HTTP port. Apart from this, I'll add my own port. So it is 3306 MySQL port number, and name MySQL port, and I would like to just give it as HTTP. Okay. So after this, I would like to just scroll down, and this is very, very important. The environment variables. We have to specify the username, the password. Okay, so I would like to just create on add environment variables, and we may have to add some variables. MySQL root password, this is very, very important, and I would like to just give the root password here, root 123. This is the most important, and after which I would like to just add MySQL database. Okay,
And the database name, I would like to give it as Telesco DB. This database name, I'm talking about what we used to specify here, right? The Telesco DB, same name, okay? And I'm getting this default values. You may have to type this because I had already created before I record the video. So I'm getting the auto suggestions here. So, okay, so user, I would like to give the username as admin, and then password, MySQL password, keep it same, don't change this, okay? These things you can decide what you want to do it, the name of the database, username, and the password, but this keys, keep it as it is, okay? This is very, very important here. So I have specified this, and after this is over, okay, let's keep things as it is, no issues, port mapping, that's fine. And now I would like to just click on create the task. So the task is created here. You can see here we are getting. So these are the details which we have here. JSON. If you want, you can just run this entire JSON. So I have just gone navigated using the console and I have created this. No problem. Now let me just go back to the cluster, and we have this cluster and we have a task here. Run a new task. That's what we may have to click here. So we have a family of MySQL DB here. Okay. So task definition revision, by default it is selecting some number. Keep it as it is. But one thing, after everything is over, all the resources we may have to delete which you have created, all the instances, NAT gateways, or anything which got created behind this in Elastic IPs. If not, the bill will be generated. You have to be careful. At the end, again, I'll remind, each and every service which you might have created here, you may have to delete. You may have to verify everything in your AWS account. Okay. What are the things we may have to verify? I will just tell you this. Okay. That's fine here. And launch type, you can go with launch type, Fargate, latest, networking. We have not created any VPC. Okay, if someone watching this are aware of AWS, and if you want, you can create your own VPC subnets, and that you can add it here. So no problem, but I have gone with the defaults which we have here. So create a new security group. I would like to give the name of the security group as Telesco Course Security Group. So I'll just add all traffic. It is for the demonstration purpose, but if it is for the production and real, you may have to specify who can enter. It's about deciding the traffic, who can get in. I will say all the traffic for now. If not, you have to specify from where. You have to give the source, which source, who can get in, customize, and you can specify the values of that particular instance. Maybe a particular server only can get into this. You may have to decide this. So now for the demonstration, it is totally fine. For the testing, for the dev environment, so I would like to just go with the all traffic, and make sure that the public IP is turned on. This is very, very important. Okay, let me just cross check if I have given everything right. That's fine. So I would like to just click on create this. So we have an option here. The security group Telesco already exists in the VPC. Okay, this name is already exists, it seems. I would like to just go with number 2. Okay, so let me just click on create this. So it should be creating within no time. So it is provisioning instance, it is creating. So you can see here, we will have the public IP. This public IP only we may have to use here. We may have to copy this and we may have to allocate it here. And before that, I would like to also test it. So let's wait for it to run it. Okay, so let me just get back to the task, and it is still in the stage of provisioning. It is pending. I hope it will be running. Let me just wait for 1 more minute. As you can see, now it is running. You just have to refresh. It shows it is running. You just have to click this. And before I add this details in my application, I would like to just check if I'm able to get connected to this. Okay, so I'll just get back to my SQL workbench locally. So after which I would like to just say new connection, and name of this connection may be AWS. Okay, only AWS I'll just give here, or maybe AWS course application, that's fine. And host name, I would like to just add this. The username, it is admin is what we have given. Password, I'll not give the root. If you want, you can give that. I would like to just give the user password for admin which we have created. Okay, so I'll just give this. I'll say okay. And AWS course, I have just clicked this to check the connection is fine. All right, continue anyway. And we could able to get connected. You can see we have the database also ready here, right? So now the same IP, I would like to just add it. I mean the IP address which we have added there, right? I may have to just add this here, and I think that is a username and that's the password there also we have set. Okay, so let me just save this, And let's see what is the next. The basic setup is ready. One container which is having the database that is working fine. Now let's create an image of our application and then push that into ECR. For which first I have updated the public IP which we have got, the username and the password of the database. After which I would like to just clean just in case if there is any jar available, the previous jar. So run as maven build. So I would like to just say here, if it is already there, clean that and then package this application, create a new jar file. Okay. So I would like to just say apply and then run. So new jar would be created. You can see on the right hand side. So we do have an option here. So it is running. I hope without any problem, the build will be successful. Okay. So great. Build is successful. So if I have to refresh my project, if I have to just say refresh, we have this target and we do have this course app jar ready with us. Okay. Now we may have to just, we already have a Docker file also. We may have to just create this and push it. Now, how do you do that? For which, as you know, we are going to use the ECR. So I'll just do one thing. I'll say right click, open that in the new tab. And here I will just search for ECR. You can see Elastic Container Registry. And I would like to just create new repository here. Name of this, I'll just give it as Telescope. Mutable, let it be. So no problem, and keep it default and create this. So we have this Telescope here. Now how do you push it? For which you just have to click on view push commands. Make sure one thing that you have already configured AWS CLI, which we have done earlier, and Docker is installed locally on your machine. I have kept in mind, people who are watching, Docker is installed locally. So that's what you may have to do it. Now if Docker is installed, AWS CLI is configured, wherever this project is, right, you have to open the command prompt from this. You have to navigate to the project where you have there, and you may have to open the command prompt from where this project is. So I would just say here, see here, Java SB is the workspace name, course app. Here is where we have a project, right? So now I just have to run these commands. Very simple it is. So let me just get back here. I'll just copy this and I may have to just run one by one. Okay, so let me hit this. So I'll have an option of login successful. Let's wait. You can see login succeeded. So after which I just have to go back and build a Docker image. This is the command to create an image. Docker file is already available. So it will create a Docker image. It is generating the Docker image. And once Docker image is generated, you may have to tag the Docker image before pushing it. Okay. So Docker image is generated. I'm tagging that image. That's also done. Now I may have to just go back and push that image. You can see here. So I would just copy this and get back here. I'll say right click and push this image. Okay. So it will take some time and the image will be pushed. It is taking some time. Okay. So let me just get back to my AWS here. And you can see if I refresh right now, no images are there. It is getting updated. Let me see if image is successfully. Yes, it is able to push that image successfully. And we do have an option of latest here, which you can see here. We do have this option. And this URI is what we may have to, update again in the ECS. Like the way we have one task, right? And we have created one task definition, MySQL, and we use public image here at the time of we creating the task. Now we may have to create one more task. Okay. And then at the time of creating one more task, we may have to add that URI, which we have here, image URI. Same thing, we may have to update that. Let's see that next. Now it's time to get back to the ECS, and in our cluster, we may have to just run and create one container for our application. Okay. So before we assign a new task here, I would like to just do one thing, go back to the task definition and create a new definition. Earlier, we have done this task definition for MySQL public image. This time we are doing for our own application. Okay. So I'll just give the name here as maybe Telescope application. All right. And keep these things default like the way earlier we have done. No changes there. So it is asking us to give the name here, course app container. Maybe I'll just give the name of this Java 2 and image URI. Same thing you may have to do here. This is our image, which we have just now pushed. And I would like to just add this image here. Fine. And the port mapping, this is HTTP port. I'll just give it as 8080 because you can see here our application is listening to the port number 8080, and same thing we have specified in the Docker file also. I just get back here and 8080, and it is web port HTTP. Okay, this is the task. This is what you have to do here. Nothing much. Keep the things as it is. Okay, so let me just cross check. Yes, this is the task. Nothing more. And I would like to just click on create the task. The task will be created here. Now get back to the cluster, and in my cluster we have a task here, and I may have to just create a new one. This is the old that I was just checking it before the video recording. Now it is Telescope application. All right, and launch type again, Fargate, latest, networking, go with the VPC which is default. That's what we have been using here. Create a new security group. I'll just give it as application security group. Okay, and you can just customize who can access. I'll just say here all traffic anywhere, so that anyone can access. Make sure that public IP is turned on here. Okay, now I would like to just click on create this, and it will take some time and it should be ready. You can see here we are getting it as provisioning. Let's wait for 1 minute and see if you could able to access. So basically what we have done is, already we have one container where our MySQL is running, and now we created our own image of our application, push that into the ECR, and from the ECR we could able to pull that into our ECS. Now we are just running this and see if we are getting the container. So again I'm refreshing it. It's still in the provisioning. Now we got the here option as it is running, and we can see public IP we have. I just have to copy this public IP, get back to the browser. I'll just paste this, and it is listening to port number 8080, and we have an endpoint called as course list. That's the endpoint. The moment I hit this, we could able to access the application. You can see here we can add whatever data you want, maybe DevOps. I'll just add the duration here, and maybe some fees also I will just add it. Say here save the course. You can see all the operations are working fine, right? So this is one more way of deploying your application into AWS, where we are using the concept of containers. Inside the containers our application is working. So many things we have done. I hope you got the clarity. There are a lot of customization which you can do it, for which you may have to learn more AWS. You can create your own VPC subnets. You can have your own networking, right? You can create Kubernetes clusters. Multiple things can be done. That's based on the AWS knowledge. If you're going for the AWS certification or maybe exploring AWS, a lot of the things can be done. This is one of the demonstration just to show that how the applications are working, how AWS services can be used for the deployment of the application. It's like not every application need to follow this process only. There are different ways to be done. You can create your VPC subnets, you can create your own instances, you can have whole customization based on how much AWS knowledge you have. I have kept it very simple by considering people who are watching, they have the Java Spring Boot knowledge, they have basics of Docker knowledge, and they can use that. And even if they are new to the AWS, they can just demonstrate the deployment of the application using one is a platform as a service, one more is using the ECS. After this is done, the entire practice is done, you have to make sure all the resources which got created should be deleted. All the tasks which you have created, right? Task, for example, just if I have to show you, and you can just have an option of stop. If not, you can say here stop all. We have an option here, you can see here select, and we do have an option of stop all, and you have to stop all the tasks. You may have to deregister the services right after the practice is done. Okay, if I have to get back to my clusters, and again the task definitions also, you can just click on this, get into this, click on this. We have an option of deregister. You have to deregister, and after that is over, everything is deregistered, you can delete this. Okay, we have an option of delete the cluster, and after that is over, you can just check NAT gateway if it is not running, elastic IPs if it is there, you have to release it. If there are any instances running, you may have to delete that. If not, you will be charged. But I hope you got the picture of how these applications are deployed in AWS.
I welcome you all onto the series on Terraform, which is one of the most powerful tool in the world of DevOps and cloud automation. Today, almost every company, every project uses the cloud-based infrastructure, whether it is for hosting, for storage, for databases or for CI/CD. So anyone who are into the tech, it becomes very, very essential for you to know about the cloud-based infrastructure. Whenever the concept of infrastructure on cloud comes into picture, there are many tools which you may have to explore. One of the most powerful or mostly used tool when it comes to the creation of or provisioning of infrastructure on cloud is the Terraform. That is what we need to understand here. But before we see anything practically, first we need to understand why we may have to go with Terraform, what exactly Terraform is trying to solve, and then we have to understand what exactly is Terraform and how do we have to work it. Fine. For which I would like to take some examples directly. Let me open my AWS account. I hope you have some idea about any of the cloud providers. There are many cloud providers who will give the services such as Microsoft. We have GCP. We have the AWS from the Amazon. We have different cloud providers apart from this also, wherein we can provision, or we can say we can create the infrastructure which is required for our application, whether it is creating the servers or getting the databases, or getting some of the storages, anything it could be. Okay, so I'll keep in mind that you might have some fundamental idea on what these cloud providers are, right? Now I have opened my AWS. Okay, this is my AWS account, a free tier account, and you can just go here and search for EC2. Right now, since I usually work with these services directly, I have option of going with one of the service EC2 on the screen. If not, you may just have to search on this. Once you create the free tier account on AWS, you will have an option to use some of the services. I'll assume that you might have created, and I would like to create one server, or you can say one Linux virtual machine onto my cloud. Manually, I'm going to do it. See, whenever you want to provision, or you can say you want to create any of the resource or infrastructure on the cloud, there are multiple options. Every cloud platforms gives you multiple options, right? Right now on the AWS, the requirement is I want to create one Linux virtual machines. We have multiple options in AWS. Option number one, you can log into your AWS account where you will be given the web UI. You'll be given one console which is web-based console, right? Internet-based. Once you have internet connection, web-based console, you will be getting it, and you can search for the services which you want. Since I want to create a Linux machine, I would like to go to the EC2. This is one of the services which we have to use whenever you want to create a Linux machine on AWS. I would like to just click on this. If you click on this, it will redirect to this page, and I have to click on launch instances. What I'm trying to say here is that one of the option is to open the web-based console of the cloud provider, and you can create or you can provision the infrastructure which you want manually by using the user interface, right? Maybe I want to create one Linux machine. I have an option here, launch an instance. I would like to give the instance name as maybe Telescope Linux virtual machine. Any name you want you can give. I'll say here Linux machine, okay? Or you can say VM, any name of your own choice. It should not create major matter of concern. After which you have option of choosing the which machine you want to go with, which flavor of Linux. I would like to go with the Amazon Linux here. I would like to click on this, and then we have an option of going through the instance type. You want how much of capacity in that machine you want, right? I want to go with the free tier because I don't want any charges there. And after which we have by default option of security groups, and I would like to just create, or you can say launch the instance, right? Now you can see select an existing key pair or create a key pair. Now I could have selected this also at the time of creating. Intentionally I have not selected this, just to let you know that whenever you are provisioning any of the resource or infrastructure on cloud platforms manually, there are chances that you might forget some of the steps. There are chances that you may miss some of the important steps. Later, going forward, you might face difficulty for the same, right? Example, here I was just creating my machine. I forgot to click on the key pair. This is a silly mistake. It could be something else also.
So if you are creating the infrastructure, provisioning the infrastructure on the cloud platforms manually using the web consoles provided by the cloud providers, there is a possibility wherein you may miss some of the steps at the time of infrastructure creation, and later you may have to struggle, right? This is one of the possibilities. Again, what if the requirement is I want to create totally 20 servers? 20 servers in the sense you may have to create 20 virtual machines. Now, you creating the 20 virtual machines manually by going through this web console is not an easy task. It is a lengthy task, a time-consuming task. There are some difficulties. Now, what if you want to create some of the resources on the Azure, Microsoft Azure? Will the UI, the user interface of the web console of Azure, will it be same as AWS? The answer is no. If you want to create any of the machines or resources on the Google, maybe GCP, Google Cloud, there will the web console and the UI of whatever you get in the GCP, will it be same as Microsoft Azure or AWS? The answer is no, it will not be same. Now, you may have to explore all the UIs. It is very, very difficult. And apart from that, what if you want to create any of the resources? There is a possibility of making the mistakes. It is error prone, right? If you want to create multiple resources, then definitely it is a time consuming process. I want to convey one message that it is very difficult and there are many limitations associated with it. Whenever you want to create this infrastructure manually by going through this, web browsers, or you can say user interface of the cloud providers. Now, every cloud providers provides its own way of automating the things also. In AWS, if you want to automate the infrastructure provisioning, if you want to create any of the infrastructure provisioning, automatically you can automate by using one of the service called as CloudFormation. Like CloudFormation, we have in the Microsoft Azure, we have something called as a resource manager. Similar that every cloud provider may have its own way to automate this, but that is again specific to a fixed cloud provider. Example, if you want to automate the infrastructure creation process in AWS, we have something called as CloudFormation. Can you use CloudFormation to automate the infrastructure creation in the Microsoft Azure? No, the answer is no, because it is something different there in the Microsoft Azure. Same thing, something different in the GCP and any other cloud platforms or any other cloud providers. Now the question is, do we have anything common using which we can automate the infrastructure creation, and also wherein we have an option to maintain the history? We can version it to the Git and know how and when we have made the changes in the infrastructure creation, and with such script which can be reused any time, any number of time. We can just write the script once, maybe to create a virtual machine, and same script you can run it for multiple times. We do have any option? The answer is yes. That's where the concept of Terraform comes into picture. Using a single tool, you can create or provision the infrastructure on the AWS also, Microsoft Azure also, GCP also, or any other cloud providers also. It is for the infrastructure provisioning, or in simplified words, it is to create the infrastructure. You want to create the servers, you need not to do it manually. You can, of course, you can do it, but again, it has its own limitations and problems associated. We do have an option wherein using one tool, you can automate the process of infrastructure creation onto the multiple cloud providers using Terraform. Now, Terraform is one of the most powerful tool which we use in the industry to automate the process of infrastructure provisioning, or you can say infrastructure creation, which is developed by one company called as HashiCorp, right? And it follows its own syntax to write the script in the Terraform file, which is HCL, HashiCorp Configuration Language, HCL. Using this HCL, you can write the code in order to automate the process of creation of infrastructure provisioning on any cloud platforms. Terraform support for multi-cloud platforms. Using the Terraform, you can create or provisioning the infrastructure on almost all the famous cloud providers which we have here. Not just famous, almost every cloud provider nearly. You can use the same tool in order to automate the process of creating any of the resources, or you can say infrastructure creation or provisioning. Fine. Also, it is free and open source. You need not to pay or you need not to buy any license in order to use Terraform. It is free for everyone. However, if you create any of the resources on any of the cloud platforms which are paid resources using the Terraform, you may have to pay. You are not paying it for a Terraform, you are paying for the cloud providers. Example, you want to create a S3 bucket on AWS. Now for that, maybe you are using Terraform to automate the infrastructure or S3 bucket creation. If you are creating that, you are not paying for Terraform. To use Terraform to write the HCL, to write the scripts, or to write the code in order to automate the process of S3 bucket creation, it is free. You are not paying it for Terraform. It is free and open source. However, if you are creating any of the resources on any of the cloud platforms, if that resource is paid there, you may have to pay for the cloud provider, not for the Terraform. It is absolutely free. So let me open the site of the Terraform here, which you can see here. If you just search for Terraform by HashiCorp. So Terraform is an infrastructure as a code, IAC. Infrastructure as a code refers to writing the code in order to provision the infrastructure, in order to create the infrastructure. We are going to write a code. How are we going to write the code? Which language are we going to use? It is HCL, right? So let me just open this Terraform by HashiCorp. You can see Terraform is an infrastructure as a code tool that lets you build, change, version infrastructure safely and efficiently. Fine. And for which we just have to use its own language, which is the HCL. Let me just click on this. We have an option. You can go through the official documents also. Now we are going to first install this Terraform in two ways. I'll be showing you how to install Terraform locally in your machine. Also, how to install the Terraform on the virtual machine, which I'm going to create on the cloud. Okay. So maybe irrespective of the operating system your laptop has, you can follow any of these steps, both the ways also, manually also on your local system. If not, also onto the cloud. Maybe I'll create one Linux machine on the AWS. Onto that machine, I will install the Terraform, and then we will try to understand how exactly we may have to work with the Terraform. Now let's proceed with the installation. There are two ways to install. Number one, you can install the Terraform locally, and then by using the ID such as VS Code, you can write the Terraform script, or you can say Terraform code. Option number two, which is universal, irrespective of the operating system you have, you can follow this to create a virtual machine on the AWS cloud, a Linux virtual machine on the AWS cloud, and then onto our Linux virtual machine, we can install the Terraform and we can work on it. All right. So I'll be showing you both the ways. First way, I would like to go with the AWS. By creating a Linux machine on the AWS, I would like to install the Terraform, and then I would like to continue with it. Option number two, I would like to also show you how to install the Terraform locally on your machine and use VS Code in order to write the Terraform code. I'll assume that you might have a free tier account or maybe account on the AWS, and then you can create the Linux virtual machine onto the EC2. By chance, if you don't have any AWS account, you can create a free AWS account by following any of the videos on the YouTube. Fine. Now let me just go here and search for EC2. If you have already bookmarked, directly you will have an option of EC2. If not, you have to search for EC2. I would like to go with it. And then I would like to just click on launch the instance, and then it will redirect to this page. I would like to give the name of this as maybe Terraform Linux virtual machine, right? So Terraform VM is what I would like to give the name. And here I have an option to select the Amazon machine image, which one you would like to go with. We have multiple options. In the Linux, we have Red Hat, Ubuntu. I would like to go with the Amazon Linux, right? I would like to click on this. Let it be instance type free tier, and key pair. I would like to create a new key pair. I would like to just go here and click into
Terraform. I would like to give it as maybe a key pair. I'll say here key pair. All right. So now rsa.pem file, let it be, because this will be required in order to get connected to this machine which we are creating. One Linux machine will be created on the cloud. We have to get connected to that machine, right, in order to perform whatever activity or whatever actions we want. So I would like to just click on this key pair. It will be downloaded. After which I would like to click any of the existing security group, or you can just choose to create a default new security group. Even by chance if this step is missed, later also you can add it. Fine. Now I would like to just go ahead and create the instance. My AWS instance will be ready. I would like to click on this. You can see the instance will be ready. That means a Linux machine is created. Irrespective of your OS of your system, whether you're using Mac or Windows or Linux, doesn't matter. We have created one Linux machine, a virtual machine onto the cloud. Now I want to get connected to this machine to perform any operation we want, right? We are in the Windows machine. We have created on the cloud one Linux machine. I want to get connected to do anything. Maybe I want to install Terraform. I'll not be installing on the machine. I have created one machine on the cloud, which is the Terraform VM. And onto that machine, I want to install the Terraform, right? So I would like to just click on this instance ID. And then you have an option of connect here, right? So there are multiple ways to get connected. If you have software such as Mob Extreme or the Putty, you can just go with the EC2 instance option and you can get connected. And I would like to go with the SSH client, irrespective of whether you are a Mac user or Windows user. If you have a Git bash, easily you can get connected with the help of SSH client, right? So you just have to first copy this permission, chmod 400. I would like to go to my downloads where it was downloaded. Let me open this. As you can see in my downloads, we have a Terraform key value.pem file. Wherever you have this pem file, from there, I would like to just right click and we will have an option of show more. I would like to open my Git bash. If not, you can just install the Git bash. It is very easy process. One of the terminal, right? So I would like to open this Git bash, and in my Git bash, you can see here is our Git bash. Okay. So let me just elaborate this. I would like to open this. I would like to, yes, I just have to first add this command. Right click, paste whatever I had copied for the permissions. It is done. And the next command which we have to run in order to get connected is, let me just go here. And we have this command, right? I would like to copy this example. Command is copied. And let me go to my Git bash, right click, and we have paste. There are multiple ways in order to get connected to the Linux machine which we are creating on the AWS. This is one of the way which is more easier. I would like to just hit this. Let me just click on yes. And now we have successfully connected. Let me just say here, who am I? It is EC2 user, present working directory. Yes, it is all working fine. Successfully now we could able to establish connection to our Linux machine. Right now we are in our Linux machine which we had created on the cloud. Now here in my machine, in a virtual machine, I want to install the Terraform. What to do? Please go to the official website of Terraform, which I would like to go here. And if you just click on Terraform by HashiCorp, on the left hand side you have multiple options here which you can see. Please click on install, and then if you just click on install, then you'll have multiple options to install on different OS. Since we are installing on the Linux machine which we have created on the cloud, right? So which version of Linux we have used, which flavor of Linux we have used here? I think we have gone with the Amazon Linux at the time of VM creation. So I'd like to click on Amazon VM only, and then it will give you commands which you may have to run in order to install the Terraform. I would like to take these commands. Okay, these are the commands I have just copied here, and then let me go to my machine, and I'll say right click, paste it. Now it will take some time. Within a few seconds or a minute, your Terraform will be installed. You can see it is started to install. Yes, it is downloading. All the required plugins, softwares, everything is installing. Yes, it is completed. Terraform is successfully installed on your Linux machine, a Linux machine on the cloud which you have created. Now let me check if it is successfully installed by going to Terraform -v. Yes, it is successfully installed because we are getting the version of Terraform. We can also check the version of Terraform with Terraform version. We are getting this option of Terraform that shows Terraform is successfully installed on our Linux machine on the cloud. Now we can run some of the commands of Terraform and we can work with it. I hope you could able to understand. Whenever you're working with this machine, whenever you're working with the Terraform, you can get connected to the machine the way I have showed, and you can write all the commands which are required in order to work with the Terraform. Once your task is over, once your practice is over, it is recommended to go back to your EC2 instance, okay? And the machine which we have created was a Terraform, right? If you just click on this, you have an option of instance state. You can stop it because we are not using anymore now. I have stopped it. Once you stop any of the Linux machine, whatever software you have installed, that will be there. That is already there. Unless and until you delete this machine, those softwares will be there. Terraform we have installed, Terraform will be present inside this machine. I have just stopped. Whenever you work again with the Terraform, open your AWS account and go to your EC2 instances, and again instance state, you just have to start your instance. After starting the instance, you have to get connected the way I have showed, and then you can continue your practice and continue your work. And this is one of the way to install the Terraform. I have just installed the Terraform on my Linux machine. Can we install Terraform on our local machines such as Windows and work? The answer is yes. But this is a universal approach, a more realistic approach. I would like to also guide you on how to install that locally on your Windows machine and use the VS Code for writing the code with Terraform also. Now let's continue with the installation. Previously we have seen how to create a virtual machine on the AWS, and then we had installed the Terraform. That is universal. Irrespective of the operating system you are using, you can follow that. Just in case if you want to install the Terraform and work locally on the Windows machine, then you can follow this step. First, you have to just search for the Terraform. Then, of course, it will lead to this page. And then we have an option here, top left, install. If you just click on this, we have an option of installing that, for Mac, for the Windows, and for the Linux. Linux, we have already followed. We have created the virtual machine and we could able to install that successfully. Now I would like to install locally for the Windows. Now we have option here, a Windows binary. Since my system is of 64 bits, I would like to just go here and click on download. Within some time, it will be downloaded successfully, and you will be able to see that in your downloads folder. So let me open my download folders. I would like to just go to my downloads, and you can see it is available here. Now you just have to extract this. Very simple process. You can extract here, you can extract in a different folder. That should not be a matter of concern. I would like to just extract here itself. It will ask you whether if you want to extract, and that will be extracted successfully. A new window also will be open, but however we do have here, right? Now once you open this extracted file, you will have one file, Terraform. The type of the file is application. You have to focus here. The type of the file is application, right? Now this file, if you open, if you want, you can keep it here itself, and you can keep it in downloads. Wherever this application Terraform file is there, this path you may have to configure in the environmental variables on your Windows machine. If not, you can keep it in a different folder. I would suggest take it from here. I would like to rather cut it from here, and I would like to go to the C drive. You can keep it in the downloads also. There is no problem. However, it is recommended. Okay. So I would like to go here within the program files. I would like to create a new folder by myself, and I would like to give the name here by the name Terraform. So I would like to give it as Terraform, and within this folder, I would like to just add this particular file. So I would like to continue. It will be added. Now, wherever this Terraform type application file is there, that path, even if you have kept it in the downloads, you can copy the path. If you have kept it in a different folder, like the way I have done, copy the entire path and open the environmental variables. Okay, I would like to search on environmental variables. Let me open that. And if I click on this, you will be redirected to this page. And here we have an option, advanced environmental variables. And both the options you have,
By chance, if you are not able to open or edit the system variables, you can edit the user variables also. It is not a major problem. I would like to go to the system variables. We have a path here, and I would like to click on edit, and here I would like to click on new. The entire path we have copied from where we have kept our Terraform file. That path I have pasted here. I would like to say OK, right? Now we also have to configure the access and security key. What exactly the access key? What exactly is the security ID? I'll talk about it in a while, right? So this is the step number 1. Number 2, in order to write your Terraform scripts, Terraform code locally, you may have to have one IDE, and the preferred IDE is VS Code. Most of you might already have installed. If not, you can just go to the favorite browser and search for VS Code. Then you'll have an option of download. If you just click on this, we have an option here. You can go with the Windows. I already have that. If you want, you can just install once again. You can see Windows and you can just click on install. And once it is installed, you just have to click the double click and you will be able to open the VS Code. Let me open my VS Code here. Once you install the VS Code, if you double click it, you will be able to open, you'll be able to see the UI. You may get the extra options also to open the folders, to open the files. You can keep that as it is, right? Now, I would like to just go to my, drive, and there I would like to just create one new folder, okay? It is not compulsory, recommended to maintain the modularity. I would like to just go here and right click, try to rename this particular folder, okay? I would like to give it as maybe Terraform Scripts, okay? Terraform Scripts as the folder name. And in this folder, I would like to just open my VS Code, right? If you want, you can go to the VS Code and here you have an option to open it where you want to open, okay? If you just go to the file and you'll have an option to open the VS Code folder, you can just open the folder. And here, I would like to go to my D drive and I had created one folder called as Terraform Scripts where I would like to write everything there. So I would like to go to Terraform Scripts and select this folder. You'll be able to open your VS Code within this folder. Even otherwise, you have an option here. If you just go to the folder where you have created, right, Terraform Scripts, and open the command prompt there. And once you open the command prompt here, you just have to run one command. Let me just show you that. Command prompt is open. I would like to just say here, code space dot. And the moment you click this, automatically VS Code will be opened in this particular folder where you're running the command. We have multiple options. You can just better to use the UI of this VS Code and open this entire VS Code in this folder. Now, whatever you write, the Terraform code, Terraform scripts, it will be within this folder. And how do we write it? What exactly it is? We will see, moving forward. And also, you have to understand about access key and the security key, which is very, very important. Just in case if you are trying to create or provision any resources on the cloud providers such as AWS, you may have to also have those access keys and security keys, which if you are trying to create the scripts of Terraform locally, then on your environmental variables, we have to set that. If not, if you're going with the Linux machine on the AWS, which you have created, there also you have to export those keys. Only then you will be allowed to provision or create any infrastructure on your cloud platform. What exactly it is, let's discuss. Now we need to understand one more important thing is that whenever we use Terraform in order to provision or create the infrastructure in the cloud platform such as AWS, the first thing we need is access to AWS itself. How will Terraform know that who you are, whether you are allowed to create a particular resources such as maybe EC2 or maybe VPC or S3, right? You have to give the credentials. You are the guy and you have the authority to create or provision such infrastructure. That's where the security credentials, access key ID and the secret key comes into picture. Whenever you are trying to provision the infrastructure on the cloud platform such as AWS, you may have to also prove who you are and you have to also prove that you are allowed to create a particular resources on that particular AWS account or any of the cloud account. And this is very, very important. And these things, you can keep it in your Terraform file itself. You can keep your security credentials in your Terraform file, and when you execute that Terraform file, it will take it and you will be able to provision the infrastructure on the AWS. However, it is not recommended. What if someone sees your Terraform file? If they could able to read the script, then they will be getting the security credentials, which is not recommended. I would like to show you that we can keep these credentials in our AWS, in our Terraform file, and then without having to, give these credentials anywhere else, we can provision the infrastructure, we can create the resources on the AWS. However, that is not the better approach. The way is to use the concept of environmental variables. Now, two ways is what I am showing here in order to with Terraform. Number one is we created the Linux machine on the EC2, and there we have installed the Terraform. Now we just have to establish connection to that machine where Terraform is installed, and we have to set the environmental variables wherein we are setting this access key ID and the security key. Option number two, if you'd like to work with the approach of installing the Terraform locally on your machine, like the way I have shown, then in your local machine in environmental variables, you may have to set the access key ID and the secret ID. Only then you will be able to execute the Terraform script, which can provision, which can create or resources on your AWS account. Fine. Now, to get that, usually every time anyone would like to get connected to the AWS cloud and they want to work with any of the infrastructure, we usually create the IAM user and we specify the roles, what they can do, how much authority they have, right? But for now, I would like to go with the root user itself. Now, to get that secret key and the access key ID, you just have to go to your account, and right side we have an option of security credentials, and if you go here, then it will redirect to this page. Okay, and already one access key is there. Okay, I would like to just action, I would like to delete this. Before we delete, first we may have to deactivate. After it is deactivated, I would like to copy this entire access ID, okay, and I would like to paste it here in order to delete this existing key which we have. Okay, now we have an option here, access keys are 0. I would like to create this access key because it is required from outside world. If you want to provision any of the infrastructure on your AWS, it is required. I would have to click on this. I understand creating a root access key. Okay, it is not a best practice actually, because we create multiple IAM users and then we set the roles for them, and based on that we create a specific IDs for a specific IAM user. Right now I don't want to again get into the AWS part of IAM and explain, so I would like to go with this because we are trying to learn the Terraform here, right? So I would like to create the access key. And now we have access key also, secret access key also. These things is what we may have to configure. Two ways you can configure this in your Terraform file itself, which is not recommended. One more, to set as the environmental variables. Fine. Now first I would like to set this locally on my machine, so that if you're working locally on your Windows machine, easily you can execute your Terraform script. Option number two, I would like to configure this in our Linux machine also by getting connected and setting that as environmental variables. I would like to copy this and let me open the environmental variables. First of all, I would like to search edit the environmental variables. Okay, and if I have to open this, it will just give it to this page, and here is where we have to add either in the user variable or you can say in the system variable. Okay, so let me open in a different way environmental variables. Allow me just a moment of time. I would like to just open this. All right, and you can see we do have an option here, advanced environmental variables, and now here is where you have to specify. Okay, you have to specify the name, access key ID, and you have to paste whatever you have copied. Okay, and the variable name I would like to give it as AWS underscore. I would like to say here access underscore key ID. Okay, that's the name of a variable and this is the key configured. And again, I would like to just specify AWS secret access key, as you can see here. And now we have to add this value. How do we add this value? Here is where the value is. Okay, if you want, you can check it. I would like to copy from here. And now I would like to go back to my environmental variables and I would like to just add this value here.
After which I would like just to click OK. Locally, you have set in your environmental variables. Now, if you are going to create your, Terraform scripts in your VS Code ID, and if you run locally, now you can successfully, you will be in a position to create the infrastructure on your AWS account. Fine. Now, if I want to do it on my Linux machine, which is there, for which first you have to establish connection to your Linux machine. Let me go to my EC2, where we had created our machines. I have to do my instances. And earlier in this videos, you might have seen, we had created one Linux machine here. And that machine I would like to establish the connection. Okay, so that was a Terraform machine. I would like to go back here and start the instance. That means I'm starting the machine. As you can see, the machine is now running. I would like to click on this and establish the connection. I would like to go and get connected. Let me just go to my downloads here, where we had kept our PEM file. So right click, I would like to just open the git bash here. So show mode, we have an option of opening the git bash, and I could able to open the git bash successfully. And you can see here, let me just, zoom it out. And we just have to add our, SSH. I would like to give me permission first so that I can get connected here. I'll say here, right click, paste it. It will give the permissions. And now I would like to go back to my AWS account, where we have a Linux machine. Now this is just a process of getting connected to our Linux VM, which we had created there. Okay. So I would like to just paste it. Now I'm able to get connected here. This machine earlier we had created, and we had installed the Terraform also here. Okay. So let me just check once again. I'll say Terraform -v. I think it is successfully installed. Now, in order to set these, access key and the security key here in this machine, you just have to use export, followed by, it is like setting the environmental variable, and whatever way we are setting here, again, it is a temporary way. If you close this CLI, again, if you are getting connected back to this Linux machine, then again you have to set these environmental variables. Every time you get connected again to the machine, every time you may have to pass this credentials, you have to set this into the environmental variables. If not, you'll not be able to run your Terraform script, because it is required. That is the security credentials. Okay, so now I just have to add here AWS. I would like to say here access and key ID equals to, I have to specify that. Let me just take that which we had done. I had saved it. Okay, I would like to copy this, and I would like to this. Okay, fine. And now again, we just have to say here export. I would like to say here AWS secret access key. I would like to go back and say here access and key, and you have to now specify the secret access key. Now the environmental variables for our Linux machine is also set. Basically, these credentials are required when you are running the Terraform script in order to provision the infrastructure on your AWS cloud, which specifies who you are and whether you have a authority in order to create or provision a particular resource on the AWS. This is very, very important step. Now we need to understand the architecture of this Terraform, what exactly or what are the important components comes into the picture, and then we shall start the journey of writing scripts or writing code with Terraform. Now we need to understand the Terraform architecture, the important Terraform commands which we run often. To start with, in order to write the script in Terraform, we use one specific language as we have discussed, which is HCL. HashiCorp configuration language. This is what we use in order to write our script. Now using the HCL, the moment we write the script, we save that by using one extension called as .tf extension. Like for the Python, we use .py, for the Java, right? And for a text file, .txt file. For a Terraform script file in HCL, the moment we write, we save that in .tf extension. After which, the next command which we write here is Terraform init command. In order to initialize your Terraform script, all the required plugins which you have mentioned in the provider, that will be installed, which we will see practically also moving forward, right? This is very, very important command to initialize your Terraform script. After which we do run some of the commands, which is the Terraform format command in order to format your Terraform script, which is an optional step. Maybe some of the spaces by using the HCL, you're writing the script, there is a problem with ident spacing, right? All this formatting will be done with the Terraform format command, which is an optional step. It is not compulsory for you that after initializing you may have to format. It is optional step. If you feel that everything has to be proper, if by chance you might have done some mistake with respect to spacing and other aspects, you can format that. And then we have one more option called as Terraform validate command, okay, to validate the syntax of your script, whether everything is fine or not. You can run this. This is also an optional step, but highly recommended. After we initialize, we run the Terraform format and Terraform validate to make sure that everything is fine, the syntax and all the things we have written in our Terraform is fine. And then before we actually apply this, before we make Terraform to create resources on the cloud, we also run one more command called as Terraform plan, which will create the execution plan, that what resources will be created, what resources will be destroyed, or what resources will be changed, all which is going to be applied. It will give you the plan, execution plan, that these are the things which are going to happen the moment you run this Terraform script. What will happen before that actually happens? It will just give you the execution plan, that these are the things going to happen if you execute this. And once you are okay with the plan, the moment you see the execution plan, that if I run these all the changes, these are all the resources which will be created on the cloud, then you can use one command called as Terraform apply. Terraform apply is the actual command which will execute your Terraform script, or you can say which is responsible to create the resources on your cloud, right? Whatever may be here in your Terraform script, you have asked to create a S3 bucket, right? And the moment you say Terraform apply, it will definitely create a S3 bucket on your AWS cloud, right? So this is the actual final step wherein the resources which you want to create after you apply, that will be created. The resources which you want to create using the Terraform, the moment you say Terraform apply, the changes will be applied and the resources on your cloud will be created. Now, whatever resources you have created using the Terraform, if you want to delete that, right? If you want to, destroy that resources, then we use one more command called as Terraform destroy. Okay. And this is the command we use in order to destroy the resources which got created the moment you run the Terraform. And using the Terraform destroy command, you can destroy all the resources which got created using the Terraform. These are the steps. So it is destroys depends on whether you want to delete that resources which got created. However, in order to create or provision the resources on the cloud using the Terraform, final command is Terraform apply. And the moment you do that, a state file also gets created, about which I'm going to talk going forward when we discuss this practically. These are the very, very important commands. Format command, validate command, they are optional. The moment you save this, you can initialize, you can create the execution plan. This is very, very important step. You cannot miss this. After which you can just write the Terraform apply. You can just hit this command and all your resources will be created. These are the commands which we are going to execute. So just to summarize here, we use, whenever we write a script using the Terraform, we save that using the .tf extension. Then we have to initialize it by using, Terraform init, which will, install all the required plugins which you have mentioned in the provider, and it will basically initialize your Terraform script. Then we can format that and validate and check for the syntax and if everything is fine, and then you have to go for the execution plan by executing Terraform plan. Once you are satisfied with the plan, that what is going to happen the moment you execute this Terraform script, you can use Terraform apply in order to finally provision, or you can say create the resources on the cloud. These steps we are going to see practically going forward. Now let's write our first Terraform script. Okay, we will be writing that on our Linux machine which we have created on the AWS. We will also write our script on locally on the VS Code. Both the approaches. For the first script I will show you. Moving forward, you can decide you would like to continue on the Linux machine which we have on the AWS and work with Terraform, or you want to work locally, right? The first thing is you have to set the environmental variables which we have seen earlier, the access key and the secret key. If not, you can add this in your Terraform script also. I would like to set in my environmental variables. I would like to just go back here and paste it. I'm just exporting this because without the access key and secret key, you cannot create any resources on the AWS cloud. Let me just add this. Apart from that, I would like to also export the secret key, and you will get the secret key and access key. I have in this series shown you how to create this and how to get this. Fine. So let me just hit this. Now it is set. Now after this is done, I would like to just clear this, and I would like to first create the directory. I'll say kdir, and I would like to create a directory. I'll say here maybe 0101 Terraform Script for the EC2. Okay, that's the name of the folder, the directory. I would like to get into this. I'll say here cd 01 and Terraform. I would like to say here EC2. Okay, now I'm inside this. Now here is where I would like to open my visual editor, and I would like to write my first script. In the Linux, this is how we do. If you're a Windows user and if you want to continue on the VS Code, it is little more easier. I would like to just go back here. I'll say vi, and I would like to create one file. Maybe I'll say here main.tf. Okay, that's the name of my file I have given here. All right, I would like to open this. Let me go to the insert mode. I'll keep an assumption that if you are learning Terraform or any of the DevOps tool, you might be knowing about the bash shell scripting, you might be knowing about the Linux command, because these are very, very important, right? Now here we have to write two things. Number one, we have to write about the provider. Which provider are we using? Okay, that information you have to provide. And the second information is, by using that particular provider, what are the resources you would like to create? These two things are very, very crucial here. Now, since I would like to go with the AWS, I would like to say here, I'm going to use AWS. This is the provider I'm going to use. And here you have to specify the region, on which region you want to create this. Let me just say here, region equals to, and I would like to just specify the region, for which you just have to go to your AWS account, right? And you'll get here Asia Pacific region. And Asia, right now on this, based on the location you are in, you can specify the region AP South 1. Okay, AP South 1. So let me open here, and I would like to specify AP South 1. Fine. And here you may also have to specify the access keys and the security key, just in case if you have not set that in the environment variables. If you have not set that, then within the script, here is where we also specify the secret key and the access key ID. Since we have already provided, so we need not to give that, because we have set that in the environmental variables, right? And now after which, I would like to just specify here, what is the resource you want to create? It is the predefined. This keyword is a predefined, then you can give alias name to it. Maybe alias name I would like to give it as, the resource I want to create is, I want to create a new Linux virtual machine. I want to create a new Linux virtual machine. That is the alias. Okay. What is the name? This is a predefined. You will get this in the official Terraform document itself. I want to create the AWS instance. So let me write down here. I have specified here. Now, within this, I have to specify the remaining details. I want to create a Linux machine by using this script. I don't want to go to the web console and manually create a Linux machine. On the EC2, I want to create by executing the Terraform script. That is the main goal here, right? So I would like to specify here. First, you have to specify the instance type which you need. You have to specify the key name. You have to specify the security groups. You can also give the name to it, which is the tag. These are the details we have to specify. So let me just say here, first of all, AMI, what is the image type you want to go with, right? And then I would like to specify here the instance type. I'll say here, after the instance type, you can specify the key name you would like to use. I would like to go with the key name, and then I would like to just go with the security groups. Whatever it takes when you are creating the AWS, EC2 instance on your AWS account, whatever it takes there, whatever you see that with the help of UI, you're writing that here, okay? I would like to go back and say here, security groups, okay? Security groups. You can also specify multiple security groups, okay? You can write the array here. That is like you want to give multiple security groups, you can give that. And apart from that, we have to give the tags, okay? So let me just write here tags. And within this, I would like to specify the name, right? So let me specify the name here. I would like to go back and let me just give the name. Okay, I'll say your name. And what is the name you want to give? Whatever name you want, you can give here. I would like to give the name here as maybe, I would like to say here, Telescope Terraform Linux machine. Any name you want, you can give. This much of lengthy name is not needed, but I just would like to show this is the name of the VM when it is getting created, right? Now, these things you can get it from your AWS account itself. What is the AMI type you want to create, right? And what is the instance type, whether it is a free tier, right? If you are creating this, I hope you know the fundamentals, because Terraform is a alternative to provision or create the infrastructure on the AWS cloud. You must be having the other basic idea about the infrastructure on the cloud. So I just have to specify all these details here. Let me just go back to my AWS account and get that here. Let me just go to my instances, and whenever you are creating the instances, right, you'll be getting the AMI type also. Even if you just go to the maybe launch instance, you can see here what is the type of the AMI you want to create. Maybe I want to go with the Amazon here. We have an option here. So I would like to just take what is the instance type, this t2.micro. You can specify. You can see here we have the AMI ID. I would like to just take that AMI ID. Okay. If you want to go with the Amazon Linux, that's the AMI ID. I would like to just open here and would like to specify this type here within the double quotes. Okay. So let me just right click and paste this. And after which you can specify the instance type also. I would like to just go back. I would like to go with the free tier, which is t2.micro, right? So I want to create a free tier account here. So I would like to just come down here within the double quote. I would like to specify to t2.micro. That's the instance type I want to create, right? And so one-time process, same thing can be repeated. You should not think that it is easier to go with the UI. You can maybe create 10 instances with just one script. If you want to do so, at the top, you just have to say count equal to 10, count equal to 20. In that case, 20 instances will be created, right? I hope it is making sense. So you can create multiple also. And there is a better way to write this Terraform script. I'll talk about the concept of Terraform variables, where we need not to add this manually in our main Terraform file. We can just keep that in the variables and create separately, which moving forward slowly we will understand, right? So now this is the type, and what's the key pair we have used? I think we have used the Terraform. At the time of we had created this, right? So which is the key pair you want to use? I would like to use the existing key pair, so which we had created. So let me just check. The one which we had created earlier, it is Terraform underscore key pair. Okay. So Terraform underscore key pair. For the first time when we created the instance, that time we had also created the key pair. I want to use that same key pair here in order to create this. And now this is a requirement of not Terraform. This is the requirement in order to create the resource on the AWS. Even if you're creating the EC2 instance on your AWS by using the web UI console, these things are required. These things will be there in front of you in the form of UI. Now these things we are writing in the script. Okay. I would like to specify, I would like to go with the default group. Okay. This is our Terraform script. Now I want to save this, escape, and I would like to save here colon wkeep. This is about the bash shell scripting, or you can say the Linux command. If you have learned the Linux, you will be knowing about this. Now let me just check if everything is fine. I would like to just open this and check. I think looks fine for now. Okay. Now I would like to just go and start my execution. How do we start? Let me just clear this first of all. And I would like to say the first command which we have to write is Terraform init. Okay. Let me just make it here. Terraform init. I'm initializing it. You can see it will be initialized. It's taking some time, but it will be initialized. Okay. And once it is initialized, we can just format this and we can validate. I hope you have gone through the Terraform architecture, which we have seen, right? It is taking some time and it is getting initialized. You can see it is successfully initialized. I would like to go back and now say Terraform validate. These two commands are optional command. It is recommended to go with so that if everything is fine with it. Okay. Terraform validate. It is validating the syntax of your Terraform file. And I hope everything is fine here. So let's wait. It is validating the Terraform. there is an error. We have done some mistake there. You can see in the resource AW instance, some mistake is there here. So we have to rectify that. Let me just check. I'll say here main, let me open that vi main.tf. Okay, I would like to open this, and here we have done some mistakes. So let me just see, and it looks fine. Maybe let me go to the insert mode. I think there is a small mistake with respect to the syntax. Yes, we have to just give here equal to. Okay, now it looks fine. I would like to just again save this, and that's the reason, validating is very, very important. I would like to just go back here, Terraform format, and it is formatting all the spaces. You can see it, cat main.tf. It is now in the proper format. See, all the equal to, all this were not in the proper format. Now they are in the proper format. And now I would like to validate this, for which I'll say Terraform validate, and it is validating now. I hope there will be no issues for now. Let's check that the configuration is valid. Okay, these two are the important commands. After which we just have to go and plan our execution. Terraform plan. That's what I have to execute here. You can see Terraform plan. Okay, it is planning that what will happen if you run this. Okay, you will be getting the entire execution plan. You can see plan 1 to add, 0 to change. We are not changing the existing resources. We are not destroying. We are adding a new resource. 1 to add. What it will add, you can see all the details. You can see here, one AWS instance will be created for this AMI. That means I'm going to get Amazon. So now I can just run the Terraform apply. Okay, I would like to just go back and say Terraform apply. Terraform apply is the actual command which will create the resources, which will provision the resources. I would like to just hit this, and one resource should be created. It will take some time. Very quickly, within few seconds or less than a minute, the resources will be created. Okay, it is asking me. We can also, at the time of we writing the apply, right, we can also write one command beside the apply, -- auto approve. If you have done that, it will not ask your approval. It is just telling that this is the resource I want to create. Would you like to continue? Yes. And if you had given there auto approve, Terraform apply -- auto approve, then it will not ask the permission. Since I had not given the auto approve, it is asking me the permission. So let me just say yes. And you can see AWS instance. Linux VM is the alias name. It is just creating one. A Linux machine. Okay, I'm just waiting. Okay, still creating. It'll take some time. You can see apply completed and one added. Let me go to my AWS account. If I have to go to my AWS account, if I have to go to my instances, see, I would like to just refresh it. If I refresh it, we'll be seeing Telescope Terraform. That's the name we had given here, right? See, a new resource got created. That means using the Terraform script successfully, we were able to provision one of the resource on the AWS cloud, which is a Linux machine. Now it is successfully able to create it. Now, by chance, if you don't want this to be there, then you can destroy also, for which you can say Terraform, I'll say destroy. Okay, you can give auto approve also. It will not ask you any permission. I'll say auto approve. It is an optional step, but you can do it. If I just click on this, it is destroying whatever resources created with the Terraform script. Same is getting destroyed. Okay, so let me just run this. It will take some time. It is refreshing the state, and it is successfully able to destroy. Want to destroy AWS instance, destroying. It will not take much time. Within less than 1 minute, this will be destroyed. Okay, as you can see, it is now destroyed. It took 1 minute of time, but the resource is destroyed. Whatever resource was created, that will be destroyed. If I just have to refresh, you can see it is terminated. It is deleted. This resource, a Linux machine which was created, that is now destroyed, that is now deleted, right? So this is the way, but this we have done in our Linux machine. Linux machine, we had installed the Terraform, and there is where we had run this. Now, locally on your Windows machine also, we had installed, we had configured the environmental variables. Now, using the VS Code ID, same script I would like to write, and I would like to demonstrate the same steps which we had done there. Now let's run the same script on locally on our Windows machine, for which I have opened the VS Code on a folder Terraform script. Here I would like to create one directory, one folder. I would like to give the name as 01 application. Any name you want, you can give. And within this folder, I would like to create a new file. Okay. The file, I would like to give it as maybe 01 Terraform EC2 script. Okay. EC2.tf. It should be .tf. I would like to say .tf. Okay. Let me just give it as .tf. Fine. Now one script is created. We have a file .tf file, and here's where the same which we had run, right, the same commands I would like to keep it. All right, just I'll make small changes so that you can understand. I would like to say here alien in place of telescope. I would like to give it as the alien so that you can understand that whatever resources is getting created, it is happening with the help of local also. I would like to copy from here. And it is the same script which we have seen earlier on the Linux machine when we tried to execute the same. Let me just add this, and it is added. Okay. I would like to now save this. Everything is saved. And we had already set the environmental variables, access key and the security key. In the videos in the same series, you'll find the video wherein how to set the what is the need and how to set the access key and the security key. We have done that. Okay. I need not to specify the access key and security key in my Terraform script because that is already been set in the environment variables. Okay, it is now saved. After which, I would like to just go here. I would like to open a new terminal. You can see the terminal will be opened, and you can see here it is right now in this folder. I want to get into this folder, so I would like to say here cd. I would like to say 01 application. Okay, right now it is in the 01 application. I would like to just go back. You can see now, as you all know, we have seen this Terraform init is the first command which we have to run, and it is installing all the required plugins as per the provider information. And you can see .terraform, a file is created here, and it will not take much time, and it's successfully installed. A log file is created, and after which you just have to go and run here Terraform. I would like to go with maybe format just to check if everything is fine. Yes. And now Terraform, I would like to just go with the validate command just to validate. These are optional steps, but it is recommended so that your syntax is fine. There is no problem in it. Okay. It is validating. It is successful. Now I would like to go with the Terraform plan. You can directly apply, but plan is recommended. Execution plan, like if you execute this particular script, what will be the case, right? So I would like to just wait for it. It is planning. Okay, there is a fail in the plan. Terraform encoded in the error while generating this plan, retrieving the AWS account details, validating the provider credentials. There is some problem with respect to the IDs, the access key ID. There is a problem here. No problem. If there is a problem, that means environmental variables that has not set properly. That's the meaning of it. Locally, when we had tried to set the environmental variables for the access key ID and the secret key, maybe there is some problem there. I might have not added the proper keys. That should not be a major matter of concern. You can do that. In that case, I could just add that locally on my, in the script itself. So let me just do that here. As you can see, I have added that here. I would like to just save it. And now again, I would like to reprocess. I would like to say here Terraform init. It is initializing. Formatting, I think it's fine. If you want, you can do this formatting also. Okay. It will reinitialize everything. And now I would like to say Terraform format. And then it is Terraform validate. I would like to validate this. And now finally, I just have to run the command Terraform plan. If validation is fine, let me just check if the syntax is correct. It is successful. I would like to say Terraform plan. Okay. Now let's see if it is creating any problem here. Terraform plan, it is planning. Okay. Since now I have given the access key, it should not create any problem. Maybe in the environmental variables locally, there is some issues. Apart from that, I would like to say here Terraform. I would like to say here apply. Okay. I would like to apply this. Since we have not specified the auto approve at the time of using the Terraform apply command, we just have to say here yes, it will ask the permission. Okay. Now it is creating the machine. It will take some time. Within less than a minute almost, the resource can be created, right? Now, using the concept of variables, we can see how these things can be stored separately. We have to achieve modularity also, about which we will talk. And this is one of the way. This is, we are just creating the AWS instance, EC2 machine. You can create something else also, some other resources also, which we will explore as we proceed further. Okay, it is still creating it. It has taken more than 30 seconds of time. Okay, now you can see it is completed. It is able to create. The moment it is able to create, one state file gets generated, right? State file is very, very important file. Okay, so that gets generated the moment you create this. More on the state file we will discuss going forward in this particular series. Let me go back to my AWS account. I would like to just refresh this. Okay, you can see, guys, a Linux Terraform, alien Terraform Linux machine, a new machine got created. A new resource we could able to create. We could able to provision a resource on the AWS cloud using the Terraform script. Now, two things we have seen. We got connected to the Linux virtual machine. Using that machine, we could able to run our Terraform scripts locally also on the Windows machine on our, VS Code ID. We could able to do that. Now, based on your preference, your choice going forward, whichever way you want, you can follow that and you can keep practicing whatever we are discussing in this series. Now, we could able to successfully run our first Terraform script. We shall see more going forward. Now, one more important thing which we need to understand is about the state file, right? State file, I'm referring to terraform.tf state. This file gets created automatically the moment you run Terraform apply. Terraform apply is a command which we use in order to run our or execute our Terraform script, right? The moment you run that, the moment you say Terraform apply, automatically this TF state file gets created, which maintains the current state of the infrastructure. It maintains the information about the infrastructure which got created using the Terraform, the instances ID, right? It could be the metadata and so and so. All the information like what Terraform has done, that entire state will be automatically stored inside this file. This file will be automatically created and all these details will be maintained here. And the moment you apply Terraform destroy in order to destroy the infrastructure, the resources which you have created using the Terraform, destroy command, it refers to this state file only in order to delete these resources, right? Okay, let me just show you one thing. Let me open this and redo this step once again. I would like to just check everything I've deleted from here. And right now we have main.tf. Also remember that whenever you're writing any Terraform script, create a separate directory. In every directory, there should be a Terraform script. And if you want to run some maybe 5 different scripts, please create 5 different directories, right? So that's how it should be followed. Now we have main.tf and let me initialize everything here. I will say here the first command, as everyone knows, Terraform. I would like to just init. And the other 2 steps, Terraform validate and Terraform format, they are optional. They are not compulsory. Since it is already configured, I would like to directly go for Terraform plan, right? Let me just go for a Terraform plan. It will just give me a plan that what resources will be created, right? So it is creating the plan. And now I would like to apply the real command, which is Terraform apply. Okay. Now I will hit this. Since I am not told auto approve, it will ask me the permission whether it has to create the resource, right? So let it take some time. Now it is asking me, I would like to just say here yes, and it will take few seconds of time and the resource will be created. As you can see, the resource is created here, right? So let me just go to my AWS account and verify if the resource is already created. I would like to go to my instances and if I just have to refresh it, you'll see a new resource which will be created here, okay? So let me just refresh once again. You can see the list code Terraform Linux. This is the resource which got created just now, okay? Now, I would like to just go back here and let me just clear this. Again, if I check ls-l, you can see here, you are getting this Terraform TF state file. This is a state file. Earlier, when we had checked before we run the Terraform apply, only main.tf was there. Right now we have terraform.tf state. This file got created the moment you have executed Terraform apply. It maintains the information about the current state of infrastructure, like what got created with the help of Terraform. Now, in order to destroy the resources which got created with the help of Terraform, usually we write one command called as Terraform destroy. Now, how it will destroy? To destroy also, it will refer the state file. It will go to the state file and it will refer the information which is there
because Statefile maintains all the information about the infrastructure which got provisioned, which got created with the help of Terraform, and it will go and take the help of the state file, and based on the information available on the state file, it will destroy that. By chance, if you delete this state file, which is very, very crucial file, then you'll not be able to destroy it. And before that, I would like to say here apply. Okay, I would like to say here apply once again. Already with the help of this Terraform script, we had already created one resources. A state file got created, right? Now one more time I'm running the Terraform apply. Will it create a new resource? The answer is no. It will not create the new resource. Let me just execute this and it will take some time. As you can see, no changes. Your infrastructure matches the configuration. How you are getting this information? When you try to rerun this Terraform apply, it will go to the state file and it will check if it has already created the infrastructure based on the information on the main.tf file, main Terraform file, whatever information is there. Based on that, if it is already created the infrastructure, it will go and check in the Terraform state, because Terraform state file will maintain the information about the infrastructure which got created. And when you just run this Terraform apply, it will go to the state file and check, and it will come to one conclusion that already the infrastructure is created based on the information on the main.tf, and there are no changes, no more changes. Whatever information is there, based on that information, the resource is created. It will check the state file, current status of your infrastructure, current state of your infrastructure, then it will not create one more resource, right? Now, if I have to go back here, and if I have to again refresh this multiple times, you'll see there will be only one machine which got created, only one machine. You can see again and again, if I run, it is only one machine. One more time, it is not created. Why it is not able to create? It is following the state file, and by going to the state file, it is checking like, yes, it has been already created. Just in case, I would like to do one thing here. If you want to see what is there in the state file, I'll say here cat terraform.tf state, terraform.tf state, TF state, that is a Terraform state file. You can see all the information in the form of JSON, the current state of the infrastructure which got created with the help of Terraform, right? Now let me just clear this, and I would like to say ls-l. Now I would like to delete this state file. Okay, please see the difference here. I would like to say remove this. It is not recommended. Just to demonstrate, I am just deleting this. Okay, in general, it is not recommended to delete this state file. Let me just hit this, and now again I would like to say ls-l. You can see we don't have this state file. Again, I would like to run Terraform apply, and if I just hit this, you can see it is asking plan 1 to add. Do you want to add this? I would like to just say yes, and you can see it is creating one more machine. Why? There is no state file available. If you again run Terraform apply n number of times, a machine will be created. A same machine will be created because there is no Terraform state file here, because the Terraform state file I have deleted, right? Earlier, when we had the Terraform state file, and again when we tried to run the Terraform apply, it did not create any resources. It told there is no need to change anything, right? No resource was created. Now, after I deleted the state file, again when I apply, see, one more resource got created. If I have to go back here, and if I have to just refresh this, you can see one more machine got created. See, Telesco Terraform Linux, Telesco Terraform Linux. Two machines got created for the same configuration, right? Now, for the second machine, the Terraform state file will be created. I would like to just clear this. Okay, and now I would like to just say ls-l. You can see we have this Terraform state file. Now again, if I say Terraform maybe apply, it will not create any resource because state file is available. So even if you are trying to destroy something, it will go through the state file only, and then it will destroy. Okay, now you can see no changes. Your infrastructure matches the configuration. Apply complete, but how many resources added? 0 resources added. I hope it is making sense here, right? Unless and until there are changes in the main.tf file, it will not create a new resource because it is the same resource. It will go and check the Terraform state file. Oh, and it will check the main Terraform script. This, based on this configuration which are available in the main Terraform file, the infrastructure is already created because that details are already there in the state file. I don't think so I should create once again. I'll come to a conclusion that based on the configuration which is there in the main Terraform file, already the infrastructure has been created. I need not to create once again. And how it is able to decide based on the state file. And just now when I deleted the state file, again I tried to run the Terraform apply. It doesn't have any information about what had happened earlier because there is no state file. There is no information on the current state of the infrastructure. In that case, it was creating infrastructure once again, right? However, this Terraform state file is very, very important. You should not delete. And even if you go for destroy, example, if I say here Terraform destroy, let me just do it auto approve because I don't want it to ask me permission. I'll say here auto approve. Okay, I want to destroy this, and now it will able to destroy these resources, whatever resources we created, right? If you want to destroy that, whatever resources got created with the help of Terraform, if you want to delete that, if you want to destroy that, then you just have to apply Terraform destroy. And this Terraform destroy, the moment you run this, it will go to the state file only in order to check what resources are there, so that I can delete that, I can destroy that. Now, if I run this, it is able to destroy all the resources because of the state file. And if you delete the state file and if you try to run the destroy, it will not be able to destroy. It doesn't have any information to destroy. Like, what is the state of the infrastructure which I want to destroy? Because state file is the one which will maintain what Terraform had already done. Now, if state file is not there, how Terraform will get to know that what I have to delete? Because in the state file everything was there. State file is deleted. Now it will not be able to destroy. Now it is able to destroy because state file is present. It is very, very important file which you have to take care. Also, we will have one file called as backup file, right? I would like to demonstrate that also here. Let's wait till it get destroyed. We can see now it has been destroyed. I would like to just clear this. I'll say here ls-l. Now we have a state file. We have a backup file also. Backup file is a backup of the state file. It is a backup of the state file. And by chance, if you make any new changes here, example, I'll do one thing. For now, let me just delete these files which got created. I would like to delete everything. And I want to demonstrate one thing here. Let me just go back. Or maybe I'll do one. Okay, let me just go back here. And I would like to delete this file also. Okay. And it is not recommended to delete this. Okay. I want to demonstrate one thing here. This it's not there. Okay, sorry. I would like to forward this. And now I'm deleting this backup file also. Okay. I'm deleting this backup file. And now if I have to clear this ls-l, we have only this. Okay. ls-l. We have only this now. I would like to say Terraform, initialize this. It will initialize. It will take some time. Formatting and validating, we have seen earlier. It is in the proper format and the syntax is correct. I need not run that again. I'll say here Terraform plan. You should always plan first, but I would like to just apply. Okay, because we already know the plan of the current script which we are running. We have seen that earlier. Okay, I'll say here auto approve. Let me just run this. And if I'm running this, please kindly focus here. You can see here the resource is created, right? That's fine. We have seen that earlier also. I want you to understand one thing, that ls-l, if I say, you can see state file got created, right? Now, I would like to make some changes in the main dot. Of course, if I say once again, Terraform dot apply, will it recreate the resource? No, because of state file, it will go and check the state file. And you'll check the main file. All this configuration, already the resource is created because that is there in the state file. That information is available. I'll not create a new, right? So please here, no changes have been made. Now, I would like to just say vi main.tf. If I have to, okay, open this, you have an option to edit. I'll do one thing here. I'll make the changes here, okay? I'll make some changes here. Maybe I would like to just go back here. I'll say here maybe AI telescope. Okay, so sometimes just to give some changes. Okay, I would like to save this. Some changes I have made here. Okay, let me just save this file. And once again, I would like to say Terraform. I would like to just say here, Terraform apply. Terraform, I would like to just apply this, right? The moment I'm applying this, it will take some time. and it will ask me, see, it is asking me permission because there is a change in the main dot TF file, the main Terraform script file. It is like, yeah, the new resource has to get created because it will go and check. And now please here, the new resource is not getting created here. Rather, the changes have been made. One changed. And the moment one change, I want you to observe this thing. Okay, I'll say ls-l backup file got created. Now, whatever new changes you have made, right, with respect to the name, tag name, based on that, when you have reran the Terraform apply, some changes happen in that existing resource. And whatever changes happen, that information will be maintained in the Terraform state. Terraform state file will maintain the current state of your infrastructure. The new change you have made, you have changed the name of the tag. Based on that, in the Terraform state file also the information will be available with respect to new changes we have already made. Now, whatever earlier, we had some other thing earlier, right? And that backup will be created here. Backup file will maintain the older state information. So what it exactly does is, you have run this once again and you had made some changes, right? Whatever new changes have been made, the resource will be updated and that information will be available in the state file, the current status, the current state of your infrastructure. Now, before that, earlier, some information was already available in the state file. There is that information. For that older information, one backup file will be created. Backup file will have the information of the older state file, because any changes you make in the main Terraform script and if you reapply, then those changes will be implemented in the resources and that current state of the infrastructure will be maintained in the Terraform state file. And earlier, some information was already available in the Terraform state file based on the previous run of the Terraform script. That information will be, one more backup file will be created and that information will be maintained in the backup file. I hope you could able to differentiate the difference between the state file and the backup file, which are very, very crucial files. Practically, I have shown, I could have just told in 2-3 minutes, but I wanted to show this practically because this is very, very crucial. Now, let's write one more Terraform script. This time, we are creating the EC2 VM, but with the user data. In the AWS, we have a concept of user data. That is, you are creating a virtual machine as a web server. At the time of machine creating, you are also hosting a basic static website. Okay, we have a concept of user data. It's like you hosting a static website at the time of resource creation. For the same, I would like to, do that with the help of Terraform script, right? So now I have got connected to my Linux machine, okay? Then I have also, set the environment variables where I have passed the access key and the secret key. Everything is set. Now I would like to just create one directory. Every time we create a Terraform script, it is recommended to create a directory. I would like to say mkdir, and I would like to create one directory 02. I would like to say we have a Terraform script for EC2 machine, which acting like a web server, okay? Web server, that's the name I have given here, right? And now I have to get into this. I would like to say, please go inside this particular machine. Let me just ask this, okay? Done. Right now, I just have to go inside this. And now, first, I would like to create one shell script, a bash shell scripting. I hope those who are watching knows the fundamentals of shell scripting and fundamentals of the Linux commands. Only then you can understand any DevOps tool. Those are very, very crucial for any DevOps engineer. Fine. Now, I would like to just create one shell script wherein we host a basic, we will have a script to host the basic static website. Okay. So, for which I'll give the name as we have to, to install the, to host the static website, we should have some of the packages also. I would like to write a script which will install httpd package and also host a static website. Okay. I would like to say install httpd.sh. That's the name I have given here. Now, let me just hit the enter key. I would like to go to the insert mode, for which I have made the arrangement, the script which is responsible to host a static website. I would like to just take this. Okay. And this is something which you might have done at the time of you learning the bash shell scripting or maybe the basics of AWS. I would like to take this particular script from here. and I would like to go back to this and add this. This is not responsible for creating any machine. This is a basic shell script which will install the HTTPD package, also host one basic static website. Okay. Now after which I would like to just save this. It's done. Now I have to create my actual shell script. I would like to say here, actual the Terraform script. I would like to say main.tf. Now it is created, and the same script which we have used earlier, and with one difference here. Okay, what is the difference? I would like to talk. We have to have one difference here, that we have to invoke this particular bash shell script which we have created, right? That we have to invoke from this script, because at the end of the day, we are going to execute this particular Terraform script, and inside the script, somewhere I have to invoke the other shell script which we have created, right? The install http.sh, that file I have to invoke from this particular Terraform file, because we are going to execute this Terraform file, right? So now let me just add that one line here. So I would like to just go here, and I would like to just say here user data, I would like to say equals to, and here I would like to specify file, which is a file, and I have to specify the name of the file. So let me just do this. I would like to say here, the name which we had given there was install httpd.sh, right? So now I would like to just save this. I have saved. Now I have to give some permission for this file so that it can install the HTTP, that is required web server, which is required to host the static website, that we have kept it here, and that we have invoked inside this file. Now I have to give the permission for this file so that it can install the required web servers. Okay, for which I have to say a chmod, and I would like to say here u plus x, the execute permission. I'm asking like, please provide the execute permission for this file called as install httpd.sh, right? So these two steps we are doing extra here, that is not exactly related to the Terraform. Here what we are doing is, I want to create a resource on my AWS, which is EC2 instance, and that EC2 instance I want to create by hosting a static website. It should act like a basic web server, right? Now for the static website, I'm doing this extra arrangement of installing the HTTPD server and also giving that permission to it. Now the permission will be granted. Now we have to execute this main Terraform file, because inside this I have done the code which will invoke this particular sh shell script also. Fine. Now let me just go here. As you all know, the command which we have seen earlier, Terraform init, right? It is initializing. It will take some time, and the Terraform file will be initialized. And once it is initialized, we may have to run the other Terraform commands. Now it is successfully initialized. I would like to say here Terraform maybe formatting. It is optional step. Terraform, let me just validate it. I would like to validate and check if everything is fine. Validation looks fine, the syntax is correct. Now I would like to just directly can apply, but recommended to go for the plan. See the execution plan first, Terraform plan, and let me just see the plan. If everything is fine, what exactly it will do? It will give you the plan, a blueprint, and then based on that you can execute. If not directly you can execute, but that's not recommended. One to add. Okay, now I would like to go with Terraform apply. And I want this to auto approve. So I would like to say auto approve. It will not ask you, again, do you want to proceed further or not? Automatically it will go and create that instance. Okay. Terraform apply, auto approve. Let me just hit this, and it will start to create the resource. Let's see if it is creating such a Linux machine which is acting like a web server with some static, a website. Okay. So the same concept of user data, right? So now it is telling one to add, and it will take few seconds of time, and that machine should be created. As you can see, it says that it is successfully able to create the machine. Let me just go to my AWS account, and I would like to go to my instances, and let me just refresh. If we have that instance here, I would like to just refresh it. You can see we have one instance, Telescope web server, which got created here. I would like to just go here and wait for some moment, because still it is initializing. Okay, so after a few seconds I would like to try to access that with the public IP. Now let me just take the public IP and check if it is installed. I would like to just go here and paste the public IP, and if I just hit this, we should be getting this option telescope learning. That means we could able to create a web server on our AWS which is hosting a static website. The concept of user data. User data refers to you creating an instance on AWS alongside a basic static website which is acting like a web server, right? We could able to create a EC2 VM with user data by using the Terraform script. We did not do that manually. We did not use the AWS web user console. We have done that by executing the Terraform script.
Now let's understand about one more concept, which is variables in Terraform, right? Variable in any technology or any programming language or anywhere comes into picture whenever you want to store the data. What we have done is, in both the cases, we have created the Linux server, we have created the Linux machine. One directly we just created, one which is hosting a static website which is with the user data, right? In both the cases, everything, the provider information and resource information also we had hard coded within the resource section of main.terraform script file, right? Everything was available within one file, and all the values within the resource section we had hard coded, right? This is what we have done. Now with the help of the concept of variables, we can make it more dynamic. I'm referring to whenever maybe in future you want to change the AMI type, then you can just change the value here. You need not to open the actual main Terraform script. If you have maintained that separately in a separate file with the help of the concept of variables, there you can make the changes. Here you need not to make the changes. So if you hard code everything here, maybe right now the instance type which you're going to create is t2.micro and you want to make it to t3.micro. Maybe you want to change the type of the instance. In that case, you have to change the main.terraform script. It will not be dynamic. So with the help of the concept of variables, you can create a separate file where you are storing your variables, and any changes you want, you can make the changes inside that file. You need not to come to the main Terraform script and keep making the changes. Also, you need not to give the provider information within one file. It will be more modular if you maintain separately. So what I'm going to do right now is I'm just going to create 3 separate files here. Number one, I'll say VI. I'm just opening the editor here. This is the Linux command. I'm going to create one variable, one file, Terraform file called as variables.terraform file. I'm going to create one more Terraform file which is the main.terraform where actual resource information will be available. Apart from that, I'm going to just create one more. Apart from this, I would like to just provide here provider.terraform where I'll maintain the provider information. 3 files I would like to create here. VI, it's not the name of the file actually. VI is all about visual editor in the Linux. VI refers to visual editor where you can just write something. Okay, that's not related to the Terraform. Anyway, now 3 files I'll create, and inside this I'm going to create the variables. I'll say here variable, and whatever is the variable name you want. This is to store the AMI value. I would like to give the variable name as AMI, right? Now within this, maybe I would like to give why this variable is about. Okay, description, let me write here. And within this, I would like to just describe why we have this particular variable. Maybe I'll say here Amazon, Linux machine, Linux image information, whatever you want, you can give the description about the variable. And then with the help of default, and I would like to here specify the actual AMI value, right? So I would like to just take this value here and I would like to just specify here. Okay, and similar to this, I would like to create one more variable, and this variable will be about the instance type. Okay, so you can give some other name also. I would like to give instance type as the name here, and let me just cut back here and just provide the instance type as the name. I would like to just give here the name of this variable as instance type. Okay, fine. Now apart from that, okay, let me just remove this. It's not required. Yeah, okay, great. Okay, let me just go back here and give this name. All right, and now I would like to just give the description. Maybe I would like to just provide the description here as type of the instance. Okay, whatever description you want, you can give. I would like to say here type of instance,
And maybe I would like to just also specify the type, which is t2.micro or t3.micro. Free version is what I'm using for my Mumbai region of AWS account. Okay, I have specified here. Correct. Now I need not to go here and make the changes. Whenever you are going to write a main script, right? In the main script, I would like to write this, what resource I'm actually going to create. I would like to write within this. Okay. All right. And here I'll not be writing any value, because this value I have stored inside variables.terraform script file separately within the variable. Now I have to access this variables here. I'm not going to hard code the values of my resources here, right? For which you just have to use here the dollar symbol. I would like to just mention here, and within this curly bracket, you can specify variable dot the AMI, the name of the variable which you have given here. It should be as it is. Okay. All right. Let me just close this. And similar to this, here also I am not going to specify t2.micro or t3.micro or any other instance type I want. Rather, I would like to just say here within this, okay, I would like to specify the dollar symbol within the curly bracket. I would like to say variable dot whatever the variable name we have given here, right? 3 separate files I'm going to maintain. Okay. All right. Let me just go back here and specify instance type. Whatever is the type of the instance, I mean, whatever is the variable name you have given here, it should be the same. Okay. This name you can give anything, but whatever name you have given here, you have to keep it same. Now I'm just trying to make it more dynamic. I'm not hard coding the actual values within my main Terraform script. I'm just maintaining that separately with the concept of variables. Actually, it is an input variable. More going forward, very short, we are going to understand what is output variables, what is input variables. However, with the help of this variable, I'm maintaining this separately, and these values I would like to access in my main Terraform script. And you can see in the main Terraform script, I'm not even, giving the information about the provider. For that also, we have maintained the file separately, and like here, everything was within the same file. Now I have just made it more modular. Okay. Now I would just go back here, and within this provider, I'm going to just specify the information about this provider. Okay. That's what I have just done it. So everything will not be within one file. I have stored that in the different files. One is about the variables, and those variables I'm going to use in my, main Terraform script. Now in future, if you want to make any changes with respect to the AMI value, with respect to the instance type, or for whatever you are creating the variables, you need not to, edit or make any changes in your main Terraform script. You just have to go to the variables and make the changes. Okay. You can just change the values here, and here it will not be affected because the variable names. In future, you cannot just change the variable names. If you change, then again in the main.terraform script also, you may have to make the changes to access, right? So now let's do the same here. I would like to just go back to my Linux machine. I would like to, let me just close this. I would like to get connected to my Linux machine, the same Linux machine which we had, created here. I would like to first get connected to it. Let me just go back here, and I'm just trying to establish the connection. Okay. All right, the machine which we had created. All right, ls-l. Now I would like to create one more folder, one more directory. I would like to say create the directory with the name 03 Terraform script, or maybe this time I would like to say EC2 more modular, or EC2 variables concept, or anything. That's fine. Okay. Now I would like to get into this. I would like to say please go inside this particular folder. All right, EC2 vars. Okay, I have gone inside this. Right now we don't have anything here. ls-l, if I check, we don't have anything here. Okay, now I would like to create 3 files. Okay, first, number 1 is variables.terraform file, and inside this, let me go to the insert mode, and whatever we had already defined here, I would like to keep this everything. Okay, I would like to copy from here. Let me just take it from here, copy, and I would like to just add the same which we had already written. Okay, I have specified here. Okay, now I would like to just save this particular file. Again, I would like to say here main.terraform, where I'll give the actual resource information, okay, which we had already written earlier also, and here also we had written that I would like to just take it from here, the resource information. All right, and that's what we had it. I would like to just go back and add this resource information here. And if you want just to have a differentiating factor, intentionally I would like to give the name of my virtual machine is just a Linux VM. Okay, so that it's a new, you can understand that's the same machine is not getting created like the way maybe the previous script, just to say that it is a different script. Okay, so Linux VM is what I have given the name here. I would like to just save this particular file, and now I would like to create one more file, okay, which is the provider.terraform, and here I'll just give the information about the provider. Okay, I would like to just go back here and give the information about this particular provider. Okay, which cloud provider you're going to use, that's the information I have maintained here, right? So let me just go back here. All right, done. I would like to save this particular file as well. Now you can see we have 3 files. Everything is not available within one file. Now we shall start the usual commands. Number 1, Terraform init. I'm initializing the Terraform script. That's the first. It is initializing the backend, initializing the provider plugins. Okay. Now it is initializing within 1 minute of time. It will be initialized. You can see it is initialized, and as you all know, next is Terraform format. Okay, I'm just formatting. If everything is fine, it is formatted very well. After which I would like to just go back here and say Terraform validate. I'm just validating if everything is fine there and we have not made any mistake. All right, it looks fine for me. Yes, it is success. Let me just clear here. And now you all know, first we have to plan our execution. Okay, so Terraform plan, it will just tell what is going to execute, what is going to happen the moment you run the command Terraform apply, which we have seen earlier also. Okay, Terraform plan error. Terraform encountered an error while generating this plan. No valid credentials. All right, no valid credentials. That is security credentials. We don't have the security credentials, and every time you're reconnecting those environmental variables which we used to say, right, export, that used to get deleted every time you're recreating the CLI. I mean, you're connecting back to your Linux machine, and whenever you are creating the resources, you should have a security credentials, which we usually add that into the environment variables. Earlier about the security credentials we had seen it. Now I just have to export that before I go and provision the infrastructure. Let me just do that. As you can see, I have added the security credentials to the environmental variables because this is very, very important. Now let me again plan here. Terraform, I would like to just plan my resource here. Terraform, of course, we have to plan it. And let me see. It will just give you the plan of execution, what is going to happen. Okay, so it is planning. It will take some time. As you can see, as per the plan, one resource is going to get added. And now I would like to write the command which we usually write, which is Terraform apply, and I want this to be auto approved. It should not ask me permission whether it has to create or not. Auto. I would like to go back and say here approve. Okay, now the resource will be created. Okay, let's wait. As you can see, the resource is created. This time the same Linux machine would be created, a server would be created. However, it will be like we have just achieved more modularity here. We have not maintained or we have not kept everything within one file. Rather, we have divided the things into multiple files, provided in a separate file. And then we use the concept of variables, wherein we can pass the values to our main script dynamically, right? If there is a change in any of the values, we need not to make any changes in the main script. We just can make the changes in the variable script, and automatically those values will be passed to our main file. So let's go here and check if the resource is created. Let me go to my EC2, and I would like to just go to my instances. Okay, and you can see here we will be getting it Linux VM. Okay, which is just initializing. Just now that machine is created. Now again we could able to provision the infrastructure. We created the server, we created the Linux machine using the Terraform, but the way we have organized the files here is different from what we have done earlier. Right now we have to understand little more on the concept of variables before we proceed further. Now, when it comes to the variables, there are two types of variable. One is the input variable, one is the output variables. Input variables is what we have used here, right? When we have created this, inside this variables.terraform script, we have used the input variables, which is going to provide input to the main Terraform script. In the Terraform script, we are going to take that data as an input, and that can be called as the input variables. We can also have the output variables. Output variables comes into picture whenever you want to know, or you want to print, or you want to give the details of the infrastructure which you have provisioned using the Terraform once it is created. That means after you execute the Terraform apply, the infrastructure which you are trying to create, that will be provisioned, that will be created. And once that is created, after the Terraform apply, if you want to print some of the values, right, and that's where the output variables comes into picture. In this case, maybe the moment this script we have executed in order to create the EC2 instance, in order to create the server, right? And the moment this machine is created, I want the public IP of that gets printed. Maybe I want the information about this VM gets created, or maybe you are writing the Terraform script in order to provision the S3 bucket. And the moment S3 bucket is created, you want to print the information about the S3 bucket, right? And maybe you have written the Terraform script in order to create the IAM user. And the moment the script is successful, the IAM user is created, immediately here you want to print the information about the IAM user after the infrastructure is created. After the execution of your Terraform script, infrastructure is successfully created, which will happen after you execute the Terraform apply, and immediately you want to print that information. That's where the output variables comes into picture. Post infrastructure creation, output variable. And on your main script, if you want to pass some input, right, directly, you don't want to hard code the values there, then like the way we have done earlier in this series, we have to create a separate variables folder. You can hard code the values there, and dynamically from there you can pass it to your main script like the way we have done just now. Okay, now I just got disconnected to my VM machine. Let's connect back here. I would like to go back and take this. Of course, as you all know, I would like to just connect back to my machine here. And whenever you connect back to the machine, you have to also add the credentials, the security key and private key. But before I do that, I would like to just check. This is the folders we have. I want to get into this. So let me just get into this. There is no such directory. Let me again get back to this particular directory which we have created. Let's go back here, and ls-l, we have all these files here. And state file, about the state file, we have understood earlier in this series. The moment the infrastructure is provisioned, automatically state file gets created. What exactly it is, we have already understood. Now I have to create one more file, which is the output file, where I'll be writing the variables, and this will be executed post the execution of your main script. The moment the infrastructure is successfully created, whatever you have specified in the output, that information will be displayed. It could be for any infrastructure, okay, not just for EC2 machine, S3 bucket, maybe you're creating the RDS, right? And then the moment the database gets created, you want to know the endpoints of your database, right? All of that can be printed using by using the output variables. Now I would like to do one thing here. I would like to just remove this state file and backup file, so that the same folder I can use in order to recreate the infrastructure. Let me just do that here. As you can see, I have removed the state file and the state backup file. Now, if you just run the Terraform apply, a new infrastructure will be created. It will not create any issue in order to provision the infrastructure. Now, I just have to create here VI. I would like to create one visual editor and create here output dot Terraform script. And inside this, let me go to this insert mode, and I would like to specify the output variables, for which I would like to write here output. Whatever name of the variable you want, you can give. I would like to just give the name as maybe within double quotes. I would like to just specify here, okay, EC2 VM. Maybe the variable name I would like to give it as public IP. Okay, I want to know the public IP. That's the meaning of it. Public. I would like to just go back here and say IP. Okay, all right, and let's go back here, and I would like to just specify this. Okay, so let me just go back. I would like to just specify here. All right, and I would like to just go here. Within this, you just have to pass value equals to whatever the resource name which you have given, that you have to specify here, which is AWS instance, and whatever the alias name in the resource section which we have given. If I have to open this before we executed the script, we had opened this right now. So for output variables, what we have to do is the value equal to what is the resource name, AWS instance dot, what is the alias name, Linux VM is the alias name dot, then you have to specify what information you need, public IP, private IP, maybe the instance state you want to know, or maybe everything about the instance you want to know. Whatever you want to know, the moment instance is created, the moment the VM is created, you can specify in the output variables. Okay, I would like to specify the AWS dot Linux VM dot whatever you want. Okay, I would like to just go back here and I would like to just specify. I'll say right click here and paste this dot. What is the machine name which we have given, the alias name? I think it has been given as let's just take this, because this is the same thing we have used earlier also, Linux VM. I don't want to give any name. I would like to just go back here, dot Linux VM. And now what you want, public IP, private IP, you just have to specify. Since I want to know the public IP, I would like to just go back here and say public IP is what I want to know, right? Likewise, you can create multiple variables also. Maybe you want to know the private IP also. You want to also know about something else. The moment whatever infrastructure is getting created using the Terraform, that information, it could be the information about the S3 bucket, it could be the endpoints of database, it could be details about the IAM user. For whatever purpose you're writing the Terraform script, and the moment it is provisioned, the moment it is created, if you want something to be displayed, then you can use the concept of output variables. Fine. Now I would like to just save this. I have saved it, and let me do one thing. I would like to add this into that. Okay, no problem. I would like to just initialize, as you all know. Let me first clear this, ls-l. These many files we have: main, actual resource section, output, what we want to print it the moment the infrastructure is created, provider, where we have given which provider we are using, AWS Azure, and then where we have the input variables, where we are taking the input from that variable into our main. I would like to just go here and say Terraform initialize, as everyone knows about it. Initializing the backend, less than 1 minute, it will be initialized. It is initialized. Now I would like to go with the Terraform format. If everything is fine, yes, then Terraform validate. If my script is proper, it is valid. Validate is one of the important yet optional step in the Terraform execution. I'm trying to validate, it is success. Okay. Now I would like to plan my execution and see if everything is fine. But now I may get error here because I reconnected to my VM through the CLI. And the moment you recreate the environment variables where you have given your security credentials, right, that got deleted. If you're reconnecting, then again you have to export that. Maybe you have to add that into your machine. If not, you can keep that within the Terraform main script also, which is not recommended. I would like to set in the environment variables, which is for temporary setting. So let me just add the access key, ID and security key here. As you can see, I have added the credentials. Okay. Now let me just again clear this. And now I would like to go with Terraform plan, right? Now I'm planning my execution. So it will just say what is going to happen with the script which you're trying to run. As you can see, it is going to add one resource in my AWS, and also it is going to change this to the output. The moment resource is created, it will also give you the information about the public IP. Okay, now let's go here and say Terraform apply, and I don't want it to ask me any permission, for which I'll say auto approve. All right, auto approve, Terraform apply, auto approve. Now it should be creating the resources on the cloud, and also it will print you the public IP. So let's wait for that. As you can see, one resource got created, resources one added. And the most interesting part here, are you all able to see the public IP of the resource which got created here? That's the use of output variables. Let's cross check here. I would like to go to my AWS account. Let me go to my EC2. Okay. And let's check if the resource is created. First of all, I would like to open my EC2. All right. EC2 is created. Let me go to my instances. And if I have to go to my instances, you can see here, a new instance, Linux VM got created. With this instance, this Linux machine, we created using the Terraform script. And if I have to open this, please kindly verify the public IP. This is the public IP. All right. and whatever information we are getting about the public IP, both of them are same here, right? Not just public IP, it could be the state of the instance, it could be the private IP, it could be everything about the instance, and not just to the EC2 instance. Any resource you are trying to provision, you're trying to create on the AWS using the Terraform. And if you want to print some of the information the moment resource is created, then you can use the concept of output variables. Now, practically, we have seen what is the use of input and output variables and how we may have to write here. I hope you could able to understand that. Now we have understood the concept of variables. We have understood the use of input variables and output variables. So far, whatever resources we have created, it is just to create a Linux machine, or you can say a server or a machine on AWS. Let's write a Terraform script to create a resource, to provision the resource other than a Linux machine, maybe RDS or S3 bucket, or maybe to create an IAM user. Okay. First of all, I would like to create one directory here. I would like to just go back here and say create one directory. Okay. Which directory? Maybe I would like to go with 04 Terraform. All right. And this time maybe I would like to create the S3 bucket. That's the one I would like to create here. All right, so let's -L, and we are inside this. Let me just go inside this particular directory. Okay, now using the concept of variables, it's up to you whether everywhere you want to use it. If not, like the way we have done the first and second script without the variables, everything, all the provided information and all the values hard coded in one main Terraform script, like that also you can write. It's not a major matter of concern. Okay, right now we don't have anything here. We may have to create. Now, can we use the AI tools in order to get the scripts? Now we have understood fundamentally how the Terraform scripts looks like, how we have to use the HCL. Let's use the AI tool in order to generate this. Okay, I would like to go to my browser, and I would like to open the ChatGPT. You can use any other AI tool also. And here I would like to just search here. Okay, I would like to say here Terraform script, Terraform. Okay, I would like to just go back here and enhance. I want a Terraform script to create S3 bucket on AWS, right? With versioning. I want to go with the versioning also. Versioning means where you are trying to maintain the track history of this, versions of this. Okay, versioning, right? S3 bucket on AWS with versioning. Okay, I would like to just run this. You can see here we got it. Inside the main.terraform only, it is giving provider. If you want, you can maintain separate provider, and then you can do, that's not a problem. Okay, and this information again you can keep separately also. You can write the versioning inside this only. Anything is fine. Okay, you can see provider information and the resource information. This is the resource name, this is the alias name of the resource, and this is the actual bucket. And this has to be a unique. You can give any name. Whenever you are creating any bucket in the S3 on your AWS cloud, it is not just related to Terraform, in general about the AWS. Whenever we create a S3 bucket, the name should be unique. Okay, it has to be unique name. And the tags, again, it is an optional. If you want, you can write it. If not, you can ignore it. And after which, what are the steps which you have to run? It is also giving you all these steps, right? Now I would like to just go back here, maybe write without the versioning. If I just write the same, okay, without, I would not like to mention about the versioning, and let's see what we get. What is compulsory? What are the things we have to have at least a minimum in order to create this? Okay, so only this much you're getting it. Tags again is optional. It is not compulsory. See, only this much you are getting it. If you want to give the permissions also, maybe I want to go with the permissions, right? I would like to just go back here, and I want it to create for me. I would like to say here with ACL. ACL means permissions. Okay, I want to go with the access control. Okay, ACL means basically the access control about the permission, whether it has to be private, a public, who can access, and what authority they have over this S3 bucket which is getting created, right? So I would like to just specify I want with ACL, and let's see if we are getting it. Region, and yes, we are getting it. ACL private, and other things are optional, right? So now I would like to go to my EC2 machine, and here I would like to say please create one provider dot Terraform. All right, I would like to just go here, and I need not to worry. I would like to just take this information from here. You can maintain everything within one also, that's not a problem. I would like to go back here, and I would like to just create one. Okay, right click, and I would like to paste what we have taken from there. Okay, of course, it is not this for us. It is South zone for us. Okay, right now I'm recording in India. For India, I'm using the Mumbai region. The region you have to specify. Change it to your preferred region. Since I'm using Mumbai, it is South region. Let me add that here. As you can see, I have added AP South 1. Okay, I would like to just save this file. All right, I would like to just save this file. Okay, and now it's done. I would like to go with the main.terraform. Right, and here you can use the concept of variables, input variables, and then you can get that. I've got into the insert mode. Insert mode means you have to press. Okay, this is about the Linux fundamentals. Okay, now I would like to just go back here and get the script what we wanted. Okay, only this much. I don't want to go with the tags. I would like to go with this. Yeah, I don't want to go with this. I want till here only private. Okay, I don't want all these things. So let me go to my resource and add the script here. Right click, I would like to paste it. Of course, you may have to close this. This is the most important part. Okay, closure of what we are writing. Okay, this is not required. Fine. Now guys, the name of the bucket has to be unique. It is not about the Terraform, it is about the AWS. Okay, I would like to maybe, this is the resource name, my bucket alias resource name. I would like to say here, Telescope 4545 bucket. Okay, B. Whatever name you want to give, maybe I would like to give it as a bucket. Yeah. Now that's the bucket I would like to create. And now after which I would like to just save this file. Okay, let me just save this. All right, and I have saved it. I'm not using any concept of output or input variables. If you want, you can use whatever we have seen in the last series. I mean, the same series, maybe the last part of this. You can try to implement input and output variables here also, which you can do it. Okay, now let's initialize this. The first part, Terraform initialize. I'm going to initialize. It is initializing within less than 1 minute of time. It will be initialized. And the next part, okay, after initializing, I'll just go for the formatting and the validation. You can see it is initialized. The next part is Terraform. Let me see if I have to format. Everything's fine. I would like to go with Terraform validate. I would like to validate my Terraform script. It is validating. This we have taken from the AI tool. Okay, so I'm just trying to validate this. It is validated, and now argument is deprecated private. It's okay, not a problem. It's just a warning. I would like to go with Terraform apply. Also you can go, that also gives you planning, and then it will create it. If not, you can just plan first and then you can execute. I would like to say Terraform and plan. All right, let me just go and say here plan. It is planning, and see, it's a plan. It will give you the execution plan, which we have discussed a number of times. Warning is there, but one resource to get added, no problem. And now I would like to say here Terraform apply, and I don't want it to ask me permission while it is trying to create the resource. Auto approve. Please don't ask anything in between. Go and create the resource. Go and provision the resource. Right. So now I would like to execute this. Right. So yeah. Meanwhile, while it is getting executed, okay, it is executing. It is creating, guys. One resource got added. You can see plan was to add one resource, and one S3 bucket got added here. We can open the AWS and we can check that. So if I have to go to my AWS, you can see here. If you just go to AWS, okay, you'll get all this. If you have used earlier these S3 or any other resources, you'll get here only recently visited. If you have not gone, you may have to search here, okay. Since I have already used it, I would like to see here. If not, you have to go here and search for S3, okay. Now I would like to just click here, and here it will give you the console of it, and you can see Telescope 4545B, right? You can see here Telescope 4545B, and just now it got created, okay, at the time of me recording this video, okay. This is the name which we had given, and we could able to do that. Right now you can destroy also, as you all know, whatever resources you have created. If you want to destroy, I would like to say here destroy, Terraform destroy, not just destroy, Terraform destroy, because some of the resources on the AWS, it is paid, it is not free. If you are using them, you may have to, bill will be generated, okay. So Terraform destroy, I would like to go with auto approve, and I would like to just delete this. Okay, whatever resources got created, it will be deleted. Not just S3, you can create IAM user, you can create RDS, whatever you want. And if you have generally understood fundamentals of HCL and Terraform, then you can use AI tools to generate the script and you can just verify and use the way we have used. Now, one more thing which you have to understand is about the taint and untaint in Terraform, which is again very, very crucial. Earlier in the same series of Terraform, we had understood about the Terraform Statefile. Whenever you create or provision any resource using the Terraform, the moment a resource gets created, one state file gets generated, which will maintain the state of the infrastructure which got created using the Terraform. And once this state file gets generated and the resource gets created on your AWS, right now we had created one resource called as Linux VM, okay, using the Terraform, and state file got created. Once again, if you try to execute Terraform apply, we have seen this earlier when we had discussed the concept of state file. If I just apply once again, auto approve, will it create a new resource? Will it delete the existing resource or create a new resource? No, it will not create so. Earlier also we had seen. One more time, if I just try to execute this, kindly see, it will say 0 to add. The resource will not get created. It will refer to the state file and say, based on this information, one resource is already created. You can see here, no changes, right? And resource 0 to add. 0 to add, that means new resource will not get created, right? So once we create a resource or provision a resource on the AWS using the Terraform, maybe there is some issue in the machine, something went wrong here. Now, without making any change on the Terraform resource main script file, can we create a resource? The answer is yes. If you want to achieve that, then you have to use the concept of Terraform taint, right? By chance, if you want to, make sure that this gets applied, a new resource has to get created, then you have to make changes in the main.terraform. If there are any changes, by looking at the changes and compare with the state file, it will create a new resource. If not, a new resource will not be created. Same thing we have already understood in the concept of state file in the same series. Now, by chance something happened to this machine, something went wrong, there is some problem here and you want to destroy this and recreate once again. If you want to do it, we have an option where we manually destroy, we delete all the state files, then we reinitialize. Without deleting the state file, without we manually destroying with the help of Terraform destroy, can we just write this command once again and that existing resource which we got created, the VM, should get deleted and a new resource has to get created. Then we have to use the concept of Terraform taint. So for which we have to just run one command, Terraform taint, and then I have to talk about the resource which I want to recreate. Example, AWS instance. Okay, AWS instance, that's the resource we had created earlier with the help of the Terraform script. And I would like to say here, dot, what was the the alias name which we had given? It was Linux VM. Right? So I would like to say I want to taint this resource. The moment you hit this button, it will be tainted. It will take some time and you'll be able to get one message here. We got the message, no such resource instance. Maybe the name I have given wrong. I would like to open this main.tf and check. You can see what was the name we had here. It was AWS instance Linux VM hyphen was there. Okay. So what I'm going to do here is, again, I would like to say here Terraform taint. And it is AWS instance, instance, and I would like to say here dot Linux. What is the exact name here? It is Linux VM, right? So I would like to taint this. It will take some time and you'll be, getting one message here. You can see here, resource instance, AWS instance, Linux VM has been marked as taint. Mark as taint means now if you just rerun this once again, I'm not destroying that. I have not used Terraform destroy. I'm not making any changes in the existing main.tf. Nothing I'm doing. Okay. I would like to just rerun this once again after I apply taint. I would like to rerun this and you can see existing resource will get deleted. A new resource will be created. You can observe this. Okay. And this is possible after you apply. You can see plan 1 to add. Okay, 0 to change and 1 to destroy. You can see we are getting the public ID because that's the script I'm running where output variables were also there. Okay, it is destroying. You can please see here, it is destroying, still destroying. it will destroy the existing resource and then it will recreate. Okay, so that's what it will happen. Please observe here. You can see here, first it got destroyed and then a new resource got created. It destroyed the existing resource, then it got created. Now, earlier, when I just applied this, right, when we just use this Terraform, then during that time, it was not working. So let me just show you this. When I just applied this Terraform apply auto approve, when I just executed this, once the state file got created, we got one message, no changes, zero resource to add, zero to add, right? And now after I just got into the taint, I marked the resource as the tainted resource. And after I applied the taint, and once again after making it to a tainted resource, when I apply, then again it destroyed the existing resource and recreated that particular resource. That's the meaning of taint. Now if you want to say here, I would like to say here Terraform, I would like to say here taint. What is the name of the resource? It was AWS instance. This is the resource which we created. And what is the alias name we had given? It was Linux -VM. Okay, if I just hit this, it will be marked as tainted. If you mark this as tainted, and now if you execute Terraform apply, then it will recreate the resource by deleting the existing resource. Generally, if you don't taint, once the resource gets created, state file gets generated, that time, if you try to run the command Terraform apply, a new resource will not be created. Existing resource will not be deleted. In that case, by chance, if you want to delete the resource which got created and now recreate the resource, in that case, normally if you want to go with the manual approach, then you have to run the Terraform destroy command. The resource will be deleted. Then you have to delete the Terraform state file, which is not recommended. Then again, you have to reinitialize and reapply. Lengthy process, right? Now, once the resource gets created and by chance, due to some reasons, if you want to delete and recreate the resource without you manually destroying, deleting the Terraform state file and all, then you have to just get that into the taint. And after you mark that resource as a taint, if you just run Terraform apply, then automatically it will delete the existing resource and recreate a new resource. I hope even if you have watched the state file, if you have understood, then now you could you could able to differentiate what difference it is. Once it is in the taint state, can we untaint that? The answer is yes, for which you just have to run one command, Terraform untaint. You just have to write Terraform untaint, and then you have to say which is the resource you want to untaint. This is the resource I want to untaint. Okay, dot Linux VM. I want to untaint this. Okay, there is a spelling mistake here. Instance. Okay, instance dot Linux VM. Okay, I would like to untaint this particular resource. The moment I run this command, you can see the message now. You are getting the message, Linux VM has been successfully untainted. If it is untainted, it is back to its normal form. Now if I run this Terraform apply, I would like to say here auto approve. Will it create a new resource? Will it delete it? No, right now it is not in the tainted state. It will go to the state file. It will check, oh, for this resource, one infrastructure is already created, right? The resource is already created on the cloud. I will not destroy that because it is not in the taint state. You can see 0 to add, normal behavior. You can see here no changes and 0 to add. Generally, that's the behavior of the Terraform apply once the resource is created. We have understood the same in the state file concept. But if you taint, you'll be able to destroy that and you'll be able to recreate it if you run the apply command. Now I got into the untaint form. Untaint means it is back to the normal form. If you try to run this Terraform apply, it will not create any resource. I hope you got the difference between the default behavior on which it is working and what is the use of taint and untaint. Now we need to understand one more important concept, which is Terraform modules, which is one of the important concept. Again, it simply means collection of configuration files which you have created within one directly. That is one module, right? Example, for an instance, if I have to say here ls-hell, let me just go back and write here. I would like to just say here maybe ls-l, and I would like to just know what is there inside this particular directory, right? So if I have to just go back and say, I would like to just say collection of all these files which you have created in order to provision or you can say in order to create the infrastructure on AWS in one directory can be called as module. This is one module here, right? All the configuration files which you have created. Now this is okay. You can do, or you can write in this way whenever you have to create one or two resources on the cloud. What if you want to create multiple resources? There is a way on which we have to organize this. There is a way we have to follow in order to write the Terraform scripts, in order to provision the infrastructure. We have to be more modular here, more organized here. So what I'm trying to say here is, if I have to open this, kindly understand what we have done so far is I had created one folder here, whatever is the name of the folder. Maybe I've told here 03 Terraform, maybe EC2 var, something like this. I've created one folder, right? Within this one particular folder, we had created all the files. We had our variables files, input files, where we had kept the input files. Similar to that, we had the provider information, right? On which cloud we are going to create the script. And here only we had the main Terraform script, and within this only we had the output variables. What is input variables? What is output variables? Everything we have already seen in this particular series, right? So we can specify all of them in one particular directory. Now this is only called as a module, but there is a better way wherein we may have to follow. This is not the approach. What if you want to create multiple resources? Maybe I want to create the resources on EC2 also. I want to create S3 bucket also. I want to create the IAM user also. I want to create the VPC also, right? I want to create multiple infrastructure. I want to provision here. In that case, provider will say, okay, we are going to create that on the AWS. It's easy. Now, for all of them, creating the variables, so many variables inside one file, so many output variables for which you want to know the information once the infrastructure is created, again in one file, and inside one main.terraform script, you are going to add all these resources information. It becomes very, very, very difficult to manage that. It's not easy, wherein everything, if you open this, you are not just creating one resource. In the same file, you have written the code in order to create the, or in order to provision the infrastructure of EC2 also, S3 also, IAM user also, VPC also. Maintenance become very, very easy. So with the help of one concept called as Terraform modules, we can organize this better. What we can do is, we will be creating one example. I'm just creating all this infrastructure for the Telesco application. I'll create one root module called as Telesco. Maybe I'll say here Telesco infra, whatever name you want you can give. Okay, Telesco infra, for example. Now within this, first I would like to specify what is my provider, which cloud provider I'm going to use, provider.tf. Great. After which, based on the infrastructure which we are creating, right, we have to create the multiple modules. Multiple modules in the sense you can say multiple directory. I'm going to create one directory here called as modules directory. After which, I would like to just create one more directory here, which is maybe EC2. Here I would like to create one more directory, maybe S3. Based on that, here I would like to create one more directory based on whatever you would like to achieve here. And again, this directory can be called as modules, child modules. This is the root module. Okay, I would like to clarify, this is our root module, and within this I'll create one directory called as modules. And again, within this, we will create multiple child directories, which is child modules. Within this particular directory, we are going to create, within this EC2 directory, we will create all our input files, input variables files. We will write our main.terraform. Here we will write the output.terraform, right? And similar to that, on the S3 directory, we will write whatever input variables which are going to use in the main script, main.tf, output.tf, where we will have our output variables. And finally, at this stage, we will have our main directory also. Okay, here we are going to write here our main.terraform script once again. What will be there inside this? Because whatever is required in order to provision the EC2 machine, that will be available here. Whatever is required in order to create the S3 bucket, that will be available here. Then why do we have one more main? Inside this main, we are going to invoke this main. We are going to invoke whatever we have inside this main. And similarly, at this level itself, we are going to create one output.terraform script. Output dot Terraform script. Okay, and here also we are just going to invoke the output variables. It is general. At the root level, we are going to just create these two folders where we will invoke the main script which are there in the child modules. Child modules means whatever directories you have created here. This is called as child module. Child module. It's all about how you're organizing your Terraform scripts, right? So this is your child module. Okay, and this is your root module. We will create one root directory. Within this, first we will specify on which AWS cloud we are going to provision our infrastructure. We will create the provider, and then we will create the modules, a one subdirectory. Within that, based on how much ever modules or how much ever infrastructure we are going to create, we will create all those subdirectories. Maybe you want to create one IAM also. You will create here IAM directory, right? You want to create VPC, one VPC directory. Within these directories, which can be called as child modules, you are going to write all these important files, which is input, main, output, input, main, output. And finally, at the root level itself, within the root directory, we are going to create one main Terraform script, from where we will invoke these Terraform scripts which are there in the child modules. In this way, it will be better organized, better, it will be more modular. And in this case, you will be able to maintain your Terraform script easily. There will be no ambiguity. There will be no confusion. Same thing I have to follow here. How to provision the infrastructure with the help of Terraform. We have seen, we have created S3 buckets. We have created the servers, web servers, one VPC Linux machine. All of that we have seen, and we have followed this approach also. Input variables, output variables, separately maintaining the provider. All of that we have seen. Now I would like to follow this module concept, and in same style I would like to create the infrastructure on the AWS cloud. Okay, so I hope you could able to understand fundamentally. Now we have to get connected to our Linux machine where we have our Terraform, and there we would like to follow the same approach and create the infrastructure on the AWS. So let me just open that. It got now disconnected. Now again I have to connect back to my Linux machine, and then we may have to follow that Terraform modules, and in the same style I would like to create the Terraform scripts in order to create the infrastructure on the AWS cloud. Let me just get connected to this Linux machine and start applying the concept of Terraform modules. Now I got connected to the Linux machine, okay, and we have set the environmental variables also for the security credentials. Now you can see all these files which we had created earlier. Now I'm going to create one root directory as per the plan which we have seen. I would like to just go back here and say create one directory, whatever name you want to give. I would like to give it as 05 telescope Terraform script. Okay, maybe I'll say here maybe project. Anything is fine. Yeah, I have given this. Now I would like to just check if this directory is created. It is created. Now I would like to get inside this particular root directory. Okay, this will act like a root directory if you just look at the plan which we had seen just now. Okay, now I am inside this. Right now we don't have anything. Now if you just look into this diagram, kindly see here, we should have in the root directory one provider file. Modules folder must be there in the root directory itself, main and output.terraform script. Okay, so now I would like to just go inside this, and I would like to create the same. I would like to first create the directory which is modules directory. I have created. Now I would like to just create the files. Later we will fill. I need not to open the editor. I need not to use vi command. Later we will open that. First I'm just creating it. Okay, I would like to create one file called as maybe provider.terraform at the root level. I would like to create one more file which is maybe main.terraform, from where we invoke the child modules, whatever main scripts are available. Okay, I would like to say here output.terraform. Now I would like to just check what we have. This we have at the root level. Now I want to get into modules. Okay, now when I get inside the modules, okay, inside the modules, right now we don't have anything. I would like to create two directories. One is EC2, where I'll write the input, output and main script for the EC2. Okay, and similarly I would like to create one more directory which is S3. For S3 also I would like to write there. Okay, ls-l, we have this here. Okay, now let me just clear this. I would like to now get into EC2. Inside this I would like to create touch and one input dot terraform script. I would like to say here touch one main dot terraform script, and again I would like to say touch and one output .terraform. As you've seen, it's not compulsory like every time you have to write input and output, everything you can write in the main script also, but this is like more organized, that's it, okay? Now, if I have to check this, we have this here within the EC2. I would like to come out of this. And now I would like to just cross check what we have inside the modules. We are inside the modules now. I want to get into the S3. Now I'm in the S3. I would like to directly create only main here, okay? If you want, you can have input outputs even for the S3 also, not a problem. You can write this for almost every infrastructure, okay? But I hope you got the context now. I would like to just go back and write only main here. Can we write input here also and pass the? Yes, you can do that. Can we write output variables and check after the S3 bucket is created the information about the S3 buckets? Yes, you can do that. There is no problem. But I would like to just keep it simple here, okay? ls-l and it is there right now. I want to get into this, right? And if I have to check, all this are present. And if I have to get into, I would like to now check, okay? Let me just clear this, ls-l, and I want to check the tree, okay? Tree of this particular, how it looks like. Is it as per the plan or not before we actually write the code there, okay? I would like to just go back. It's not there. So I would like to install this tree command, sudo yum. Since it is Amazon Linux, it is yum. If not, it is Ubuntu. apt is what you have to write the command for the Linux. For a DevOps engineer, Linux is the most important skill. If someone asks me to take the interview, I would focus 60% on the Linux and then I would focus 40% on the other DevOps tool. It is the most critical. I'll make an assumption that you already know the DevOps tool, okay? Sudo yum. Install. I would like to just say here a tree, okay? Now it will install the tree. Yes, please do install. The tree is installed. Let me just go back here, clear this, ls-l, and now I would like to say a tree. What you want to check, what you want to see the tree of. I want to see this project structure. Is it created as per the plan or not? You can see it is as per the plan. Look at this. And we have main, we have modules, we have EC2 output, Terraform, and inside this EC2 also we have this, inside the S3 also we have this. And if you just compare the diagram, it is exactly same, which you can see here, okay? And of course, maybe I have written this main down, but it is at the root level. Doesn't matter a tree is showing first main or output. It is not about first. These files are there at the root level. That's what it is important, okay? I hope that much you have. Now I would like to get inside this and I have to start writing the code, okay? So now I'll do one thing. I would like to just first get into this folder, okay? And now I would like to get into modules inside this folder, right? And now I want to get into EC2 directory. Right now, I would like to open the files. If I have to check here, I have this input, out, main and output, right? If you want to open in the editor, vi and output.terraform, because earlier we used touch, we just created this, okay? And what to write here, I'll get into insert mode by pressing I, and we had already written this script, right? I would like to just write the same, okay? I would like to take it from here. And also guys, one more part is that which I would like to highlight here. If you want, you can pass the input variables from the root directory main Terraform script. What do you mean by that? From here, we invoke this child modules, right, for the execution. At the time of from the main root file, at the time of we invoking this, if you want, you can pass the input variables from here also. Of course, you can keep it in the input file and then automatically it will be taken care inside the main. But when you're invoking this main sub-modules, the child modules main Terraform script from the root level main Terraform script, at that moment also, if you want, you can pass the input variables. Maybe you don't have example here. I have not created. If you want, you can pass the input variables from here only at the time of invoking. That can also be done just in case, okay? Maybe we'll do one thing. AMI value, I would like to pass it from the main, okay? Just to show you the variable for the t2.micro, the instance type, I would like to keep it in the input file only. And here what I'm going to do is this AMI value I not like to pass from here. We can keep it in the input file and we can pass it. We have done that earlier, but interestingly from the root main directory is there. No, whatever I've just said, I would like to prove that it is possible. For now, I'll not give anything. Maybe I'll say a type equals to string, nothing more than that. Okay, I would like to just save this. Now I would like to open the main.terraform script, and if I have to get into the insert mode, for that earlier we had already written this. Earlier we have already seen this, right? And I would like to just take this resource. I would like to copy from here and I would like to just get into this, right click, and I would like to just add it. And one more point is that you need not to write this always within the double quotes and curly brackets. If you want, you can ignore that directly. Also, you can call like this. Okay, there should not be any problem, but by chance if there is a problem, we will again change it to the normal. Okay, I would like to just go back here, and like this also we can write. I would like to just provide this and remove this part. Okay, I would like to come inside this, and I would like to do like this. Like this can also be done. Now let me just save this file. I would like to just go here and save this particular file. We have saved this. Now let me open this output. I would like to say here output.terraform script. Okay, I would like to say here output dot terraform script. And again, earlier before this in the same series we had already written, just to save the time, I would like to add whatever you want in the output. What exactly is the output variables, how do we write it, almost everything we have seen it, so that should not be a major matter of concern. Okay, I would like to just go back and save this file, and this is fine. I would like to say ls-l, we do have this, and whatever we had to add we have already added. I'll say here cat just to check if everything is fine. Terraform, yes, we have added the variables. I would like to say here cat and get into main.terraform. Okay, and I would like to get into cat and output dot terraform. It's there here, right? I would like to just come out of this out of this folder EC2. And now I would like to check, we have one more folder, and now I would like to get into this S3. Okay, within this S3 right now we have one folder main. I want to get into this main folder. I would say main.terraform, and here I would like to add the same which we have executed in order to provision the S3 bucket. Let me just add that. As you can see, I have added that. I would like to just save this. Okay, earlier also we had done in order to create this. All right, and then now I would like to just get out of this ls-l, and I would like to get out of it, and I would like to say ls-l, and we have this. And now we have to just edit this provider which is there at the root level .tf. And here we have to add the provider information, that which is the provider which we are using right now. Okay, we are using this AWS in the Mumbai region. So I would like to just specify here AP South 1. Right click, and I would like to just specify this, right? And I would like to now save this file. I have saved this. Okay, saving the file and all these commands, it is related to Linux. I'll make an assumption you already know Linux. I've been telling this in repeated way. All right, now I have to get into this VI main.terraform. This is the main Terraform script from where it is at the root level, from where we have to invoke the child level, whatever main Terraform scripts are there in the child modules. I just have to invoke. For this, in specific syntax you have to write here. You have to use something called as a module here. Let me just write here. I would like to just say here module, whatever name of the module you want. I would like to say here my EC2. Okay, I'm going to invoke that here, right? So I would like to just get into this, and here I just have to specify source equals to, where is the source you have to specify here. Okay, I would like to say here it is in the from the root directory. You have to go inside this modules directory. Inside that directory we had created one more directory called as EC2 directory. There is where the main file is present. Okay, that's part you have to specify here. Apart from that, since one of the value I showed that from the main Terraform script which is there at the root level, from there also if you want you can pass the input value to the child modules Terraform main script if you want, right? I just had explained that also, we can do it. So there in the variables of EC2 I had given for the instance type but not for the AMI image. I have to pass here. So when I'm invoking the scripts of the child module EC2, one input also I'm passing. Okay, one input also I'm going to pass here, which can be done here. So let me write that here. Let me just get this value from this script AMI value. I would like to just take it from here. Okay, all right, or maybe I would like to just take it from here. Okay, and get into this, and I would like to pass it. It's not compulsory. We can keep that in the input variables only, like the way I've kept the instance type, but this can also be done. I just wanted to show you. Okay, similar to this, I would like to just write here a module, and I would like to say here maybe my S3. Whatever name you would like to give, and then now I would like to just get into this, And here I would like to just specify the source equals to where exactly is the file from where you want to invoke. From this root directory, go inside the modules. There we have one folder directory called as S3 that I have to specify, right? If the path is something different, then you have to specify the entire path here, right? And that's all. I'm not passing any input values to the S3 buckets main file, so it's fine. This much is more than sufficient. I would like to just save this file here. It is done. Now comes the output file. Let me open this output. I would like to say here output dot tf, which we had already created, output dot tf main. Yeah, done. And from here I just have to invoke that output variables which are there only in the EC2 directory, output variables file I had given there. Okay, so let me just add that here. As you can see, I have added that, but however, I want to add this, okay, I have to specify. It is there inside the module. What is the module name we had given for the EC2? I think we had given my EC2, right? That's a module name from the main EC2. And now I would like to say dot public IP. Okay, that's what you have to specify here. And this is the name which we had given the module name inside our main Terraform script in our root directory, right? Module we had created, and this was the name we had given. And public IP we have to, from there is where we're invoking the child modules, right? So whatever name you had given, that name you can give it here. Okay, now I would like to just save this. I have saved it. Okay, so let me just clear this first. I would like to say ls-l, and I would like to just okay, great. And now I would like to just do one thing. I would like to just see what we have, all these files we have here. Now I would like to say, let me just, okay, I think the tree also we have already seen. I would like to say Terraform init as normal. Everyone knows very well. And we are initializing the files. Hopefully it will initialize without any problem. Okay, so fingers crossed. Right now, no errors. Let's wait for the initialization. So seems like there is no problem, and I would like to just format Terraform formatting, no issues, and let's check the validation. Okay, Terraform validate. If everything is fine, I hope there will be no error here is what I feel. All right, it is validating, fingers crossed. Oops, unsupported attribute in the output file. Unsupported attribute, it is telling that value module dot ec2 dot public IP. This I have to rectify. It is a object. Okay, so somewhere this naming is wrong. The object does not have an attribute name public IP. So let's check what is the name we had given there. I would like to just say ls-l. I want to get into modules. Okay, or I'll do one thing. I would like to say here cat, go inside modules. Inside that, go to EC2. Inside that, see what is there inside this output dot Terraform script file. That's I would just want to check what is there inside this. Okay, of course it is not dot, it has to be the / because we are getting inside this. And I would like to just execute this, and we had given the name here Linux VM dot public. Okay, whatever the name we had given, I think we have to give that a same name only directly, not the public IP. So what I'm going to do right now is I would like to just edit this file vi. Okay, but I would like to copy this and see if this is working out. Okay, and now I would like to go inside output dot Terraform. This output is the root level output. Okay, let me just edit this, and I would like to just okay, keep it here like this. Okay, let me just paste it. Dot I would like to say, and I would like to just paste it. Okay, so maybe I would like to just specify the name here, or maybe dot, not the dot. I would like to just give it as underscore. All right, and here it is dot. I would like to just remove this. Yeah, this should be fine because directly public IP we don't have there. It is there with EC2 VM public IP, and then we had specified this. So of course 2 times public IP should need not to we have it. That's a variable name we had given there. Okay, so now I hope it should work. I would like to just go back and save this, and now I would like to again say Terraform. Maybe again I would like to initialize, already initialize. So yeah, at the root level I'm doing this. Okay, so it is initializing the backend. Seems like no problem. We're using the existing log file. Okay, log file means a file which gets generated the moment you initialize the Terraform init, one log file gets generated. Okay, I would like to say formatting was done. I would like to say Terraform validate. Okay, now see if it is still creating the problem. If not, we may have to rectify what is the exact issue. Now there is no problem there. Yeah. Now I would like to say Terraform plan, right? If I have to go for the Terraform plan, let's see what is a plan, how many resources. As per the in the module we had 2 resources. Okay, in the entire project you can see 2 to add, and one public IP also has to be displayed once it is created. So now I would like to go back and say Terraform, as you all know, apply. I would like to go with auto approve, right? So it is apply auto approve. Okay, and you all know very well it will create 2 resources now. One is S3 and one is EC2 machine. Now this time we just have executed this in a structured way, right? That's what it is, creating the EC2 machine first, and then it has to create the S3 bucket. Now S3 bucket it is creating, EC2 machine also it is creating. It will take less than a minute of time and it should be created. So let's wait for that. As you can see, 2 resources got added here, okay, and also you're getting the output of public IP VM which you are printing in the output variables, okay. Now let me just go back to my machine and cross check if it is getting created. I would like to go to first the EC2 machine and check if the instance is created or not. If I have to go to my instances and it is loading, and let's check if it is getting created. Terraform Linux instance running and it is initializing. Initializing means just now it got created. So this machine is created, and also I'd like to just check if the S3 bucket is also created, right? So I would like to just go back here and say S3, okay, S3, and I would like to just check if the S3 bucket is also getting created. If I have to check here, the ISO 4354, this particular S3 bucket also got created here. Now since some of the resources are paid, including the S3, I would like to just destroy that here, okay. But with the help of modules, we could able to organize our files and provision the infrastructure on the AWS cloud using the Terraform, right? This is how you have to do it in the real time, okay. So now I would like to just destroy all the resources which got created. Terraform, and I don't want it to ask me any permission. I would like to say here auto approve, and please destroy all the resources which you had created at the time when we had run the apply command. So this is about this modules project, guys. I hope you could able to understand what is Terraform, why Terraform, how do we write the scripts, what are the commands, the architecture of the Terraform init, format, validate, and then we have seen about plan and apply, destroy command. We have seen about input output variables when we have to use the modules. We could able to create S3 buckets, EC2 machine. You can create any infrastructure. We also use ChatGPT to generate the Terraform scripts, and I hope now you got a big picture about the Terraform to start your journey with Terraform. Now I got connected to the Linux machine, okay, and we have set the environmental variables also for the security credentials. Now you can see all these files which we had created earlier. Now I'm going to create one root directory as per the plan which we have seen. I would like to just go back here and say create one directory, whatever name you want to give. I would like to give it as 05 telescope Terraform script, okay. Maybe I'll say here maybe project, anything is fine. Yeah, I have given this. Now I would like to just check if this directory is created. It is created. Now I would like to get inside this particular root directory. Okay, this will act like a root directory if you just look at the plan which we had seen just now. Okay, now I am inside this. Right now we don't have anything. Now if you just look into this diagram, kindly see here. We should have in the root directory one provider file, modules folder must be there in the root directory itself, main and output.terraform script. Okay. So now I would like to just go inside this and I would like to create the same. I would like to first create the directory which is modules directory. I have created. Now I would like to just create the files. Later we will fill. I need not to open the editor. I need not to use vi command. Later we will open that. First I'm just creating it. Okay. I would like to create one file called as maybe provider.terraform at the root level. I would like to create one more file which is maybe main.terraform, from where we invoke the child modules, whatever main scripts are available. Okay. I would like to say here output.terraform. Now I would like to just check what we have. This we have at the root level. Now I want to get into modules. Okay. Now when I get inside the modules, okay, inside the modules, right now we don't have anything. I would like to create 2 directories. One is EC2 where I'll write the input, output and main script for the EC2
Okay, and similarly I would like to create one more directory which is S3. For S3 also I would like to write there. Okay, ls-l, we have this here. Okay, now let me just clear this. I would like to now get into EC2. Inside this I would like to create touch and one input dot terraform script. I would like to say here touch one main dot terraform script, and again I would like to say touch and one output dot terraform. As you've seen, it's not compulsory like every time you have to write input and output, everything you can write in the main script also, but this is like more organized. That's it. Okay, now if I have to check this, we have this here within the EC2. I would like to come out of this, and now I would like to just cross check what we have inside the modules. We are inside the modules now. I want to get into the S3. Now I'm in the S3. I would like to directly create only main here. Okay, if you want, you can have input outputs even for the S3 also, not a problem. You can write this for almost every infrastructure. Okay, but I hope you got the context now. I would like to just go back and write only main here. Can we write input here also and pass the? Yes, you can do that. Can we write output variables and check after the S3 bucket is created the information about the S3 buckets? Yes, you can do that. There is no problem. But I would like to just keep it simple here. Okay, ls-l, and it is there right now. I want to get into this, right? And if I have to check all this are present, and if I have to get into, I would like to now check. Okay, let me just clear this ls-l, and I want to check the tree. Okay, tree of this particular, how it looks like. Is it as per the plan or not before we actually write the code there? Okay, I would like to just go back. It's not there, so I would like to install this tree command sudo yum. Since it is Amazon Linux, it is yum. If not, it is Ubuntu. apt is what you have to write the command for the Linux. For a DevOps engineer, Linux is the most important skill. If someone asks me to take the interview, I would focus 60% on the Linux, and then I would focus 40% on the other DevOps tool. It is the most critical. I'll make an assumption that you already know the DevOps tool. Okay, sudo yum install. I would like to just say here a tree. Okay, now it will install the tree. Yes, please do install. The tree is installed. Let me just go back here, clear this ls-l, and now I would like to say a tree. What you want to check, what you want to see the tree of. I want to see this project structure. Is it created as per the plan or not? You can see it is as per the plan. Look at this. And we have main, we have modules, we have EC2 output, Terraform, and inside this EC2 also we have this, inside the S3 also we have this. And if you just compare the diagram, it is exactly same, which you can see here. Okay, and of course maybe I have written this main down, but it is at the root level. Doesn't matter a tree is showing first main or output. It is not about first. These files are there at the root level. That's what it is important. Okay, I hope that much you have. Now I would like to get inside this, and I have to start writing the code. Okay, so now I'll do one thing. I would like to just first get into this folder. Okay, and now I would like to get into modules inside this folder, right? And now I want to get into EC2 directory. Right now I would like to open the files. If I have to check here, I have this input, out, main, and output, right? If you want to open in the editor, vi and output dot terraform, because earlier we used touch, we just created this. Okay, and what to write here, I'll get into insert mode by pressing I, and we had already written this script, right? I would like to just write the same. Okay, I would like to take it from here. And also guys, one more part is that which I would like to highlight here. If you want, you can pass the input variables from the root directory main Terraform script. What do you mean by that? From here, we invoke this child modules, right, for the execution. At the time of from the main root file, at the time of we invoking this, if you want, you can pass the input variables from here also. Of course, you can keep it in the input file and then automatically it will be taken care inside the main. But when you're invoking this main sub-modules, the child modules main Terraform script from the root level main Terraform script, at that moment also, if you want, you can pass the input variables. Maybe you don't have example here. I have not created. If you want, you can pass the input variables from here only at the time of invoking. That can also be done just in case. Okay. Maybe we'll do one thing. AMI value, I would like to pass it from the main. Okay. Just to show you the variable for the T2 .micro, the instance type, I would like to keep it in the input file only. And here, what I'm going to do is this AMI value I'm not like to pass from here. We can keep it in the input file and we can pass it. We have done that earlier. But intentionally from the root main directory is there. No, whatever I've just said, I would like to prove that it is possible. For now, I'll not give anything. Maybe I'll say a type equals to string. Nothing more than that. Okay. I would like to just save this. Now I would like to open the main.Terraform script, and if I have to get into the insert mode, for that earlier we had already written this. Earlier we have already seen this, right? And I would like to just take this resource. I would like to copy from here, and I would like to just get into this, right click, and I would like to just add it. And one more point is that you need not to write this always within the double quotes and curly brackets. If you want, you can ignore that directly. Also, you can call like this. Okay, there should not be any problem, but by chance if there is a problem, we will again change it to the normal. Okay, I would like to just go back here, and like this also we can write. I would like to just provide this and remove this part. Okay, I would like to come inside this, and I would like to do like this. Like this can also be done. Now let me just save this file. I would like to just go here and save this particular file. We have saved this. Now let me open this output. I would like to say here output.terraform script. Okay, I would like to say here output.terraform script. And again, earlier before this in the same series, we had already written, just to save the time, I would like to add whatever you want in the output. What exactly is the output variables? How do we write it? Almost everything we have seen it, so that should not be a major matter of concern. Okay, I would like to just go back and save this file, and this is fine. I would like to say ls-l. We do have this, and whatever we had to add, we have already added. I'll say here cat, just to check if everything is fine. Terraform, yes, we have added the variables. I would like to say here cat and get into main.terraform. Okay, and I would like to get into cat and output.terraform. It's there here, right? I would like to just come out of this, out of this folder EC2. And now I would like to check, we have one more folder, and now I would like to get into this S3. Okay, within this S3 right now we have one folder main. I want to get into this main folder. I would say main.terraform, and here I would like to add the same which we have executed in order to provision the S3 bucket. Let me just add that. As you can see, I have added that. I would like to just save this. Okay, earlier also we had done in order to create this. All right, and now I would like to just get out of this ls-l, and I would like to get out of it, and I would like to say ls-l, and we have this. And now we have to just edit this provider which is there at the root level .tf. And here we have to add the provider information, that which is the provider which we are using right now. Okay, we are using this AWS in the Mumbai region. So I would like to just specify here AP South 1. Right click, and I would like to just specify this, right? And I would like to now save this file. I have saved this. Okay, saving the file and all these commands, it is related to Linux. I'll make an assumption you already know Linux. I've been telling this in repeated way. All right, now I have to get into this VI main.terraform. This is the main Terraform script from where it is at the root level, from where we have to invoke the child level, whatever main Terraform scripts are there in the child modules. I just have to invoke. For this, in specific syntax you have to write here. You have to use something called as module here. Let me just write here. I would like to just say here module, whatever name of the module you want. I would like to say here my EC2. Okay, I'm going to invoke that here, right? So I would like to just get into this, and here I just have to specify source equals to, where is the source you have to specify here. Okay, I would like to say here it is in the from the root directory. You have to go inside this modules directory. Inside that directory, we had created one more directory called as EC2 directory. There is where the main file is present. Okay, that's path you have to specify here. Apart from that, since one of the value I showed that from the main Terraform script which is there at the root level, from there also if you want you can pass the input value to the child modules Terraform main script if you want, right? I just had explained that also, we can do it. So there in the variables of EC2, I had given for the instance type but not for the AMI image I have to pass here. So when I'm invoking the scripts of the child module EC2, one input also I'm passing. Okay, one input also I'm going to pass here which can be done here. So let me write that here. Let me just get this value from this script AMI value. I would like to just take it from here. Okay. All right. Or maybe I would like to just take it from here. Okay. And get into this, and I would like to pass it. It's not compulsory. We can keep that in the input variables only, like the way I have kept the instance type, but this can also be done. I just wanted to show you. Okay. Similar to this, I would like to just write here a module, and I would like to say here maybe my S3, whatever name you would like to give. And then now I would like to just get into this. And here I would like to just specify the source equals to where exactly is the file from where you want to invoke. From this root directory, go inside the modules. There we have one folder directory called as S3 that I have to specify, right? If the path is something different, then you have to specify the entire path here, right? And that's all. I'm not passing any input values to the S3 buckets main file, so it's fine. This much is more than sufficient. I would like to just save this file here. It is done. Now comes the output file. Let me open this output. I would like to say here output dot tf, which we had already created, output dot tf main. Yeah, done. And from here I just have to invoke that output variables which are there only in the EC2 directory, output variables file I had given there. Okay, so let me just add that here. As you can see, I have added that, but however, I want to add this. Okay, I have to specify it is there inside the module. What is the module name we had given for the EC2? I think we had given my EC2, right? That's a module main from the main EC2. And now I would like to say dot public IP. Okay, that's what you have to specify here. And this is the name which we had given the module name inside our main Terraform script in our root directory, right? Module we had created, and this was the name we had given. And public IP we have to, from there is where we're invoking the child modules, right? So whatever name you had given, that name you can give it here. Okay, now I would like to just save this. I have saved it. Okay, so let me just clear this first. I would like to say ls-l, and I would like to just okay, great. And now I would like to just do one thing. I would like to just see what we have, all these files we have here. Now I would like to say let me just, okay, I think the tree also we have already seen. I would like to say Terraform init as normal. Everyone knows very well. And we are initializing the files. Hopefully it will initialize without any problem. Okay, so fingers crossed. Right now, no errors. Let's wait for the initialization. So seems like there is no problem. And I would like to just format Terraform formatting, no issues. And let's check the validation. Okay, Terraform validate. If everything is fine, I hope there will be no error here is what I feel. All right, it is validating. Fingers crossed. Oops, unsupported attribute in the output file. Unsupported attribute. It is telling that value module dot ec2 dot public IP. This I have to rectify. It is a object. Okay, so somewhere this naming is wrong. The object does not have an attribute name public IP. So let's check what is the name we had given there. I would like to just say ls-l. I want to get into modules. Okay, or I'll do one thing. I would like to say here cat, go inside modules. Inside that, go to EC2. Inside that, see what is there inside this output dot Terraform script file. That's the, I would just want to check what is there inside this. Okay, of course it is not dot, it has to be the / because we are getting inside this. And I would like to just execute this, and we had given the name here Linux VM dot public. Okay, whatever the name you had given, I think we have to give that a same name only directly, not the public IP. So what I'm going to do right now is I would like to just edit this file vi. Okay, but I would like to copy this and see if this is working out. Okay, and now I would like to go inside output dot Terraform. This output is a root level output. Okay, let me just edit this, and I would like to just okay, keep it here like this. Okay, let me just paste it. Dot I would like to say, and I would like to just paste it. Okay, so maybe I would like to just specify the name here, or maybe dot, not the dot. I would like to just give it as underscore. All right, and here it is dot. I would like to just remove this. Yeah, this should be fine because directly public IP we don't have there. It is there with EC2 VM public IP, and then we had specified this. So of course 2 times public IP should need not to we have it. That's a variable name we had given there. Okay, So now I hope it should work. I would like to just go back and save this. And now I would like to again say Terraform. Maybe again I would like to initialize, already initialize. So yeah, at the root level I'm doing this. Okay, so it is initializing the backend. Seems like no problem, reusing the existing log file. Okay, log file means a file which gets generated the moment you initialize the Terraform init, one log file gets generated. Okay, I would like to say formatting was done. I would like to say Terraform validate. Okay, now see if it is still creating the problem. If not, we may have to rectify what is the exact issue. Now there is no problem there. Yeah. Now I would like to say Terraform plan, right? If I have to go for the Terraform plan, let's see what is a plan. How many resources? As per in the module, we had 2 resources. Okay, in the entire project, you can see 2 to add, and one public IP also has to be displayed once it is created. So now I would like to go back and say Terraform, as you all know, apply. I would like to go with auto approve, right? So it is apply auto approve. Okay, and you all know very well it will create 2 resources now. One is S3 and one is EC2 machine. Now this time we just have executed this in a structured way, right? That's what it is, creating the EC2 machine first, and then it has to create the S3 bucket. Now S3 bucket it is creating, EC2 machine also it is creating. It will take less than a minute of time and it should be created. So let's wait for that. As you can see, 2 resources got added here. Okay, and also you're getting the output of public IP VM which you are printing in the output variables. Okay, now let me just go back to my machine and cross check if it is getting created. I would like to go to first the EC2 machine and check if the instance is created or not. If I have to go to my instances and it is loading, and let's check if it is getting created. Terraform Linux instance running, and it is initializing. Initializing means just now it got created. So this machine is created, and also I'd like to just check if the S3 bucket is also created. All right. So I would like to just go back here and say S3. Okay, S3, and I would like to just check if the S3 bucket is also getting created. If I have to check here, the ISO 4354, this particular S3 bucket also got created here. Now, since some of the resources are paid, including the S3, I would like to just destroy that here. Okay, but with the help of modules, we could able to organize our files and provision the infrastructure on the AWS cloud using the Terraform, right? This is how you have to do it in the real time. Okay, so now I would like to just destroy all the resources which got created. Terraform, and I don't want it to ask me any permission. I would like to say here auto approve, and please destroy all the resources which you had created at the time when we had run the apply command. So this is about this modules project, guys. I hope you could able to understand what is Terraform, why Terraform, how do we write the scripts, what are the commands, the architecture of the Terraform init, format, validate, and then we have seen about plan and apply, destroy command. We have seen about input output variables when we have to use the modules. We could able to create S3 buckets, EC2 machine. You can create any infrastructure. We also use ChatGPT to generate the Terraform scripts. And I hope now you got a big picture about the Terraform to start your journey with Terraform.